Hello out there, you're welcome to Day2 Academy, where we're devoted to building excellence in students, especially when it comes to the basics of the STEM subjects. Now, for our students out there, we know that your exam normally features the compilation of your curriculum for 3 years, and revising such can be such an Herculean task. That is why we have compiled a list of at least 10 past questions in which we have walked through both the theory and the objective of your mathematics exam paper for school candidates, for private candidates, the WAEC exam, the NECO exam, the GCE exam, and you are going to find this video very resourceful as it covers the main curriculum for all these O-level exams that we are talking about, even covering GED and GCSE for international students. In addition to all of this, the WAEC official marking scheme is also included, which can guide you on how best you can actually answer the questions with the way that WAEC is going to grade and assess your performance in the exam. Now, we know that this can be quite a lot, but for easy navigation, you can follow the timeline at the base of the video so that you can know where you stop, you can know which particular exam paper you want to navigate to, and want to believe that that will seriously help you to gain that excellence that you are looking for. So just get your writing materials, get your calculator, and let us walk through these questions together. We believe that given this diligent effort, you are going to actually reap the reward, and at the end of the day, testimonies shall surely abound. Don't forget to like our video and also subscribe to the channel, and much more importantly, if you wish to support us, you can buy us a coffee, you can give your voluntary donation. We really appreciate that, and it will help us to do more videos like this. We wish you all the very best. Let's go ahead and delve into our video. In this question on geometric progression, which is featured from sequence and series, we are told that 7 minus 2x, 9, and 5x plus 70 are consecutive terms of a GP, and the common ratio is greater than 0. We need to note this, okay? Now, our mandate is to find the values of x. Now, if we are given that the common ratio is greater than 0 and we have these terms, generally we can say that the common ratio is the ratio of the next term to the initial term. So in this case, we can define it as Tn plus 1 over Tn, and in this case we can see that for this particular case, that means that the common ratio is first and foremost 9 over 7 minus 2x. But if we are also looking at 5x plus 17, we can also say it is 5x plus 17 over the term before it, which is 9. So we have this as defining the common ratio, and for us to just solve this question, we'll do it to just cross multiply here to say that 9 times 9, that is giving us 81, is equal to 7 minus 2x multiplied by 5x plus 17. Okay, so here we still have that 81 is equal to 7 multiplied by 5x is 35x. 7 multiplied by 17, let's bring in our calculator for that. 7 multiplied by 17, this is 119, so we have 119. Then minus 2x multiplied by 5x, we need to be careful here. It is minus 2 multiplying some other thing, so it will still be negative. So we have minus 10s squared. Minus 2 and 5 will give us minus 10. X and x will give us s squared. Then minus 2x times 17 will give us minus 34x. So we still have it as 81 is equal to 35x minus 34x. That will give us x. Then we have plus 119, and we have minus 10s squared. Let's just rearrange to put everything on a single side, so I can bring this and subtract it from both sides. So that I have 10s squared. Now it will become minus x, then minus 119 plus 81 is equal to 0. So that if I want to simplify this, I have 10s squared minus x. Now 119 that we got initially, let me say minus 119 plus 81, what's that going to give us? This is minus 38, so minus 38 is equal to 0. Very good and very interesting. So now we have this quadratic equation that we want to say we want to solve, and calculator can be a quick sheet, but let me just do this. Let me say I have a sum and I have the product. Okay, the sum is the middle term, which is minus x. The product is this first term and the last term. 10s squared and 38 will be minus 380 s squared. So I'm looking for two terms that will have their sum as minus x and they have their product as minus 380 s squared. Now, if the sum is minus s, that is giving me an indication that they have to be consecutive terms in which the greater number will need to carry the negative sign. That's why the sum can be minus x. Okay. Now for 380 s squared, coming here 10 and 38. What if I take 2 from 38 and bring it to 10? That will be 20. Then 38, that will be remaining 19. So I can imagine that I have minus 20x and 19x. And of course, look at this. If I'm to add these two, that would definitely be minus s. If I'm to subtract them, if I'm to multiply them, minus 20x multiplied by 19x, x and x will be s squared. Minus 20 and 19, that will be minus 380. Good and fine. So the equation is translating into 10s squared. Instead of minus s as the second term, now I can say minus 20x plus 19x, then the last term minus 38. This is equal to 0. Now I can factor out 10s squared and 20x. 10x is common to both, so here we have x remaining minus 2, so that 10x times x is 10s squared. 10x times minus 2 is minus 20x, and the same is applicable in the second case. 19 is common, we have x minus 2 remaining. Now x minus 2 is common to these two terms, so I can say x minus 2 here, and then here I have 10x remaining, here I have 19 remaining. So this is 0, such that x minus 2 is equal to 0, or I have 10x plus 19 is equal to 0. If I'm to solve this, here x will be 2, or here it will be minus 19 divided by 10, x will be minus 19 over 10. But look at what we were told. We were told initially that see, your r is greater than 0. Okay, this is a big factor for us. And what are the values of r? Is either this or this. Now this is what I want to do. How do I finalize my answer? I think I will do it to just quickly check. You can compute this, put this into the equation and see what it's going to give you. But I just want to make use of the calculator to say, in the first case, I have 9 divided by 7 minus 2x, 7 minus 2x. Okay, yes, I got that right. So I want to check with these values for x. So I'm going to say calc when x is say 2, what's that going to give me? That is 3. That r is 3, so that is greater than 0. Okay, what about when x is minus 19 over 10? So I want to say calculate again. What's the value for x? Minus 19 divided by 10. Okay, so what's that going to give? This is 5 over 6. Definitely that value of r is also greater than 0. Or maybe I want to use this second value for the common ratio. I want to say, okay, I'm not doing that. I want to say I have 5x plus 17. Okay, all those should be in brackets. Okay, so I'm saying all of this divided by 9, and I want to solve it. Okay, this is the initial value that we use for x, minus 19 over 10. So what's that? This is also 5 over 6, which is still greater than 0. Or if you want to use in the second case 2, so this is quite consistent. That means that for this expected result that r is greater than 0, x is 2 or x is minus 19 over 10. For that, either of these are going to be correct and we'll get the values of x as stated. Now, assuming that after testing for any of them, r was not greater than 0, maybe r is equal to 0 or r is less than 0, then we cannot use that value of x for which r will not be greater than 0. So these are things you just need to watch out in your exam. But if you are consistent like this, definitely your full mark will be given and then you'll be on your way to excellence. All right. In this question on ratios and algebra, we are told that two positive numbers are in the ratio 3:4, and the sum of twice the first number and twice the second is 68. We are to find the smaller number. Okay, so it is the smaller number that is our mandate, and in a bit to maximize time, we will just try and focus only on that. So if you have two positive numbers being the ratio 3 to 4, let's say those numbers are x comma y, and then they being the ratio 3 to 4 means that x over y will have to be 3 over 4. We can simplify this further to say we want to cross multiply and say we have 4x is nothing but 3y. Now, you know, x is our first number. We are asked to find the smaller number. Looking at this ratio, x being the first number is not the criterion for us to just pick it as a smaller number. It is this ratio that, see, x is corresponding to a ratio of 3, while y is corresponding to a ratio of 4. So x is what we are looking for here, all right? But even before we get to that, we have gotten that 4x is 3y. Since x is what we are looking for, we can say, for this case, we can divide both sides by 3, so that in this case we just have an expression for y in terms of x, since x is what we are looking for. So we can say therefore y is nothing but 4 over 3x. Okay, I'll just keep that as an equation. And now told that the sum of thrice the first number means that 3 multiplied by the first number, which is x, and twice the second number, that sum, twice means 2y. This sum is nothing but what? 68. So we are to find the smaller number. Now, I took my time to actually make y the sort of the formula because I clarified that we should focus on the smaller number that we are looking for. So here I'm to use y is equal to 4 over 3x. If I substitute that into this equation, I will have 3x, okay, plus 2. Instead of y now, I have 4 over 3x is equal to 68. So I can try to say I want to solve this with whatever method I can find suitable, because here I have 3x plus 8x over 3 is equal to 68, and here I can say I want to find, let's say I want to find the LCM 3. Now 3x and 3, I have that as 9x plus 8x is equal to 68 over 1, and again I will have this as 9x plus 8x, that will be 17x is equal to, here cross multiplying, it will be 3 times 68, and what's 3 times 68? We can have that as 204. This 204, so that if I divide both sides by 17, then x will be 204 over 17. Okay, so 204 over 17, our answer divided by 17, what are going to give us? This is 12. X is nothing but 12. Now I don't need to find the other number because already I can say that my smaller number is x. So if I'm to just work that out, I can say, maybe from originally, I say let the numbers be x and y. Okay, so the numbers being x and y, x is the smaller one as is corresponding to a ratio of 3, y is the larger one as corresponding to a ratio of 4. Now if I still want to find the value of y, I can say to find y, I can just use this to say, in that case, y will be 4 over 3x, and of course 3 will cut that x, so it will be 4 times 4, which is 16. So I can just say y is 16. But for this case, I don't need that. I'm only asked to find the smaller number, which is 12, and then the answer is out, done and dusted. I don't need to waste my time. Okay. Here in this question, change of structure of formula, we're given that y is this expression pr over m minus p square r raised to power minus 3 over 2. And in the first case, we have to make r the formula and then find the value of r when y is equal to minus 8, m is 1, and p is 3. The very first step, because what we are trying to isolate out is r, and you can see r is here and r is also feature there. So looking at those, we want to work in such a way that R will be standing. That's what it means by making R the formula. And for that, first and foremost, I would just want to multiply the power of both sides by minus 2 over 3, the inverse of this. So here I'm saying this is minus, multiplied by minus 2 over 3, and then y will also be multiplied by minus 2 over 3. Okay, so we are going to have PR over m minus p square r. Okay, the power had been taken care of, is equal to y raised to power minus 2 over 3. So now we can see that r is common in these two cases. Even though p is common, let me just take r, which is my interest. So I have r into p over m minus p squared. Okay, this is equal to y raised to power minus 2 over 3. And then I can just find the LCM here to say r into here m, then I have p minus m p square, okay, is equal to y raised to power minus 2 over 3. So now I can say I want to choose to cross multiply. In that case, r will be m multiplied by y raised to power minus 2 over 3 divided by p minus m p square. So this will be the solution to the option A part of the question. Now in the second part of the question, we are given that y is minus 8, m is 1, and then we have p is 3. We have to find the value for r, and we just got that r will be m, which is 1, multiplied by y, which is minus 8 raised to power minus 2 over 3. This is an interesting piece that we need to look at. Okay, over p is 3 minus m, that is 1, multiplied by p, which is 3 raised to power 2. So let's look at this. Minus 8 raised to power minus 2 over 3. In the first case, when we have the power being raised to a negative number, that means we have 1 over minus 8 raised to power 2 over 3. So the negative of the power have been taken care of. Okay, so now if we have this is telling us that we are looking for a number that if we are to find this cube root. Okay, let me break this down further. This will be 1 over the cube root of minus 8 then raised to power 2. Okay, this is the right expression for this. I'm just leveraging on the understanding of indices and that to break down all those rules from indices. That is what I'm applying here. So for minus 8, what is the cube root of minus 8? A number that we can multiply by itself in 3 places to give us minus 8. You will discover that it is minus 2 times minus 2 times minus 2 that will give us minus 8, because minus 2 times minus 2 is 4 plus 4. 4 times minus 2 is minus 8. So that means in this bracket the answer is minus 2, but then when we raised that minus 2 raised to power 2, it itself it is 4. So this is nothing but 1 over 4. I think you students to get to understand is that this particular expression is nothing but 1 over 4. So if we want to put in those values into r, we are going to say r will be the first one multiplied by this whole expression we have gotten to be 1 over 4. So 1 over 4, then over 3 minus 1 times 3 raised to power 2 is 1 times 9, which is 9. So we have this as the numerator is 1 over 4 over 6. Okay, this over 6 is something we should be careful of, because this is telling us that r is nothing but 1 over 4. Okay, not 6, minus 6. 3 minus 9 is minus 6. 1 over 4 divided by minus 6. And if we are having something like this, of course, we know that means we are saying times 1 over minus 6. So 1 times 1 is 1. 4 times minus 6 is minus 24. Or we can just write it out holistically to say this is nothing but minus 1 over 24. So this is going to be the value of r when y is minus 8, m is 1, and p is 3. We just need to take note of this so that we don't make mistake there. And once we are able to get this as 1 over 4, we can proceed and get our answer as appropriate. In this question on mensuration of a circle, we're told that a chord subtends an angle of 72 degrees at the center of a circle of radius 24.5 meters. We have to calculate the perimeter of the minor segment. So to effectively tackle this question, we need to understand all of these terminologies that are being used here. What does it mean that a chord is subtending an angle at the center of a circle with radius, and then what is a minor segment? So a pictorial view will really help us if we have this as our circle in question in this particular case, and we have to look at the minor segment. The minor segment is the region that is actually shaded here. Okay, so we have this chord that is subtending an angle of, so this is the chord. If I can call that, let me say I call it chord AB. So running from A to B here, that is the chord of this particular circle. Now, meaning that it's subtending an angle of 72 degrees at the center, we mean that what we are looking at here, this angle, that is 72 degrees. Okay, so we can apply that to say this is nothing but 72 degrees, but I'll just come to that later. Then the circle is of radius 24.5 meters. The radius is from the circumference of the circle to the center of the circle, and since from A to center O of the circle and O to center B of the circle, they are both constituting the radius of the circle, so each one of them is 24.5 meters, and this is also 24.5 meters. Okay, so we need that understanding first and foremost. So we now want to calculate the perimeter of the minor segment. That means it is this length AB on the straight line and this length of arc AB, because the perimeter is going to add all of the sides of that segment. So it will be the addition of this length AB, which is the length of the chord, and to the length of the arc AB, this curve here. That is what we are looking for. So we can say perimeter of the minor segment. Okay, let me just write minor. Perimeter of the minor segment in this case is going to give us nothing but the length of the chord AB plus the length of the arc AB. So what we need to find is twofold. First, this length AB and then the arc AB. And we're told that this angle is 72. Now, for us to look at the length of the chord AB first, we can see that looking at this particular, okay, there are quite a number of ways that we can even say we want to look at. First, we can say we want to divide this triangle into two, in which this will be a right angle triangle, and then we can look at this 72 have been divided into two already, then half of it will be 36. So we know this angle 36. We have this side, which is the hypotenuse, the longest, 24.5, and then we are looking for this. If I can call this, let's say this is x, then this is also going to be x, because this straight line is dividing the length AB, the chord AB, into two equal parts. So I can say that and use calculator to solve that. But is that the only way for which you can actually solve this? That's not the only way. I can also see that you are seeing this triangle, okay, and then as we are looking at the triangle, we have this angle here that we have identified as 72 degrees, and of course we can use either the sine rule or the cosine rule to find the length AB. Okay, now I want to use the cosine rule because I know that in this case, since I have AOB, this will be A, this side is facing A, B, this will be B, this side facing O is AB, so this is O, this O length is AB now. So now maybe you can try the trigonometry part that I just showed. I want to make use of this, and you see that we're going to arrive at the same answer. I can say by the cosine rule, the length AB, in short, the square of AB is going to be A square plus B square minus 2AB cos the angle, which is 72 degrees. Okay, so I can say it is cos theta degree. Okay, and for this theta, it is 72. A is 24, B is 24.5, B is also 24.5. So I can just say, let me appropriately label it, chord AB raised to power 2 is going to be A square 24.5 square plus b square 24.5 square minus 2ab. 2ab is also 24.5 raised to power 2. Okay, cos what? Cos 72. Okay, so I can say I want to input this into the calculator to say I have 24.5 raised to power 2 plus 24.5 raised to power 2 minus 2 multiplied by 24.5 raised to power 2. Okay, cos 72. So what's that going to give me? 829.525. 829.525. So I have it that chord AB in that case is going to be square root of 829.525. 829.525. Okay, so what's that going to give me? So the square root of the answer I just got, this is 28.8. so this is 28.8 meters. Student, please don't use this method. That's why I said we should just walk along. Try and divide this into 2. Okay, then use your trigonometry identity. This will be 36. Okay, and then you can find here x, and that we also amount that this is also x, and the addition of these two, you are going to see that is going to give you 28.8. just try that out and let's have the feedback of how it goes. You can leave it in the comment section so that we can see that truly you are following along. Okay, so now that is the chord AB, but we also have the length of arc AB. So for that length of arc AB, we know that the length of arc AB is theta over 360 multiplied by 2 pi r. Okay, and what is our theta? We know that already. That is 72 over 360 multiplied by 2 multiplied by pi. Pi is 22 over 7 multiplied by our r is 24.5. so we can also find the length of arc AB to say that's going to be, again, our calculator here, we have 72 divided by 360. Okay, multiplied by 2 times 22 over 7. Okay, I could as well just use pi for that, then multiply by 24.5. so what's this? This is 30.8. so this is 30.8 meters, such that, like we're looking at originally, the perimeter of the minor segment is going to be this length of chord AB that we got as 28.8 plus the length of the arc AB that we got as 30.8, and that's going to be 58, that's 59.6 meters. So just try this also, you will discover that you are going to arrive at the same answer. But very key for us is to note that this is the formula that we first need to understand, that the perimeter of this minor segment will need to be the addition of the length of the chord AB to the length of the arc AB, and shaded in blue here is that minor segment as requested. All right. Okay, here's a beautiful question on circle theorems, okay, in which we need to bring in our ingenuity of understanding of circle theorems to solve it effectively as appropriate. So we are told that in this diagram, BCD is a circle with center A, then the angle BCD is given as this, angle BAD is given as this, angle BED is given as this, and ADC is this, just as shown in the diagram. Now, this is how you identify these angles. ADC, for example, we have ADC. So this angle is 40. So that's how you just identify all of them. Our mandate is to find the values of X and Y and to find the angle ABC. So in the first case, for us to look for the value of X and Y, that means that we are looking for two unknowns. And to effectively solve for two unknowns, we need at least two equations. So we need to formulate from our understanding of circle theorems two equations in x and y that will help us to solve this particular first question that we are being asked in this question. So let's look at this diagram. First, I can see that I have this angle 2y plus 10 and this angle 2x plus 40 facing each other, and since already we are being given the values for all those, I can say in the first case 2y plus 10 plus 2x plus 40, the addition of the two is 180 degrees. Why am I saying that? Is because they are opposite angles of cyclic quadrilateral, and in circle theorems we are given that opposite angles of cyclic quadrilateral are supplementary. Supplementary means that they add up to 180 degrees. Once I'm able to state that, I'm good and fine. So I can open up this bracket, just solve it that, okay, I love to write x first, so I have 2x plus 2y. Now 10 plus 40 is 50. If I subtract 50 from both sides, that will be 180 minus 50. Okay, so I can have 2x plus 2y is equal to 180 minus 50 is 130. Okay, so to bring it to its barest minimum, I can divide all through by 2 to say x plus y. I'm dividing each of the terms by 2, will be 130 over 2 is 65. So I have this as equation 1. Recall, I was saying that for us to effectively solve this, we need two equations. So we have one already. What else can we see? What else can we say? We are saying that for this angle BAD and this angle BED, actually there's a relationship between them, because BAD is the angle at the center of the circle, while BED is the angle at the circumference of the circle. And in that particular case, we can say angle BED is half of angle BAD, or we can say angle BAD is 2 times angle BED. So I want to say angle BAD, which is 5x minus 35, okay, that is equal to 2 multiplied by 2y plus 10. And why am I saying that? Is because angle subtended at center of circle is twice angle subtended at the circumference. Okay, so I'm just using shorthand here. I trust that you understand the statement that I'm making. So I'm postulating this, that 5x minus 35 is 2 times 2y plus 10, because angle subtended at the center of the circle is equal to 2 times angle subtended at the circumference of the circle by a chord. So BD in this case will be the chord. Okay, so you can say by a segment. BD will actually still refer to that segment that we're talking about. So yeah, that means we have let's open up the bracket also. 5x minus 35 is equal to 2 times 2y is 4y, 2 times 10, that is 20. So if you collect like terms, we have 5x minus 4y is equal to 20. When minus 35 is added to both sides, it will take care of this minus 35. On the right hand side, it will be 20 plus 35, so this will be 55. So again, I can say I have this as equation 2. Now these are not the only means to go about it, and students, that is where you really need to grill in, work, so that you can see how best to solve this type of questions. But for me, I think these are sufficient. You can look for the other methods. You may not necessarily use this, because there are even quite a number of other ways. Let me also leave that to your intuition for you to discover, so that you can build your muscle of proficiency on your path to excellence. So I have these two equations now, and I can choose to solve them simultaneously. Solving them simultaneously will help me to effectively find the solution to x and y as we are being told. In the first case, x plus y is 65. In the second case, 5x minus 4y is 55. So we are going to be working with that now. Okay, so these are the equations I want to solve, and you can choose to use whatever method you are finding comfortable. I will just want to use elimination. So I can say equation 1, if I multiply equation 1 multiplied by, let's say, 4, okay, then in that case I'm going to have 4x plus 4y is going to be 65 times 4 will be 130 times 2, that will be 260. Okay, so I can take this as equation 3. So after having done that, I can say I'm looking at this, that I'm having equation 2 and equation 3. I can see that this is minus 4y, this is 4y. If I'm to add equation 2 and 3, equation 2 plus equation 3, then I will have 5x plus 4x, that will be 9x, minus 4y plus 4y will just be that they are knocking themselves out. This and this will just knock out, so I don't need them again. Then is equal to 55 plus 260, that will be 315. Okay, such that x itself will be 315 over 9. So what's 315 over 9? 315 divided by 9, so that's 35. X is 35 degrees. Now students, you may choose not to use this elimination method. You can use substitution method to say x is equal to 65 minus y, and use that in this particular equation. You will discover that you are going to arrive at the same answer. Okay, but for me this is quite good. Now having gotten x, I can say from equation 1, x plus y is 65, y will be 65 minus x. So I can say y is nothing but 65 minus the value of x, 35, and that is going to give me 30 degrees. So looking for the values of x and y, I can say therefore the solution is that x is 35 degrees and then y is 30 degrees, and that effectively solved this question for me as requested. Okay, so now for the second part of the question, we're asked to find angle ABC. Now to get angle ABC, we are already using x and y as a variable. Let me say I'm calling this M. Okay, let's identify that angle. It is ABC. This angle here, that's what we are looking for. So I can say, let me just shade it for the sake of identification, and then in shading it, I can label it that I'm tagging it as M already. Okay, so that's angle M for me. Now I'm looking at this quadrilateral ABCD, and I know that the sum of angles of quadrilateral is 360 degrees, just like a rectangle or a square, which is constituted of 4 right angles. In short, if you recollect n minus 2 multiplied by 180, for this quadrilateral, a polygon with 4 sides, it is 4 minus 2, which is 2 times 180, and that is 360. So I know that the sum of angles of this quadrilateral is 360 degrees, meaning that if I'm to add this angle at A to the one at B to the one at C to the one at D, all of them should be 360. So in that case, I can say sum of angles of quadrilateral is actually nothing but 360 degrees. Therefore, okay, let me even say quadrilateral ABCD, particularly here, is going to be 360 degrees. That means I can say that 5x minus 35, okay, that's the angle at A, plus the angle at B, which is M, plus the angle at C, 2x plus 40, plus the angle at D, 40 degrees. The addition of everything is going to be 360 degrees. But if you collect from our initial solution, we have gotten the value of x and y, that x is nothing but 35, while y was gotten as 30. But y is not even reflecting here at all. We only have x, so we can just say 5 multiplied by 35 minus 35 plus, now our unknown is m, okay, plus 2 multiplied by 35, okay, plus 40, then again plus this other 40. Everything is going to give us 360 degrees. So we can just bring in our calculator to try and solve this now. So we can have 5 times 35, that's 175 minus 35, that's minus this 35, that is 140, plus 2 times 35 is 70, plus 70, then this 40 and 40 is 80, plus 80, that's equal to 290. So I have m plus 290 is equal to 360 degrees. So if I'm to subtract 290 from both sides, m will be 360 minus 290, and that's going to give me 70 degrees. Okay, so angle ABC, which we are asked to find now, which I've denoted as m, is nothing but 70 degrees. So students, this is as good as it gets. We just use our understanding of the circle theorems, we applied them in this particular question, and eventually we got all of the questions that were being asked, that x is 35, y is 30, and the angle ABC is nothing but 70 degrees. In this question on trigonometry and surd, we are given that m is tan 30, n is tan 45, and we are to simplify without using the calculator m minus n over mn, leaving the answer in this particular form, p plus root q. So for us to be able to solve this question, you need to have a very good grasp of your trigonometry ratio. And for Dave Academy, we have a particular video that we have taken time, just about 2 minutes or 3 minutes, to demystify how you can get this on the fly, that you don't even need to cram it at all. It's quite easy. You can do it to check that video so that you get to know how to arrive at all these trigonometry ratio of common angles. Now, so if we are to employ our understanding of what we have here, we are going to see that m is nothing but tan 30. In this particular case, tan 30 is 1 over root 3, okay, and then n, which is tan 45, is nothing but 1. So n is 1, such that what we are asked to get, m minus n over mn, this will inherently mean m is 1 over root 3 minus n, which is 1, divided by mn will be 1 over root 3 multiplied by n, which is 1. So this is what we need to work with. And here in this particular case, we can say for the numerator we want to find the LCM. So we have root 3 as the LCM. This will be 1. Then 1 over 1, when we want to bring in root 3, we mean that we're having it as minus root 3, so that root 3 over root 3 is 1. Okay, then the whole denominator will be 1 over root 3 times 1, which is 1 over root 3. So here we can say we want to break this down as 1 minus root 3 divided by root 3. Okay, now this division will be divided by 1 over root 3. But we know if we want to solve this, we need to reverse and turn this to multiplication. So I can just say that means what I'm having is multiplied by root 3 over 1, and this is as good as it gets. You can see that root 3 will cut out, such that this is going to be nothing but 1 minus root 3. So the solution to this, to evaluate m minus n over mn, is quite simple, but we just need to have that knowledge of what tan 30 is and what tan 45 is without using the calculator. So just check out the video on that trigonometry issue and you'll be good and fine, and subsequently you'll be able to solve this question on the fly. This question is combining set theory, Venn diagram with probability, and we'll do it to pay attention to what they're asking us here. We're told that there are 20 women in a bus and 15 of them wear glasses and 10 wear wristwatches. So if a woman is choosing at random from the bus, we have to find the probability that she wears both glasses and wristwatch. Already, if we are not talking about probability, you will know that this is a question, a very typical question that is being featured from set theory. And for us to actually solve it, we will be making use of the Venn diagram. So let's have a look at what the Venn diagram is going to look like. So we have this particular diagram in which already we have been told that the total number of women is 20. Some are wearing glasses, some are wearing wristwatches. Now we are told that 15 of them wear glasses, so here is just 15, okay, and then 10 of them wear wristwatches, so 10 are wearing wristwatches. But there is a set of women that are wearing glasses and also wearing wristwatches, so we can call that X. Since the whole of those that are wearing glasses is 15, and now X is being taken out of it, then glasses only will be 15 minus X, And the same thing for wristwatches. Wristwatches only will be 10 minus x. So the combination of all this is going to give us 20. We are doing this because for us to get the probability of those wearing both glasses and wristwatch, that will be this particular region common to both of them. This is the region for those wearing both glasses and wristwatch, and then we will say that number, we can divide it with the total number of women, which is 20, for us to get that probability. So we need to get those who are wearing both glasses and wristwatches. So from here, if we want to just solve for x, we can add all of these entries and equate them to the total number of women, which is 20. So in that case, we have 15 minus x plus x plus 10 minus x. Everything is going to give us 20. And this is coming from the general set equation that for cases like this, we have the number of glasses plus the number of wristwatches minus the number of glasses intersect wristwatches is equal to the number of glasses union wristwatches. Okay, so it's deriving exactly from here, and you see that this will eventually land into that, because if we want to simplify this, we can say this minus x and this plus x, they are going to take care of themselves, so that what we have is just 15 plus 10 minus x is equal to 20. So you can see directly number of glasses is 15, number of wristwatches is 10, minus the intersection of the two, which is x, is equal to 20. So we can try and solve this. 15 plus 10 is 25. So we have 25 minus x is equal to 20, such that if we change the position in x to be 25 minus 20, and that is equal to 5. Okay, so that is the number of those wearing both glasses and wristwatches. So you can say number of those wearing both glasses and wristwatches is equal to 5. Then already we have the number, the total number of women is 20. In this particular case, the probability for those wearing glasses and wristwatches is equal to the number of those wearing glasses and wristwatches over the total number that we have in this particular case, and that will be 5 over 20. And if you want to just cut, you can say 5 can go here, 1, 5 in 24. So the probability for women wearing glasses and wristwatches in this particular question is nothing but 1 over 4. It is our understanding of set theory that really helped us to interpret this and find the probability as we are requested to find. Now this question is going to be quite interesting, because students, this is not just going to be testing your understanding of being able to work on graph. You need to really understand how graphs are being plotted and the features that are going to be seen on the graph. So let's look at this question together. So we're told that this particular graph is showing the relation of the form y is mx squared plus nx plus r, where mn and r, they are constant. Now using the graph, first we have to state the scale used on both axes. So let's start with that. The scale for this particular graph, look at this graph critically. You can see that from, let me take here. Okay, let me just take here. From here to here, these are the tick boxes that are featured here on the graph, and those tick boxes is just 2 centimeters. So that is for the x-axis. For the y-axis, we will have it like, okay, I can use here. That is for the y-axis, and that is the 2 centimeters for the y-axis. Now what they're asking us when they're saying that what is the scale is that what is 2 centimeters representing on the x-axis and what is 2 centimeters representing on the y-axis. If you look at this, for x-axis here on the horizontal, we can see that 2 centimeters is taking values from 0 to 2. So 2 centimeters is representing 2 units on the x-axis. We can say 2 centimeters represents 2 units on the x-axis, and this is how to just write it out. Okay, and then on the y-axis, you can see that the values from the set of 2 tick boxes is 0 to 10. Okay, is that you can measure in the positive direction is 0 to 10, or you can even take the scale downwards, it is consistent, so it is the same thing. So you can say on the same case 2 centimeters also represents 10 units now on the y axis. So if you are able to state that, you are good and fine, and for the very first question your marks will be good and fine. Now I will clear my board to look at this second question, finding the values of m, n, and r. Okay, so now in this second part of the equation, this is where it gets interesting. We have to find the values of m, n, and r. But if you look at this particular curve, we see that the curve is cutting the x-axis at -2 and 4, and that is where we regard as the roots of the equation, so that we can say x is equal to -2, or we can say x is equal to 4. So these two, we can work on them to reverse engineer in such a way that we can get our quadratic equation as appropriate. So in the first case, we can add 2 to both sides, so that we have x plus 2 is going to be -2 plus 2, which is 0. Or we can subtract 4 from both sides, so that on the right hand side we have 4 minus 4, and that will be 0. Now these two we can combine together to say we have x plus 2 multiplying x minus 4, and that product will be 0, such that if we open the bracket, we have s squared, then x multiplied by -4 is -4x, 2 multiplied by x is 2x, 2 multiplied by -4 is -8, that is 0. And if we simplify, we have x squared minus 2x minus 8 is equal to 0. Now the question is that, can this be the equation that we are looking for? That is not the equation. This is because student, this is where you really need to understand your quadratic graph, particularly if it's going to be a maximum, as in this case, or conversely if it's going to be a minimum. Here, this is a maximum. You can see that it's having a maximum value at here, and that is at 9. That is the maximum value. Okay, so in that particular case, the rule of thumb is that the coefficient of s squared must be negative. Okay, so the coefficient of s squared should be negative, because this is a curve that has a maximum value. Okay, since it has a maximum value, in that case you can say we multiply all through with -1. Therefore our equation will be -1 multiplying all of this. -1 times s squared will be minus s squared, -1 times -2x will be plus 2x, -1 times -8 will be plus 8, is equal to 0. So this is what we need to compare with the equation that we have, ms squared plus nx plus r is equal to y. Okay, if we are doing that, we can see that readily m will be -1, okay, and n will be 2, and finally r will be 8. So these are the things that we need to take note of for us to be able to solve this question as appropriate. And I think you should do this as an exercise. For the second derivative, whenever it is greater than or equal to 0, what we are going to have is a minimum curve. Okay, whereas if the second derivative, if it is less than 0, this is a maximum curve. So students, take this particular equation that we just arrived at. Okay, take that equation, find the second derivative, put in the value of x, put in the value of y, and see what you are going to get. But here I'm just going to confirm with you with the scientific calculator, so that it will demystify whatever doubt you have on your mind. So let me check with the scientific calculator. The equation we have is this, and we'll see how that goes now. So if I have to bring in our calculator, let me just use the equation mode, which is in 5 under mode, and then we're looking at a quadratic that is of degree 2, that's corresponding to 3. Now we want to look at the coefficient of s squared, the coefficient of x, and the constant c. So we are first going to use this equation, this one here, which I'm saying that cannot be the equation in this particular case. So the coefficient of s squared is 1. Then for b, that is minus 2, which is coefficient of x, and then for c, that is minus 8. So you can say this calculator, try and solve this for us. Okay, very good. It's telling us that one of our root is 4, which is consistent with what we have, and the other one is minus 2. Okay, but let's move further. Now it's saying that look at this, the minimum value for this particular curve is occurring at the point where x is 1. Now it's already telling us it's a minimum value, and you can see here 1 is between 0 and 2, which is going here, but what we're having here is what? A maximum value. But interestingly, let's just check on if that is the point where we're having the minimum value. What is that minimum value? Look at this. It's saying that that minimum value for y is minus 9. So that means this is the point that is regarding as the minimum value, and in that case the curve will be coming something like this. Okay, so that being said, let's now look at the equation that eventually I'm postulating that this is going to be the solution to this question here, this particular equation. So we go into our calculator to say, okay, now we just want to change the values of those input that we have initially. Instead of 1 as coefficient of s squared, we now have minus 1, and then instead of minus 2, we have 2 as coefficient of x, and instead of minus 8 as c, we have 8 as c. And then let's see, interestingly, yes, our first root is 4, good. Our second root is minus 2, and that is how it's going to be. But look at this. Now it's telling us that the maximum value is occurring at the point where x is 1, and here it is here that x is 1. But what is that maximum value? Interesting and good. It's saying that that maximum value is 9, which is what our graph is depicting here. So students, you just need to know this so that you can get to the root of the question. If you stop here and you say that your m is 1, your n is minus 2, and your r is minus 8, you are not going to get that as a solution to this question. So that is the technicality here, and I'm sure that so many people are going to miss it. But now you know, so that if you are facing this kind of question in the exam, you'll be good and fine, you'll get your work done and dusted, and then you'll be on the path to excellence. So let's move on to our next question after this. Okay, so in moving ahead to solve for question C, we have to find the gradient of the line through P and Q. Let's look at P and let's look at Q. Q is quite easy because it's sitting exactly in the middle between 2 and 4 and between 10 and 0. So you can see that this is Q, and that will be 3 directly between 2 and 4, and then on the y-axis it is directly between 0 and 10, and then that is nothing but 5. Okay, that's interesting. But now when it comes to P, now let's be careful here, because we can see that yes, on the x-axis P is directly on minus 5, but look at the y-axis, it's between minus 20 and minus 30, but this is minus 25. How many boxes are we seeing that are going down to P? After this 5, we still have 1 and we have 2. Okay, so that is minus 27. So you also need to know how to read off your graph in order to get this question particularly. I can read that P is nothing but the value for x is minus 5, the value for y is minus 27, and then Q, the value is on the x it is 3, and on the y it is 5. So it is the gradient for the line through these 2 points that we are actually looking for, and we can say that the gradient in that particular case, the gradient of the line PQ, is generally given as the difference in the y-axis over the difference in the x-axis. Now you can take anyone as your 2, you can take anyone as your 1, you just need to be consistent. Okay, so for me, I want to take Q as 2 because we are actually even moving from P to Q, from the negative to the positive axis. So I can say in this particular case, the gradient of the line joining point P and Q is going to be y2 will be 5 minus y1 is minus 27. Please don't forget your negative sign. Okay, x2 is 3 minus x1 is minus 5. So again, we didn't forget that negative sign, it is minus 5. So 5 minus 27 will become 5 plus 27, that will be 32. Or let me just write it out straight first. So this will be 5 plus 27, and then in the denominator it will be 3 plus 5, such that that gradient of the line joining point P and Q will be 5 plus 27, that is 32. 3 plus 5, that is 8. So 32 over 8 is nothing but 4. So the gradient of the line joining P and Q, or we can say the gradient of the line through P and Q, is nothing but 4. Okay, then we can move on to the final question. Here in this particular question, we are asked to state the range of values of x for which y is greater than 0. So where is the region in which y is greater than 0? If we are to look at that, the range of values for which y is greater than 0, this is y and this is 0. This is 0 for y. Okay, so it is this particular place that I'm shading in green. Those are the points where we have y to be greater than 0. Okay, in the other case, you can see y is actually less than 0. So we are being asked to find the range of values of x that is starting here and ending here. But there is actually a way that we need to state this particular request that they are asking us. Okay, it is for which y is greater than 0. I didn't mean that they say y is greater than or equal to 0. Then we could have said it is starting from -2, and then it will be -2 less than or equal to x, which is less than or equal to 4. But that's not what we are being asked. We are just being asked for which y is greater than 0. So that range we need to put in the appropriate format to say the range is nothing but, this is how you actually write it, that you define it as x in such a way that -2 is less than x and it is less than 4. So once you can place it in this particular case, your full mark is assured and you are good to go and find as appropriate. In this question on commercial mathematics, we are told that a man purchased 180 copies of a book at 250 naira each. Now he sold y copies at 300 naira each and the rest at a discount of 5 kobo in the naira of the cost price. So students, we need to be able to understand what is meant by 5 kobo in the naira of the cost price for us to be able to effectively solve this question. Okay, now if you made a profit of 7,125 naira, we have to get the value of y. Good and quite interesting a question. Now let's break down what we are being told. Initially, we are told that he purchased 180 copies at 250 naira. So if you want to get the total cost price for the man, we are going to say it is the number of books, which is 180, multiplied by the price of each one, which is 250. Okay, and if we do that, and we are going to use our calculator for that, we can say 180 multiplied by 250, so that is 45,000. So this is nothing but 45,000. So that is the total cost price for the man. Okay, now before we look at the matter of his selling price, since we are talking about profit here, okay, before we look at the matter of his selling price, let's try and get this discount of 5 kobo to discount of 5 kobo in the naira. Okay, what is our understanding of this? Ideally, we know that 100 kobo is equivalent to 1 naira. Okay, so if we are talking about discount of 5 kobo, that means we are reducing that 100 kobo by 5 kobo. So we have 100 minus 5 kobo, and that 100 minus 5 kobo is nothing but 95 kobo. Okay, so 95 kobo to the naira will means that to 100 kobo, which is the naira. Okay, so this is discount in the naira, but then we are talking or this discount of the cost price. And what is the cost price? 250. So the discount of the man will be this particular 95 kobo to the naira multiplied by 250 naira. We need to just understand this for us to get this question, otherwise we are going to miss it. Okay, now let's look at his selling price. Now since we have gotten his cost price, we can now look at the selling price to say that he sold y copies at 300 naira each. Then the price for that will be 300 multiplied by the number of copies, which is y. So we can say that is 300y. Okay, but that's not all. y out of 180 will means that there is 180 minus y remaining. Consider what we are being told. The total number of books is 180. Okay, now he had sold y at 300 naira, so the remaining will be 180 minus y. But how much is he selling them? He's selling them at this particular price. Okay, that is the price that is selling the remaining. So we can say it is 95 over 100, a discount of 5 kobo to the naira, multiplied by that 250 naira, which is the price that he used to purchase it, his cost price. Okay, so this is what we now need to just open up, break down to say our cost price is going to be nothing but 300y plus, now let's evaluate this. I can say this is 180 minus y multiplied by the answer here, that is 95 divided by 100 multiplied by 250. Okay, so this is 475 over 237.5. so this is 237.5. so we can say we want to open our bracket. This will be 300y. now we have 180 multiplied by 237.5 and minus y multiplied by 237.5. I want to do the y first, so I have minus 237.5y, this minus y multiplied by this, then plus 180 multiplied by this. Okay, so let me use my calculator. This my answer multiplied by 180, so that's 42,750 plus 42,750. We can still break this further down. Okay, we can say this is going to be nothing but 300 minus 237.5, 300 minus 237.5, that's what this is, 62.5. so we can say that the selling price is nothing but 62.5y plus 42,750. so students, we got this to be our selling price, we have this as our cost price. What is our profit? We know that profit, when we are talking about commercial mathematics, is nothing but the selling price minus the cost price. Had it been that we are talking about loss, we would have been talking about cost price minus selling price. But since he made profit, that means the rate at which he sold the goods, his selling price, is greater than his cost price. So looking at what we have, the profit we are giving us 7,125 is equal to the selling price we got as 62.5y plus 42,750. that is the selling price. Okay, let me put it in bracket. Okay, minus the cost price we got as 45,000. Okay, so we can say we just want to simplify this, and we have 62.5y standing alone, then 42,750 and 45,000. we can evaluate that. Let me bring in a calculator. So we can say 42,750 minus 45,000, that's minus 2250 minus 2250, such that if we rearrange, I can have 62.5y is going to give me 7125 plus 2250. Okay, so 62.5y is going to be, let's sum this, 7125 plus 2250, 9375, so that to get y, I can divide both sides by 62.5. so this also by 2.5, and if I'm to do that, this we have y only remaining, and then the answer we just got divided by 62.5, that's going to give 150. So y is 150. The number of books that is sold at 300 naira was given as y, so that number of books is nothing but 150, and this is as good as it gets. But yeah, just understanding our concept of this discount of 5 kobo on the naira is the key factor here. If we cannot understand that and evaluate it appropriately, we are going to miss this question. But once you follow this step, you are good and fine, and your full mark is assured. In this question on commercial mathematics, we are told that a trader bought X bags of rice at a cost C is 24X plus 103 and sold them at a price S is 33X minus S squared over 20. We have to find the expression for the profit, and if 20 bags of rice were sold, we have to calculate the percentage profit. In the first case, we are given the cost price C and the selling price X. We have to find the expression for the profit. We need to know that profit is actually selling price, which here we are given as S, minus cost price, which here we are given as C. So for us to evaluate it, let's just substitute. The selling price is 33X minus S squared over 20. That is the selling price minus the cost price, we are given as 24X plus 103. If we can express this linearly, we'll be good and fine, and then we'll find that profit as appropriate. So this will be for the X. We are seeing that this is 33X, this minus 24X. So 33X minus 24X minus S squared over 20. Then what is remaining? We have this minus 103 minus 103. 33X minus 24X, I think that is 9. So we can say P that we have to find is 9X minus S squared over 20 minus 103. So that is the solution in the first case. In the second case, we are asked that if 20 bags of rice was sold, so what is that translating into? We are already told that it's the number of bags that we regard as X. So here we are saying X is nothing but 20. Therefore, we can look at first the profit. That's going to be 9 multiplied by 20 minus 20 raised to the power 2 over 20 minus 103. Now 9 multiplied by 20 is 180. So here we can cut, it will remain only 20. So we have 180 minus 20 minus 103. That's 180 minus 123. And I think that will be 57. So the profit for this one is 57. So once we have P as 57, which is the profit, we can talk about the percentage profit, which is going to be the selling price minus the cost price, and already we identify that as profit. So we don't need to say selling price minus cost price again. We can just say that is nothing but the profit, okay, divided by the cost price C multiplied by 100%. Now for us to solve this, we can just recall that C was given as 24X plus 1 over 3. So we can say, but our C is going to be 24X will be 24 times 20 minus, okay, not minus, plus 103. 24 times 20, that is 480, plus 103, that is nothing but 583. Okay, so if that is the case, then we can say that conclusively our percentage profit will be the profit, which is 57, over the cost price, which we just evaluated to be 553 multiplied by 100%. Okay, that is going to give us, let's use our calculator now. 57 divided by 583 times 100. Okay, this is 9.77. So we can approximate it to be 9.78. So that is 9.78 percentage as the percentage profit if 20 bags of rice were sold. All right. In this question on statistics, which is featuring the pie chart, we are being told that the table shows the monthly expenditure, but it is in percentage of Mr. Okafor's salary. So we have all of this listed. First, we are to calculate the percentage of Mr. Okafor's salary that was put into savings. Now, ideally, if you are looking at this question A, we know that when we are talking about percentage, we should sum up to 100. So 100 is the grandiose scale for which we are considering when we are talking about percentages. Okay, and now since we have all of this, but we have this as unknown X, if we add everything, they should sum up to 100. So we can say in this case 35. Therefore we have 35 plus 7.5 plus 10 plus 15 plus 17.5 plus X, which is amount which is amounting to the part of Mr. Okafor's salary that went into savings. Okay, everything is going to be 100. So we can just use our calculator to add all of this. Okay, so we have 35 plus 7.5 plus 10 and 15 is 25. 25 plus 17.5, that's equal to 85. So we have all of this as 85 plus x is 100. Therefore x is going to be 100 minus 85, and that is nothing but 15%. So we can say that the percentage put into savings, which is s, that is x, is nothing but 15%. And with that, we've gotten this question. We need to move on to the next one, which is to illustrate the information on a pie chart. So here we have the table that will help us to convert these percentages into degrees, because if we are working in degrees, instead of using a linear scale of 100 when it comes to the percentage, for the pie chart we are working with degrees, and we know that the sum of angles at a point is going to be 360 degrees. So we are going to scale each of the percentages into the degree equivalent of its value, and then that's what we are going to use to locate the region and plot the region where it's going to take on this particular pie chart. The amount for savings, the percentage for savings, we just got to be 15. So we can calculate this. And how do we go about that? Since this is in percentage, but we want to scale it to 360, what we do is that we prorate it 35 over 100 and multiply by 360 degrees. The same thing we do to the other ones. 7.5 over 100 times 360, then 10 over 100 times 360. This is quite straight. 10 here 1, 10 in 10 is 10, 10 in 100 is 10, then 360 over 10, this will be 36 degrees. Okay, for the rent we are going to have 10 over 100 multiplied by 360, and we don't even need calculator because we know that these zeros will cut and it will be equivalent to 36 degrees. We also have 15 over 100 multiplied by 360, then 17.5 over 100 multiplied by 360, and finally we have 15 over 100 multiplied by 360. So it is each of these that we need to put into our calculators, which I'm going to do now. That I want to look at. Okay, for me, since I'm using this, I can say x divided by 100, then I want to be multiplying it by 360 just to put it. Then I'll ask it to calculate. Initially, when x is 35, what's that going to give me? 126. So this for food and drinks is 126 degrees. Okay, and then for fuel, x is 7.5, that will be 27. So this is 27 degrees. For 15, I can put it directly. If 7.5 is 27 degrees, 15 will be 2 times the value of 7.5, because 15 is 2 times 7.5. So this will be 54 degrees. You can check that to say we want to solve for 15 now. That's 54. Okay, we want to calculate when this is 17.5. So that is 63. So this is 63 degrees. Then 15, we have done that before, that is 54 degrees. But you need to ensure that all of these they will need to sum up to 360 degrees. So we can take our calculator to confirm that. Let me shift this a bit. So we can say we are looking at 126 plus 27 plus 36 plus 54 plus 63 plus 54. What is that? Okay, so this is good. We're on track because the addition of everything should be the angle at a point, which is 360 degrees. So students, these are the values of degrees that we are going to be using to get our partial done. Okay, now you can make use of your protractor to mark up the angles, but as a rule of thumb, I think if you are good enough to estimate where that value is going to be, you can as well just mark it off and get it done as appropriate. At least you can use the understanding of the sum of angles on a line, then the sum of angles at a point, a right angle triangle, to get all of those. And that's what I'm going to be doing. For example, I know that angle on a line is 180 degrees, a right angle is 90. So if I'm to say I want to start like here, I want to commence here. So from here up, that will be 90. But then I have 126 as the portion for food and drink. 126 will be somewhere here because I'm dividing the second quadrant into like 3. So I'm having this as like 126. 27 and 36, that will be like 63. Okay, if I'm adding 63 to 126, that is like 189. So I know 180 is angle on a straight line. If I'm looking for 189, I can just add a bit to that. So this portion is fuel and rent. Rent is much more than fuel, so let me divide. The bigger one will be rent, the smaller one will be fuel. You can use your protractor to just mark it off, but since it is a question embedded in other questions, you can just go ahead and mark it off like that. So here I have 54 in 2 places and I have 63. Now I'm coming at 100 and let's say 190. 190 and 54, that should give me like 240. That is the case. I can just have maybe 50 should be coming somewhere here. That can be 54, and then I have 63, and then this is another 54 again. This 54 and this 54, they should be almost the same. So I can say these are almost the same. Then this is the biggest circle. So I'm just using that as a guide, and I can say here I will label appropriately. This is 126 degrees for food. You need to label correctly, food and drinks. Okay, and then next, this is 27 degrees, and that is for fuel. Then I have 36 degrees, and that is for his rent. Then I have building project. This is 54 degrees, and that is his building project. Once you are just consistent like this, you get your full mark. And then education, this is 63 degrees, and it's good that he's spending so much on his education. And then savings, here and say this is also 54 degrees, and this is his savings. And once I've done this, I'm good and done. My full mark will be awarded for me, and I'll be on the path to excellence. All right. Now in this third question, we are told that if his annual gross salary is $28,800 and he pays a tax of 12%, we have to calculate his monthly tax and the amount saved each month. Now when we are talking about his gross salary, that is amounting to 1 year, and that 1 year of course is 12 months, because 12 months make 1 year. So if you are now talking about 12% of his gross, that will be 12% of gross, which will be 12 over 100 multiplied by this value that we have here, $28,800. And if you use our calculator, 12 divided by 100 times 28,800, that's going to give us 3,456. So this is $3,456. Okay, and now if that is for 1 year, okay, because that is the gross. Now if we are to talk about his monthly tax, will need to be 1 over 12 of his gross tax. Okay, and that will be 1 over 12 multiplied by that 12% of this 28,800, which you got to be 3,456. This is the amount is going to be paying per month. So our answer divided by 12, that's going to give us $288. So The amount being deducted from Mr. Okafor's money on a monthly basis for tax is nothing but $288. Now, you want to look at his savings. Okay, already we have seen that the savings X will got to be 50% of his monthly salary. Okay, so that means what we are saying here is nothing but his savings will be 15 over 100 multiplied by what's going to be his monthly salary. If this is his gross salary, that will be 1 over 12 multiplied by this total amount that is being paid, but there is a caveat because he will need to deduct tax from it, and that tax for one full year is nothing but 3,456. I hope this is clear enough for you students. We are saying savings is 15%, which is x that will go to be 15% initially, so that is 15% of his monthly salary. But to get the monthly salary, we need to prorate this is annual gross salary to 1 month, and before we can do that, of course, he's going to pay tax of this amount for 1 full year. So we need to deduct that tax from that gross, which is here, and then divide by 12 so that we can take it to a month. Is the 15% of that amount that is going to give us his monthly savings. So this we can say we want to evaluate from the calculator. Let me place this correctly. I can say 15 over 1,200, 15 divided by 1,200 multiplied by 28,800 minus 3,456. Okay, what's that going to give us if you put it in decimal? 316.8. So this is nothing but $316.8 as the savings that is having every month. All right. Yeah, we have this question on graphical solution to trigonometry function, and we are asked to copy and complete the table of values for y is equal to 3 sin x plus 7 cos x for values of x ranging from 0 to 180 in an incremental value of 20 degrees, just as shown on this table. And we have some values already inputted there, so we can use that as a means to confirm if what we're doing is on the right track. Now, there are two methods that I'm going to show you students on how to solve this. First, we want to use this equation. Then in the other case, we want to generate the table of values directly from the calculator. So on the first count, we have 3 sin x. This is how you get x. Okay, it is alpha close bracket on this type of calculator, then plus 7 cos x, again alpha close bracket. And now you can solve for subsequent values of x by saying you are pressing calc, and then it's asking you the value for x so that you can solve for that. Now initially wants to take 0. I'm okay with that, and you can see it's telling us that when x is 0, the solution to this equation is 7, which is exactly what we have as given in the table here. Then you can do the other ones. When x is 20, then we have 7.6. So I can write 7.6 as the answer here, and this is nothing but 7.6. Okay, now you can do that for subsequent values. Now alternatively, you can say you want to generate a table of values directly from the calculator if you are using a calculator that is enabled for that. In mode 7, you can see is synonymous to table, so I'm pressing 7. It's asking me for the function of x, which I'm concerned about it. That is this equation. So I have 3 sin x plus 7 cos x. Okay, that is the equation. It's asking me if there's any other equation. So we have f of x, again g of x, but there's no other equation here, and we can just move on. Then what is going to be the start value? Here we have 0 as the start value. What's going to be the end value? We have 180 degrees, not 5, so I can put 180 degrees. And then what is the step, the incremental value? We can see that it is 20, like 100 to 120, 120 to 140, and so on. So I can say that is 20 degrees. Then I can ask it to generate the table, and you can see here it's saying that when x is 0, f of x is 7, just like we have as given in the table. When x is 20, f of x is 7.6, which we just got. When x is 40, f of x is 7.29. But if you notice, we are being given our options in 1 decimal place, so we also need to round this up to 1 decimal place, so this will be 7.3. So you can just do that to just go ahead and input all of the values, whichever method you find suitable. So then just go ahead with that. I'm just going to fill in this table right about now. Okay, so if you are consistent with the way to do that, you get this table of values, and notice that we have computed everything to 1 decimal place in consistency with the values that were given: 7.0, 4.2, and minus 0.9. We are given a scale as 2 centimeters to represent 20 degrees on the x-axis and 2 centimeters to represent 2 units on the y-axis. Now we have to find the value of y when x is 150 degrees. Then we have to get the range of values of x for which y is greater than 0. So that is all the question there is to it. Quite straightforward. And we'll do well to try and see how to centralize our graph in this particular case. We are saying that y is taking its range of values from 7 to minus 7. So that is quite symmetrical. We can just confirm from that that the x-axis should be at the middle, because there is a total number of division 7 on the positive and minus 7 on the negative for y. Okay, that is good. Then how do we place x? We can see that x is starting its value from 0 and ending at 180 degrees. So we don't need any negative values of x. We can just start that here, so that if this is 0, we are taking incremental values of 20. We have 20, 40, 60, 80, 100, 120, 140, 160, 10. I think this is good. So this place can be the center of our graph, and that's what we're going to be doing just right about now. Okay, so in keeping with consistency with what we just explained, this is how our axes are going to look like, in which on the y-axis we have 2 centimeters, which is the difference between each of the tick boxes from 0 here to here. That's 2 centimeters. On the y-axis, it is taking 2 units, so we have 2 units as incremental value. And on the x-axis, 2 centimeters from here to here is taking 20 degrees, so we have 20, 40, 60, and that is as good as it gets. What is left for us to do now is just to extrapolate those values. When x is 0, y is 7, so we have x here is 0, y is 7. 7 will be directly between 6 and 8, so here that is the point of interest. Okay, when x is 20 degrees, y is 7.6, so 20, in short, all the values of x are directly on the thick lines. We only need to be concerned about the values of y. So x is 20, y is 7.6. How do we get 7.6? We know that from 6 to 8 here, these 2 centimeters are representing 10 boxes, and those 10 boxes take values from 6 to 2, that is 2. That means each small box is going to take 0.2, so that we have 6, 6.2, 6.4, 6.6, 6.8, 7. Then moving on like that, we have 7.2, 7.4, 7.6. So that is where we are going to consider, and in that particular case, we just take that value of 7.6 and try and trace to the point where we will meet the 20 coming from the x-axis, and then we'll be concerned about this point of intersection. This is what we are going to be doing for every other one. I just took time to explain this, so students, you can just practice this so that you can replicate as appropriate. That's 7.6 and 20. Okay, so if you do that correctly, those are the points that you have, and you can go ahead to say you want to get the best fit joining all of these points together. So if you extrapolate the point quite correctly and you use your French curve or your broomstick to join all the points, you are going to get something like this as a line of best fit. So with that, we've been able to answer that question, and maybe it will be good for you to just label this graph of the equation y is equal to 3 sine x plus 7 cos x. Okay, so sometimes people tend to just write their scale also on this. That is a very good practice. So in our next question, we have to get the value of y when x is 150 degrees. So if we look at the graph, this is the x. 150 is between 140 and 160, so we are looking at this location. Okay, that location is a point of interest for us, and if we are to trace to the curve, we'll have something like this. So at the point of meeting the curve, we can trace to the y-axis, and looking at that, this is our point of interest here. And if you are looking critically, this will be -4, -4.2, -4.4, and then -4.6. So the value of y when x is 150 degrees from the graph is nothing but y is equal to -4.6. Now you can use your calculator to also try and evaluate that. Okay, you can say, and let's go back to our normal computer mode. What we are using initially is we are saying that 3 sine x, okay, you can just use this as a means of confirming, plus 7 cos x. So you want to calculate what's the value of x. We are looking at 150 degrees, and we try and solve that. This is the answer, but in decimal place. Okay, this is -4.5621, which is approximately -4.6. So we are quite on track with this particular solution. All right, so now finally we want to get the range of values of x for which y is greater than 0. That means we are looking at regions here. Okay, you can see those are the positive values of y. So within this boundary, that's what we are interested in looking at, and we can see that it is from x being 0 to this point, nose diving into the negative value range. And if you are observant, we can see that this is here, that is 0 less than or equal to x. And what is this particular value here? This is 100, this is 120. Directly in between them is 110. And then if we have two subunits for each of the small boxes, we have 112, and this is like in between 112 and 114. We can say 113. Okay, so we can say it's like 113, and then this region is what we can look at to say that is the answer. That this is how we write it, student. You said x defined in such a way that 0 degree is less than or equal to x, which is less than or equal to 113 degrees, and defining like this, that region that we identify as 0 less than or equal to x, which is less than or equal to 113 degrees. And with this, our question is done and dusted, and we are good to go on our way to excellence. Here in this question of statistics, we are told that this table is showing the distribution of ages of a number of children in a school, and if the mean distribution is 7, so we have the mean distribution as 7, we should know that we are to find the value of x, this x that is featuring here, and the standard deviation of their ages. In this first case, for us to find the value of x, we can see that we are given the mean distribution, and that mean distribution is an expression of the fact that we are finding the average of the data set, and that will be summation fx over summation f, where x is the data set, and in this case that x will have to be the age of those children, the age of each of the children, and the frequency, the occurrence value, the times that the ages occur will have to be the frequency. So that is what we are going to use in this case. And if we are to make use of that particular video, we have been given that mean distribution is 7. So it's going to be the summation of the product of the frequency and the data set fx. So we can multiply each of this column, which is corresponding to f multiplied by x. So if you want to do that, 3 times 2, that is 6, plus 4 times 6 is 24, plus 5 times 5, that is 25, plus 6 times x, we can leave that as 6x. 7 times 6, that will be 42. 8 times 9 is 72. 9 times 8 is another 72. Then 10 times 5, that is 50. So we are saying all of this, which is summation of fx, we are dividing with the sum of the frequencies, and those frequencies will amount to 2 plus 6 here, okay, plus 5 plus x. We still have as a variable there, plus 6 plus 9 plus 8 and plus 5. So our task is to simplify this such that we can say 7, or we can say 7 over 1, which is also 7, is equal to the sum of all of this, which you can use our calculator to evaluate. Okay, so you can have 6 plus 24 plus 25 plus, let's leave 6x, okay, plus 42 plus 72 in 2 places, and then plus 50. What's that going to give us? This 291. So we have this as 291 plus the 6x that we just left divided by the sum of all of these. 2 plus 6 is 8 plus 5 is 13. We are still leaving that x. 13 plus 6, 19 plus 9, 28 plus 8, 36 and plus 5, that will be 41. Then plus the x that we have left initially. So here we can just say our work can be simplified if we just choose to cross multiply this particular expression, so that we have 7 multiplied by 41 plus x is equal to 291 plus 6x. Okay, so 7 times 41, that will be 281. 7 times 41, that will be 287 plus 7 times x is 7x. This is equal to 291 plus 6x. So if we just collect the like terms, we can see that let's subtract 6x from both sides. We have 7x minus 6x is equal to, because here this 6x minus 6x will be 0. And let's subtract 287 from both sides. 287 leaving here will be just leaving that blank. So we have it to be 291 minus 287. Therefore, holistically, 7x minus 6x is x, and then 291 minus 287, that will be 4. So the value of our solution is going to be 4, and we can check. 291 plus 6x will be 291 plus 6x will be, if x is 4, that will be plus 24. That's 315. Okay, 41 plus x will be, that will be 45. So we can say this 315 divided by 45, what's that going to give us? 7. So we are quite on track to get the value of x as 4. Then we can move on to find the standard deviation of the ages of this student. Okay, so in the second part of this question, for us to get the standard deviation of the ages of these children, normally we can make use of any of these two equations. Now I'm going to be making use of these. Students, you can try your hands on this, but know that your table will be slightly different, because you need to get each of the difference between the entry value and the mean, and then you have to find the square. So you need to find x minus x bar, then the square of x minus x bar, then the product of f and difference between the two raised to power 2. You just need to compute your table appropriately. Okay, but now I'm going to be sticking with this. You can verify to see that eventually we'll arrive at the same answer. We got the value of x, which is featuring as the frequency for the age of 6 to be 4. So this is 4, so that the addition of the frequencies will be, initially we got 41. So we have 41 plus 4, summation f will have to be 45. Okay, so let's look at the other parameters that we need to reflect. These are the values of x. What will be x squared? 3 raised to power 2 will be 9, 4 raised to power 2 16, and we can just fill the other ones just like that. Okay, and so once we have that, we can now find the product of f and the square of this x. So 2 times 9, that will be 18. 6 times 16, let's use our calculator. 6 times 16, 96. So this will be 96. 5 times 25 is 125. 4 times 36 will be 72 times 2, that's 144. Then 100 times 5, that will be 500. So that we can look at the sum of all of these to say we want to have 18 plus 96 plus 125 plus 144 plus 294, just summing everything together, plus 576, ensuring there's no mistake, plus 648, and then plus 500. What's that going to give us? 2401. So this is 2401, and we have all the other parameters that we have. Mean we're given as 7. So we can say conclusively our standard deviation following this second formula will be the square root of what the summation fs square, it is 2401, over what is the summation f, that is 45, minus the square of our mean, that's 7, and we can square that. Okay, so let's have our calculator at hand. 2401 divided by 45. So what's that going to give us? 53.35. So this bar means that it's a repeated 5, 3, 5, 5, 5, 5. So we have square root of 53.3556 minus 7 raised to the power 2 is 49. So we can say the answer that we just got minus 49, that's 4.3335. So we can just put in our answer and say, okay, square root of this answer now, the square root of the answer we got finally. So this will be 2.0869. I can say 2.087. Okay, so this is, we're not asked to give it in any one, so I can just say this is 2.087 as the standard deviation for this data set that we are giving. Students, try your hands on this and see if you are going to also get the same answer as what we got here. But if you are consistent, definitely our answer will be the same. In this question on polygons, we are told that the exterior angles of a polygon are given as all of this. And now, if x is 7 degrees less than y, we have to find the values of x and y. Let's take this statement and try and interpret that. That means that if we add 7 to x, that is going to give us y. Or you can choose to say that y minus 7 is x. These two actually interpretation of this, and either of them will earn you the correct thing and you'll be on your way to solving it. So that's the very first thing I'm noticing. And then we have the fact that we are talking about the exterior angles of a polygon. And for you to be able to solve this, you need to understand that the sum of the exterior angles of a polygon is going to give us 360 degrees. And if you're understanding this fact, then we know that we have this as a first equation in two variables. And then since x and y are featuring in all of these exterior angles, we can sort them to 360 degrees to give us the second equation, and we'll be able to solve it straight and direct. Meaning that we can have 42 plus 38 plus 57, then plus x plus y, then plus 2x minus 15, and finally plus 3x minus y. Everything is going to give us 360 degrees as a result of the postulate that the sum of the exterior angles of a polygon is 360 degrees. So we can do it to just bring in our calculator to try and evaluate all of this. Okay, so we have 42 plus 38 plus 57, and then okay, we can just subtract 15 straight, minus 15, and that's all. Okay, so we have this as 122. So we can say we have 122. Then if you have to look at the x, we have x plus x, that is 2x, plus 2x, that's 4x, plus 3x, that is 7x. But for the y, we can see that this is plus y, this is minus y. So y is out of this particular equation. We can sum this to 360 degrees such that we can say 7x is equal to 360 minus 122. And that's going to give us what? The answer we just got, or let me just say 360 minus 122. So that's 238. This is 238. Therefore, x is going to be 238 over 7 and divided by 7. This is 34. So the value of x is nothing but 34 degrees. But from equation 1, which we have written initially, we can see that y is equal to x plus 7, and that will be 34 plus 7. 34 plus 7 is nothing but 41 degrees. So we can say from our understanding of the statement that we're giving and the fact that sum of exterior angles of a polygon is 360, we have our x to be 34 degrees while y is gotten as 41 degrees. This is the solution to this question. In this question on circle theorems, we are told that in the diagram, O is the center of the circle x, y, z. So we have x, y, z. This circle, O is the center. An angle ZXO was given as 34 degrees. And angle XOY was given as 146 degrees. Our mandate is to find angle OYZ. So let's try and identify angle OYZ. So this angle here is the angle of interest. So first, I want to say that I want to use alphabet X for that. So I will say let angle OYZ, let it be X, okay? Then from this particular diagram, let's try and use our understanding of circle theorems and circle geometry to see how we can find this angle S. First, we know that this, from the center of the circle to the circumference, that is the radius. This is also the radius. This is also the radius. You can see each one of them is from the center of the circle to a point on the circumference. So I can say that line OZ is also line OX. That's also line OY. And that is radius of the circle. Is the radius of this particular circle we are talking about here. That's one. If that is the case, that means that triangle OZY is actually an isosceles triangle. You can see this is one side of the triangle, this is another side of the triangle, and in that case, that means this particular angle is also going to be X. So I can say furthermore, angle OYZ, which we are looking for, is the same as angle OZY, and that is also X. And why am I saying this? Is because they are base angles of an isosceles triangle. Okay, base angles of isosceles triangle are equal, and they are isosceles because two of the sides are equal. Then the base angles are also going to be equal. Okay, so that being that, the same principle is also applying to this triangle OXZ. There, I can also say that angle ZXO, this angle here, which we are giving as 34, is also equal to angle OZX, and that is also going to be 34 degrees because they are also base angles of an isosceles triangle. This isosceles triangle OXZ. Okay, so if that is the case, I can say this angle here is also 34 degrees. And then interestingly, I think my work is getting almost done because I can see that here, looking at this angle, from the understanding of the fact that the angle subtended by an arc at the circumference at the one at the center, they are related to one another. So I can say angle XOY, this angle 146 that we are giving here, okay, I can say that angle is equal to 2 times angle XZY, this angle that I'm having here. And why am I saying that? Is because the angle subtended at center of a circle is twice the angle subtended at circumference. So I'm just using shorthand here. Just the explanation is what you need, which I have stated already. So therefore, I can say this angle 146 XOY is equal to 2 multiplied by angle XZY. And what is angle XZY? You can see that it's a combination of this 34 and X. So I can say that's equal to 34 plus X. So if I open up this bracket, I'm going to have 2X plus 2 times 34 will be 68 is equal to 146. Therefore, 2x will be 146 minus 68. So in that case, I have 2x to be 146 minus 68. 146 minus 68. That's 78. And then, in that case, I will just divide both sides by 2. X will be 78 over 2, and that will be 39 degrees. So the understanding of circle theorems and the properties of triangles, in this particular case isosceles triangle, had helped us to solve this question holistically. And so then notice, this is not the only way you can go about trying to solve this question, and you can try to lay your hands on such, and you see that eventually we also arrive at the same answer, that x, which is angle OYZ, is nothing but 39 degrees. Here in this question on probability, we are told that the probability that an athlete will not win any of the 3 races is 1/4. So we need to know that we are talking about the probability of him not winning. That means this is the probability of him losing the race. Okay, so we are being told that if the athlete runs in all the races, what is the probability that the athlete in the first case will win only the second race, then the second place, all the 3 races, and in the third case only 2 of the races. This is quite interesting, and we'll just interpret the question on the fly. In the first case, before we even dabble into that, let's look at this interpretation that we're having. Probability of him not winning means that his probability of loss is what we are giving, and we're giving as 1/4. Okay, then we know because of the unitary nature of probability of him winning will have to be 1 minus the probability of him losing. Okay, and that probability of him losing we were given as 1/4. So the probability that is going to win is 3/4. Okay, so we have probability to lose is 1/4, probability to win is 3/4. So we cannot go ahead into our very first question that is going to win only the second race. That means that in the first case is going to lose. In the second case, and because in this particular case we are considering 3 cases, we are going to multiply. In the second case is going to win, and then in the third case is going to lose. So this is the probability that is only to win only the second race, and that is as featured here. That is the only one that is winning. Once you're able to get this, you will be on your way to Xing this question, and that will give us 1/4 multiplied by 3/4, which is the probability of him winning, multiplied by 1/4, the probability of him losing the third race. So if you are to compute this will be 1 times 3 times 1 is 3, 4 times 4 is 16, times 4, that is 64. That is the probability of him winning only the second race. Okay, so interestingly, in the second case, the probability of him winning all the 3 races, it means that he's going to win the first race, then he's also going to win the second race, and then he's going to win the third race. Okay, so in this case we just have 3/4 for the first, 3/4 for the second, and in the third case we're also having 3/4. So 3 times 3 is 9 times 3, that is 27, and then 4 times 4 times 4, we just got that initially to even be 64. Now in the third case, we are considering the case in which the athlete will win only 2 of the races. There are 3 races that we are talking about here, so we need to be careful. We are going to say probably that winning only 2 of the races will be, let's say in the first case he loses the first one, then in that case he's going to win second and then win the third. But this is not the only case, so this is just one of the instances that we can have. So is either this is the case or an or in probability we warrant that we are talking about addition. Okay, and then the combination again now is going to win the first one, okay, but he will lose the second one while he's going to win the third one. So students, this is the critical thing that you need to be careful of here. Okay, and then we have another third instance in which in this particular case it's going to win the first 2 and lose the third one. So we have probability of win multiplied by probability of win, then multiplied by the probability of lose. Okay, so these are the 3 instances that we can consider for him to win only 2 of the races. And interestingly, we have gotten all of those probability. In the first case, we are going to have probability of losing, that will be 1/4 multiplied by 3/4 multiplied by 3/4, okay, plus in the second case winning, that is going to be 3/4, and then losing 1/4, winning again the third one 3/4, and then finally we are going to have winning 3/4, another win 3/4, and now a loss 1/4. So you can see that this is just the replica of the same entity. So you can say this is nothing but 3 multiplied by 1/4 times 3/4 multiplied by 3/4. And looking at this, it's just like saying we have 3 times 1, 3 times 3, 9 times 3, that is 27, and then 4 times 4 times 4, that is 64. So it's the same probability as a case in which he's winning all of the 3 races. So This is the breakdown of what you need, students, and once you're able to get this done, you are good to go and your full marks are assured. Okay. In this question on mensuration, we are told that a cone with perpendicular height 24 centimeters has a volume of 1,200 centimeter cube. We are to find the volume of a cone with the same base radius but an height of 84 centimeters. The value of pi is 22/7, and this is a pictorial view of what we're talking about. And if we want to include the parameters that we are given, it is just as shown that this one with height of 24 centimeters is having a volume of 1,200 centimeter cube, and this one with the height of 84 centimeters is having an unknown volume which you have to find, but they share the same radius. So I think there are basically two means that you can go about trying to solve this. You can actually look at this smaller cone that we have and you can find the radius, then use the radius in this second one to find the volume. But that's not what I'm going to be doing. What we know that the general formula for the volume of a cone is given as 1/3 pi r square h. Okay, and now we're having a particular smaller cone. We have its volume, okay, 1,200 centimeter cube, and then the r is there, but we have its h1 to be 24 centimeters. All right, in the second case we are looking for the volume of the bigger cone. The same radius is what we are looking at here, and we are having the height of the second one to be 84 centimeters. If you bring in your understanding of variation into this particular case, you can see that we have pi to be common to both of them, and we also have the radius. These two, they are common to both of them. So if I'm also to include this 1/3 and I'm going to take that as a constant of proportionality, I can say all of this I regard as k, such that I have the v is equal to kh, and then I can say k, which is the constant, is v over h, and what I'm saying inherently is that v1 over h1 is the same as v2 over h2. So to solve this, you can say we just want to cross multiply such that v2 is going to be v1 h2 over h1. That's what we're going to do. That's what you're going to get if you cross multiply, and we have all of these parameters given already. V1, we have it as 1,200 centimeter cube. Okay, then h2, now you need to be careful, it's h2 not h1. H2 is 84, and then h1 was given as 24 centimeters. So this is what we just need to impute to the calculator, and we'll get the value of v2 to be, let's bring our calculator down. Okay, so we can say we have 1,200 multiplied by 84 but divided by 24. What's that going to give us? 4,200. So the volume of this particular second cone is nothing but 4,200 centimeter cube. So if you take the other route, first you find r, then use r in this particular case. Since the radius of the base, they are the same, you are going to see that you will arrive at the same answer. But I think your understanding of mathematics should prompt you to be able to use this, and you get your full marks just as you will get in the other case. This is a question on mensuration in which we are told that the diameter of a cylinder closed at both ends is 7 centimeters. If the total surface area is 209 centimeters square, we are to find the height of that cylinder. This is the picture that is worth 1,000 words explaining what we are given in the question, and we are giving, what we need to note is that diameter is what we are given, not the radius. But by reason of understanding, we know that radius is actually diameter over 2, and this will be 7 over 2. So the radius for this particular cylinder is nothing but 3.5 centimeters. Okay, now we are given the total surface area as 209, but what is the formula for total surface area of a cylinder? The total surface area of a cylinder, just as in this case, is nothing but 2 pi r multiplied by h plus r. Okay, that value we have been given as 209 centimeters square in this particular case. But what are we looking for? We are looking for the height of the cylinder, and for us to get the height of the cylinder from here, I think we'll do it to make h the formula. You can plug in your values. You know the TSA 209, you know r 3.5, you know pi 22/7, but I love to make h the formula So I can say in this particular case, if I divide through by 2 pi r, I will have h plus r is equal to the total surface area over 2 pi r. Okay, now if I just subtract r from both sides, I can say that means that h that I'm looking for is the total surface area over 2 pi r, then minus r. So this is what I'm going to be using, so that I can say my h is, what's the total surface area? That is 209. Okay, divided by 2 pi r will be 2 pi is 22 over 7. Okay, r I just got as 7 over 2. Okay, then minus that r again, 7 over 2. So this is what I just need to compute, and I can start cutting that. This 7 can cut here, this 2 will cut it. So I have 209 over 22. My h is going to be 209 over 22 minus 7 over 2. Okay, if I want to find the LCM, I can just say I'm having this as 22, and 209 minus 22 over 2 is 11. 11 times 7, that is 77. So I'm going to have, this is 2, 20 minus 7, that will be 13. So 132 over 22 is going to be the height of this cylinder. Now let me use my calculator. Okay, I have 132 divided by 22. What's that going to give me? This is nothing but 6 centimeters. So the height of the cylinder is 6 centimeters, and even if you plug in your values directly, you also arrive at the same answer as this. In this question on angle of elevation and depression, we are told that point x and y, which are 90 meters apart, are on the same side of a tree. Then the angles of elevation of the top T of the tree from x and y on the horizontal ground with the foot of the tree are 43 degrees and 38 degrees respectively. First, we have to illustrate the information, and then we have to find the height of the tree correct to 1 decimal place. This is how that particular tree in question is going to be looking. Okay, so we can say we are looking at the point T, which is at the top of the tree, but then we are looking at the point x and y, which are away from the tree on the same side, but with angle of elevation 43 and 38 degrees respectively. That means x is taking 43, y is taking 38. Now if you are just to look at some random points, so you can look at this, let's say this particular point, that this is our x, and this particular point, let's say this is our y. So in this case, we can say we want to join this from x to t, just as shown, and then from y to t, just as shown. Now students, you don't need to actually show the tree. I'm just using this for the sake of explanation. This is going to be the height of the tree because it's just vertical, and then once we have that, we can join the base together to say we have something like this. Okay, so our diagram is out. We can go away with that diagram. This is what I expected to draw. Maybe I can call this point the base of the tree, so let me call that B, and definitely that's going to make a right angle with the ground. The ground will be taken as horizontal. Okay, giving us horizontal ground. So having this, we can just include our angles as that. Here this angle is 43, so we have 43 degrees, and this angle was given as 38 degrees. Okay, and then we have to find the height h of the tree. The distance between x and y we are told is 19 meters apart, so we have this as 19 meters. I can call the distance between this base of the tree and point x, let me just call that a. Okay, so with this I've answered the very first part of the question, which is to illustrate the information. Then in the second part, for me to find the height of this particular tree, which is h as identified there, that's line BT, I can say I want to make use of circuit tour to understand this question, because from what I'm seeing here is definitely a right angle triangle, and I can use the trick identity circuit tour to solve this. H that I'm looking for is going to be the opposite to angle 43. Interestingly, is also the opposite to angle 38. So I'm having opposite. And what are the other variables that I know? The other parameters, I know this base, which is the adjacent. So I have the opposite, I have the adjacent, I have the opposite, I have the adjacent. I'm seeing two triangles already. So I can say on trig identity from triangle, let me say first from triangle TBX, I can readily see that this is the opposite edge. I have the adjacent. So tangent is what is relating that. I can say tan 43, which is the angle at x for triangle TBX. This angle 43 here is equal to the opposite, which is h, over the adjacent. The adjacent here is a. Okay, so I can just say therefore h itself is a tan 43. Okay, this is something I need to note. Then from the other triangle TBY, from triangle TBY, again is tangent that is relating the opposite to the adjacent, but now we're looking at tan 38 is also equal to the opposite, which is h, over, now the adjacent in this place is the combination of a and 19. You can see from the base of the tree to the point y, so I'm having a plus 19 meters, such that in this second case the height of the tree is a plus 19 tan 38 in this particular case. Interestingly, this is giving me two unknowns and I have two equations. This is equation 1, this is equation 2. So now this means that I have these two simultaneous equations that I can choose to solve by any method of solving simultaneous equation. But for me, I think I will equate them because this is h on the left hand side, this is also h. So I can just equate it together to say, in the first case, I have a tan 43. And then on the right hand side, let me just open up the bracket. It's going to be a tan 38. Okay. Then plus 19 tan 38. 19 tan 38. Okay. So here, I can just choose to collect like terms, a being on one side, the other one being on the other side. Here, if I bring a tan 38 to the other side, a is common to both, so I will have a into tan 43 minus tan 38 is equal to, here I will have 19 tan 38 remaining. So interestingly, I can just say a in this case is nothing but 19 tan 38. Student, if you are confused with what I just did there, you can get your hands dirty and just lay your hand on it. You see that is eventually what you are going to get also. That tan 43 minus tan 38. So this I can choose to input in the calculator to find the value of the distance between the base of the tree and point x. So we want to express, let me use fraction so that I will not get confused. 19 tan 38. Okay, that is the numerator, and the denominator I have tan 43 minus tan 38. Okay, this is where it gets interesting. So let me make sure that I close this bracket so that it's not associating this second one with the first tan 43. So we have tan 43 minus tan 38, 19 tan 38 as the numerator. So what is that? 98.1583, 98.1583 meters. But nobody asks us to find a. Okay, this is just the value for a, the distance between the base of the tree and point x. What we have to find is height h, and that height h, we can use any of these two equations, either the first one or the second one, to solve that. So I'm going to be clearing my board to just get that out as appropriate now, right? So having gotten the value of a, I can now say h is going to be, from the first equation, a tan 43 will become 98.1583 tan 43. Okay, so the height of the tree, as we are asked to obtain, will be the answer we just got, tan 43. Okay, so what's that? 91.534. So add this as 91.534. But look at our question, we're asked to find it correct to one decimal place. So after the decimal, we are taking the first digit, which is 5. 3 will be inconsequential because it's not up to 5, that we could have rounded up to 1 and add to that digit we are considering. So this is approximately 91.5 meters as the height of this tree that we are asked to find originally. And with this, we can say we are good to go. We've been able to solve this question and solve it as requested to get the height of the tree as nothing but 91.5 meters. In this question on sequence and series, we are told that a sequence of numbers is defined by a subscript n plus 1 is 2a subscript n minus 3, where n is greater than or equal to 1. Now, if a1 is 5, we have to find a2, a3, and a4. Now, from here, originally we are giving an plus 1 is 2an minus 3. And then if you are to look at it, we already supplied with the value of a1, the first term, that it is 5. So if you want to use that in this equation, we can get a2 to say, in this case, a2 will be, now that n is 1, we are adding another 1 to it. That is what is giving us a2. So if we have 2an, then n is 1. So we have 2a1 minus 3, okay? And that will give us, a1 is 5, so we have 2 times 5 minus 3. And that is, 2 times 5 is 10. 10 minus 3 is nothing but 7. So that is the very first mandate before us, and we have scaled it successfully. A3 will now be 2a2 again minus 3, and if we are to just continue in that model, a2 will go to be 7, then minus 3. This will be 2 times 7 is 14. 14 minus 3, that will be 11. So yeah, you need to be careful that you don't miss any step, because you are going to use that value in the next operation. So here we can say a4 is now going to be 2a3 minus 3, and that will be 2 times, what is a3? That is 11 minus 3. 2 times 11 is 22. 22 minus 3, that will be 19. Okay, and with that, all we are asked to find, a2 we got as 7, a3 we got as 11, a4 we got as 19. We've done that, and our work is done and dusted. All right. In these beautiful questions on fractions, we are told that the student had an account of P Ghanaian cedis at the beginning of a semester. Now, he spent 1/3 of the amount on books and 3/5 of the remainder on snacks. If 100 Ghanaian cedis was left at the end of the semester, we are to find the value of the original amount of money that he had in Ghanaian cedis. So, this is a very good question. We just take each of the sentence, each of the statements, try to interpret it, and then see how that can help us to solve this question. So originally, what he had was P. The original amount that this student had was P. Okay, now when he spent 1/3 on books, we can say books will be 1/3P. Okay, and then if books is 1/3P, we can say that the remaining after the books will now be P minus 1/3P is P/3. Okay, so this is going to be 2P/3. Okay, because if we say we want to look for the LCM, we can just say we have this like 3, then this is like P/1, so that this will be 3P minus 3 can cut 3, just 1, then this will be minus P. So inherently, what we have is 2P/3 as the remainder after he had deducted the money for the books. And then we are now told that furthermore, he spent 3/5 of the remainder on snacks. So this is that remainder, and we need to look at 3/5 of this remainder to get the amount he spent on snacks. So if that is the case, we can now say that snacks will amount to 3/5 of this remainder, which we got to be 2P/3. Okay, so this is the consistency we need to ensure that we get our question right and dusted. We can see that those 3 will cut out, and then the snacks will be 2P/5. Okay, now we're told that 400 Ghanaian cedis was left at the end of the semester. Okay, so if this is the original amount, he spent this fraction on books and he spent the fraction on snacks, the total remainder, which we are being told is equal to 400 Ghanaian cedis, will be the original P minus first the amount he spent on books, that is P/3, plus the amount he spent on snacks, that is 2P/5. I hope this is clear enough. I hope this is simplified enough, because once we get this, then we know that we are good to go. Yeah, we can say we want to look at this holistically. Let's just say we are finding the LCM. 3 and 5, that will give us 15. So this P will be 15P minus, this is where we need to be careful. This is the amount is spent on books and snacks, so it will still remain in that bracket. 15 divided by 3 is 5. 5 times P, that will be 5P. Then plus, now I'm putting plus because the negative sign is affecting the whole of this bracket, okay? 15 divided by 5 is 3. 3 times 2P will be 6P. Okay, so that means this total remainder, what were we giving us? We are giving it a 400 Ghanaian cedi. So we can say 400 is equal to nothing but, now 5P plus 6P is 11. 15 minus 11, that will give us 4P over 15. So the P that we are looking for, if we cross multiply here, will be 400 multiplied by 15, and then to leave only P, we need to divide it by 4. Okay, so we can just cut, saying that here we can have 4 here, 1, 4 in 400 is 100, such that the value of P that we are looking for, which is the original amount, will be 100 times 15, and 100 times 15 is nothing but 1,500 Ghanaian cedis. So we have 1,500 Ghanaian cedis as the original amount that the student had in his account. Okay. In this question on word problem, we are told that two cars A and B, which are 180 kilometers apart, started the journey at the same time towards each other through the same route. Okay. Now, if the speed of A is x kilometers per hour and that of B is x minus 20 kilometers per hour, that means that A is traveling faster than B. Our mandate is to calculate the distance covered by each car just at where they meet after 90 minutes. Okay, so a picture is worth 1,000 words, and this is a pictorial view of what we are being told is happening in this particular case. That A is moving at x kilometers per hour, so this is x kilometer per hour. Then B is moving at a speed which is x minus 20 kilometer per hour. So we have that as given. So like I said initially, that means that A is traveling faster than B. So if they are meeting, they will meet closer to B. So let's say somewhere around there. So this may inherently be their meeting point. Now we have to talk about the distance. If A, the car A, will cover some distance, let's say this will cover distance A to their meeting point, that means that B will cover 180 minus A kilometers, because we have been told that the distance between them originally is 180 kilometers. So if A will cover A kilometers, okay, if I say this is A kilometers, B will cover 180 minus A kilometers, so that the addition of the two will just be 180 kilometers. So we have to get the distance covered by each car just at where they meet. So A will cover A kilometers, B will cover 180 minus A kilometers. Now we are giving one parameter that the time is 90 minutes. So if I want to work with that, in the unit of the dimensions that we are giving, you can notice that we are giving kilometers per hour. So we need to take 90 minutes and take it to hour. And we know that 90 minutes, which is the time, that time is going to be 1 hour, 30 minutes, or I can say it is 1.5 hours, because 30 minutes is half of an hour. Inherently, I can say this is one whole number, 1 over 2. I can say this is 3 over 2 hours. Okay, so this is good because it can help us to solve this, because we know that normally speed is defined as distance over time. But here we have the time, we have the speed as a variable of unknown, we have the distance as a variable of unknown. So I can say time, which I know, can be distance over speed by changing the subject of formula in this particular case. Okay, so in that case, I've gotten that time to be 3 over 2. I can say for A, the timing for A, which is 3 over 2, is that 3 over 2 is equal to, what is the distance for A? It is A, and what is the speed? That is x. And then for B, I have that same 3 over 2 is equal to, what is the distance for B? It is 180 minus A. And what is the speed for B? That will be x minus 20. Okay, so from here I can say I may just say I want to choose to cross multiply, so that I have it that 3x equal to 2a, and from there I can make anyone decide the formula as I will be needing in this case. Now for this second case, I can say here I just want to cross multiply, and for me to cross multiply like that, I will just have 3 into x minus 20 is equal to 2 into 180 minus a. So let's open up. This will be 3x minus 60 is equal to 2 times 180 is 360 minus 2a, and then here I can see that 3x minus 2a is equal to 360 plus 60. Okay, this is plus. If I add 2a to both sides, then if I add 60 to both sides, it's just like this. Now look at this. 3x is equal to 2a, or 2a is equal to 3x. So this is just inherently the same value. If I want to just solve for a, since a is what I'm looking for, I can say this 3x, yeah, it is 2a now. So I can say this is just 2a plus 2a is equal to 360 plus 60. That will be 420. So that I have 4a is equal to 420. Then a itself will be this over 4. Because I can see that this 4 can cut this 4. 4 here, this is 1. 4 in 400 is 100. 4 in 20 will be 105. So I can say the distance for car A, which is equal to A, is nothing but 105 kilometers. And already we have said the distance for car B, distance for B is what? It's giving us 180 minus A. And then that is from here. That A is 105. So the distance for the car B will be 180 minus 105, and that is 75 kilometers. So our understanding of the concept of speed, distance, and time had helped us to interpret this question correctly, and we got the distance of car A to be 105 kilometers, while the distance covered by car B is 75 kilometers. For this question on mensuration of triangles, we are told that the perimeter of an equilateral triangle, so we need to understand what an equilateral triangle is, that is of side 14 centimeters, is the same as the perimeter of a triangle MNP. Now, if the length of the sides of triangle MNP are consecutive integers, we are to calculate the longest side of triangle MNP. So what is the meaning of the sides of triangle MNP being consecutive integers? That means they are numbers that sequentially follow each other. Is either we have 4, 5, 6, or 11, 12, 13, or 22, 23, 24, or something like that. They need to be consecutive. They need to follow each other. So if you want to look at this question, let's say we have this as a diagram, and in the first case, we are told that it is an equilateral triangle. So if you call this triangle ABC, which is equilateral, each of the side is 14. That is the meaning of equilateral. The sides are equal, and of course, the angles, they are also going to be equal. For the equilateral triangle, each of the angle is 60, so that 60 times 3 is 180. We are told that the perimeter of this triangle ABC is nothing but equal to the perimeter of this other triangle. Let's call this MNP. Okay, but now how do we get the perimeter of a triangle? It is the sum of all the sides of that triangle. So in this case, it will be 14 plus 14 plus 14, or we can say it is 3 times 14, and that will be 42. So this is 42 centimeters. So this perimeter is the same as the perimeter of this triangle MNP. But now we are told that the sides of MNP are consecutive integers. So let's say x is the least side. So this is looking like the least. The next one will have to be x plus 1, and the longest one will have to be x plus 2. What we have to find is the longest side of MNP. So what we are looking for is x plus 2. So now if you want to look at the perimeter of triangle MNP, we just need to sum all the sides. That will be x plus the second side, x plus 1, plus the third side, that will be x plus 2. We are told that the perimeter of these two triangles are equal, so that means the sum of all this is 42. So that if you collect like terms, x is featuring in 3 places. We have 3x plus 1 plus 2, that is 3, is equal to 42. And then 3x will be 42 minus 3, and that will be 39. So that if we divide by 3, okay, we can just get the value of x to be 3 here 1, 3 here 13. So we can say from here x is nothing but 13. But note that nobody asks us to find x. We are asked to find the longest side. So we can just say from what we have seen so far, the longest side will be the higher of those consecutive numbers. That will be x plus 2, okay, and that will be 13 plus 2, which will give us nothing but 15 centimeters. So 15 centimeters is a solution to this particular question that we are given here. In this question on intercept theorem and parallel lines, we are told that the diagram features angle RPQ to be 32. So this is RPQ, that is 32 degrees. SNO is 90 degrees. SNO is a right angle here. And then NS, line NS is parallel to PR. So NS and PR, they are parallel. We have to find angle NOP. NOP, this is the angle of interest to us. That's what we are looking for in this particular question. Okay, good, fine, and wonderful. How best can we solve for this? You can actually make use of whatever means is suitable for you. But for me, I'm noticing that for this particular diagram, if I draw another parallel line from that point O, and you can see it's actually going parallel to these other two lines that are parallel. So I can say this is also parallel to them. This will help me to postulate the theorems that I know are applicable to parallel lines and the transversal between them. First, I can say that this angle here that I will just shade in this blue, that angle TOP is also going to be 32 degrees because comparing that to this, it is complementary to this angle. So I can say angle TOP is equal to angle RPQ, and that is also going to be 32 degrees because they are complementary angles. They are similar to one another, they are facing the same sides, they are complementary angles. Okay, so having gotten that, I can look at this particular side and say that this angle here, I can say this is going to be 90 degrees because that angle and SNO that we have, they are angles on a line. So I can say that angle MNS is equal to 180 minus angle SNO, and that's going to be 180 minus 90, which is 90 degrees. And why am I saying that? Because they are angles on a line, and the sum of angles on a line is actually 180 degrees. Okay, so that is MNS, but it's not only stopping there. I can also see NOT. So this NOT in blue also, angle NOT is also equal to angle MNS, and that will also be 90 degrees. Why? Again, they're also facing the same sides, and they're also cross with the transversal between two parallel lines. So I can say that is 90 because these are complementary angles. Okay, so having all of this now, why am I doing this? Because I'm seeing that angle NNOP that I'm looking for is comprising this NOT, which is 90, and this TOP, which is 32 degrees. So I can just say the angle I'm looking for, angle NOP, is equal to MNS that I got to be 90 plus angle TOP that I got to be 32. So that will be 90 plus 32, and 90 plus 32 is nothing but 122 degrees. So the understanding of the parallel lines that are crossed by a transversal had helped us to solve this question. You can also look for some other means. In short, just try it out. Look for so many other ways that you can also solve this question, and you see that inherently you will arrive at the same answer, and the question would have been done and dusted. In this question on angle of elevation, we are told that a boy sitting on a tree at a point 12 meters above the ground observed that the angle of elevation of the top of a tower 60 meters away was 28 degrees. We have to find, correct to one decimal place, the height of the tower. So this is a very good pictorial view of what we are looking at in this particular case, and I will be overlaying the diagram of what we can do to actually get this done correctly as appropriate. Now this is the boy, and we are told that he's 12 meters above the ground. So we can say from his high level to the ground, we are looking at 12 meters. So this is 12 meters. Then we are told that is observing the top of a tower at an angle of elevation 28 degrees. That means from his point of perspective horizontally, is now looking at the top of the tower, so that the angle of elevation here, this angle is 28 degrees. Okay, and then the tower we are told is 60 meters away. So the distance between the boy and the tower, like here, we can say this is 60 meters. We are to find, correct to one decimal place, the height of the tower. So we can just say we want to finish up our diagram by completing that, and we can say we want to join it fully. So this is the diagram now. We are asked to find the height of the tower. So the height of the tower will be from the base of the ground to the top of the tower. So we can call it as h, and that h we will be able to look for it, saying that this is the distance from the top of the tower to the base of the tower. Now let me reduce the opacity of what we have at the base so that we can see our diagram straight and fine. If you are taking this side facing this angle 28, if we call this x, okay, we can see that h is nothing but the addition of this side, which is also 12 meters because it is parallel to the height of the tree. So we have this as also 12 meters. So h is nothing but 12 plus x, okay. And then we have been told the distance between the boy sitting on the tree and the tower to be 60 meters. So we have noted that before. So inherently we are seeing that for this question we have 12 meters, but we need to find x, and the addition of 12 and x will give us the height of the tower. Okay, so if we can solve that, we'll get this done and dusted, and that would really help us to solve this. Already considering angle 28 degrees, so if I want to take this point 28 degrees, we will see that the side facing 28 is this x, so that is inherently the opposite. So this is the opposite to x. Okay, this is the hypotenuse, and this 60 is the adjacent. So we have it that from SOHCAHTOA can help us to solve this very wonderfully, because we know that we are looking for the opposite, but we have the adjacent. What trigonometry identity is relating the opposite and the adjacent? It is a tan. So that from here we can say tan 28 is equal to the opposite, which is x that we are looking for, over the adjacent, which is 60, so that our x will be 60 tan 28. So we can use our calculator to try and evaluate that. Okay, so we can say we are looking for 60 tan 28 in our calculator, and that is 31.9025, or let me just say 31.90. so this is 31.90 meters. Okay, but nobody asks us to find the value of x. What we are asked to find is the height of the tower. We can see that height of that tower, from what we have been able to deduce from our diagram, is nothing but 12 plus x. Therefore ht, which is the height of the tower, is 12 plus 31.9 meters. Okay, so that will be 43.9 meters. And oh good, we are even asked to find it correct to one decimal place. So in this particular case, 43.9 meters is going to be the value of the height of this tower as requested. In this question on a map, we are told that the scale of a map is 1:5000. Okay, now if the distance between 2 points on the map is 12 centimeters, now 1:5000, which one is smaller? We are looking at a map now, which you can look at on a paper. Definitely is going to take the smaller scale. So this is the map ratio, the real life scale. The map is the lower one, the real life is actually the larger one. So one is corresponding to the value we are going to have on the map. The real value is corresponding to 5000. Now I told that the distance between 2 points of the map is 12 centimeters. That means 12 centimeters is now relating to a particular value that we are looking for, which we can call, let's say it is x. All right, but now you should note that this x we are looking for will have to be also first in centimeters, but since we are asked to find it in meters, we need to eventually convert it to meters. So from here we can say we just want to cross multiply to say that x will be 12 multiplied by 5,000. Okay, 12 multiplied by 5,000 will be 60,000, but that 60,000 will be the unit in centimeters. So if you want to take it to meters, we can say x is going to be 60,000, we have centimeters, over 1. But then to take it to meters, we need to multiply by meters. How many centimeters make 1 meter? That is 100 centimeters. So this is just saying 1 meter over 1 meter, because 100 centimeters is 1 meter. And that will help us to take care of the centimeters, so that our answer will only be in meters. But then we are seeing these two zeros can cut them, so that the value between those 2 points, which we denoted as x, will be 600 meters in the real world. Okay. Here in this question on probability, we are told that a bag contains 24 identical balls, 8 of which are red, 6 are blue, and the rest are green. Now, if a ball is drawn at random from the bag, we have to find the probability that it is green, it is red or green, then it is not green. So let's look at the pictorial view of what our bag may look like, okay? And then if you are to look at how our selection can be made, already from the information that we are given, we are told that there are 8 red balls, 6 blue balls, and then the rest are green. For us to get the number of green, we are told that the total number of balls was 24. So the total balls is 24. Now if we find 8 red, 6 blue, then the number of greens, that number of green ball will be 24 minus the addition of 8 plus 6. Okay, that will be 24 minus 14, and that will be 10. So we can just append that green as 10. So this is what we have, and we need to look at this probability as requested of us. In the first case, we have to find the probability that a ball selected at random is green. That probability of picking green in the first question is going to be the number of green balls over the total number of balls. Okay, or let me just say n total. It will be the total number of balls. And what's the number of green? We got it to be 10 initially. The total number of balls were given as 24. If we cut out this, 2 can go in 10, that is 5. 2 in 24, that is 12. So that's the probability of picking a ball that is green. Okay, now let's be careful here. In the second case, if a ball is drawn at random from the bag, we have to find the probability that it is red or green. Okay, so just a singular ball, but now we're looking at probability of red or green, and that will be probability of red plus the probability of green. Okay, so this is what we need to note. And then if you want to do that, probability of red will be the number of red balls, which is 8 over 24. Okay, but the probability of green, that is 10 over 24. And since we didn't cut out, this will just be 18 over 24. And now for us to cut, think 6 can go in 18, that will be 3. 6 in 24, that will be 4. That is the probability of picking red or green. And then in the third case, what's the probability that the ball that will be picked is not green? So we are looking at probability of green prime. And since you are saying it is not green, that means it is the 1 minus probability of green. And to solve that, that will just be 1 minus what the probability of green that we got initially, 5 over 12. And this will be nothing but, you can say we want to find the LCM, it will be 12 minus 5, and that will give us 7 over 12 as the probability of picking a ball at random from the bag, but the ball is not green. And with that, we've solved this question and dusted it as appropriate. Okay, here's a question on binary operations, and here we are told that the operation asterisk is defined on the set R of real numbers by m asterisk n is half of m minus n. Now, if m is 2, n is 4, and p is 6, we have to evaluate. In the first case, let's do this. We have m asterisk n plus p, and if we want to put in those values, what is m? M will be 2 asterisk. We need to first carry out the operation in bracket. If you recall your board mass or PEMDAS, so we have n is 4 plus p, this is 6. So if you carry out the operation in bracket for, so we're having 2 asterisk 10 in this particular case. or we can just write 10 directly to say this is nothing but 2 asterisk 10. But we recollect that m asterisk n will be half of m minus n. So in this case, that's going to be 1 over 2. The first alphabet, which is relating to m, is actually 2. Then minus the second alphabet, which is relating to n. In this case, that will be 10. Alright, so we have 1 over 2 multiplied by 2 minus 10, that is minus 8. And then if you cut, minus 8 over 2 is minus 4. Alright, that's good and fine. In the second case, we have m asterisk n plus m asterisk p. So we have m asterisk n. We have to put that in brackets. So we evaluate that. Then m asterisk p. Again, if we are bringing in board mass, we need to do the operation in bracket first before we go on to the addition. Okay, so m is 2. So what we have here is inherently 2 asterisk n is 4 plus m. Again, m is 2 asterisk p, and p is 6. So if we want to do this now, we just want to carry out this binary operation. So we have 1 over 2, the first alphabet, 2 minus the second alphabet, which is 4, plus 1 over 2 into the first alphabet, 2 minus the second alphabet, which is 6. So this will give us 1 over 2 into minus 2 plus 1 over 2 into 2 minus 6 is minus 4. So we can just cut, and that will give us minus 1, okay, then plus minus 2. Here, negative sign and the positive sign will multiply to give a negative sign. So this will be minus 1 minus 2, which is nothing but minus 3. So these are the answers that they are requesting of us. And once you're able to get this, you are good and fine. Your full mark is assured, right? Okay, yes, this is a question on equations, particularly quadratic equations. Arguing that the root of the equation 2x squared plus m plus 1x plus n equal to 0 are 1 and 3, where m and n are constant. But to find the values of m and n. Okay, so I think there are generally 2 means that you can go about trying to solve this. It may be more than that, but that I'm seeing and perceiving already. You can actually start to reverse engineer by saying the roots are 1 and 3. So x is 1 and x is 3. Then you take it back. So x minus 1 into bracket, x minus 3 is equal to 0. And you expand the bracket. You can do that, but that's not what I want to do. I want to actually simplify this to say this will become, dividing through by 2, I have s squared plus, look at this, m plus 1 over 2x plus n over 2 is equal to 0. So I just divide through by 2. Dividing by 2 is giving me this, okay? And so if I'm to compare with the general form of equation saying s squared minus alpha plus beta x plus alpha beta is equal to 0, where alpha plus beta is the sum of roots and alpha beta is the product of roots, then I'm to see that alpha plus beta, or inherently let me just say minus alpha plus beta, is equal to m plus 1 over 2, okay? And what is my alpha and beta? They are 1 and 3. In short, let me say alpha is 1 and let me say beta is 3. So from here, that means what I can have is that minus 1 plus 3 is equal to m plus 1 over 2. So this is 1 plus 3 is 4, minus 4 times 2. So I have minus 4 multiplied by 2 is m plus 1, so that I'm saying m plus 1 is equal to minus 8, and then m will be minus 8 minus 1, which will be minus 9, okay? And then the product of roots, I'm having alpha beta is equal to n over 2. Therefore, alpha is 1, beta is 3. I'm having 1 multiplied by 3 is equal to n over 2, such that n itself will be 3 times 1 is 3, 3 times 2 is 6. So you have 3 multiplied by 2, which is equal to 6. Okay, so this is what I would like to say is the solution. And then let me just show us this. The original equation will mean that we have 2x squared plus m plus 1. M plus 1 will be minus 9 plus 1 will be minus 8. So I can say minus 8x then plus n. What is n? N is 6 plus 6 is equal to 0. I think this will reduce to, if I divide through by 2, it will be x squared minus 4x plus 3 is equal to 0. Now, you can just try and factorize this to see that it will actually give us this as a root of the equation. For example, we have minus 4x, that will be x squared minus 3x minus x plus 3 is equal to 0, such that I will have x common to both, x minus 3, then minus 1 common to both, minus 1, note that x minus 3, so that minus 1 times minus 3 will be plus 3. This is 0. So here again, x minus 3 is common, and then we have x minus 1 remaining is 0, such that x is 3 or x is 1. I just took this as a check. Okay, this is just a check. You don't need this in the exam. Once you are able to get 6 and minus 9, that is fine. But I just want to show you students to do this, then you can arrive at the same answer. Interestingly, like I said initially at the starting point, you can reverse engineer to say, okay, x is 3 or x is 1, then you want to open bracket like this, and then after opening that bracket, you want to multiply out, you will get this, and eventually you arrive at this equation, which you can now equate to this, that n plus 1 is minus 8, and then n is 6. You arrive at the same answer, and your full mark will be awarded on your way to excellence. All right. Okay, we have this question on equations, and we're told that in an athletic competition, 812 tickets were sold for $1,912. If the student paid $2 per ticket and non-student paid $3, how many more students than non-students were present? Okay, I think I like the idea of this type of question. So let's say x should represent the student, and then y should represent the non-student. Okay, so if that is the case, we can go ahead to say we want to interpret this now. The total number of tickets that were sold was 812. That means that we can say x, the tickets bought by students, plus the total tickets bought by non-students, everything is going to be 812, and we can append this as our equation 1. Okay, and then now these were sold for $1,912. No problem. There's a breakdown. Student pay $2 per ticket, so x is for students, so 2x, the amount paid for ticket by student, plus non-student paid $3 plus 3y, that's the amount paid by non-students. The total of that is giving us 1,912, and we can take this as equation 2. Okay, so we want to get the difference in numbers between those who are students and those who are not students. What I would like to do in this case is that equation 1, I'm going to multiply it by 2. Okay, let me just do that. Then I will have 2 multiplying each of these terms will give me 2x plus 2y is equal to, this will be 1624. Okay, and then I can tag it as equation 3. Having done that, now what I want to do is to say, looking at this equation 2 and equation 3, I can subtract. I can say equation 2 minus equation 3. You can see 2x minus 2x, that will be 0. So that I can say is actually out of discussion. Then I have 3y minus 2y, and that will be y. 3y minus 2y is equal to 1912 minus 1624. 1912 minus 1624. So here I'm going to have y is equal to, what's this? Let me use my calculator. 1912 minus 1624. Okay, y is 288. That is the non-student. But then if I got that to be non-student, I can get from equation 1, from 1, I can see that x is going to be 812 minus y, and y I got to be 288. So x will be 812 minus 288. Then x is going to give me what? 812 minus 288. This is 524. 524. Okay, that's good and very fine. But now we're being told how many more students than non-students were present. So the more students, the number of more students will have to be the difference between these two, and that will be 524 minus 288. Okay, so we have 524 minus 288, and that's going to give me 236. So that is equals to 236. So what we are looking for is nothing but 236 students were around in that competition, more than those who are non-students. All right. Here we are told that two numbers are such that twice the first added to the second is 21. If twice the second added to the first is 27, we have to find the number. So let x and y be the numbers. If x and y are the numbers, we can use the interpretation of this statement to solve this question. In the first case, twice the first, so we have 2x added to the second plus y is equal to 21, all right? And then twice the second added to the first is 27, so the first x plus twice the second 2y is equal to 27. Again, we have this as two equations, equation 1 and 2. And to solve this, I think I would like to say, let me do equation 1 multiplied by 2 so that I'll be able to eliminate y. So that will give me 2x times 2 is 4x plus y times 2 is 2y is equal to 21 times 2, that will be 42. So I can call this equation 3. And then looking at this now, I can just see that for equation 2 and 3, 2y is common to both of them. So I can say equation 2 minus equation 3. And in that case, for the first terms, x and x, I have x minus 4x. Now, 2y minus 2y will be 0. We don't need to write that. This is going to be equal to 27 minus 42. So I'm having minus 3x is equal to 27 minus 42. That will be minus 15. And if I'm dividing by minus 3 on both sides, this first case, minus 3 will cut. And then minus 3 in minus 15 will give me 5. So the value of x is 5. That is the first number. Okay, the second number, from here we can say from equation 1, y will be 21 minus 2x. Therefore y will be 21 minus 2 multiplied by 5. So that will be 21 minus 10, which is 11. So from what we are asked, we can readily say that the first number as it was depicted is 5. And then the second number as asked for the question is nothing but 11. And we can just verify twice of the first number, that will be 2 times 5, that is 10, plus the second, 10 plus 11, of course, that's 21. Twice the second, 2 times 11 is 22, added to the first, 22 plus 5 is 27, that is 27. So we're on the right track, and this is our solution as expected of us. In this question on angle of depression, we are told that from the top of a tower 80 meters high, the angles of depression of the top and bottom of a building are 28 degrees and 36 degrees respectively. Students, that means that the angle of depression of the top is 28 and that of the bottom of that building is 36. That's how I'm saying respectively, okay? Now, if the base of the building is on the same horizontal level as the foot of the tower, we have to calculate correct to 4 significant figures the height of the building. So a picture is always worth 1,000 words. This is going to be a similitude of what we are going to be having in this particular diagram. If you are to look at it, we have the tower and we have the building, because we are told that the angle of depression from the top of the tower, so that means the tower will have to be higher for the building sighting to be a depression of the view. So initially, let's say this particular person that is on the tower is trying to walk on the tower but is looking down on the building. Maybe then he is looking initially like this, then the angle of depression to the top of the building, this, and then the angle of depression to the bottom of the building, this. That is just what is highlighted for us. Furthermore, we are told that there is a particular height for the tower. Okay, so that height we are given as 80 meters, and then Our mandate is that first we have the angle of depression of the top of the building. This is the top. So from its horizontal view, its initial horizontal view to that, we are going to have something like this, that this is 28 degrees. So let me depict that as such. Okay, and then I will use another hint for this. The angle of depression of the bottom of the building, now that will be from that initial horizontal viewing to the inclination of the bottom of the building, that was given as 36 degrees. Okay, so that was shown in red. For the top is shown in blue. So our mandate is to find the height of the building. So for us to identify the height of the building, we'll be looking at something like this. Let's say we have this there. Okay, then we'll be looking at from here to here, that this is the height of the building that we are asked to find. Okay, and we are asked to get it correct to 4 significant figures. So good. Now that we have the diagram, let me just tone our image so that it will not be unnecessarily confused. Okay, so if you have that as shown now, we can see that we have this diagram that we can try and complete. Let's say I just want to finish up by joining this line to that diagram we're coming from. Okay, oh, beautiful, beautiful. So I may also want to label. Let me say I want to call this A, B, C, D, and maybe I can call this E. All right, we are looking for H. Already the height of the tower is corresponding to AE. Because it is parallel to BD, they are going to be the same. So AE and BD, they are the same. But for us to get this height, we will notice that that height is going to be the height of the tower itself, which is 80 meters, minus this side BC. Okay, so the height that we are looking for, let me say height of the building that we are looking for, the height H, is going to be the length of BD, which is also AE, that is 80 meters, minus this BC, minus BC. But okay, let me just call BC, let me call it, since it is facing A, let me call this A. So I will say 80 minus BC, or 80 minus A. Okay, then how do you go about finding A? Now for this particular A, it is included in this triangle ABC. We don't know any of the sides, but we know this included angle 28 degrees. That's good. Looking for A, not knowing any of the sides. These sides AB, this side AB, we can get from the bigger triangle ABD, because for ABD, we know that BD is 80 meters, which is going to be the opposite to this angle 36 degrees, and then we can use AB at its adjacent. So we are looking for the adjacent, we know the opposite, definitely we know the angle, and then we can use those parameters to get that adjacent. So this adjacent, let me call it X. That means that I can say from the triangle ABD, first the bigger triangle ABD, I'm having the, okay, I want to make use of SOHCAHTOA, so that I can have that as a reference. Now I'm having the opposite, which is BD. I'm looking for the adjacent, which is going to be relevant to me. It is tangent, because tangent is opposite over adjacent. So I can say the tangent of, now I'm talking about the bigger triangle, it will be angle 36, then 36 is equal to the opposite, that is BD, and that BD we know is also equal to AE over, what is the adjacent? The adjacent is AB for that triangle. Now that BD, of course, I have tagged as 80, AB I have tagged as X. So here, if I just cross multiply, I can say that means that inherently X is going to be 80 over tan 36. Okay, so what's that going to give me? I will use my calculator to try and solve this. So I'm having 80 divided by tan 36. Okay, so this is 110.11, let me say 111. This is 110.111 meters, but that's not where I'm going. Now, since I have the value of adjacent AB, which is X, I cannot find A. I can say from the triangle, the smaller triangle now, ABC, again, what we have is the included angle, which is 28 degrees, that smaller one. Then I want to relate the opposite of it, which is BC, to the adjacent. tangent is still going to be what will be relevant for us. So I can say tan 28 now is going to be opposite, which is BC, over the adjacent, which is AB. And of course, that opposite is nothing but A. That adjacent is X. So my A, which is what I'm looking for, is going to be, now if I cross multiply in this case, going to be X tan 28, but X I just got to be 110.111, so I have 110.111 tan 28. Okay, so calculator will help me to solve. Oh, just the initial answer multiplied by tan 28. What's that going to give us? 58.5468, 58.5468 meters. But then that is A. The height of the building we are looking for, already we have said it initially that that height is nothing but 80 minus A. And now look at A. A is 58.5468. So if you want to do that, you can say 80 minus the answer we just got, 21.4532. That's 21.4532. But look at the question. We have to get it correct to 4 significant figures. And that means that, students, you need to understand that even if you are having decimal place, your significant figure, the digit after the decimal place, they will still count. So that height will have to be 21.45 meters, because 3 is less than 5. We will round it down to 0 and did not affect the digit before it. So 21.45 meters is going to be the height of this particular building as featured in this question. All right. Yeah, in this question of mensuration, we are told that one of the diagonals and perimeter of a rhombus are 32 centimeters and 80 centimeters respectively. That means the diagonal is 32 and the perimeter is 80. That's why we're having the word respectively. Our mandate here is to find the area. Now, if you are to take a look at the picture of a rhombus, ideally, we know that the area of a rhombus is given as 1/2 multiplied by the product of the diagonal, so D1 and D2. And in this diagram, if you want to identify those D1 and D2, you can say you want to join from this vertex to the one opposite it. And also, okay, let me use another ink for that. And also something like this. Okay, so this is D1 and this is D2. And that is how we actually go about getting the area of the rhombus. But interestingly, we are told that one diagonal is 32. So if I take this as the red as 32, that means here, let me say this is 16 and this is 16, so that the addition of the two will be 32. Good and fine. Now we are told that the perimeter will mean that the sum of all the sides. For a rhombus, the sides are equal. So if this is A, then definitely this is also A, this is A, and this is also A. So we have it that we can say 4A is equal to the perimeter of this particular rhombus, which is equal to 80. And in that case, A is going to be 80 over 4, and that is 20 centimeters. So we can say we are looking at something like this. Say this side is 20 centimeters. Now, looking at this already, the diagonals are observed to be dividing the rhombus into 4 triangles, in which at the center we have 4 right angles. Okay, so if that is the case, we can see that for this particular one, let me just try and see if I can color it for you to see clearly. Here and here, we can see that that is a right angle triangle, in which we have the hypotenuse and we also have one of the sides. So if I call this other side, let me call this other side, let me call it H. Okay, and of course this will also be H. Okay, this is H, this is H, because like we did for the red diagonal, we are dividing it into 2 equal parts. This will also be H. So from here we can say that by Pythagoras theorem, recall this is the perimeter that we actually use to evaluate the side A. Now we can say that by Pythagoras theorem, we are saying that here for this triangle, 20 square is equal to 8 square plus 16 square. And that means that 8 square is going to be 20 square minus 16 square. we can use the difference of two squares in this case. So say this is nothing but 20 plus 16 multiplied by 20 minus 16. Okay, so h square is, what is 20 plus 16? That's 36. 20 minus 16, that is 4. 36 and 4 is just as say you are saying 12 and 3 times 4, 12. So this is 144, such that h is the square root of 144. Okay, so from here we have it that our h is equal to square root of 144 is 12 centimeter. Originally we have one of the diameter, so if we call that d1, that we are given as 32 centimeters, we have deduced from this diagram that d2 is going to be h plus h, so that is 2h, and that is going to be 12 times 2, that is 24 centimeters. Okay, so that means we can find our area from where we are coming from, that the area is going to be 1 over 2 multiplied by d1. What is d1? That is 32, and again multiplied by d2, that is 24. So we can use our calculator to solve this now, to say we have 0.5, which is 1 over 2 multiplied by 32 multiplied by 24. What is going to give us? That's 384. So this is 384 centimeters square as the area of this particular rhombus. Now, good as that is, interestingly, there is another route we could have taken. We could have said that the area of this particular rhombus, since the diagonals are dividing them into equal parts, that means we can say it is 4 multiplied by the area of one of the right angle triangles that we have, because this right angle triangle is equal to this one and this one and this one. So we can say it is 4 multiplied by half multiplied by the base and height, which in this bracket, that is the area of this particular triangle. So if you want to do that, we could have said it is 4 multiplied by 1 over 2 multiplied by, what is the base of this triangle? It is 16. What is the height? It is h, that we got as 12. Okay, and to evaluate that from the calculator, we'll see that this is 4 times 0.5 times 16 times 12. Okay, and what's that going to give us? You can see that is also 384 centimeters squared, just as we have gotten initially. So whichever method you choose to use, just be consistent and you'll see that your answer is out and your work is done and dusted. All right. In this question of mensuration, we are told that the area of an equilateral triangle is 2 root 3 meters square. We are to calculate the length of a side of the triangle. Okay, so what are the properties of an equilateral triangle that we know that can be useful for us to solve this question? First and foremost, the side of the equilateral triangle, they are equal. So this side and this third one, they are equal. Okay, and then the angle included in the equilateral triangle, each of the angle is 60. So that 60 plus 60 plus 60, that is 180, summing up to the sum of angles of a triangle. So I can say here, this is 60, here this is another 60, and here I have another 60. Okay, but now we are given in this question that the area of this particular equilateral triangle is 2 root 3 meters square, and we are to find the length of a side of the triangle. So let's call this side, let's call it B. Okay, so how can we go about trying to solve this question? One thing I'm noticing is that if I choose to bisect this triangle, to say I'm dividing it into 2 equal parts. Now for this particular base, since I'm dividing this length into 2 equal parts, then here I'm going to have B over 2. This is also going to be another B over 2. This angle that I've bisected, initially it was 60, now this is going to be 30 degrees, and this is also 30 degrees, whereas this is 60 degrees. So I can just, let me note it like this, that this is 60, however this here, that is 30. Okay, now if I tag this particular vertical line, if I tag it as H, okay, I know that doing all this will also warrant that the area of this side of the triangle, this right angle triangle, will be half of this. Okay, so that area of this particular half side, this right angle triangle, okay, let me just label A, B, C, D. Initially D is area of triangle, let me call this area of triangle ABC, is this as given originally. Now area of triangle ABD, half of that is going to be 1 over 2 into 2 root 3, which is equal to root 3 meters square. But I know by reason of this rectangle triangle that the area of that triangle ABD is actually half multiplied by the base multiplied by the height. But let's notice something here. What is the base of this triangle? It is b over 2. So I can put it appropriately that half multiplied by b over 2 multiplied by the h, which is bh over 4. Now I did that because I can actually find h by reason of SOHCAHTOA. So if I want to say I'm using SOHCAHTOA and I want to take one of the, okay, let me say I want to make use of 60. For 60, I can say that h is what? H is the opposite to 60. B over 2 is the adjacent to 60. So I can say tan 60 is equal to the opposite, h over the adjacent, b over 2. Okay, therefore h that I'm looking for is b over 2 tan 60. So that means I can use that value of h in this particular case. So say instead of saying h, I have it as b over 2 tan 60. Okay, so that area, this particular area that I have here, I can express it as this now. Okay, I can say in trying to relate that the area of that triangle, half of that triangle, which is triangle ADB, area of triangle ABD is going to give me something like this. I got it initially as root 3 is equal to BH over 4. Let me say I have B over 4 that I want to write straight. B over 4. Now what is H? H I'm seeing as B over 2 tan 60. So what is tan 60? Tan 60, we can say we want to use our calculator. So what is tan 60? Okay, tan 60 is even root 3. Good and fine. Okay, so I have it as B over 4, which is this B over 4. H is now B over 2 tan 60. That tan 60 I just got to be root 3. Okay, so looking at this now, I can say that root 3 is going to cut root 3. So with that, I can say here 1 is only going to remain here. I can say 1 is equal to b times b is b square. 4 times 2 is 8. Now if I just cross multiply here, I will have it that b square is equal to 8. Therefore b itself is root 8, and root 8 is actually 2 root 2 because it is 8 is 4 times 2. Square root of 4 is 2. That's here. Then that square root of 2 remaining will still be here. And this is going to be the length of the side of this particular triangle, this particular equilateral triangle, whose area is 2 root 3 meters square. What we did is that we are looking at the area of the full equilateral triangle. If we divide it into 2, we are going to also divide the area into 2. But then we know that dividing it into 2 will run that we're having a right angle triangle whose area is half base times height. Now the base here is corresponding to b over 2, half of the side of the original equilateral triangle. So SOHCAHTOA with tan 60 helps us to find the height. We don't need to express the value of the height out. We just use it in the original equation for the area of the right angle triangle to get the side of this equilateral triangle to be 2 root 2 meters. All right. This question is featuring a combination of mensuration and number base. So let's just take our time to look at it together. We are told that Mr. Kubi has a backyard garden in the form of a rectangle. Okay. Now the breadth of the garden is 212 base 3 meters and the length is twice the breadth. Our mandate is to calculate the area of the garden and leave the answer in base 5. Okay, so let's have a pictorial view of what we are being told here. We are told that first and foremost, the breadth of the garden is 212 base 3. So we can say this is 212 to base 3. And then the length is twice the breadth. So here we can say this is nothing but 2 multiplied by 212 base 3. Okay, so we have to calculate the area of the garden and leave the answer in base 5. Since it is in the form of a rectangle, the area will be the length multiplied by the breadth. Okay, so you can say you want to do it directly. Okay, that here we can just say area of this rectangle is going to be 212 to base 3. Okay, multiplied by 2 times 212 to base 3. Okay, if you are very proficient in number base, you can say you want to multiply this out straight, but for me, as a rule of thumb, since we are going to be having mixed students, I would first like to convert 2 and 2 in base 3 to base 10, multiply in base 10, and then convert to base 5 to solve as we are requested in this particular case. Okay, so I can say in 2 and 2 of base 3, if we want to take this and convert to base 10, we are going to have it that each of these digits, in the first case we have 2, we multiply by 3, I will come back to the power, plus 1 multiplied by 3, then plus the last digit 2 multiplied by 3. Now for the power, I need to start from this right hand side and take the power as this is 0, this is 1, and this is 2. So inherently what I'm going to have is, in this case, 3 raised to power 2 is 9, 9 times 2, that is 18, plus 3 raised to power 1 is 1, 1 times 3, that is 3, plus any number raised to power 0 is 1, 1 times 2, that is 2. So this is 18 plus 3 plus 2, and that is 23 in base 10. Okay, so what we are having as the area, therefore the area of this rectangle is going to be 23, which is in base 10, multiplied by 2 times 23, because this is going to be the breadth, the length is 2 times the breadth, so this is what we have. So we can just say this is nothing but, let's use our calculator now, this is just 23 times 2 times 23 is 46. So what's that going to give us? 1058. So this is 23 times 46, which is 1058 meter square. Okay, but now we are not asked to get the area in base 10. This is in base 10. We are asked to leave the answer in base 5. For us to do that, we just need to divide this particular area by 5, and we take the remainder. That's going to be what will give us the answer in base 5. So we have 1058. We'll be dividing with 5. Okay, and then we can just do our long division to say we should have something like this, and then we are dividing straight like this. So we are having 5 in 10, that will be 2, 5 in 5 is 1, 5 in 8 is 1, remainder 3, so we have plus 3, because 5 times 1 is 5, plus 3, that will be 8. Again, we are using 5 to divide this. Okay, and if you are dividing like that, we are going to say what we are having is nothing but 5 in 21, that is 4, 5 times 4 is 20, remaining 1, 5 in 11, that is 2, there will also be a remainder of 1. Okay, again, 5 in 42, that is 8, 5 times 8 is 40, remaining 2, so we have 2 remaining. 5 in 8, that is 1, 5 times 1 is 5, we are going to have 3 as a remainder. So finally we can say 5 in 1, what is that going to give us? Is going to be 0, okay, as 1 is way less than 5, and what is going to remain? We are going to have that 1 remaining. Okay, so the answer that we are looking for in this particular case will be we taking this and taking it up to say our area that we are looking for is nothing but 13213. Let me move this a bit so that we have space to put my work. Okay, so inherently I'm saying that my area is nothing but 1058 meters square in base 10, but in base 5 it will be 13213 to base 5 meter square. Let's write just the way they wrote for us, and this will be the solution to this question, done and dusted. All right, for this question on mensuration, we are told that 4 of the interior angles of a heptagon. So first you need to know what is a heptagon. Okay, they are 106 degrees, 110, 127, 120 degrees. Okay, now the remaining angles are in the ratio 2 ratio 3.5 ratio 5. We have to calculate the smallest angle of the heptagon. Even if you don't know what a heptagon is, you can count these angles. So say this is 1, 2, 3, 4, 5, 6, 7. So an heptagon is a polygon that has 7 sides. In short, as a refresher course, quadragon is 4, pentagon is 5, hexagon is 6, heptagon is 7, octagon is 8, nonagon is 9, and decagon is 10. Okay, so in this particular case, we are looking at a polygon with 7 sides. So 7 sides is of interest to us in this particular case, and the sum of interior angles of a polygon with n number of sides is given as n minus 2 multiplied by 180 degrees, and here in this case we have n to be 7. Okay, that is good and fine. So with all of this understanding, we can say we want to have all of the angles to say we have 106, we have 110, we have 127, we have 120. Now with what I just explained, we are going to have 2x, we are going to have 3.5x, and we are going to have 5x. Now since we know that the sum of the interior angles of a polygon is given as n minus 2 divided by 180, and in this case n is 7 for heptagon, then the sum of angles, we can say 106 plus 110 plus 127 plus 120 plus 2x plus 3.5x plus 5x is going to be 7 minus 2 multiplied by 180 degrees. So let's bring in our calculator to try and solve this. We have 106 plus 110 plus 127 plus 120. What's that going to give us? 463. So we have 463 plus 2 and 3.5 is 5.5 plus 5. We have 10.5x is going to give us 7 minus 2 is 5. 5 times 180 will be 900. Okay, therefore 10.5x is 900 minus 463. Okay, and if you use our calculator for that again, 900 minus 463, this 437 is 437, so that x itself is 437 over 10.5. Okay, so our final answer that we just got divided by 10.5, this is 41.61. so it's repetitive, that's why we have this bar. I can just say 41.62. so this is 41.62 degrees. Now look at this. Nobody asks us to find x, we are asked to find the smallest angle of the heptagon, and then we are having the base divisor as 41.62. and look at all of these values. Look at all of these values that we have. Which one is going to be the smallest? Of course 106. All the ones that we are given, they are quite large. So we have between these three that we're having a base divisor to consider, and of course 2x is actually the least of it all. So we can say for this particular case, the smallest angle, the smallest interior angle of this particular heptagon is going to be 2x, which is 2 multiplied by 41.62 degrees. And if you are to use a calculator for that, you can say what we got multiplied by 2 and then straight, it will be 23.24, 83, not 23, 83.24 degrees as the smallest angle for this particular heptagon. All right. In this question, we are told that the sum of the first 10 terms of an arithmetic progression, that is an AP, is 120, and of course that's telling us that this is a question in sequence and series. Now, if the fifth term is 6 less than the 8th term, we are to find the common difference and the first term. So let's take the information we have here piecewise. In the first case, we are saying that the sum of the first 10 terms is 120, but from understanding of arithmetic progression, what is the formula for the sum of the first n terms of an AP? It is given as n over 2 multiplied by 2a plus n minus 1d, okay, where n is the number of terms, then we have a to be the first term, and then d that we are featuring is the common difference. That's the common difference for that particular arithmetic progression. So it is this formula that is inherently equal to 120 for the first 10 terms. So that means that we can say when n is 10, okay, let me just write that. For n equal to 10, then what we have is that S10 is now being given as 120 is equal to n over 2 will be 10 over 2. So we have 10 over 2 into 2 multiplied by the first term plus n is 10. So we have 10 minus 1 multiplied by the common difference. Okay, so if we simplify this, we can just have these 2 can cut 10, and then 5 can go in 120. That will be 24. So what we have inherently is that, okay, let me just open this, 2a plus 9d. So we have 2a plus 9d is going to give us 24. So we can note this as one equation that we can find useful. I'm calling it equation 1. Now the second statement, we are being told that fifth term is 6 less than the 8th term, means that we have t5 is equal to t8 minus 6. Okay, or if we rearrange this, we say t5 plus 6 is equal to t8. But normally between t5 and t8, how many common difference are we going to have? From t5 to t6, that is 1d. t6 to t7, that is another d. t7 to t8, that is another d. So what we are having is that we can say t5 plus 3d is equal to t8 from the explanation that we have. And that means that, look at this, this 6 is actually 3d. So what we can say is that means that 3d is equal to 6, such that in this particular case, d will be 6 over 3, and that is nothing but 2. And that is giving us the first answer that we are looking for, that the common difference is actually 2. Okay, now for us to get the first term, look at this particular expression, the equation we got initially, that 2a plus 9d is equal to 24. So we have 2a plus 9. What's the value for d? We just got it to be 2 is equal to what? That is 24. So from here, we can now say that looking at this, it means that 2a is equal to 24 minus 9 times 2 is 18. So 2a is equal to 24 minus 18, that is 6. That means that a will be 6 over 2, and that will be nothing but 3. In this question on circle theorems, we are told that in the diagram, PQRS is a circle, then angle QRP, this angle here is 41, angle PTQ, this angle here is 35, then PT, this is PT, is a tangent to that particular circle, and then line QR is parallel to line PS. That's why we're having these double arrows on each one of them. Our mandate is to find angle first PAQ and then PQT. So let's identify PAQ. We have PAQ, so it is this angle here. If I'm to just depict it like this, so this angle is what to find. Okay, and then looking at this particular diagram, how best can we go about trying to solve for this angle? There are so many ways that you can choose to go about the student. You can try your hand on them. Let me just, by reason of just looking at it, let me just postulate one. If I'm to say I'm drawing another parallel line like this, now this 41, we also render this as 41. Okay, this particular angle here is also going to be 41 because it is the angle in the same second like this. We have QRP, we have QSP. So QRP and QSP are in the same second. So this is also 41. Then this 41 is also this particular 41 because again it is alternate to that. And this angle we are looking for is just, you can see this angle here and this angle here, they are vertically opposite. So I can say this is equal to 41 plus 41, and that is 82. So that is one means that you can go about, and there are even so many other means, but this is the format that I want to follow. This angle QAP, if I call it theta, okay, I'm looking for theta. This is what I would like to do first and foremost. I will say this angle QRP, okay, angle QRP is also going to be angle QSP, and that value is nothing but 41 degrees. And why am I saying that? Because they are angles in the same segment of a circle. So angles in the same segment of a circle, they are equal. So that is also 41. So I can just say QSP, this here is also 41 degrees. Okay, and then apart from that, if I look at this QRP also and RPS, this angle here, they are also going to be equal. It's 41 because they are alternate angles. So I can say angle QRP is also equal to angle RPS, this one here, and that is also 41 degrees. Why am I saying that? It's because they are alternate angles. So I'm doing another method of solving it, but eventually we'll still arrive at 82 as the same answer. Now, looking at this triangle from triangle APS, we can see that this theta we are looking for is exterior to these two angles. So we can say our QAP that we are looking for is going to be angle QSP plus angle RPS. Why? Because exterior angle of a triangle is the sum of the two opposite interior angles. Okay, in short, even for that, you can say first we want to look at this, that the addition of the 3 is then theta plus that angle is 180 because the angle on a straight line. So there are just so many ways you can choose to go about it, but I think I love this to say then in that case angle QAP is going to be, what is QSP? We have gotten QSP as 41 before, that is 41 degrees, plus what is RPS? We have gotten RPS also to be 41 degrees initially, such that the addition of the two is going to give us nothing but 82 degrees, just like we postulated originally. So you can also take this as an exercise. Look at so many other means in which you can try to solve this, but with this we've been able to solve the first question. You can now move to say we want to look for the solution to the second question. All right, now in the second part we have to find angle PQT. Let's identify that angle PQT. So we start from P. Okay, so we have P here and we are going to Q and then we are going to T. Now sometimes you have questions like this that you need to actually include the angle you are looking for. So in this case PQT is what we are looking for, and it is as shown here, and I will just try and color that so that we will get to see. So it is that angle that is shown in red. I can call that alpha. That is the angle that we are also looking for. So once we've identified like this, you can say we want to solve for this angle PQT that we identify as alpha. Okay, now looking at this particular diagram, originally in the question we are told that PT, this line at the base, is a tangent to the circle, and there is an angle that that tangent is making with this particular chord of the circle. So if I want to depict that out, I can say I'm looking at this angle here, and that angle and this particular one here, actually they are going to be the same, because that is what the alternate segment theorem is telling us. So I can say this is also nothing but 41 degrees. And why am I saying that? Let me just write it out, that I'm seeing that angle QRP, that is also equal to angle QPT, and the value is nothing but 41 degrees because it's the alternate segment theorem. That's one of the theorems in circle that is going to be useful for us, that the angle between the chord and the tangent of a circle is equal to the angle in the alternate segment. So that is what we are putting into play like this. And once we have gotten that to be 41, we can see that this triangle PQT is a triangle that we know two of its angles. We know 35, we know 41. We are looking for alpha. So we can say already angle PQT, which we are looking for, plus angle QPT, which got to be 41 here, plus angle PTQ that we are given, the sum of everything is 180 degrees. Why? Because they are the sum of angles of a triangle. Sum of angles of a triangle. And the sum of angles of a triangle is nothing but 180 degrees. Therefore, the PQT that we are looking for, which we call alpha here, we can say that that PQT plus QPT, which just got to be 41, plus PTQ, this one here, which we are given as 35, the sum of the three is 180 degrees, such that PQT that we are looking for is nothing but 180 minus the sum of these two. This will be 76 minus 76. So we have this as 180 minus 76. 180 minus 76. What's that going to give us? That is 104. So this is nothing but 104 degrees. And as beautiful as it gets, that is just the solution. You can also look at the diagram and look at the theorems that you can find useful to try and solve this particular question. There is not just one singular way to solve questions like this. No. Just like we saw in the first question, you can look at it. In short, I'm challenging you. Look at it and postulate other means by which you can get the solution, and just ensure that we arrive at the same answer and your work will be done and dusted. In this question of statistics, we are told that the table shows the height of players of a basketball team. This table here, we have to calculate correct to one decimal place in centimeters the mean height of the player. So this is a very good question asking us about mean. And what is the formula for mean? Mean, as typified in this case, will be summation of the product of frequency and data entry over summation of frequency. So which one is the frequency? Which one is the data entry here? This height, which we are asked to find the mean of, will be the data entry, and the number of players will have to be the frequency. Okay, so if we are to do that, we can just say for this case, the mean is going to be the product of each of these entry in the columns. So we sum them together. So we have 4 multiplied by 160 plus 6 multiplied by 161 plus 3 multiplied by 162 plus 7 multiplied by 163 plus 8 multiplied by 164, then plus 9 multiplied by 165. So that is summation fx. We are using that, and we are saying we'll be dividing everything there with summation f. That's the addition of all of the frequencies. So we have 4 plus 6 plus 3 plus 7 plus 8 and plus 9. So we just need to be careful to ensure that we put in the right values into the calculator. The first one is 160 and 4, 161 and 6. Okay, so I'm having 160 times 4 plus 161, let me just be putting it in bracket so that I don't make mistake, times 6, then plus 162 times 3 plus 163 times 7 plus 164 times 8 and plus 165 times 9. Okay, so what's that going to give us? That's 6030. So this mean is nothing but 6030 divided by, let's sum the frequencies. We have, okay, 4, 6, 3, 7, 8, 9. We have 4 plus 6 plus 3 plus 7 plus 8 and plus 9. 4, 6, 3, 7, 8, 9. So this is 37. So we have it as over 37. So this is going to be our mean height. So we have 60, 30 divided by 37. Okay. So this is 162.972. This bar means is being repeated. So 162.972972. So this is 162.972972 and repeated on and on like that. But look at this, we have to find it correct to one decimal place. Okay, so if you want to take it to one decimal place, that means one decimal place will mean that this is just the digit that we'll be considering, but we need to look at digit after it, and it is 7 greater than 5. We round it up to 1 and add to the initial digit. If we add 1 to this, of course it turns into 10. So that means it is 163.0 that is going to be the mean height of these players in question. So we can say our mean height is going to be 163.0 centimeters as the solution to this question here. In this question on probability, we are told that a bag contains 4 blue, 5 green, and 6 red identical balls. Now a ball is selected at random from the bag and then replaced before a second ball is then selected. So we need to notice that the first ball that was taken is always replaced before the second one is selected. That means this is actually a set of independent events because there's replacement of the balls. So our mandate is to find the probability that the balls selected are, in the first case, both are green. In the second case, one blue and one red. In the third case, all of the same color. So if you want to have a look at what we are talking about here, we will have something like this. And then looking at what we're told that there are some 4 blue balls, and after that we are looking at 5 green balls, and then in addition to that we are looking at 6 red identical balls. Okay, so that's what we have, meaning that from here we can know that the total number of balls that we have is just the addition of all of this, which is 4 plus 5 plus 6, and that will be 9 plus 6, that is 15 balls. So in this case, 15 is the total number of balls that we are looking at, and that's going to be the total number of probability that we could have gotten no matter the situation. But now let's take it piecewise. In the first case, we're talking about 2 balls, and they are saying we should find the probability that both are green. So we are looking at probability of the first one is green and the second one is also green. So it's probability of green and green. And in this particular case, what is the probability of picking a green ball? It will be the possibility of a green, which is 5, over the total probability, which is 15. But since we are talking about and, that means we need to multiply. Okay, again, in the second case, the ball would have been replaced, so the number of greens are still 5 and the total are still 15. So this is what we need to look like. We can of course see that we can have this as 1 over 3 multiplied by 1 over 3, such that that probability is 1 over 9 in the first case. Okay, now we need to be careful as we move on, because in the second case we are talking about probability of 1 blue and 1 red. Hey, so now is either we have that probability is, in the first case we have blue, and then in the second picking we have red, or the probability that in the first case we have red and then in the second case we have blue. So these are the 2 case scenarios in which we can have 1 blue and 1 red. So this is what we are going to have for 1 blue and 1 red. It's either we pick blue first and then red after, or we pick red first and then blue after. So if we want to look at that, for that too, that means we are looking at, let's use the guide of what we have there. That means that for blue is 4 over 15. That's probability of picking a blue ball. But now we are saying and red, it would have been replaced, so it will still be 6 over 15. And then when we are having or means addition in probabilities, we have plus. Now red first will be 6 over 15, then and blue, that will be 4 over 15. Okay, or we can even simplify that this is nothing but 2 multiplied by 6 over 15, because it's the same thing, okay, times 4 over 15. So we can use our calculator to try and evaluate this, to say we have 2 into bracket, first we have 6 over 15, then we are multiplying that with another fraction, which is 4 over 15. Okay, so we can close that, check that we are on track, and that is what, 16 over 75. So this is 16 over 75 as the probability of picking 1 blue and 1 red. Okay, and then in the third case, again, we need to be careful here. We are to find the probability that the 2 balls selected are of the same color. Okay, in this case, what we are going to have for them to be of the same color will mean that in the first case we are picking either, okay, let's start with the order in which we are giving. In the first case we are picking blue and blue. In the second case we are picking green and green. In the third case we are picking red and red. So in the first case, that means we are having probability of blue and blue, plus in the second case we are having probability of green and green, okay, plus in the third case we are having probability of red and red. Okay, so this is what we actually need to work with to say we can get this. And for us to solve this, it's going to be that blue and blue will be 4 over 15 times 4 over 15. Okay, then green we have 5 over 15 times 5 over 15, then red plus 6 over 15 multiplied by 6 over 15. Okay, so this is what we can make use of now. Okay, let me just reduce my work area a bit. So in this particular case, I will just want to leave the base as the same and just multiply the numerator. 4 times 4, that is 16. 15 multiplied by 15, what's that going to give us? 15 times 15 is 225. So this is 225 plus, 5 times 5, that's 25 over 225. Again, 6 times 6, that is 36 over 225. So what I'm going to have eventually is that I'm having the addition of these three, 16 plus 25 plus 36, that's what 77. So I'm having this as 77 over 225. You can leave as this, or you can say you want to say this answer, which is 77 divided by 225. What's that going to give us in decimal? 0.342. But since I've been putting everything in fraction, let me just leave this as fraction also. So it's the understanding of the fact that these are independent events that really helped us to solve this, and we got our answer as shown here. Okay. In this question on trigonometry, we are told that given that sine 5x minus 38 degrees is cos 2x plus 16 degrees and x is having its range of values between 0 and 90, we are to find the value of x. Now, for us to really understand this, I've come up with this triangle that I will help us to understand, because we are being told that actually x is between 0 and 90. Inherently, this is calling it nothing but a right angle triangle. And for a right angle triangle, if we have one of its angles to be 90 already, this is 90, I want to look at the other angles. In this case, if I call this theta, by reason of the understanding that the sum of angles in a triangle is 180, 90 is out of it already. Now we are taking theta out of the remaining 90, so this place definitely will have to be 90 minus theta. And you want to apply trigonometry identity SOHCAHTOA. Let's just take it piecewise. That what is, let's just take sine and cos of one single case, and I believe we should be able to get the other one. So if I say sine theta, in this case, what is sine theta? This is theta. Sine theta will be opposite over hypotenuse. And what is the opposite of theta here? It is this C. So that is C over, what's the hypotenuse in this case? It is B. Okay. If you are observant, this C over B is also going to be the cosine of 90 minus theta, because what is cosine? Cosine is adjacent over hypotenuse. So for 90 minus theta, what is the adjacent? It is C. What is the hypotenuse? It is still that B. So we can say this is also going to be cos 90 minus theta. As a rule of thumb, we just have it that sine theta is always equal to cos 90 minus theta. Okay, so I took time to actually explain that, because that is what will help us to solve this question that we have here and demystify it holistically as expected of us. So in that case, I can say, since we're having that sine of this angle is equal to cosine of this angle, that means that inherently I can say let 5x minus 38, let this be my theta. Okay, then in that case 2x plus 16 will be what? 90 minus theta. I hope this is well understood. Okay, it is this that will help us to really solve this question. And then if I'm to just tag it as this is equation 1 and this is equation 2, I can simplify equation 1 to say I have it as 5x minus theta is equal to 38. I just collect unknown terms to the left hand side, and then in this second case I have 2x, then this minus theta, when it comes to this side, it becomes plus theta, is equal to 90. When 16 I subtract from both sides, it will knock out from this left hand side. On the right hand side, 90 minus 16, that will be 74. So I have these two equations that I can say I want to solve. Since I have negative theta, positive theta, I can add the two together. So if I'm adding them, 5x plus 2x, that will be 7x, is equal to 38 plus 74. 38 plus 74, this is 112, is equal to 112. Such that if I divide both sides by 7, I'm going to have x is equal to 112 divided by 7, and I can use my calculator to say 112 divided by 7 is going to give me what? 16. So this is nothing but 16 degrees. So for this particular equation that we are giving, and the fact that x is taking its value between 0 and 90 degrees, this is going to be the answer to this question. And we are coming from that because of the understanding that sine theta is nothing but cos 90 minus theta. All right. In this beautiful question on mensuration and triangles, we are told that in the diagram, mn is 15, mo is 3x minus 1, no is 3x plus 4, and angle OMN and angle PON and angle MNP are all right angles. So we have this angle, and this angle here. They're all right angles. Our mandate is, in the first case, to even find the value of x. Looking at this particular diagram, we can say, using Pythagoras theorem on the triangle MNO, this triangle MNO, because we are seeing that it's a right angle triangle with a right angle here, we can say, see, this longest side is 3x plus 4, this is 15, and this is 3x minus 1. In that case, we can have it that 3x plus 4 raised to power 2 is equal to 15 square plus 3x minus 1 raised to power 2. This is the application of Pythagoras theorem, and we're quite on track to say we want to use this. Now, there are so many ways you can say you want to go about solving it, but for me, I think if I can use difference of 2 squared, that will simplify my work. So I can say 3x plus 4 square minus 3x minus 1 square is equal to 15 square. So for difference of 2 square, that means instead of having all of this, I can just have it as 3x plus 4 minus the whole of this. But I need to put it in bracket, 3x minus 1, then multiply by, that is the difference. Now, the sum, 3x plus 4 plus 3x minus 1, this is going to give me 15 square. Okay, so this is just applying the law of difference of 2 square, that a square minus b square is a plus b multiplied by a minus b. That's what I applied in this particular line for this as a and this as b. Okay, so once we are able to do that, we can now go ahead to say we want to simplify this to say what we are now having is nothing but, look at this, this 3x and this 3x, they subtract each other. 4 minus 1 will become 4 plus 1, so that will be 5. Okay, and then in this case, what we are having is 3x plus 3x, that is 6x. Okay, 4 minus 1, that is 3. This is equal to 15 square. 15 square is 15 multiplied by 15. So if I'm dividing both sides by 5, 5 here 1 and 5 here will just be 3. Even 3 can still go, but don't let me flog the horse. Let me just try and solve it now. That I have 6x plus 3 is nothing but 15 times 3, that is 45, such that 6x is 45 minus 3, and that is 42. So dividing both sides by 6, x will be nothing but 42 over 6, and that will be 42 over 6 is nothing but 7, and the unit will have to be centimeter because it is included in this centimeter. So that is the value for x. You can as well just try and say you want to expand this bracket, find it in the power of x raised to power 2, also this one in the power of x raised to power 2. You will eventually see that we will arrive at the same answer. But working smart is quite better than just working unnecessarily hard. That's why difference of 2 square helped us to solve this question, and we got x as 7. Okay, so that being said, I can look at a scenario now in which I'm having, since x is 7, 3x plus 4, that will be 3 times x, that's 21 plus 4. So this is actually 25 centimeters. In this particular case, 3x minus 1, 3 times x, 3 times 7 is 21, 21 minus 1. So this place is actually 20. Okay, so this is 25, this is 20. We can go ahead to say we want to find the area of triangle MNP. So let me just clear this space here now to say, now in the second part of the question, in this B part, We want to find the area of angle MNP. Okay, that's interesting now because this is actually looking like a trapezium in which you can say the area of MNPO is going to be 1/2 multiplied by the sum of the parallel sides, and that will be okay, how best can I label this now? Let me just call it A plus B multiplied by the height h. In this case, h is actually 15. H is 15 centimeters. All right, and then we know this. If we say this is A, that 20 is A. This A is 20. This is B. But we need to find B also because this side and this side, they are parallel. For them to say this is a right angle and this is a right angle, then this is actually parallel to this. So just leave this center first. Let's get that right, that this is A, this is B, and then 15, this is actually our H. All right, so if we have that, we can look at a means of finding B, and this is what I want us to do. In this particular lower triangle, we have all of the sides, so we can get any of the angle. Then I will notice that this particular angle, because these lines are parallel lines, ON is a transversal across those parallel lines. So this angle is also equal to this angle. So if I call this theta, this is also theta. So I can just note this is theta, right? Then I can relate the properties of triangles, trigonometry identity in this case, since we have it as two right angle triangles. I want something that will relate this side, which is the hypotenuse of the lower triangle, and yet it is the adjacent of the upper triangle, and yet I'm talking about theta. Okay, so let me say from triangle MNO, sine theta is opposite over hypotenuse, that is h over 25. Okay, and of course h was 15. Sine theta is 15 over 25, which is, of course, 5 can go 5. So that is 3 over 5, such that theta is arc sine 3 over 5. Can we get that? Yes, we can. So what is arc sine 3 over 5 is 0.6. This is 36.8698, or let me say 36.87. So this is 36.87. But that is not all. Also from triangle, this is what we are trying to find. It is this B. Okay, so from triangle PNO, I can say this 25 now is now the adjacent of that triangle, and this B is now the hypotenuse. So what is relating the adjacent and the hypotenuse? It is cos, because we have it as SOHCAHTOA. So we have the adjacent, we are looking for the hypotenuse, and of course we know the angle. It is cosine that is relating that. So I can say cos theta is going to give me the adjacent, which is 25, over the hypotenuse, which is B that I'm looking for, such that B is nothing but 25 over cos 36.87, which is the value for theta. So I can take my calculator to say 25 divided by the cosine of the answer that we just got. And what's that going to give us? This is 125 over 4, or 31.25. So here I can say this is 31.25 centimeters. Now, having that, I can now use this formula for the area of this trapezium, that it is half A plus B H. H is 15, of course, that is good. A we have gotten as 20, so let me just fill in those values. A we got as 20, and now B we just got as 31.25. So with all those parameters, we can say the area of MNPO is nothing but 1/2 A plus B. A is 20 plus 31.25 multiplied by the height H, that is multiplied by 15. So Let's put this into the calculator to say we have 0.5, to say we have 0.5 multiplied by 20 plus 31.25. I'm closing that bracket, then multiply by 15. Okay, so this is, that's 384.375. So we have 384.375 centimeters square as the area of this particular shape MNPO, which we identify to be a trapezium. In this question on simple interest, we are told that Mr. Safo borrowed $25,000 from Efia Financial Services at 21% simple interest per annum, and he did that for 3 years. Now, he was able to pay back the loan in 2 years at equal yearly installments. So that means that he paid the same amount of money each year, and he paid that for 2 years. So how much did he pay each year? Let's look at the question on simple interest. We already know that normally simple interest is principal times rate times time over 100. And if we identify all of this from the question, we can see that the simple interest to pay additionally on the amount is borrowing will be the principal, which is the amount that is actually borrowed, multiplied by the rate. We are giving that as 21%. Okay, multiplied by the time. The time was originally for 3 years, and we can divide this by 100. So these zeros can cut out. So what we have here, we can use our calculator to say 25, okay, 250 times 21 times 3. So that simple interest is $15,750. Okay, so that is the amount that is going to be the interest capitalized on what he already borrowed. So the total amount he needs to repay, total amount to pay back, will be the addition of that capital originally, which is $25,000, plus this simple interest, which is $15,750. And if we are to evaluate that, so we add this plus 25,000, that is $40,750. Now, this is the amount that he needs to pay back. However, we are told that he paid back the full loan in 2 years at equal yearly installments. So for us to get how much he paid each year, we just need to divide the total amount that he needs to pay divided by 2. So amount he paid per year will just be half of this total amount that he needs to pay that we just got. So we can divide that and say that with this it will be 27 divided by 2, that will be 3. 15 divided by 2, that will be 7 and 5. Okay, so that's the division, that the amount he's paying per year will now be $20,375. All right. Here in this word problem, we're told that 2 consecutive numbers are such that the sum of thrice the smaller and twice the larger is 17. We're to find correct to 3 significant figures, the smaller number as a percentage of the sum of the 2 numbers. So don't let's be intimidated. Let's just take this piece by piece. If you take those 2 numbers to be x as the first one, we are told that there are 2 consecutive numbers. So the next one will be x plus 1. So x can be anything. If x is 1, the next one will be 2. So we have 1, 2. And you can see they are consecutive. If x is 13, the next one will be 13 plus 1. That will be 14. That's why we have x and x plus 1. Okay. So once we have that, as what we're given, we're now being told that the sum of thrice the smaller one. Now here the smaller one is x, and they're talking about thrice, so 3 times x. Then we're talking about the sum plus twice the larger. Twice the larger will be 2 multiplied by x plus 1. Okay, so that sum is equal to 17. Okay, I think we have this and we should be able to solve this and get at least we can get the smaller number. Okay, so if you open up this bracket, we have 3x plus 2 times x is 2x, and 2 times 1 is 2 is equal to 17, such that 3x plus 2x is 5x. When we subtract 2 from both sides, here it will be 17 minus 2, which is 15. So 5x, we can say is equal to 15, and divide both side by 5, we can have x to be 15 over 5, which is 3. Now, that means the numbers that we have are x is 3, and then the next number consecutively will be 4. So these are the two numbers, but this is not where we're supposed to stop. What we have to find is correct to 3 significant figures. We have to find the smaller number as a percentage of the sum of the two numbers. So that means what we are looking for is the smaller number, which is 3, as a percentage of the sum. The sum will be 3 plus 4, then as a percentage will be times 100%. Okay, so this is what we are inherently going to look for, and this will give us 3 over 7 multiplied by 100%. Okay, so we can bring in our calculator to evaluate this. So we have 3 multiplied by 100 divided by 7. Okay, so in decimal this is 42.857. so this is 42.857%. but look at what we have. So we are told to get that correct to 3 significant figures, and if we want to do that, we can just say this is approximately 3 significant figures. Means that 3 digits is what we are going to write. So we can write the first two, 42 points. Now, to write the third one, we need to consider the number after it. 5, we round it up to 1 and add to this, so it will be 42.9%. That is going to be our answer for this question. All right. And pay serious attention to if you really want to get it. We are being told that a man left town M at 10 a.m. and traveled by car to town N at an average speed of 72 kilometers per hour. He spent 2 hours for a meeting there and returned to town M by bus at an average speed of 40 kilometers per hour. If the distance covered by the bus was 2 kilometers longer than that of the car, and he arrived at town M at 1:55 p.m., our mandate is to calculate the distance from M to N. Wow. Okay. Student, you don't need to be frightened. Just interpreting this correctly will give you the solution to this on the fly. Okay. First and foremost, I would like to define that we know speed to be distance over time. Okay. And in this particular case, because we have been given the speed, okay, we are looking for the distance. But from the information that we have, we can deduce the time for this particular journey. So I want to make T the sort of the formula here to say the time will now be the distance divided by the speed. Okay, so this will be a very good guide for us to try and solve this. And looking at the information that we are given, originally we are told that this man, he left at 10 a.m. and then he spent 2 hours at town N before he now returned back to town M. And obviously the route he took was different from the one he took originally, because we're being told that when he took the bus, the distance was 2 kilometers more than when he took the car. Okay, so that inherently means that he took another distance, but the distance we are being asked here is actually the distance that he took by car. Okay, so we can deduce the time that this man used here by saying that that time will be the time he arrived back at town M, 1:55 p.m. minus the time that he left the town M already, minus 10 a.m. Okay, let me just specify that as p.m. so that we will not mistake that. Minus 10 a.m. minus the 2 hours that he spent at town N. So I will say minus 2 hours. Now, 1:55 p.m. is the same as if we are having 13:55. Okay, minus 10. Okay, that is just 10. Then minus 2 hours. So this will be nothing but 10 and 2 will be 12. So it's as if we are having 13:55 minus 12. That is 1:55. Okay, now we're going to be working in fraction, and 1:55 is not ideal for our fraction, so we need to express it as a fraction. That will be 1 hour 55 over 60, because 60 minutes make 1 hour. This is like 1 hour 55 minutes, but we need to convert it totally to hour, because our speed was even given in per hour. You can say 73 kilometers per hour, 40 kilometers per hour. So we just do well to append it like this. And if we want to do this, this will be 5 can go in 55, that will be 11. 5 can go in 60, that will be 12. So it is one whole number
11 over 12 hours. Okay, that is the timing that this man took for the journey, both from town M to N and from town N back to M. We have considered the 2 hours that is spent for the meeting and we have taken that out. So this is what we have holistically. So that is a very good starting point for us. But we also need to note that this particular time included his to journey and his fro journey. That means we can say that this total time that we are looking at is equal to the time from M to N plus the time from N back to M. So this is where it gets interesting now. So that time, okay, I can even say this is 12 times 1 is 12. 12 plus 11 will be 23. So I can say what we're having here is 23 over 12 hours as the total time is equal to what is the time taken from M to N. Here we define it as distance over speed, okay? What is that distance? It is x that we are looking for in kilometers over what is the speed? It is 72 kilometers per hour, okay? Plus the time the man spent from town N back to M. I hope this will be clear for you students. It's just these little breakdowns that will help us to solve this holistically, okay? So that will be what's the distance from N back to M. We are being told that now it is x plus 2 and we are dividing it by the speed that is using from N to M, and that will be 40 kilometers per hour. So 40 kilometers per hour. This is the equation that we need to solve for us to get the distance from M to N, which is actually x, okay? So once we are able to get that, we should be good to go and everything will be fine for us, all right? So this is what we have as our equation coming from our solution so far, and we can just find the LCM and try and see what we are going to have. This is going to be here on the right hand side. The LCM, I just want to walk straight and not try to be factoring out. I just want to say 72 and 40, that will be my LCM. Here, 72 times 40 divided by 72 is 40, so I have 40x plus here. Now, 72 will be multiplying the two terms that we have as the numerator here. So I have 72 multiplied by x plus 2. So students, I hope that will be clear enough for you, such that with this, if I cross multiply, this is what I'm going to have, that 23 times 72 times 40 is equal to 12 multiplying the whole of 40x plus 72x plus 72 times 2 will be 144, okay, and I can now bring in my calculator to just punch in this number. Okay, I can still simplify this, but let me just take it piecewise. 23 times 72 times 40, 66240 is equal to 12 multiplied by 40x plus 72x will be 40 and 72, that will be 112x plus 144. Okay, so 12 I can actually use to divide both sides to say 112x plus 144 is equal to 66240 divided by 12, and that will give us what? So that answer divided by 12, this is 5520, such that 112x will be 5520 minus 144. So that will give us 5520 minus 144, 5376, 5376. And with all of this now, I think I can just move my work a bit up. So having known that, what we are left with is that 112x is equal to 5376, and we divide both sides by 112. That means that x will be, this will cut. So we have what we are having initially, 5376 divided by 112 as our answer. Wow, okay. So x will be 48, and what is the unit? It is kilometer, because it is distance. So it's just as we took our information piecewise and just stick with the consistency that we know will eventually land us on the answer. that we're able to arrive at our final answer as x to be 48 kilometers. So that is a very good approach for us to take. If you have word problem like this, we don't need to fret. We just need to be consistent with what we are doing. And here, I ensure that if I'm opening up the bracket, it may give me some headache. So I stuck with the base means of solving this. Open up the bracket by multiplying the whole numbers together and eventually working out the algebra and finding the final answer as the distance from town M to N to be nothing but 48 kilometers. All right. In this question on bearing and distances, we are told that the point X, Y, and Z are located such that Y is 15 kilometers south of Z and Z is 20 kilometers from X on a bearing of 270 degrees. We are to calculate the distance YZ to two significant figures and the bearing of Y from Z to the nearest degree. Okay, to look at this question, we can see that in the first case, Y is going to be south of X and then Z is also from X on a bearing of 270 degrees. So our point of interest where we need to start from is point X. And for us to just pick that, if we just say south of X will be down and then 270 degrees of X will be just to the left of X. So we can just look at a convenient point and say if you want to call this X and we are taking this as north, south, east, and west of the point X. So here we have our X here. First, we want to look at a scenario in which we are drawing south of X, which will be 15 kilometers, and that will take us to Y. So we can say here, at this point, we are having Y, and this distance is 15 kilometers, okay? And then we're also told that Z is 20 kilometers from X on a bearing of 270 degrees. And now, for us to take 270 degrees, we know north to east, that is a right angle, that is 90. East to south is another 90, making 180. South to west is another 90, making 90 plus 180, and that is 270. So, inherently, we are saying that 270 is actually to the west of point X, and that is 20 kilometers. So, just a bit longer than 15, and I think this will be good. Maybe I just need to move this a bit. And then this will take us to point Z, and Z is 20 kilometers from X. Then we can just finish up our diagram to say here we are having Z and Y, they can be linked like this. So in the first case, what are we have to find? The distance YZ. So this is YZ, and since it is opposite X, we can just call that small x. So this is small x. By looking at our diagram, we can see that what we're having here is nothing but a right angle triangle, because this here between the south and the west is 90 degrees. And for us to find x, we can make use of the Pythagoras theorem. So we want to say in the first case, the first question, by the Pythagoras theorem, we can just evaluate this and we'll be good to go. So in this particular case, we can just say that means that s squared is nothing but 20 squared plus 15 squared. Okay, so s squared itself will be 20 squared will be 400 plus 15 squared will be 225, so that the addition of both will be 625, and x, which is actually the line yz that we are looking for, will be the square root of 625. So we have square root of 625, that's 25. So this is even a perfect square. We have to find it correct to two significant figures, and we can see this is already in two significant figures, and then the first solution is out and we are good and fine. In the second case, we have to find the bearing of y from z. That means that we need to go to z, and at z we need to compute the bearing that we can get to locate the point y. So on z, if we draw our cardinal point just like here, we need to start from the north, we have the south, we have the east, and we have the west. Okay, no problem. So now we want to get the bearing of y from z, so we are taking it from z. Here we can see that first this is 90 degrees, okay, and we can get this angle here, if I call that angle theta. So the bearing of y from z will be coming from the north and computing to the inclination of y from z, and that will be 90 plus this theta. So our mandate is to find this particular theta. And looking at the theta, we can use whatever we want to use by SOHCAHTOA. I think SOHCAHTOA will be very good for us. If we want to use SOHCAHTOA, we can say for this particular one, the opposite is 15, the hypotenuse is x, which just got to be 25. So we can say from here, sine theta, since we have the value of all the sides, we can even use anyone we like, maybe cosine or tangent, but I think I just want to use sine. Sine theta from this particular diagram will be the opposite, which is 15, over the hypotenuse, which is x, and that is 25. So theta will be arc sine 15 over 25, 5 can go, that will be arc sine 3 over 5. And if I want to compute that, 3 over 5 is actually 0.6, but I can just say I want to impute it directly. Arc sine, here I have 3, and then at the base I have 5. So I can go out, close the bracket, and solve for this. So this is 36.86989. Let me just take it as 36.87. Okay, so this is 36.87. But the bearing that we are looking for, that bearing, we have already identified it as 90 plus theta. So that will be 90 plus 36.87, and this will give us nothing but, we want to solve this, 90 plus 36.87 will be 126.87. But look at what we are given. We are asked to find it to the nearest degree. Even if you are not asked to find it to the nearest degree, bearings are only written in 3 digits. You don't put decimals in bearings. So this will be approximately, 3 digits will be 1, 2, 3. But we need to consider the other numbers and round them up or down as appropriate. 8 will have to be rounded up to 1 and added to the initial numbers. So this will be 127 degrees. And with that, we've been able to solve this question on bearing and distance as requested. All right. In this question on circle theorems, we are going to use our understanding of the circle theorems and triangles to solve this question, and we'll be fine and dust it easily without any problem. So we are told that in the diagram, the line AD is the diameter of a circle with center O. So this is the center. Then if ABD is a triangle, ABD is a triangle in a semicircle. Okay, that's interesting. An angle OAB as given here is 34 degrees. We have to find angle OBD. So let's find that OBD. So this here, that's the angle we are first to find. If I call that X, and then angle OCB, OCB. So here, that's how you actually get the angle. I will call that Y. And these are the highlights of what we are expected to solve for in this question. So let's look at this diagram holistically and try and postulate what we can get from this. In the first case, I want to notice that the line from the circumference of the circle to the center is always the radius. So AO, here, this is the radius, and OB, this is also the radius. Interestingly, this here is also the radius, but I don't think we need that. But looking at this, meaning that triangle AOB is an isosceles triangle, and if it is an isosceles triangle, we know that the base angles of isosceles triangles, they are equal. So this angle here, that's going to also be 34 degrees. So I'm going to say that angle OAB that we are given is also equal to angle OBA, and the value is nothing but 34 degrees. Why am I saying this? Because they are base angles of isosceles triangle. So normally, if you are solving your questions, make sure you write the reason why you are postulating those theories. Okay, so with that, we have taken a very huge step that can help us to solve this holistically. In the second case, I can look at this particular triangle and say that since we are giving AD to be the diameter of the circle, and we have ABD at the circumference, then there's another theorem that tells us that the angle that is subtended by the diameter of a circle at the circumference is 90. So this inherently is nothing but 90. So I have it that the angle ABD, that is nothing but 90 degrees. And why am I saying that? It is angle subtended by diameter at the circumference. So I hope students you get this. Angle subtended by the diameter at the circumference. That is why ABD, that is why it is given as 90 degrees. And if we look at this, you can see that at point B, we are seeing that angle OBA, and angle OBD, which we are looking for, OBD. The two of them, they sum up to be the right angle 90 degrees, which is ABD. So let me just write that appropriately. They sum up to be angle ABD. That means inherently what we have is that, what is OBA? OBA is 34. So we have 34 plus OBD, which we are looking for, that is X, is equal to ABD, that is 90 degrees. So students, I hope you can get this on the fly such that X can be 90 degrees minus 34 degrees, and this is nothing but 56 degrees. And with that, we've been able to solve this question that angle OBD is 56 degrees. That is fine, good, and dusted. In the second case, for us to get this angle OCB, we'll notice that this line BC just touches the circumference only at a single point. So that is rendering it as a tangent. This is a tangent to this particular circle. Okay, so if we get that to be a tangent, then we also know that the angle between the tangent of a circle and the radius, and you can see BO is actually the radius of this particular semicircle. The angle between them is also 90. So I can also say angle OBC is nothing but 90 degrees. And why? It is angle between tangent and the radius of a circle. So if I put that, that is going to help me to solve this question holistically, because having gotten that, if I can find this angle here, I'll be able to sum this angle in blue, let me call that A, plus the 90 that is OBD plus Y, and equate them to 180 degrees, because they are the sum of angles of a triangle. Since I know that, I can now look at this. How do I find A? There are two methods you can use, whichever is suitable. You can say that A is the exterior angle of the triangle AOB, in which the interior opposite angles are 34 and 34, so that A will be 34 plus 34. Or you can say that A is actually the angle subtended at the center of the circle, whereas BAD is angle 34. And by reason of the postulate of the circle theorem, we can say that the angle subtended at the center of a circle by a chord, so the chord is BD now, this angle subtended at the center is twice the angle subtended at the circumference. So whichever one you want to postulate, just say it, and you'll be good to say. Here, I will just say angle A, which I got to be angle OBD, is equal to 2 times angle OAB, and that means it is 2 times 34, which is equal to 68. And why am I saying that it is angle subtended at center O is twice angle at circumference? So again, I'm just using shorthand here, students, just for you to understand, so that you know how to write it in your exam, and that is getting us the value of angle A. Then from the triangle OBC now, triangle OBC, we can now see that A, which you just got, plus, okay, let me just even use the notation. A, we have it as OBD, angle OBD, plus angle OBC, plus the angle we have to find, OCB. The three of them is going to be 180 degrees. Why? They are the sum of angles of a triangle. Okay, so don't let me just, I have very little space left, don't let me write that. I'm stating this because they are the sum of angles of a triangle. And since I have that, I can now say, what is OBD? OBD, we just got to be 68, so I can say 68 plus OBC, we have gotten that to be 90, okay, plus the angle we are looking for, OCB, plus Y, that is 180 degrees, such that the Y that we are looking for is 180 minus the sum of 68 and 90 is 158, and if I subtract that, this will be 22 degrees. So 22 degrees, which is OCB, is Y, and X, which is 56 degrees, is angle OBD. And with that, we've been able to solve this question by making use of our understanding of triangles and the circle theorem, and we are good and fine. Here we have a question on statistics in which we are asked to represent the information here on a pie chart, which is showing the way a man shared this property among his children. And now, if we want to do that, we can have this particular table that is going to help us put this information on a pie chart. This information was given in percentages, so you can see this was percentage share. So for the percentage share that we're given, that means that we need to look at all of these percentage share and ensure that they need to add up to 100. Like we say, 5 plus 15 is 20, plus 10, 30, plus 45, that's 75, plus 25, so this is 100%. And for us to get the corresponding angle that will be aligning with each of these percentage share, we need to calculate that angle. And in the first case, what we just need to say, the particular share of each child over the total, which is 100, multiplied by 360. And that 360 is going to be reflective of the angle that the share will represent on the pie chart. You can see this is a fraction of the percentage multiplied by the total number of degrees that we can have on a pie chart. So this is what we are going to do, and for each one we are going to have just the same thing. I just want to use the calculator to show students how you can do this on the fly, okay? Particularly if you have access to a calculator that can be intuitive, this can just be on the go. You can get this straight and fine, okay? So here is the calculator. I just want to put in this over 100, then I want to multiply by 360. So I'll just calculate what's the value of x in the first case, 5. So that is 18. I want to calculate again the value of x, 15, that's 54. The value of x again, when x is 10, that is 36. The value of x when x is 45, that is 162. And the value of x again when x is 25, that is 90. So we can have all those, and we just need to pull them and put them in this particular place. I think initially we got 18, and then if you're observant, 5 and 15, actually 15 is 3 times 5. So the next value here also, if you can get that first one, you can say this is 3 times 18, and that will be 54. Okay, for 10, that will be 18 times 2, this will be 36. Then for 45, that 45 will be the value of 15 times 3, because 45 is 15 times 3, so it is this 54 multiplied by 3, and that is 162. And then this is 25, is like 5 multiplied by 5, so 18 multiplied by 5, this is 90. So that's another way you can just go ahead to try and solve that. Just be intuitive to know that you don't need to be stereotyped to use any method. Just use what can be convenient, and these are tips that can help you be very fast when you are calculating. We also need to sum all of this to ensure that they add up to 360 so that we can represent them appropriately on the pie chart. So if you want to check that, you can say 18 plus 54 plus 36 plus 162 plus 90. What's that going to give us? So we're on track. This is 360, so we can say that this sum is 360. And then the onus is lying on us to now put all of this information on the pie chart, okay? And for us to put it on the pie chart, I just want to start with 90, because I know that 90 is a right angle. So this is looking like the center of the circle. So 90 can just go straight like this. So that will be Akosua. I will still label. Then which one am I seeing again that I can put very representative was 162 is going to be almost 180. 180 is going to be a straight line coming from down to up. So 162 should not be up to 180 like this. So it should be maybe something like this, 162. I think it should be fine. All right. Then we have 18, 54, and 36. And we are looking like, we are saying that these are in ratios 5, 15, 10. So this is like ratio 1, 2, 3. Okay, 1, 2, 3 means that maybe you are dividing it into 6. 1 plus 2 plus 3, that is 6. So one is going to take like half, the other is going to take like 2. So half of this, let's say this is half of it. All right, this is half. So this is taking 3. So this is another 3. Then one should take 2 and the other should take 1. So I think this should be a very good representative of what we have. Just pictorial like that. And then don't forget to label after doing all of this. you can now say you want to label who is having 90 degrees. So let's say we have this as 90, that is Akosua, and that is a right angle. And then who is having 162, that is Nuno. So here we have this is 162, and what is 162? That is for Akosua. Okay, and then the one having the larger out of the three is Afia, that is 54 degrees. So we have 54 degrees, and that is for Afia. Okay, and then we have 36. 36 will be for Kiji. So here, this is 36, and that is for Kiji. And then 18 will be for Anne. So here, this is 18 degrees, and it is for Anne. And with that, we've been able to just look at this and put in the information as we are requested. This is 90 degrees. And we have answered this question holistically as expected of us. All right. Here in this question of probability, we are told that a box contains 5 red, 3 green, and 4 blue identical bits. Our mandate is to calculate the probability that a girl takes away 2 red bits, one after the other, from the box. So what we need to know is that we are looking at probability in this case, and probability as has been defined is actually the ratio of your desired outcome over the total possible outcome that you can get out of a case scenario. Okay, desired outcome will be what we are looking for. Possible outcome will be the total number of instances that we can actually have to be occurring. Okay, now for this particular case, we are saying that a girl is taking out first and foremost 1 red ball, and to take that 1 red ball, we can actually see that from here the total balls that we have will be 5 plus 3 plus blue. So now the possible outcomes that we have in this case, since we are picking out balls, okay, that will be 5 plus 3 plus blue, which is the total number of balls. So we have 5 plus 3 plus 4, and that will be 5 plus 3 is 8 plus 4, that is 12. Okay, and then we are told that it is one after the other. That means we need to look at the probability of picking a first red ball, and how many number of red balls do we have here? 1, 2, 3, 4, 5. So we have 5 over 12. Okay, and then we are told one after the other, meaning that after taking out that first red ball, this is out already. What do we have now? We have the total possible outcome to now be 11. So after that, the possible outcome for second, this is for first, will be the number of red balls is now 4 plus the 3 green balls plus the 4 blue balls, and that will be 11. And then the probability of picking a second red will now be, how many reds do we have remaining? 4 over the total 11. So the probability that the girl takes away 2 red balls one after the other will be the product of these two. So we have 5 over 12 multiplied by 4 over 11, and 4 can go here, 1, 4 in 12 is 3. So we have 5 times 1, that is 5, 11 times 3, that is 33. So 5 over 33 will be the solution for this question in this particular case. In this question on set theory with Venn diagrams, we are told that in a class of 80 students, so we can say the number of students in our universal set is 80. Okay, 3 over 4 study biology. So the number of those who are studying biology is 3 over 4 of 80. Okay, because the 3 over 4 of this 80 is studying biology, and if we are cutting that, 4 in 80 is 20. So we have 60 to be the number of students studying biology, and 3 over 5 studying physics. So if we say P is physics, that will be 3 over 5 of 80, and if we cut 5 in 80 is 16. So 3 times 16, that is 48. Then if each student studies at least one of the subjects, that means that there is no student studying neither biology nor physics. At least students will need to offer at least one of the two. Okay, so we have to draw a Venn diagram to illustrate the information, and then to also get how many students study both subjects. So I have this particular template for our Venn diagram, and if I call the student that study both, if I call that X, the biology already you have been told is 60. So here, those who study biology alone will be 60 minus X. And physics we have been told is 48. So those who study physics alone will be 48 minus X. While X represents the student that study both biology and physics. So I can say number of biology and physics is X. Okay, so that is the key point for us to note here. Okay, and then looking at this particular question, what we need to do is that since we have the total number of students to be 80, the addition of those who study biology alone and those who study biology and physics and those who study physics alone will culminate into 80. So we can just say for this particular question, if we add everything, 60 minus X plus 48 minus X is going to give us 80, which is the total number of students that we are looking at generally. Minus X and X will cancel out. 60 plus 48, that will be 108 minus X is equal to 80. And if you rearrange, X will be 108 minus 80, and that will be like 100 minus 80 is 20. Then with the 8, we have 28 students. So 28 students are those that study both subjects that we identified as biology intersect physics. Okay, so here our Venn diagram is question number 1. The number of those that study biology and physics is question number 2. We now need to get the fraction of the class that study biology but not physics. Okay, so now in the third question, we have to find the fraction of the class that study biology but not physics. That means we are looking at number of those who study biology but not physics. We mean complement of physics. Okay, and then we are dividing that over the total number of students in the class, and that particular region that we are looking at will be nothing but this region here, and that will be this region here. Okay, divided by the total of the student, because these are those who study biology only. You can see physics is not included. Those that study physics only and those that study biology and physics, we have excluded them. So it is this shaded region that we are looking at, and that is nothing but 60 minus X. So if you want to reflect it, you can just say this is nothing but 60 minus X, which we already got to be 28, divided by the total number of students, that is 80. If you are just to do this, this will be 32 over 80, and for 32 over 80, we have 16 in 32, that is 2, 16 in 80, that is 5. So the fraction of the class that study biology but not physics is nothing but 2 over 5. And with that, we've been able to look holistically at this question, interpret the question correctly, and give the answer as requested. All right. In this question on commercial mathematics, we are told that Johnson and Jokato Limited owned a business office with floor measuring 15 meters by 8 meters, and that floor was to be carpeted. Okay, now the cost of carpeting was 890 Ghanaian cedi per square meter, and if a total of 216,120 Ghanaian cedi was spent on painting and carpeting, our mandate is to find how much was the cost of painting. So we can look at that floor just as represented, and we have it as 15 meters by 8 meters. Now, from the information that we are given, we have been told that the cost of carpeting was 890 per square meter. So that is per square meter. But now the area of the floor that we are looking at in this particular case was given as 15 meters by 8 meters. So if you are to compute that, that will give us, let's look at our calculator, 15 times 8. So that is 120 meters square. So this is 120 meters square. But we are told that the cost of carpeting was 890 Ghanaian cedi per square meter. Now, for all this 120 meters square, we need to multiply by this 890 Ghanaian cedi. So we can say that carpeting cost, the cost for carpeting cost is going to be this 120 that we just got multiplied by 890. And if you are to evaluate that, you can just say our answer times 890. Okay, so that's 106,800. So you add that to be 106,800 Ghanaian cedi. So that is the cost for carpeting. We were told that a total cost spent was 216,120 Ghanaian cedi, which was spent on painting and carpeting. So the cost of painting will be this minus what we got for carpentry. Okay, so we can just say painting plus carpeting. The two of them, they cost a total of 216,120. Okay, now for us to be looking for the price for painting, cost of painting, we now have to be that total, which is 216,120, minus the one for carpeting, which you got as 106,800. So if you are to just compute this from our calculator, so we can say this is our answer, but we have 216,120 minus the answer that we got, and that will be 109,320. So we have it as a Ghanaian CD 109,320 Ghanaian CD. And that is the cost of painting for that particular office that was gotten by Johnson and Jokato. All right. If you are preparing for your WAEC NECO or GCE exam, you should know that graph is a question that you cannot miss in any way. And so, we want to look at this question on the graphical solution to quadratic and linear equation. And we have been asked to copy and complete the table for the relation y is 2x squared minus x minus 2 for this range of value, which we have been given the table that is pre-conceived already with some values inputted there. And then we have to use a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on y-axis to draw the graph for that range of values. And then on the same axis, we have to draw the graph of y is equal to 2x plus 3. And then we will use the graph to find the root of this particular equation, and then for the range of values for which this equation is less than 0. So before we just go ahead to start solving, let me just say something about this particular equation. If you look at that equation and what we are asked here, okay, originally we are given y to be 2x squared minus x minus 2. Now, as a rule of thumb, whatever subsequent question is coming from your graph, you should make sure that you tailor it to this particular equation. And in the very first case, look at what we are told for this particular equation. We are told that 2x squared minus 3x minus 5 is equal to 0. So for me to try and reflect y out of it, if I just take y out of this equation, I can say this is 2x squared minus x minus 2, okay? But what is remaining after taking this y out? We can see that we still have minus 3x, but we have taken minus x out, so we have minus 2x, such that minus x and minus 2x will be minus 3x, okay? And then, again, for the third term, we have taken minus 2 out, but what we have originally is minus 5. So if we have minus 3, minus 2 and minus 3 will be minus 5, so this is equal to 0. This is the manipulation that we need, and you can see that this in bracket is y already, so I can say I want to just write that as y. Then when minus 2x moves to the other side, it's going to be 2x. When minus 3 goes to the other side, it becomes plus 3. So the root of this equation is meaning that you should find the point where y, which was given as 2x squared minus x minus 2, is equal to this new equation 2x plus 3. So definitely you are going to have maybe something like this for the quadratic, and then something like this for the linear. Then this point of intersection, you can see we have the quadratic having that U shape, and then we have the linear having a straight shape. This point of intersection is what you need to trace to the x-axis, and that will be the root of the equation, okay? And then interestingly, the second one, the range of values for which 2x squared minus x minus 2 is less than 0. So most likely you will have something like this also. And then let's say this is the x-axis, and hypothetically, let's say this is the y-axis. So now for the range of values for which 2x squared minus x minus 2 is less than 0, looking at this graph, on the positive here, that is greater than 0. On the negative, this is less than 0. So the region of interest will be this region, talking about the quadratic, and then the range of values for x for which that is equal will be from here to here. So inherently what they're also asking is like, look for the root of the equation, okay? Because at that root, the graph is going to move on to the negative side, which is less than 0. So those are the things that we need to do, but our understanding is first and foremost key. And now that we understand, we can go ahead to say we want to solve the question as appropriate, which we are going to start doing with the table of values. Okay, so now I prepared the table of value ahead, and I just put in all the values that we'll be needing as showcased in this particular case. Already we have been given the values of x, so that is reflecting on the very first row. These are the values of x. Okay, we have also been given some values of y for the quadratic, and these are those values: 19, -2, and 26. But looking at the question, we have -2 as a constant. -2 is not going to change its value at all, so that is there. But then this is for the quadratic, so this here is for the quadratic. Y is equal to 2x squared minus x minus 2. Okay, this is for this quadratic. But that's not the only equation we have. We also have this linear equation: y is equal to 2x plus 3. So this will amount to y is 2x plus 3. So those are the two values that we have. And already we also note that 3 is a constant, so that value is not going to change, but we need to evaluate the value of 2x. So I'll just do maybe just 2 or 3, and then the other ones, so then you can also get your hands dirty. You don't learn by just watching, you also practice. So you do the other ones by yourself, because I'm just going to increase my speed and you'll not be able to see that. So in the first case, when x is -4, x squared will be 16, 2 times 16 will be 32, and make it the point of duty that don't forget your 2. Ensure that you include it in your equation, okay? When x is -4, minus x will be -4. The negative signs will multiply to become plus, so this will be 4. And the addition of this particular 3 values will give us the value of y here. And for us to do that, we'll say 32 plus 4 is 36, minus 2, that will be 34, okay? And then in this particular case, you can just use it to check if you are on the same track, and we're also going to get the answer correctly, okay? So -3 raised to power 2 is 9. 2 times 9 is 18, so we have 18 here. Minus x will be -3, and that will be 3. So 18 plus 3 is 21. 21 minus 2 is 19. So we are on track. That is quite correct. And then let me just do this as the last point, and I will just fill in the other ones. -2 raised to power 2 is 4. 2 times 4 is 8. Then minus 2 will be 2. 8 plus 2 minus 2 will be 8. Okay? And I can just speed up now since you get the hang of it. Okay? Now, in looking at the values of y that we just got, one thing I'm noticing was that this is not symmetrical. Generally, most of the times, with the values that you have, by the time you have your turning point, the values to the left and the values to the right, they'll just be reflective of one another. Like maybe you have, like if -3 is the turning point, then you have 1, then this will also be 1. You have 8, this will also be 8. You have 19, this will also be 19. You have 34, this will also be 34. That means that for this particular set of values, we are not having the turning point at all. The turning point is not included here. So students, just note that, so that by the time you are putting in your point on your graph, you notice that you need to be consistent with what you need to do. Okay, so we just extrapolate the values for this particular linear graph also, and then 2x will just be 2 times the value of x that we have. 2 times -4 will be -8. -8 plus 3, this will be -5. 2 times -3 will be -6. -6 plus 3, that will be -3. And I can just speed up now since you get the hang of it, okay? Now, with this value, you can also notice that there is a consistency of an incremental value of 2 in this particular case. So, it's going to actually be like that because it's a linear graph. It's going to be straight. It will be consistent in its differences. So, this is our table of value now, and this is what we are going to use to actually plot our graph. All right. So, here is our table of values that we just extrapolated out. And the questions we have to solve is the root of 2x squared minus 3x minus 5, which I have explained that is the point at which the quadratic is equal to the linear. And you can see here, if 2x moves to this left-hand side, it will become -x minus 2x, which is -3x. And if 3 moves to the left-hand side, it will become -2 minus 3, which is -5. So we need to look at the point of intersection of the two graphs. And then for the range, we also solve that appropriately. But now, we need to see how we can extrapolate our values for x and y on the graph. We have been told 2 centimeters to 1 unit on the x-axis. Here on the x-axis, 2 centimeters to 1 unit. And on the y-axis, we have been told 2 centimeters to 5 units. Now, for the x-axis, we don't have any problem because 1 unit, this is also 1 unit. We just need to look for means to actually locate that. So if you want to put that maybe here and just look at the center, let's say this is our origin. So for x, we have 1, 2, 3, 4, and then minus 1, minus 2, minus 3, and minus 4. And you can see that is quite good. Now for the y-axis, 2 centimeters to 5 units, meaning that between 2 centimeters, between this point and this point, this is actually 2 centimeters. And those 2 centimeters is comprising of 10 small boxes. So inherently we are saying 10 boxes should be 5 units. 10 boxes, we are saying it is 5 units. Okay. Then if that's the case, what is one box? What is going to be the unit of one box? That unit of one box will be here. We just need to cross multiply. Okay. So we are going to have it as 5 times 1 divided by 10. And this is just 5 here, 1, 5 here, 2. So this is 1 over 2. So each of the small boxes is going to be 0.5 units. I'm doing this because I need to extrapolate numbers that are not going to lie directly on the tick boxes, because 5 units, we only have 5, 10, 15, 20, 25, 30, and co. But here, look at this. We are even having 34, 19, 18. We don't even have anything that is a multiple of 5. So we need to know how we can appropriately adjust that. So if I just want to read it off and show it on the graph, I will say for me to get each incremental value. So here, this is 0, and then reading on the vertical axis, this will be 0.5. So this is 1, this is 1.5, this is 2, this is 2.5, this is 3, this is 3.5, this is 4, this is 4.5, and this will be 5. So I can have 5, 10, 15, 20, 25, 30, 35. Okay, so the point at which I'm taking the graph is quite good. That is quite interesting. I think that can be useful. I can use this as my origin. I didn't mean that my 35 is eating up, then I know that I need to move my graph down. But I think with this, it's quite okay. I can just input that, and I will draw my vertical and horizontal axis and put in the scale. I will go ahead to solve the question. All right. So we have our graph prepared already with the scale that we're given and placed on the graph in such a way that everything will be centralized as appropriate. And then want to extrapolate those values. In this first case, for the quadratic equation, when x is minus 4, y is 34. And I've been able to establish the fact that now, in this case, this is 4, okay? 34 will just be 1 unit before 35. And 1 unit will correspond to 2 boxes, because each of the small box is 0.5 units. So we are looking at something here to say this point of intersection is a point of interest for us when x is minus 4 and y is 34. So we can note that here. Okay, and again we can look at the value of x minus 3 and y 19. 19 will also be 2 boxes before 20. So we have somewhere here. So that point of intersection is also our point of interest, which we will note now. So here, that is 19. And then since we get the hang of it, you can just go ahead. Minus 2 and 8. It will just be... You can just get the other ones. I will speed up the video now. Okay. So if you do that correctly, you are going to have something like this as the curve that is joining all of your points. Okay. And then as good as it gets, you can also do the same for the linear graph. Like here, when x is minus 4, y is minus 5. You can see this is minus 4 here. And then we can look at minus 5 here. And this should be quite straight because it's going to even be a straight line graph. Okay, so we can say this is our point of interest. And when x is minus 3, y is also minus 3. Minus 3 will just be, mid here is 2.5 plus 1 box. That will be minus 3. That will be like here. Okay. And then we can just continue. So when x is minus 2, it is minus, y is minus 1 here. When x is minus 1, y is 1. This is exactly the same point. And interestingly, here, that is the point where the value of y for the quadratic and the value of y for the linear, they are overlapping. So that is still the same one that we have notched initially. You can just get the other ones. I will speed up the video now. Okay. When x is 4, y is 11. So that is 11. And then we can say we want to join them all with a straight line, just passing through all of them. And then I think this is as good as it gets. Okay, so that is our graph, and as a rule of thumb, it's just good that we label here. This is the quadratic. Y is 2x squared minus x minus 2, and this is the linear. Y is equal to 2x plus 3. All right. So in the first case, where we're asked to find the roots of the equation 2x squared minus 3x minus 5, which we have explained to be the point of intersection of the quadratic and the linear graph, you can see here this point, and that is minus 1, okay? And here, this point, but if we trace that down, we're going to see that it's going to land directly between 2 and 3, and that is 2.5. So here is down on minus 1, which we even got from the graph initially. So you can just say the roots of that equation are x is equal to minus 1 and x is equal to 2.5 as seen from the graph, okay? So student, you can still go ahead to verify this answer by solving for this question, maybe by factorization method or formula method, to get the root of that. But here, let me just make use of the calculator to say I want to equate the two equations together, like I have 2x squared minus x minus 2 is equal to, that equal to will be alpha calc, okay, is equal to 2x plus 3. So I want to solve for this. So I'm using shift calc, that is solve. And I want to solve for x, starting its iteration from 0. No, I have two values, one in the negative, one in the positive. So I will take minus 4 as the first point to start its iteration. Start from minus 4. What is that going to give me? Okay, x is minus 1. That is for this. If I still want to solve, I want to use 4. Okay, let me just use 3 now. I want to use 3 as the starting point for its iteration. Then what is that? So you can see 2.5 and minus 1. And that is giving me the hint that I am quite on track with this solution that I've got. But that's not all. For the graph, we also have to find the range for which y is less than 0 for the quadratic. And in that particular case, if you are to look at it, we can look at this. These are the points where y is actually less than 0. You can see up here we have the positive values of y. Y is greater than 0 there. Down here we have the negative values of y. Y is less than 0. And then we are asked to find the range for that particular case. If you zoom in, you can see that here and here, those are the points that we have as the range for which y is less than 0. So we can say we want to get the particular range as shown on the graph. Now, on the horizontal axis, we have 10 boxes that are amounting to 1 unit. So each of the boxes is 0.1 unit. And here, we have 2 boxes just before 1. So that will be 1 minus 2 of those boxes, which will be 1 minus 0.2. So that will be minus 0.8, negative because it is to this side. And here, I can see it's just between 1, 1.1, 1.2, and 1.3. So I can say, let me just say, this is x less than or equal to 1.25. Okay? That's what I'm seeing as that. But actually, this is also the root of the quadratic equation, where it's cutting the x-axis. And we can also say we want to solve for that. We can just say we have our equation, okay, 5. We want to solve it is a quadratic, that is amounting to 3. And what is the first term? That is 2. And then the coefficient of x, that is minus 1. And then the constant c, that is minus 2. So you can ask the calculator to solve that. And then the very first solution, x1, this is 1.28. That's quite interesting. And you know, we got 1.25 close to 3, okay? Okay, and then the other one, this is minus 0.7, which is approximately minus 0.8. And then, okay, it's also giving us the minimum value of x and the minimum value for y. We are not concerned about that here, but we have just verified that, yes, within this range of values that we have, we're actually quite on track and our solution is done and dusted. So students, you can do well to practice on this type of questions a whole lot, particularly because there are sure bankers in the exam, and proper preparation like this will prevent poor performance. We hope this has been useful for you and wish you the very best. All right. In this question on triangle and mensuration, we are told that in triangle PQR, angle PQR is 90 degrees if its area is 216 centimeters square and the ratio of the side PQ to side QR is 3:4, we are to find PR. Okay, now this is quite very interesting, but students, first and foremost, you should be able to interpret this question so that all that we need to put and how we need to get, we need to define it. Okay, in the first case, we are told that PQR is 90 degrees, so that is rendering this triangle as a right angle, and because Q is a point at which we are taking that angle, that's why it's in the middle here. So we can say this is our point Q. It is at the right angle there at point Q. Then we have PQ and QR to be ratio 3:4, meaning that PQ is shorter. PQ is the one that is smaller. QR is longer. So I can say R is here so that QR is longer. PQ will not be the other one. But what we are asked to find, look at this. It is the side PR, this particular side. If I call that Q, since it's opposite Q, let me call this Q. That is what we are asked to find. Now, from this question, we're also given the area to be 216 centimeters square. Now, if we can relate that area to these sides, because we know that generally the area of a triangle, particularly as relevant in this case, will be half base times height. So the base will be QP, the height will be QR. Okay, so we can get those two. We can use Pythagoras theorem to get the side Q. Okay, but from the question, we are given PQ over QR to be in the ratio 3/4, such that if I want to just make it flat, PQ is going to be 3/4 QR. Okay, now since it is 3/4 QR, do I want to be working in QR? Let me just call it X. Let me just say if QR is X, I can say PQ will be 3/4 X. Let QR, let that be X. Then PQ will be 3/4 X. So here, QR, if this is X, QP or PQ, that will be 3/4 X. But before we move on, we are given the area. So that area that we're given as 216 will now be 216 is equal to 1/2. What is my base now? The base is QP, which is 3/4 X. And what is my height? That is QR, which is X. And with this, I can just say, that means from the right hand side, X and X will be S square. We have 3/8. So we have 216 is equal to 3/8 S square. So S square will be 216 times 8 divided by 3. Okay, so we can solve for this. 216 times 8 divided by 3. So this is 576. What's the square root? Square root of our answer, 24. Okay, so this is 576 and X will be the square root of 576 and that will go to be 24 centimeter. Okay, let me just move my work area to create more space. Okay, so having gotten this, you can make use of the Pythagoras theorem to help us evaluate the value of Q, which is PR that we are looking for. And Pythagoras theorem is telling us from this triangle, what we are going to have is that Q square is equal to S square plus 3/4 H square. Okay, that means that the square of Q will be S square, which is 24 raised to power 2 plus 3/4 times 24 raised to power 2. Okay, so that will be 24 raised to power 2 plus, here we can cut 4 here 1, 4 here 6, 3 times 6, that's 18 raised to power 2. So if you are to input that in the calculator, we are going to have 24 raised to power 2 plus 18 raised to power 2. So this is 90. Okay, so this is 900, such that in that case, Q is going to be the square root of 900, and the square root of 900 is nothing but 30 centimeter, which is the value of the line PR that we are asked to find originally. So we didn't need to fret. We just need to interpret our question correctly, represent them in a diagram to just help us visualize it, and then put in all the parameters that we have, so that at the end of the day, we can find the line PR, which is the hypotenuse, to be 30 centimeter by making use of the Pythagoras theorem. All right.
In this word problem, we are given that the present ages of a man and his son are 47 years and 17 years respectively. So that inherently means that for the man, his present age is 47, and for the son, his present age is 17, okay? In how many years would the man's age be twice that of his son? Meaning that if we add some years, let's say x, to the age of the man, we are looking for a time period which is x, that the age of the man, which will be his present age now 47, plus that number of years we are looking at, will be equal to 2 times the age of the son, and the age of the son at that time will also be 17 plus x. Since is a futuristic year that we're going to add to their present age, that's why we have 47 plus x and 17 plus x. But we are being told that at that particular year, the man's age will be twice that of his son. That's why we're multiplying his son's age, the new age, that's why we're multiplying it by 2. So all we just need to do is to solve this question, and we'll get that number of years, which is x, okay? So if we just open up this bracket, we have 47 plus x is equal to 2 times 17 is 34, and 2 times x is 2x. All we just need to do is to move the like terms together, and in this case, we will have 47 minus 34 is equal to 2x minus x, okay? Then 47 minus 34, this is 13, and 2x minus x, that is x. So the number of years when the father's age will be twice that of his son is nothing but 13, and our work is done and dusted. In this question of mensuration, we are told that in the diagram, PQRS is a trapezium and QR is parallel to PS. So we have QR parallel to PS. Okay, that's why we have these double arrows on both of them. Then U and T are points on PS such that PU here is 5 centimeters, QU is 12 centimeters, and angle PUQ is the same as SCR, that is a right angle. So PUQ and then STR, you can see both of them are 90 degrees. Now, if the area of triangle PQR, this triangle here, the area is given as 20 centimeters square, we're to find, correct to the nearest whole number, the perimeter and the area of the trapezium. Wow, okay. So looking at this, ideally, the perimeter of this trapezium is going to be the sum of all of the sides. And if you want to append that, instead of just using all this P, Q, Q, R, I want to peg it as, let's say, this is A, this is B, this is C, this is D, this is E, and then, okay, let me call this F, okay? So it's the addition of A, B, C, D, E, and F that will give us the perimeter. So I have this as A plus B plus C plus D plus E plus F. So I'm noting that. And then how am I going to get the area? The area of this is going to be 1 over 2 multiplied by the sum of the parallel sides, which is QR and PS. So that will be sum is B. But for the PS, we have it as F, E, and D, or D, E, and F, plus D plus E plus F, multiplied by the height of the trapezium. That is QU. Okay, so if I call this G, let me just use red so that I don't confuse this. If I call this G, okay, that G is actually also 12 because it is the same QU, RT, they are the same. So that area of the trapezium will be half multiplied by the sum of the parallel sides. One of the sides is B, QR, the other is D plus E plus F, which is PS. So multiplied by the height is now RT, or I can say multiplied by G. So the mandate I have before me here, first and foremost, is to find all of these unknowns from A down to E, because I now have F is 5 centimeters, G is 12, but I need to find A to E. That is the mandate that I have before me, and the steps are going to be taken are going to be geared towards solving that, such that once we can get that, we can bring in those values here and find the perimeter and the area as appropriate. Okay, so students, let's kick in and see how we can solve this. In the first case, A, from this particular triangle PQU, we can see that it's a right angle triangle. If we have considered the angle at P here, 12 will be the opposite, 5 will be the adjacent. A will be the hypotenuse. So we can use Pythagoras theorem to find A, to say A square is going to be 12 square plus 5 square, and that is 144 plus 25. So A as the first parameter will be 144 and 25, that will be 169. A will be the square root of 169, and that will be 13 centimeters. Okay, our first mandate is done. B, how do we find B? Looking at this question, okay, interestingly, you can see that B is also E. We are given in the question originally that the area of triangle PQR is 20 centimeters square. So PQR, that area is 20 centimeters square. But interestingly, if you look at this very well, and let me just say this particular side A, if I draw another line parallel to that particular side A, just something like this, okay? If I do that, and here, what can I call this now? Let me just call this point A, okay? This particular parallel side, which is also A, renders this shape PQRA to be a parallelogram, okay? This is a parallelogram, and we know that normally the area of a parallelogram, this is interesting, the area of a parallelogram is this height, 12, multiplied by the base. So that's going to be B multiplied by H, or that's G also, B multiplied by G, where B is the base and H is the 12 centimeters. But interestingly, that's not where I'm really going. The area of the triangle PQR is going to be half of the area that I just defined. That is just a normal theorem postulated when you are looking at a triangle and a parallelogram. You can see ideally, if you look critically, that that triangle is actually half of the parallelogram. So it's dividing the parallelogram into two triangles, and the areas of those two triangles are going to be equal. So inherently, what I'm saying is that for this particular stuff, we have it that the area of the triangle PQR, which we have been given as 20, that 20 is going to be 1 over 2 multiplied by, is this B that we are looking for, okay? Then multiplied by G, which is the height of that parallelogram, that is 12. So B multiplied by 12. So from here, we can see that our B is 2 times 20 divided by 12, okay? So if we want to use our calculator for that, we have 2 times 20 is just 40 divided by 12, and that will give us, okay, 3 points. That dash on top of 3 means that it is continuous. So it is, this is B, interestingly, which is also the value for E. Okay, this B, QR, and UT, they are the same. That is nothing but 3.333 centimeters. Okay, that's quite good. Now we can move on to C. For us to find the value of C, we can see that we have triangle from the triangle SRT. We can make use of SOHCAHTOA, and SOHCAHTOA will help us to effectively solve this, because we can see that from this diagram, if you consider this angle 50 degrees, we are going to see that for that angle, this G or 12 is the opposite, C is the hypotenuse, then D is the adjacent. Then if we can make use of those trigonometry identity, we can find the value of C and D as appropriate. In the first case, if I say sine 50 will be opposite, which is 12, over C, that is the hypotenuse. So I can have sine 50 is what? Opposite, which is 12, over the hypotenuse, which is C. So that C will be 12 over sine 50. And if I use my calculator, 12 over sine 50, I have 12 divided by sine 50. That's going to give me 15.6648. Okay, 15.665. So this is 15.665 centimeters. And that's not all. I also have D. I can make use of maybe Pythagoras theorem to say C square is 12 square plus D square. But I still want to make use of the trigonometry identity, so that I will just use the value of 12, that is a whole number, and given already to evaluate D. So for D, it is adjacent, then this 12 is opposite. That means I need to use tan, opposite over adjacent. So I can say again, tan 50 is the opposite, which is 12, over the adjacent, which is D. And then that will render D to be 12 over tan 50. Okay, and then that D will be, so this is C and this is D. Okay, that d will be, I can just change this to say I'm deleting this and putting tan 12 over tan 50, 10.069. So this is 10.069. Okay, again, the unit is centimeters. What else? We are looking for our E. Okay, we have gotten E to be the same value as B, and that is 3.333 centimeters. And F, we have been given as 5 centimeters. All right, so now we are good and fine. We can say holistically now, we can look at this question, find the perimeter by adding all of the sides, and then find the area by using this formula as we have postulated before. Now, for me to do that, let me just put all the values of these parameters appropriately on the diagram, because I'll need to clean my board. A is 13, B will got to be 3.333, which is the same as E, 3.333. C will got to be 15.665, and then D will got to be, this is 10.069. All right, okay. So let's try and find our question set now. In the first case, we are asked to find the perimeter, and we have said perimeter is the sum of all of the sides. So we can put in those sides. The perimeter will be 13 plus 3.333 plus C 15.665 plus D 10.069 plus E 3.333 as discovered before, then plus F, that is 5. So I just need to add all of this in the calculator, and that will give me, in the first case, A is 13, plus B is 3.333, plus C is 15.665, plus D is 10.069, plus E is 3.333, plus F, that is 5, and that's going to give me what? 252 over 5, and okay, this is 50.4. So 50 is 50.4. But looking at the question, we're asked to find it correct to the nearest whole number. 4, we need to round down to 0, and that will make sure that our answer is nothing but 50 centimeter as the perimeter of this particular trapezium. Okay, quite interesting. And then in the second case, we are saying that the area of that trapezium is nothing but half multiplied by the addition of the parallel sides, which is QR and PS, that we have found to be B plus D plus E plus F. So we want to put that B is 3.333 plus D is 10.069 plus E is 3.333 plus F, that is 5, multiplied by G, which is QU or RT, and that is 12. Wow, okay. So I'll just do the one in bracket first, okay? So let's do that. So I have 3.333 plus 10.069 plus, again, 3.333 plus 5. What is this giving me? It's 21.735, 21.735, then multiplied by 12, okay? So I can just cut here. Let's say this is 2 here, 1, 2 and 12 is 6. So what I'm having inherently is 21.735 times 6. So my initial answer multiplied by 6. And this is 130.41, 130.41. But if you recall, we have to find to the nearest whole number. So again, 4 will round down. So this will be 130 centimeters square. Wow. We didn't need to fret. We just need to be consistent with how we are going to get all of the sides of this trapezium, and after getting them, use the formula for the perimeter as the sum of all those sides, and then the formula for the area as half multiplied by the sum of the parallel sides, then multiplied by the height of the trapezium, and we got our answer here by making use of postulate of the area of the parallelogram as compared to the area of the triangle, and then SOHCAHTOA from trigonometry, and we got our answer out and fine. What a question, right?
In this question on bearing and distance, we are told that a cottage is on a bearing of 200 degree and 110 degree from Dugbe's and Manu's farms respectively. Now, if Dugbe walk 5 kilometers and Manu 3 kilometers from the cottage to their farms, we are to find correct to two scenario figures, the distance between the two farms, and to the nearest degree the bearing of Manu's farm from Dugbe's farm. So let's look at this critically. Now we are told that the cottage is on a bearing of 200 and 110 from Dugbe's and Manu's farm. So we need to take the bearing of 200 from Dugbe and 110 from Manu. So in the first case, we want to locate 200 degree. We can say we want to draw our cardinal point just like this, okay? And then we have our north, our south, our east, and the west. And we will notice that 200 will be in the third quadrant because north to south is a straight line, that's 180 degrees. So 200 will be just a bit off of that. So we can look at a scenario coming like this. So I can say what I'm having from the north to this inclination is 200 degrees, okay? And then in addition to that, we're also told that from Manu's farm, it is 110 degrees. If we look at 110 is going to be in the second quadrant. Let's just use this as a reference. North to east is 90 degrees. So 110 will just be 20 more than 90. That means it will be something coming in this direction, okay? But we are not taking it from Dugbe's farm. We have to take it from Manu's farm. That means that Manu's farm should be located somewhere here, okay? Somewhere here, so that this inclination that can just come to meet this one as shown in the diagram. So that's what we are going to do to locate Manu's farm. I can just say I want to take that cardinal point, just say from here. All right, again, I want to have my north, south, east, and west. Let me just leave that because I'll be including that in the diagram. Then I want to join this point to say this should come just like this, which I can draw the bearing to say from the north to that inclination is 110 degrees. Then I can say I want to just finish up with the diagram by just drawing this line to join and finish here. And then I can label, okay? Now, we are taking the bearing from Dugbe's farm is 200. So this is where we are taking the 200 from. That is Dugbe's farm, D for Dugbe. Then M for Manu. This we have to be M, okay? And then we are talking about the cottage. Is the bearing to the cottage. So this we can label as our C. So for us to finish up the diagram, I just include the distances. Dugbe walked 5 kilometers to that cottage. So this is Dugbe. This is the cottage. So this is going to be 5 kilometers, okay? And then Manu walked 3 kilometers from his own cottage to the farm. So this is 3 kilometers. And you can see how I use a shorter distance from Manu as compared to Dugbe. And then using the relative positions of the bearings, I'm able to locate this as appropriate. So let's try and solve this and see what we can use to get the distance between the two farms. Manu's farm, M here, to Dugbe's farm, D here. Okay, so since that distance, MD, is opposite C, I can just call this C. Okay, so 5 kilometers will be small m, 3 kilometers will be small d. So let me just leave this at this. So we have this question and it's giving us a triangle already. I want to find this particular side, but we need to get any of the included angles so that we'll be able to solve this effectively. Now, looking at this diagram and what we have, we can say at point C, we can get the angle at this point C because looking at this particular point M, we know that from north to south is 180 degrees, is a straight line, and angle on the straight line is 180. So here, that will be 180 minus this 110. So that will be 70 degrees, okay? But we are not going to be stopping there because we know that from this particular point M to point C, we can take this particular angle and bring it down to C, okay? And also take it up to say this angle here that we are looking at is also 70 degrees because it is alternate to this 70 that we got by deducting 110 from the angle on the straight line 180, which is from north to south, okay? And then interestingly, from D also we can see that here we can have something like this. At D we can also have this straight line from the south and then incline it to this particular point C again, and then again we can take it up to see that this angle here, which will now be 200, that is from north to the inclination of C from D, minus 180, which is from the north to the south. So this angle is 200 minus 180, which is 20. And then this place is also going to give us 20. And as interesting as that gets, we are seeing that at this particular junction, at this point C, what we are having is inherently nothing but a right angle. So this is just 70 plus 20, and the addition of the two is going to give us nothing but a right angle, 90 degrees. So it is the breakdowns like this that will help us to holistically solve our question, and that renders the triangle MDC as a right angle. So what we're having is that triangle MDC is nothing but a right angle triangle. And if we can get this, then we know that we can postulate just the two theorems to help us solve right angle triangle. First, the trigonometry identity, SOHCAHTOA. We can use SOHCAHTOA, and then we can use the Pythagoras theorem. Okay, the SOHCAHTOA plus Pythagoras that can help us to solve questions like this when we have a right angled triangle. So let's see how we can use that to solve this particular question. In the first case, we want to find the distance between the two farms, and we have said that is C, distance from M to D. And by Pythagoras theorem, we can say that C square is going to be D square plus M square. And I've said D is this particular 3 kilometers, which is facing the vertex D. And M is this particular 5 kilometers, which is facing the vertex M. So that means I'm having C squared to be nothing plus, what is D square? That is 3 square plus M square, that is 5 square. So C square is 9 plus 25, which is equals to 34. And then I can say C is equal to the square root of 34. And then C, which is distance between the two farms that we are looking for, is going to be, we can bring our calculator to solve this, okay? The square root of 34, this is 5.83095. Let me say 5.83. So this is 5.83. But from the question, we're asked to get this to two significant figures, okay? So we can say approximately two significant figures, which means that we need only 2 digits. 5 is the very first one, we need to take that. Now, to consider the second digit, we need to look at the third or the extra digit and see if we need to round it up or round it down. 3 is not up to 5, so we round it down to 0, and it will not take effect on 8 at all. So this is approximately 5.8 kilometers as the distance between the two farms, which is C, okay? So that is the very first thing. In the second case, they are asked to find, to the nearest degree, the bearing of Manu's farm from Dogbe's. So this is Dogbe's farm. We need to get the bearing of Manu's farm from Dogbe. Already, we have seen that from Dogbe to the cottage is 200. If we can get this particular angle, let me call that theta, we will see that the bearing of Manu's farm from Dogbe's farm will be 200 that we got initially plus that theta, okay? Because here, we are starting from the north, we get to the bearing of the cottage from Dogbe's farm, and then add theta to it to get to the bearing of Manu's farm from Dogbe's farm. So that bearing that we're asked to find is going to be 200 plus theta. So that is what we are looking for. But for us to get theta, since this is a right angle triangle, if I'm to consider this part, okay, we are considering this angle, theta, we have the opposite to it, which is 3. We also have the adjacent to it, which is 5. So what is relating the angle, the opposite, and the adjacent? That is tan. So we can say from here, tan theta that we are looking for is equal to opposite, which is 3, over the adjacent, which is 5. So that is equal such that theta will be arctan 3 over 5. And in that particular case, our theta is going to be, what's arctan 3 over 5? That will be arctan 3 over 5 is 0.6. Okay. So we have this as 30.9637 or 964. That's 30.964, such that the bearing that we are looking for is 200 plus 30.964. And if you had this, that would be 230.964. But again, we are told that we are to get this to the nearest degree. Even if you are not told to get that to the nearest degree, you need to always note that bearings are only given in 3 digits. Even if it is 2, maybe like it is supposed to be 70, you need to add 0 in front, that say it is 070 degrees, okay, and you don't say 70 degrees, say 070 degrees, okay. So for this particular question, we are going to round this up, and we can see that 9 will round up to 1 and add to the initial number such that that bearing will be 231 degrees. So these are the two answers that we're supposed to get. Distance between the two farms is 5.8 kilometers, and the bearing of Manu's farm from Dogbe's farm is 231 degrees. And with that, we've been able to solve this question by first interpreting and getting our diagram correctly and making use of SOHCAHTOA and Pythagoras theorem, since it is giving us a right angle triangle. If it was giving us a scaling triangle, we could have used the sine and the cosine rule, but yeah, we are good since it's a right angle triangle and our question is done and dusted. All right. In this question on triangles, we are told that a ladder 10 meters long leaned against a vertical wall which is x meters high, and the distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. Our mandate is to calculate the value of x. So if we have this as our diagram as being representing the information that we're giving, the ladder itself is 10 meters long, so we have the length of this ladder to be 10 meters, okay, and then it's leaning against a vertical wall which is x meters high, so this is going to be x meters, okay. Then the distance between the wall and the foot of the ladder is 2 meters longer than the height of the wall. So here we are being told that it is 2 meters longer than that height, so we have it as x plus 2, and of course it's going to be a right angle because the wall is ideally inclined at 90 degrees to the floor, so we have to find the value of x. Now, having gotten this, we can see that Pythagoras theorem is going to help us to solve this question holistically, because we just have the hypotenuse, we have the opposite, we have the adjacent, and we can use the Pythagoras theorem to solve this, saying that the square of the hypotenuse, which is 10, the square of that 10 is equal to the sum of the square of the opposite and the adjacent. So that would be s squared plus x plus 2 squared. And you can see how I actually included s plus 2 holistically in that bracket. So our mandate is to open this bracket and solve, and we'll find the value of x. 10 squared is 100, so we have that is equal to s squared. X plus 2 raised to the power 2 is us having x plus 2 multiplying itself, okay. So this we can just open up to say this is x squared plus x times x is x squared, x times 2 is 2x, 2 times x is another 2x, and then 2 times 2, that is 4. So I want to bring everything together to say s squared plus s squared, that is 2s squared, okay, plus 2x plus 2s, that is 4x, plus 4, okay. If I have 100, if I subtract 100 from both sides, I can say that it will be 100 minus 100 here will be 0, so we can equate that to 0. 4 minus 100 will be minus 96, so this will have to be minus 96 is equal to 0. So this is a quadratic that we can actually solve. But before we say we even want to solve, we can break this down and divide each of those terms by 2. Divide everything by 2, and we have it as s squared plus 2x minus 48 is equal to 0. So for us to solve this, we are looking at a product of terms that is going to give us minus 48 s squared, this s squared and minus 48, then their sum is going to be 2x. So this is the product, this is the sum. What two numbers can we look at here, okay? I think 8 times 6 is 48, so we have 8 and we have 6, 8x and 6x, we have 8x and 6x, but we need to determine the sign, okay? Since the addition of the two should give us 2x, 8 is a larger number, so we can say 8x minus 6x, okay? Because 8x minus 6x, that would be 2x. 8x multiplied by minus 6x, the plus in front of it to multiply the minus to give us minus 8x times 6x to give us 48x squared. So 8x and minus 6x is good for us, and we can make use of that to solve this equation to say we have it as s squared plus 8x minus 6x minus 48 is equal to 0, okay, such that in the first two terms x is common, so we have x plus 8. Then in the second term minus 6 is common, so we have x plus 8 again. We need to be careful here because minus 6 times plus 8 is minus 48, so you cannot say minus here. Okay, so once we have gotten that, we can see that we can factor this out to say what we have inherently is the x minus 6 into x plus 8 is equal to 0, and from here is either x is equal to 6 or x is equal to minus 8. But let me ask you a question. Can the value of x, which is a measurement of distance, can it be negative? It can't, so this cannot be our answer. Then definitely s is going to be 6. And that is why they didn't ask us to calculate the values of x. They only asked us to calculate the value, a singular value of x. And then 6 will be the answer here, and our question is done and dusted. All right. In this question of statistics, we are told that the table shows the distribution of the number of hours per day spent in studying by 50 students. So in the first row, we have the number of hours per day, and in the second row, we have the number of students taking those hours to study. Now, our mandate is to calculate, correct to two decimal places, the mean and the standard deviation as appropriate. So I prepared a table that we are going to use to compute the values that we need, and the formula that we'll be using is here. For the mean, we need to find the summation of the product of the frequency and the data set. And here, the data set happens to be the number of hours, and the frequency is the number of students, okay? So we'll divide that by the summation of the frequency. Then for the standard deviation, we can use this formula here, and we need to find the product of the frequency and the square of the data set. Then we can use them in this formula to solve this. There's another formula that you could have used, in which you'll be subtracting the mean from each of the data set entry, and you'll be finding the square. Students, you can try that out. We have done that type in a number of our questions on our playlist, and you can also check those out. But here, we'll be consistent with this because it just gets us to our final destination quick and fine. So here we have fx to compute, and that means just the product of these values for x and the value for f. And for us to do that, 4 times 5, that is 20, 5 times 7, that is 35, 6 times 5 is 30, 7 times 9 is 63, 8 times 12, that will be 96, 9 times 4 is 36, 10 times 3, 30, and 11 times 5, that is 55. Okay, we can do it to just compute the total of that. 20 plus 35 plus 30 plus 63 plus 96 plus 36 plus 30 and 55. Okay, so this is 365. The summation here, summation fx, that is 365. Okay, here for the frequency, let's just sum that straight. 5 plus 7 is 12, plus 5, 17, plus 9, 26, plus 12, 38, plus 4 is 42, plus 3, 45, plus 5, that is 50. So summation f is 50. Okay, then in that case, we can get our mean out to say the mean is nothing but 365 divided by 50. And if we want to put that into our calculator, the answer that we got last divided by 50, so this is 7.3. Okay, but look at our question. We are told to find it correct to two decimal places, so I can say this is 7.30 hours. Hours because x is our data set. It is the number of hours per day that we are looking at. Good and fine. We can go ahead to now say we want to compute s square. 4 square will be 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square is 100, and 11 square is 121. Okay, then moving on, we can find the product of the frequency and the square of the data set in this particular question. So s square will be 4 raised to power 2, which is 16 that we have gotten here, times 5, that will be 80. So we have 80 here. Then 7 times 25. Let me just bring in my calculator. 7 times 25. This is 175. 175. And then we just do that for each of those other ones. 100 times 3, that's 300. And then 5 times 121, that will be 605. Okay. So if you are not sure, you can check that. 5 times 121 at 605. Then we can do well to sum all of these entry now. Well, we have 80 plus 175 plus 180 plus 441 plus 768 plus 324 with 300 and finally 605. Okay, so this is 2873. So the summation here, summation fs square is 2873, and these are the values that we can use to get our standard deviation. So since we have all of these requirements that we need, we can now say we want to find the standard deviation to be the square root of summation fs squared, that is 2873, over summation f, that is 50, minus the square of the mean, 7.30 square. Okay, so this is what we need to compute, and if you want to put that into the calculator, we can have our final answer divided by 50, that is equal to, that's 57.46. So this is square root of 57.46 minus 7.3 raised to the power 2, 7.3 to the power of 2. This is 53.29 minus 53.29, and then we can find this to say what's going to be this value, 57.46, 57.46 minus the answer that we just got. So this is 4.17, square root of 4.17, that's going to give us what? So the root of this answer now, that is 2.042, 2.042. But recall, we are asked to get it to correct to 2 decimal places. So here, 2 will round down to 0. That will not have effect on 4. So we have it as 2.04 hours as the standard deviation for this particular question. And with that, we've been able to solve this question holistically, compute our table, use the formula that is appropriate, and our work is done and dusted. All right. In this question on circle theorems, we are told that in the diagram, PQRS is a circle, and then PQ is equal to QS, and angle SPR is given as 26 degrees, and the interior angles of triangle PQS, this triangle here, okay, the interior angles are given in the ratio 2:3:3, and mandate is to find PQR, RPQ, and PRQ. In the first case, what I want to point out is that when we are told that the interior angles of this triangle PQS are in the ratio 2:3:3, let's identify those angles on this particular diagram. Okay, since line QS is equal to line PQ, that makes this triangle an isosceles triangle. And one thing we note is that for an isosceles triangle, the base angles of isosceles triangle are equal. And what are the bases? It will be this angle here, SPQ, and this angle here, QSP. So I can say angle SPQ is equal to angle, this is SPQ, is equal to angle QSP, and because they are the base angles of isosceles triangle. Now, in the other information, we're told that the interior angles of the triangle are in the ratio 2:3:3. So which is going to take the least and which are going to be the same? Because we are saying the base angles are equal, then this particular angle here, this will have to be the one in ratio 3 because it is the same as the one here. Okay, so if I'm to say this other one, I can call this one the one of magnitude 2, but that is a ratio. I can actually take a baseline value to say I want to call this 2x, then this one will be 3x. But look at this particular triangle. This is also supposed to be 3x, but already we have taken 26 out of that 3x. So the remainder, just this one, will have to be 3x minus 26. Okay, we just need this consistency so that we'll be able to get our answer correct and out. Okay, so if that is the case, I can say this angle SPQ, which is also QSP, is actually having 3x, and because they are base angles of isosceles triangle, just like this. Okay, now looking further in this triangle, I can identify this particular region here, this angle 26. I can see that it is also the same as this angle here, that is also going to be 26. And why am I postulating that? Is because they are angles in the same segment of a circle. You can see SR is the chord for both of them. We have S going to a point on the circumference P going to R, then again S going to another point on the circumference Q going to R. So these are angles in the same segment. So I can also say that angle SPR is equal to angle SQR, and the value is nothing but 26 degrees, and it's because they are angles in the same segment of a circle. So once we have this, we can look at how we can now use this information to try and solve this particular question. In the first case, we have the mandate to calculate angle PQR. Let's identify that PQR, we can see, okay, this we just got to be 26. I can say this is 26. Now from the triangle SPQ, we can see that this angle is 3x, okay. This whole here is also 3x because the two of them are base angles of this isosceles triangle we are considering. And then this is 2x. The sum of the three is going to give us 180 degrees as the sum of angles of a triangle. So I can say 3x plus here, you can see 3x minus 26 plus 26. The 26 will knock out, so it's also 3s. Okay, then plus 2x, this angle here, okay. The three of them will add up to 180 degrees because they are sum of angles of triangle. Sum of angles of a triangle is 180 degrees, and this can help us to solve for x. Plus 3x plus 3x, that is 6x plus 2x, that's 8x is 180, such that we can just find our x to be 180 over 8. Okay, that was going to be 8 in 18, that is 2, remaining 2. 8 in 20, that is also 2, remaining 4. 4 over 8 is 0.5, so x is 22.5 degrees. Then our first mandate PQR, we can see from this diagram that in the first case, angle PQR, what is going to give us? PQR, this region here, that's what we are looking for, and that is 2x plus 26. And instead of 2x, I can just say this is 2 times 22.5 plus 26. So if we want to add this, you can say 2 times 22.5 plus 26. What is that going to give us? This is going to give us 71. So this is 71 degrees. All right. Our first solution is out. In the second case, we are looking at the angle RPQ, and looking at our diagram, this is RPQ. We can see from that diagram that this is nothing but 3x minus 26. And thank goodness we have gotten our x. So this is 3 times 22.5 minus 26. So we can compute this to say, okay, let's just adjust this. So this is minus, and in the first case it is 3 and not 2. Okay, so this is 3 times 22.5 minus 26, and this is what? This is 41.5. So have this as 41.5 degrees. And then in the third case, we are mandated to find angle PRQ, and looking at our diagram, this is PRQ, this angle here, that's what we are again asked to find, this angle here. And now there are two ways you can even go about, so even many ways, but two that I'm seeing clearly is that in the first case, you can sum the angles in this triangle PRQ to say this angle that we are looking at, if I call that y plus 26 plus 2x plus 3x minus 26, the sum of the angles in this triangle, that will be 180, and then you can get y hat since we have x already, and that will be fine. But alternatively, I can see that this angle is also the same, even though I'm calling it y, is also the same as angle PSQ. This is also the same as angle PSQ, which we have gotten to be 3x originally. And why am I saying that? Because there are angles in the same segment of the circle. You can see PQ, that is the chord. So we have PSQ as angle in one segment and PRQ as angle is in another segment. So I can say this is angles in same segment, just like we have gotten one before. Okay, and then that means that the y that I'm looking for, or angle PRQ, is just nothing but 3 times x, and that's 3 times 22.5. And if I use my calculator again, I can just say, okay, let me just remove this last set of entries. 3 times 22.5, that is going to give me 67.5. So this is 67.5 degrees. And you can see how our understanding of the circle theorems, the properties of isosceles triangle, and the sum of angles of a triangle had helped us to solve this question holistically, so that our answers are done and dusted without any glitch at all, and we have the solution fine and good. All right. In this question of coordinate geometry, we are told that the coordinates of 2 points P and Q in a plane are 7, 3 and 5, x respectively. So P is 7, 3 and Q is 5, x, and x is given as a real number. Now, if the magnitude of the line PQ is root 29 units, we have to find the value of x, and a picture is always worth 1,000 words for me. and we have been able to locate P, which is 7,3, and you can see on the x-axis 7 between 6 and 8 is here, okay, and then on the y-axis 3 between 2 and 4 is here, so that is P. What we are asked to get inherently is the coordinate of the point Q, which is defined as 5, x. So on the x-axis is going to be 5, and that 5 is here, okay, and then we want to find the value of y. And now if you look at this critically, there's something you should get, which for me is quite interesting. Within this value, we may get two values, that this length and maybe this length, they are going to be the same, because well, this will be root 29 and this will also be root 29. That is what I'm suspecting already, but let's just find out as we solve this question together, okay? Now, by reason of our understanding of coordinate geometry, we know that the length of a side, in this case PQ, will be the square root of the difference between y raised to power 2 plus the difference in x raised to power 2. So if each of those points are taking x1 and x2, then we can have this as a particular formula. And recall, what we are given is that P is having 7,3 as its coordinate and Q is having 5, x as its coordinate. If we want to be consistent, I will take P as the first point, even though we are moving, okay, if we are moving in the positive direction, Q will be the first point. So we can say Q will be, this is x1 and this is y1. So y1 is x, x1 is 5. Then P, x2 is 7, and then y2, that is 3. So if you want to use this particular formula here, you need to recollect that you have been given the magnitude of that distance to be square root of 29. So what we have is root 29 is equal to the square root of all of this. Y2 minus y1. Y2 minus y1 will be 3 minus x, and then we square that, okay, plus x2 minus x1 will be 7 minus 5, and then we square it. Now, look at something. Because of this, I'm having square root here, I'm having square root here. I can say, I can take off the square root, or I can say I want to square both sides of the equation, okay? And what I'm having here is as if I'm having a raised to power half, which is root a. Then if I square it, I will just have a raised to power half multiplied by 2, and these two can cut each other. So this is just a raised to power 1, and that is it. So inherently, if I'm saying I'm squaring both sides of this particular equation, that means I'm taking care of the square root in such a way that what I'm going to have is only on the left hand side, I will have 29 is equal to, on the right hand side, 3 minus x raised to power 2 will be 3 minus x multiplied by 3 minus x, okay? Then plus 7 minus 5 is 2, 2 raised to power 2, that is 4. So I just need to open up this bracket, take 29 to the other side, and solve for the value of x in this question, okay? So 3 minus x multiplied by 3 minus x is just going to be, let me just take everything to the right hand side. I'm going to have 3 times 3 is 9. 3 times minus x is minus 3x. Minus x times 3 is again minus 3x. Minus x times minus x is plus s squared. You need to take note of your sign, okay? Then we have plus 4. Then when 29 moves to the other side, we have minus 29 is equal to 0. So this is a quadratic already, and we can try and solve that. Let me just arrange appropriately. S squared being the first term, minus 3x will be minus 6x. Now I have 9 plus 4 minus 20. In the first case, 9 minus 29 is minus 20. Minus 20 plus 4, that will be minus 16 is equal to 0. So if we want to factorize this, we are looking at a product of terms that will be minus 16x squared, the first term and the last time. And we are looking at the sum that is going to be minus 6x. Now, normally we just look at 16 itself. We can say it is 8 times 2. Of course, we are looking at x with it. And then for the sum, let's also look at 8x and 2x. Now, looking at this, we can see that it is negative 6x that we are looking at. So, if we append minus 8x plus 2x, of course, that's going to give us minus 6x. And then, for the product, we say minus 8x times 2x. Minus 8 times 2 will be minus 16. X times x will be x squared. So, minus 8x and 2 will be very good for us to use. And that's what we are going to do now. Okay. So, we can say this is nothing but it's giving us x squared minus 8x plus 2x minus 16 is equal to 0, such that here we can say in the first two times x is common, so we have x minus 8 remaining, and the last two times 2 is common, so we have x minus 8 remaining. So this is equal to 0, okay? And then if we look at this, we can just say x minus 8 is common to both. So we have x minus 8 into bracket x plus 2, which will be remaining after we factor out x minus 8 from them. This is equal to 0. Now, this is where it gets interesting. This is telling us that it's either x minus 8 is 0 or x plus 2 is 0. So we have x minus 8 is 0, or we have x plus 2 is 0. And that means that x is actually 8 or x is actually minus 2. Now, this is where our understanding of geometry can really come. If we go back to our diagram, you can see that I'll be able to locate P, and I'm suspecting that yes, I'm going to have two answers that are going to be right in this case. Let's locate x is minus 2, but recall it is 5 comma x, so that x is located on the y. So minus 2, this is minus 2, minus 2, so this is where we have minus 2, and then 8, good, this is where we have our 8, and yes, this is what I was suspecting originally, that this can be the length that we're asked to find, or this can be the length. And you can see it's looking something like an isosceles triangle in which this side and this side, they are equal because they're actually of the same length. So the value of x that we're asked to find can be 8 or it can be minus 2, and we have been able to do that and find it out as required, and we are good and fine. In this question on commercial math, we are told that on Sam's first birthday celebration, his grandfather deposited an amount of $1,000 in a bank, compounded at 4% interest annually. So we need to know that here we are talking about compound interest, okay? So we have to find how much is in the account if Sam is 4 years old. Let's list all the parameters that we are given. We need to know that we are talking about Sam's first birthday celebration. So he's not starting when he was 0 years old. And the question is asking us to find how much is in the account when he is 4 years old. So in this particular question, the time period will be 4 years old, which we are being asked, minus the period when the deposit happened, which was when he was 1 year old, and that will be 3 years. We need to get this straight and correct, otherwise our answer will be off the mark, okay? Then the principal that was deposited originally was $1,000, and then the rate, it was 4% compound interest annually. Now, for us to solve this question, to find the amount when Sam is 4 years old, we can actually do it year by year, okay? But I want to use a formula in this particular case that the accrued amount is going to be the principal multiplied by 1 plus the rate raised to power the number of years, okay? And that number of years is this time that we are looking at as 3 years. So you just want to put in all the parameters there. We can say the accrued amount, which is going to be in the account, is going to be the principal, which is 1,000 multiplied by 1 plus the rate is 4%, and 4% is the same as 4 over 100, which is 0.04, and then n will be 4 minus 1, that will go to be 3 initially. So I can say this is nothing but 1,000 multiplied by 1.04, because 4 over 100 is 0.04 raised to power 3. So this is what I need to put in the calculator to solve for this question, and we'll be fine, okay? So we have 1,000 multiplied by 1.04, okay? And that 1.04 is raised to power 3. So I can say shift square, and we can get this 1124,864. So this is 1124,864. Generally, finances, we only have 2 decimal places, so we can say this is approximately 1124.84. Will round down to 0 because it's not up to 5, and then we only retain 6, and this will be the answer for us. You could have taken this year after year, look at the interest for the first year, add that to the initial amount, use that as the principal for the next year, add that to the initial amount, and then you can get this final answer just as we got. But I think this is quite good and fast, and you'll find it useful also. All right. In this question on circle theorems, we are told that in the diagram A, B, C, D are points on the circle with center O here. Now, if the length of AB and BC are equal, so we have AB and BC, they are equal. That's why they even notch them. and angle ADC is 50. So ADC, this angle here, is 50 degrees. Our mandate is to find angle BAD. Okay, let's locate that. Is angle BAD. So this angle here is what we are mandated to find. So this angle here is what we are mandated to find. Okay, now looking at this particular diagram, a very crucial point that will help us is to divide this particular diagram. Since we are told that there is this length AB equal to BC, let's bring in an isosceles triangle that we can have the base of that isosceles triangle to be equal. So we can just say we want to look at a scenario in which we have from point A to point C. This is as good as it gets. Okay, and then we can see that from this particular diagram, first and foremost, we can say we want to find this angle ABC, and I can see that ABC and ADC, they are opposite angles of this cyclic quadrilateral. First, I can say angle ABC plus angle ADC, the sum is 180 degrees. Why? And why am I saying that? Is because they are sum of opposite angles of a cyclic quadrilateral. So our understanding of that will help us to solve this question. And then we have given ADC as 50. So ABC, that means that angle ABC will be nothing but 180 minus ADC, and ADC is 50. So this is 130 degrees. So we can just append it on the diagram that this is 130 degrees. Okay. Now, that being 130 degrees, I can call this angle here the base angles of the isosceles triangle. If I just call each one of them X, let me say this is this angle here, this is X, and this angle here, they will also be X. And I'm saying both of them are X because they are the base angles of isosceles triangle, meaning that I can say angle BAC is equal to angle BCA, and I'm appending them as X. And I'm saying this because they are base angles of isosceles triangle. Isosceles triangle have two of its sides equal, and then the base angles equal. All right, so that is good and fine. I think I can also look at the triangle ACD, or particularly the angle ACD, and this angle ACD will be 90 degrees. Why am I saying it's 90 degrees? Because it is the angle subtended at the circumference by the diameter AOD of the circle. So I can look at this and say angle ACD is nothing but a right angle, is 90 degrees, and I'm saying that because it is angle subtended at circumference of the circle by the diameter of the circle. So these are all geared towards my getting this particular angle BAD here. So since I have gotten that, I can now say that 130 degrees plus angle X plus angle X, this 130 plus this X plus this X, the three of them, they are the angles of the triangle ABC, and the sum of angles of a triangle is 180 degrees. So I'm postulating this because they are the sum of angles of the triangle ABC, okay, such that I will have 2x to be 180 minus 130, which is 50, and then x itself will be 50 over 2, and that will be 25 degrees. So x is 25 degrees, and that is good and fine. But I can also look at this particular region and say I can find this angle. If I call that y, okay, if I'm calling this y, I can see that from the triangle ACD, y plus 90 plus 50 is going to be 180 degrees, and because they are the sum of angles of a triangle, so I can say furthermore the angle y plus the ACD that I got as 90 degrees initially, plus the 50 degrees that we are given as angle ADC, plus that 50 degrees, the three of them, they add up to 180 degrees because they are the sum of angles of the triangle ACD, the triangle ACD. And with that, I can find my y to be 180 minus the sum of 90 and 50, that is 140. So y is nothing but 40 degrees. And what I was originally asked to find, we are told that it is angle BAD. Now we can see from the diagram that angle BAD is the combination of x and y. Look at this. This is the interesting thing that we should be doing in our question. This angle x, okay, and then this angle y, you can see that the two of them are what constitute angle BAD, which we are looking for. So we can easily say the angle BAD is the sum of x and y. And what is our x? We got x to be 25, so x is 25 degrees. What is our y? Y is 40 degrees. So angle BAD is nothing but 65 degrees. And with that, we've been able to solve this question, making use of the properties of triangles and the circular quadrilateral and the angle subtended at the circumference by the diameter to get the value of angle BAD at 65 degrees.
Here in this question on indices and logarithm, we are told that log to base 10 of 6 plus log to base 10 of 45 minus log to base 10 of 27, we are to solve it without using mathematical tables. Now, this is what we want to do. Since each of the entity is log to base 10, you can just write a single log to base 10, okay? And then by reason of the law of logarithm, here, since we are adding them, addition will turn to multiplication, subtraction will turn to division. So we have 6 multiplied by 45, then divided by 27. And what are we doing here? We're only applying the law of logarithm that is telling us that if you're adding logarithm of the same base, we can take a singular base, and for the addition we can multiply, for the subtraction we can divide. That is why we do this. So we can just go ahead and just simplify this. For example, 9 can go in 45, that is 5, okay? 9 can go in 27, that is 3. 3 here 1 and 3 in 6 is 2. So what we have inherently is log to base 10 of 2 times 5 is 10, 10 divided by 1 is also 10. And whenever you are seeing this, the logarithm of a number to the base of that number is nothing but 1. So in the first case, in this A, the solution is 1. Isn't that simple? Okay, that is quite interesting. In B, in this question B, we are told that 8 raised to the power x is equal to 32. And if we want to solve this, we can notice that 8 is actually a multiple of 2. 32 is also a multiple of 2. So if we want to write to the barest base, we can say 8 is 2 raised to the power 3. You see how that x, okay, is equal to 32 is 2 in 5 places, so it is 2 raised to the power 5. And by reason of this that we have, we can open up this bracket to say, therefore, what we have is 2 raised to the power 3x is equal to 2 raised to the power 5. Now, if you have questions like this, and we're seeing that the base are of the same value, this is 2 and this is 2, then that means that the powers, they must be equal. And in that case, we can just say this implies that 3x is equal to 5. And if we divide both sides by 3, that means x is nothing but 5 over 3. So that is also done and dusted. And we can go to our question C, in which we have 81 raised to the power 1 over 6 is dividing 27 raised to the power minus 1 over 9. Alright, this is also quite interesting. First and foremost, I can also see that 81 is 3 raised to the power some power. Ideally, 81 is 9 times 9. 9 itself is 3 times 3. So 81 is 3 times 3, which is 1 9, then multiplied by 3 times 3, which is another 9. So that is 3 in 4 places. I can say this is nothing but 3 raised to the power 4. Then this 1 over 6 raised to the power 1 over 6. Then divided by, okay, this is where it gets interesting. Now, for the 27, 27 in itself is 3 raised to the power 3. 3 times 3 is 9, times another 3 is 27. So we know that. But what do we do with respect to this negative power that is at the base? When you're having negative power like this in indices, that means you're having 1 over, okay? So 1 over all the other values that we have, which is 27 will get to be 3 raised to the power 3, okay? Then we still have 1 over 9. So this is interesting now. We can just say, furthermore, trying to solve this, this will give us, okay, we can just open up the bracket like here. 4, 2 can go in 4 is 2. 2 can go in 6, that is 3. Here, 3 can go in 3, 1. 3 in 9 is 3. So I can just say this is nothing but 3 raised to the power 2 over 3. Okay. Divided by, let me just write this out first. Divided by 1 over 3 raised to the power 1 over 3. Okay. So this is interesting now. And we know that if you have division, I want to solve it. What we are going to be having is that
By the time we turn the division to multiplication, this will reverse. Numerator will go to denominator, denominator will go to numerator. So what we have here inherently is that we're having 3 raised to power 2 over 3 multiplied by 3 raised to power 1 over 3. Because since we have turned division to multiplication, then this numerator and denominator, they must change. And this, we can just say we want to take one base. Since it's multiplication, laws of indices tells us that we can add the power. So we have 2 over 3 plus 1 over 3. And 2 over 3 plus 1 over 3, the same denominator, that is 3. 2 plus 1, that is 3. So this is nothing but 3 whole number, 3 over 3. So this 3 over 3 is 1. So we have it as 3 raised to power 1. And 3 raised to power 1 is actually 3. So the solution here is 3. And with that, our question here in this indices and logarithm had been done and dusted. And we got our answers as 1, 5 over 3, and 3. Alright. In this question, the equation of a line, we are told that a straight line passes through the point A, which is defined as 3, 0. So that means here, what we're having is x, y. X is 3, y is 0. And B defined as 2, minus 1. Again, we have it as x, y. So here, x is 2 and y is minus 1. So we have to look for the gradient of the line and the equation of the line. A picture is worth 1,000 words. So I just want to show us what this is looking like. And in this case, this first point A, which is defined as 3, 0, x is 3, y is 0. So this is the point that is A, okay, here, over 3, that is A. Then B is 2, minus 1, x is 2, here, and y is minus 1. So this is point B. And we have to look at that graph. That means we have something like this. So that graph will give us something of this order. Okay, so that is the straight line that they are particular to be asking us about. So first, they're asking us to find the gradient of the line. If we want to work within the confines of the value that we're given as A and B, we can just look at this, that this is going to be the gradient. So we can have the change in y-axis between 3 and minus 1 over the change in x-axis. But furthermore, for me, you can even just take it bigger. You can say you are looking at something like this, which you are looking at a change in y-axis divided by a change in x-axis. Either one, you see that you are going to get the same thing. But ideally, if you just want to use your equation as a guide to solve this question, you can just say the gradient in the first case, gradient, which is m, that we have to look for is change in y-axis over change in x-axis. So in this particular case, what is the change in y-axis? Y is the second one. So we can take B as the second case, or can take A as the second case. Whichever one we are actually given, you still arrive at the same answer. I want to make use of B as the second. So I'm going to say minus 1, which is the value of y in the second case, minus the value of y in the first case, minus 0, over the value of x in the second case, which is 2, minus the value of x in the first case, which is 3. So I'm going to have minus 1 minus 0 is minus 1, 2 minus 3 is minus 1. So the gradient, which is the slope, is nothing but 1, because here we are going to have it that minus sign, we cut out minus sign, so we have 1 over 1, and that is 1. The same thing could have gotten directly from the graph, that you can say that, okay, between this point A and this cut, if you just extrapolate the value, you see that you are going to get the same answer. So that is the gradient. In the second case, we're asked to find the equation of the line. Students, I want to quickly show you something. The general equation of the line is given as y is equal to mx plus c, where m is the gradient that we just got as 1, okay, and c is the intercept on the y-axis. So in this case, we have it as minus 3. So because of the understanding that I have of this question, I can just say my answer that I'm going to get is going to be nothing but y is equal to m, I got it to be 1. I don't need to write 1 as a coefficient of s, so I'll just say x, then plus c. I'm seeing from my graph that c is minus 3. I'll just say minus 3. And I know that this is going to be the answer that I'm going to get in this second equation, that the equation of the line is nothing but y is equal to x minus 3. But I'm only extrapolating that from the graph because I understood the concept of the straight line and I can pictorially view it on the graph and even sketch it out. But for you students out there who want to just get your hands dirty and work this out, so we can say out of the myriad of equation I want to use, we just want to get it out. And in this case, I will use y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1, okay? So I'm taking A as my 1 and B as my 2. So I'm going to have y minus y1. What is the value of y in the first one? I told it is x comma y. So y here is 0, y minus 0 over x minus, what's the value of x1 here? It is 3, okay? Is equal to, in the second case, y2 now is minus 1 minus y1 is 0 over x2 is 2, okay, minus x1 is 3. So this is what I have, and I have y minus 0 is nothing but y. I can also cross multiply y minus 0. Okay, let me just express it out first. Y minus 0 is y over x minus 3 is equal to minus 1 minus 0 is minus 1, 2 minus 3 is minus 1. And again, I can see that minus 1 will cut minus 1, and that will be 1. So that if I cross multiply, I'm going to have y is equal to x minus 3. And if you're observant, can you see that that is exactly what I extrapolated from the graph initially? So your understanding of all these simple techniques in mathematics can help you just sort out this question, and you'll be able to solve your question on the fly, and you are sure that yes, what I did was the right thing and I'm on my way to excellence. So we have gotten our gradient to be 1 and the equation of the line to be y is equal to x minus 3. All right. In this question on mensuration of shapes, we are told that ABCD is a parallelogram with side AD given as 8 centimeters, side AB as 6 centimeters, and angle ABC at 60 degrees. We have to calculate, correct to 3 significant figures, the area of triangle ABC and parallelogram ABCD. So that will warrant that we really understand how to put in all these parameters into our parallelogram, okay? So if I look at the information that we're given, like AD is 8 centimeters, so that should be either here or here because that's the longer side, okay? Then AB is 6 centimeters, that should be here or here. But looking at this angle, I think this will be the determining factor. That angle ABC is 60 degrees, so that is acute. It is less than 90. So the two angles that are less than 90 is either here or here. So for me, if I want to append that appropriately, ABC means it is at point B that we are taking that angle at 60. So I can say, let my B be here, okay? So this angle here now is 60 degrees, okay? Then I want to look at my AB, which is 6 centimeters. I have this and this as the option to pick. I'm saying that the shorter one is 6, so this should be 6. So I have this as AB, and say this is 6 centimeters. And then AD, so AD will be the next one. Of course, this cannot be C because we are giving AD, so I can say this is D, and then that will leave this place to be C. So these are the hints that can actually help you to get your question right because you're already interpreting the question correctly. And here I can say AD is 8 centimeters. And since you can interpret the question correctly, then you are good and fine. So what we asked to do was that here we are told that we are to find the area of triangle ABC. Wow. So even though it's a parallelogram, we need to first find the area of the triangle ABC. And to finish up so that I can get the triangle ABC, I can just join A and C with a straight line. So I have triangle ABC here that we're actually looking for. Since it's a parallelogram, the two parallel sides facing each other will be equal. So this is also 8 centimeters. And this AB will also be equal to DC. So this is also 6 centimeters. So we have to find, in the first case, the area of the triangle ABC, and by understanding of area and what we have, I think we can use half base times height, in which 8 centimeters is the base, but we need to get the height of this particular triangle ABC, we can go to point A and draw our straight line down, and we can say this is the H of this triangle. Okay, so if you look at this, okay, let me just call this point T. For us to get the area of the triangle ABC, it has to be half base. Base is BC, okay, multiplied by the height. The height is this 80, which is H. But if you look at this triangle ABT, we can see that H is opposite to 60 degrees, while 6 is the hypotenuse of that triangle. So consider that triangle is a right angle triangle, triangle ABT, and we want to use SOHCAHTOA. If you want to use SOHCAHTOA with that, we can see readily that this is the opposite and this is the hypotenuse. What is the relationship between opposite and hypotenuse? That is sine. Sine is opposite of hypotenuse, so we can say sine 60 is the opposite, h over hypotenuse 6. Therefore, our height is 6 sine 60, okay? So that the area of the triangle ABC that we are looking for is 1 over 2 multiplied by the base, which is 8, multiplied by the h, which is 6 sine 60. So this is what we need to put into our calculator, and we'll get the area out, and then we can evaluate it correct to 3 significant figures as requested. So let's bring out our calculator. We are going to have half, which is 0.5 times 8 times 6 sine 60, and close that bracket. So this is 12 root 3, or I can take it at 20.7846. 20.7846, but we are asked to get it correct to 3 significant figures. 3 significant figures will warrant that we look at this, and we're only going to take 3 digits, okay? So we can look at 2, 0, and then we need one more. We can take 7, but 8 is greater than 4, so we need to round it up to 1 and add to 7, so that will be 20.8 centimeters square. That is the area of the triangle ABC as requested. So in the second case, we have to find the area of the parallelogram ABCD, okay? And this is nothing but the base multiplied by the height. Interestingly, we have gotten our height, and the base is 8 centimeters, so we can say this is just 8 multiplied by, what's the height? 6 sine 60. Okay, that is even 2 times the previous answer that we got initially, because this is having half as a coefficient, but this is not having half as any coefficient. So if you take our calculator, I could just say we want to delete this 0.5. So we have 8 sine 60, so that's 24 root 3, and that will be 41.5692. 41.5692. But again, remember that we are told to find the answer correct to 3 significant figures. So we can say we want to round it up to 3 significant figures. We have 4, we have 1. Those are 2 significant figures. 6, we round up to 1 and add to 5. So 5 will become 6 centimeters square. And with this, we've been able to solve this question on mensuration and gotten our answer, because first we are able to interpret the question well to get our diagram, and then we can use the formula for area of triangle and then area of parallelogram, and we are good and fine. We had this question on word problem in which we are told that a village P is 12 kilometers from village Q, and it takes 3 hours 20 minutes to travel from Q to P and back to Q by a boat. So that is both the to and the fro journey. It is taking 3 hours 20 minutes. So we're now being told that if the boat travels at a speed of 6 kilometers per hour from P to Q and 6 plus S kilometers per hour back to P, we have to find the value of S. Let's look at this distance that we are looking at. We are saying first is moving from P to Q, and for that it is going at a speed of 6 kilometers per hour, okay, and then back from Q to P. So we are having a return journey, and that is taking 6 plus x kilometers per hour. So our mandate is to find x. Let's look at all the parameters that we are given. The total time that we are given was 3 hours 20 minutes, but we cannot actually be working with 20 minutes because look at the question. The speed is given as kilometer per hour, so we need to express that 20 minutes as hour. It will be 3 whole number 20 over 60 because 60 minutes makes 1 hour. So 20 can go here 1, 20 can go here 3. So this is 3 whole number 1 over 3 hours as the total time that we are looking at for this journey to and fro. Okay, that is the journey both from P to Q and from Q back to P. So that's the very first thing that we need to note. Then from understanding of speed and distance, we know that if you are giving speed to be distance over time, if you cross multiply, you can say time is also distance over speed. So if you want to look at the journey to and fro, in the first case, the journey from P to Q, the time from P to Q is going to be the distance, which is 12 kilometers, over the speed, which we are given as 6. So this is 2 hours. Okay? If that is 2 hours, from Q back to P will be the total time, which is 3 whole number 1 over 3, or I can say it's 3 times 3, 9. 9 plus 1 is 10. 10 over 3 minus 2. So what I'm saying is that the journey from Q back to P will be the total time, which is 3 whole number 1 over 3 hour minus the time taken from P to Q, which is 2 hours. So if you want to solve this, you can find the LCM. This is 3, 10 minus 3 times 2 is 6. So we have this as 6, so that it will be 4 over 3 hours. So 4 over 3 hours is the time taken from Q to P. But from this particular formula, that time is distance over speed, and the distance from Q to P is still the same. So we can have 12 over, what is the speed? The speed is 6 plus x here that we are given here. Okay, so we can have 6 plus x, that is equal to 4 over 3. So here we can just say we want to cross multiply, and that will give us 12 times 3 is 36. So we have 36 is equal to 4 times 6 is 24, and 4 times x is 4x, such that 4x will be 36 minus 24, and 36 minus 24 is nothing but 12. So 4x is equal to 12, and therefore our x that we are looking for will be 12 over 4, and that is 3. So what is going to be the unit of x? You can see that x is being featured in brackets, and the unit appended to that was kilometer per hour. So the unit of x itself will also be kilometer per hour. So this is the value of x that we are asked to find from this word problem, that is a journey from village P to village Q. Alright.
Yeah, in this question on quadratic equation, in which we are asked to find the equation whose roots are 2 over 3 and 3 over 4, there are two methods you can go about trying to solve this. In the first case, you can make use of the general equation that x squared minus sum of roots alpha plus beta multiplied by x plus the product of roots alpha beta is equal to 0, in which alpha and beta are the roots of the equation. So in this case, you can say alpha is 2 over 3 and then beta is 3 over 4. So if you have that, we can just make use of alpha plus beta to say it will be nothing but 2 over 3 plus 3 over 4. And in that case, you can find the LCM, which is 12. That's 3 multiplied by 4, that's 12. 12 over 3 is 4. 4 times 2 will be 8, plus 12 over 4 is 3. 3 times 3 will be 9. So this will be 8 plus 9 is 17 over 12. Okay. Then alpha beta, the product of roots will be 2 over 3 multiplied by 3 over 4. So this will be 6 over 12. Okay. So if you want to use that in the equation, we can say that means we have x squared minus the sum of the roots, that is 17 over 12 multiplied by x, then plus the product of the roots, that is 6 over 12. And you will notice that I didn't change the value of the denominator because in this case I can multiply all through by 12 to say 12 can multiply
everything on the left hand side, and of course 12 multiplying everything on the right hand side will still be 0. So in this case, 12 times s square will be 12s square, okay? If I'm saying 12 times 17 over 12, the 12 will cut out this 12, so I have minus 17x. Then, in the same case, 12 multiplied by 6 over 12, this 12 will cut out, so we have only 6 remaining, so we have plus 6 is equal to 0. So this is as good as it gets, but that's not the only means by which you can choose to solve this question. We can also say we want to look at a scenario in which the roots being 2 over 3 and 3 over 4 means that x is equal to 2 over 3 or x is equal to 3 over 4. So we just want to work our way backwards from the situation in which we are working with means of maybe factorization means of solving the question. So here, if you cross multiply, we can say this means 3x is equal to 2, or we have 4x is equal to 3. That is just by cross multiplying. And then if you just take everything to the left hand side, in this case we have 3x minus 2 is equal to 0, or 4x minus 3 is equal to 0. So if you have this, that means these are the two factors that we're eventually solving, that if you are bringing them together, you can have 3x minus 2 multiplying 4x minus 3 is equal to 0. So we just need to open up this bracket now. 3x times 4x is 12x squared. 3x times minus 3 will be minus 9x. Minus 2 times 4x will be minus 8x. Minus 2 times minus 3. The negative signs will multiply to become plus. 2 times 3 will be 6. And this is 0. So if you just want to simplify this, this is 12x squared. Minus 9x minus 8x will combine to be minus 17x. Then we have plus 6 is equal to 0. And you can see in the same vein, we are actually arriving at the same answer that we got the other time. And whichever method you want to use in the exam, just be consistent, work out your question, and you see that you will arrive at the correct solution. All right. In this question on differentiation, we have to differentiate y is equal to s squared over 1 plus s squared with respect to s. And we can see that we have a numerator and a denominator. This is best solved by saying that we have y to be u over v, such that we will have our differentiation to be the differentiation of y with respect to s. As standard rule will be v du dx, okay, minus u dv dx divided by the square of v. Now, in this particular case, what we are noticing is that since you are saying y is u over v, that means our u is s squared, and in that case, du dx, the differentiation of u with respect to s will be 2x as standard differentiation, and then v we are taking as 1 plus s squared, and then dv dx is also differentiation of a constant is 0, so differentiation of 1 is 0. Differentiation of s squared is also 2x. How are we differentiating? We are saying that if y is a multiplied by x raised to the power n, then the y dx is going to be nothing but this coefficient multiplied by that particular power, then you have x and you reduce the power by 1. So that is the means by which we are differentiating here. And if you want to put in all these values here for u, v, du dx and dv dx, then we can say that the differentiation of y with respect to x will be nothing but v. What is our v? V is 1 plus s squared multiplied by du dx. Du dx is 2x. Okay, then minus u. U itself is s squared multiplied by dv dx. dv dx is 2x, so multiplied by 2x. Then we are dividing by v squared. V squared is 1 plus x squared. Okay, so we now raise it to the power of 2. So this is what we need to simplify. Open up the bracket and see what that is going to give us. So we can say the y dx is nothing but 2x times x is 2x. 2x times s squared, we have x raised to the power 2 and s raised to the power 1. We can add the power. So we have it to be plus 2 as a coefficient, then x raised to the power 3, which is 2 plus 1, okay? Then minus here, again, we're having x squared multiplied by 2x. It's going to be 2x3, just like we did initially. Then we are dividing by 1 plus s squared raised to power 2. So we can see in the numerator that 2x3 minus 2x3, they will knock out. So this will give us 2x over 1 plus s squared raised to power 2. So inherently, what we are asked to find that the differentiation of y with respect to x is this as 2x over 1 plus s squared raised to power 2. This is our final solution and our answer is out and done. Here in this case, we have to solve this particular equation that 2 over 3 multiplied by 3x plus 2 is equal to 3 over 4 multiplied by 2x minus 3. And as a rule of thumb, what I will solicit that students should do, look at 3, look at 4. These are denominators. You can choose to cross multiply, or you can choose to multiply both sides by the product of these 3 and 4 that are the denominator. Okay, whichever one is suitable for you. If you say, okay, 3 multiplied by 4, that is 12. So I want to multiply both sides by 12. 12 multiplying all of these, and 12 also multiplying all of this. In that case, you can see that 3 can cut 12 to give us 4, and 4 can cut 12 to give us 3. So if you open up this now, 4 times 2, that is 8, into bracket 3x plus 2 is equal to 3 times 3, that is 9, into bracket 2x minus 3. It's the same thing as if you just want to say you want to directly cross multiply, that 3 times 3 is 9, so you have 9, 4 times 2 is 8. We are still going to arrive at the same thing. So we can now open up our bracket. 8 times 3x is 24x, plus 8 times 2 is 16, is equal to 9 times 2x is 18x, minus 9 times 3, that is 27. Here, you can just collect like terms to put the variables on the left-hand side. So we have minus 18x is equal to minus 27, and when 16 goes to the other side, it becomes minus 16. So 24x minus 18x, that is 6x, is equal to minus 27 minus 17. Minus 27 minus 16 will be minus 7 plus 6 is 13, remaining 1. 2 plus 1 is 3. With that one, we have 43. So if we are to divide both sides by 6, x will be minus 43 over 6. And this will be, 6 can go in 43, and that will be 7. 6 times 7 is 42. 43 minus 42, that is 1 over 6. So we have our answer to be minus 7 whole number 1 over 6 as a solution to this equation that we are asked to solve. Alright. We have this question on statistics of grouped data. So it is grouped because you can see that already there's a tabulated value in which we are grouping a set of values, a set of mass in this case, together, and we are looking at the number of occurrences, that is the frequency in which they occur. So we have this particular table showing the mass of logs of wood to the nearest kilogram, and our mandate is to calculate the mean and the mode. I would have actually loved that they asked us the mean, the median, and the mode, but no problem. Let's work within the rotation of what we are given. Now, in this particular question, for us to find the mean, that will just be quite straight and direct. But because we are looking for the mode, we are looking for the most occurring mass among all these data entry, we need to tabulate our result and formulate some data sets that will be useful for us to estimate the mode of this particular data that we have. So this is what that table will look like, and I will just do some so that we will see how this is done. First and foremost, we need to replicate this data entry into this particular table. Our interest is the data set, which is the mass, the frequency, the number of occurrences. We are going to get the median value of that particular mass because it's actually a range from 31 to 40. We need to get the midpoint of that class, and we can multiply the frequency and the midpoint of the class as fx. Then the class boundary, we need to find the upper and the lower class boundary, and this is how we go about that. First, let's tabulate all the data entry, and we just do that as given on the go. The frequency we have also been given, we just need to replicate that. Now, for us to get the midpoint of this particular data set, we need to look at something sort of like the median of this particular data entry. Like we are having 31 plus 40 divided by 2, that will be 71 over 2. So what's the median of this? 2 in 7 is 3, and that will be 2 times 3 is 6, remaining 1. 2 in 11 will be 5.5. So the midpoint for the first particular set of data grouping is 35.5. And I'll just show you something now. Add this as 35.5. If you are consistent, you see this as 45.5, 55.5, 65.5, 75.5, and 85.5. You can check that out and you see that this is the midpoint of this particular data set that we have. Now, for us to get our fx, we just need to multiply all through the frequency multiplied by x. That is going to give us fx, and I'll just do like 3 times 35.5. So we have this as 106.5. So we have this as 106.5. And you can just do the others just like that. Now, for us to get the class boundary, just look at the last entry in this particular first data set and the first entry in this, and try to find the midpoint between them. Okay, that midpoint in this case is going to be 40.5. So what you have with this as 40.5 is just that in the first case, you can see that at the upper class boundary, we are adding 0.5 to 40, and at the lower class boundary, you are going to subtract 0.5 from 31. You have it as 30.5 to 40.5. And then the next one will just kickstart from that, 40.5 to 50.5, then 50.5 to 60.5, then 60.5 to 70.5, 70.5 to 80.5, and then 80.5 to 90.5. So that is what we are going to have as a means of generating our table of values. Then we can go to our question originally, as we are asked that in the first case we are to find the mean, and here is the formula for the mean. It is the summation fx over summation f. This is our fx here, that is fx. So we have to sum all of these together to get the total, and then we divide by the summation of f. Okay, so you can just take our calculator to try and compute that. Fx is what we want to sum now, and for that we have 106.5 plus 455 plus 832.5 plus 786 plus 453 plus 342. So what is that sum? 2975. So I can say here what we have is nothing but 2975 divided by the summation f. You can say 3 plus 10 plus 15 plus 12 plus 6 plus 4. So that is 50. So we have divided by 50. So our mean that we are looking for is nothing but 2975 over 50. So we have 2975 divided by 50. So this is 59.5. So the mean is 59.5. And what's going to be the unit? You can see is mass we are talking about here, and is measured in kilogram as given. So the mean of this data set is 59.5 kilograms. So this is the easy part. We now need to look at how we can evaluate our mode. So for us to be able to get our mode, this is the formula that we're going to be making use of. You don't need to fret at all. I'm going to demystify all of these terms, okay, and we're going to work them out together. In the first case, the LL is going to be the lower limit of the modal class, okay, and the modal class is the class that where we have the highest occurrence of data entry. It's going to be the class with the highest frequency, and for this you can identify it that this is a class of interest that we are talking about. Is this 51 to 60? That is going to be our modal class, and its frequency is 15. So we are talking about the lower limit. That lower limit means that we need to look at that modal class as featured here, okay, and that lower limit you can see from the class boundary, from lower limit to upper limit. The lower limit is 50.5. So you can have our LL to be 50.5. all right. So we want to evaluate theta 1. What is theta 1? Theta 1 is going to be the difference in frequency between the frequency of the modal class and the frequency of the class before it. Now, we have seen that here, this is actually the frequency of our modal class. The frequency before it is 10. So, theta 1 is going to be 15 minus 10, and that is going to be 5. Okay. Theta 2 is going to be, now, the frequency of the modal class minus the frequency of the class after it, and that will be 12. So, we are going to have 15 minus 12 here, and this is going to be 3. Okay. Then, the C is going to be the class size, and you can get that by subtracting the lower class boundary from the upper class boundary. Maybe we can say 40.5 minus 30.5 if you want to use that first class, or 60.5 minus 50.5 is going to be the same thing. So that is 10. It is 60.5 minus 50.5, and that is 10. So these are the parameters that we need to solve this holistically, so that we can say our mode for this particular question set is LL, which is 50.5, plus theta 1 is 5 over theta 1 plus theta 2, that will be 5 plus 3, multiplied by the class size, which is 10. So you can say our mode is nothing but 50.5 plus 5 over 5 plus 3, that will be, okay, 5 times 10 is 50. 5 plus 3 is 8. I think we can just get this out straight, that our mode is nothing but 50.5 plus 8 in 50, that is 6. 8 times 6 is 48. So we have 2 remainder. 2 over 8 is 1 over 4, and that is 0.25. So our mode is going to be 50.5 plus 6.25, and that will be 56.75. And what's going to be the unit is going to be kilograms. So the mode in this particular group data that we're actually given is nothing but 56.75. All right. In this question on geometric progression under sequences and series, we're told that if the second term of a GP is 6 and the fourth term is 54, we are to find the first term and the fifth term. So, as a reason of a recall of our understanding, the nth term of a geometric progression is given as the first term A multiplied by the common ratio raised to power n minus 1, where n is the number of terms. Okay, so in this particular question, we already told that the second term T2 is 6, and then the fourth term T4 is 54. Okay. What we need to note is that if we want to apply this particular formula, we need to say that T2 is nothing but the same as A, which you don't know yet, multiplied by the common ratio, which you don't know also, then raised to power n minus 1. Since we are talking about T2, n is 2, so we have 2 minus 1, and that is 1. We don't need to write 1, okay? And then for T4, it's going to be A, the first term, multiplied by R raised to power 4 minus 1. So I have 4 minus 1 here. Okay, let me just write this as 2 minus 1. So if you want to reflect that really, these two, you can now say that that means that AR is equal to 6, because 2 minus 1 is just 1. We don't need to write that. Then AR raised to power 3 is equal to 54. So these are two equations that we can have here, equation 1 and equation 2. To solve this, since it is actually a product, it will be best that we divide. So you can say equation 2 divided by equation 1, and that is going to give us nothing but AR raised to power 3 over AR is equal to 54 over 6. Okay, and then from here you can see that A is cutting out. 6 can go here, 6 can go in 54, that is 9. So what we have inherently is that R3 over R, which is the same as a single R, 3 minus 1 is equal to 9. So 3 minus 1, this is applying the laws of indices anyway. 3 minus 1 means that we have R raised to power 2 is equal to 9. And therefore R is going to be the square root of 9. Now notice, students, square root of 9 is not just 3. It is plus or minus 3. Okay, so you should know that. That means for this particular question, as you are getting the solution for the positive 3, you also need to be getting the solution for the negative 3. Okay, so we are noting R to be then we know that AR is 6, therefore A will be 6 over R. In the first case, when R is 3, A will be 6 over 3, and then in the second case, when R is minus 3, A will be 6 over minus 3. So we have A to be 2 or A is minus 2. Just like we have R is 3 or minus 3. Okay, so that being said, we can now say we want to go and look for whatever nth term that we are being asked to get. Like in this case, we are asked to find the first term and the fifth term. Okay, so that is good. We have gotten the first term, that the first term can be either 2 or minus 2. And that is very, very good. Then for us to get the fifth term, let me just clear some section of this board. So we can see that we have two sets of data value. In the first case, we have one in which we have our A is equal to 2 and then R is 3. And then in the second case, in which we have our A to be minus 2 and R is minus 3. So even for the first term, we are going to be saying that A is 2 or minus 2. And then in this second question, in which we are also being asked that we have to find the fifth term, T5. T5 is AR 5 minus 1, which is AR raised to power 4. So it's either we have it as, for the first case, you can say T5 is equal to A is 2, multiplied by R is 3 raised to power 4. So this will be 2 times 81, and that will be 162. Okay, or that's not the only case, or we can say our T5 is also A in the second case with this second option, minus 2 multiplied by minus 3 raised to power 4. Okay, so since this is an even number, the powers of minus 3 will still be positive, but we now have minus 2 as the coefficient multiplied by 81. So this will be minus 162. So these are the possible solutions that we can have, that T5 can be 162 or minus 162, and the first term A can be 2 or it can be minus 2. And with that, we've been able to solve this question. Don't just take the square root of 9 as 3 and think you are getting your correct answer. You're only going to get half of the mark, because square root of 9 is not 3, it is plus or minus 3. Okay, so just know that, and once you are able to pick that, you solve your question, you are good to go and your full mark is assured. Alright. We have this question on set theory with Venn diagrams, and we're told that in a school of 160 pupils, 75 have pencils, 87 have pens, 93 have rulers, 25 have both pencils and pens, 30 have pencils and rulers, while 47 have both pens and rulers. Each pupil has at least one of the three items. Our mandate is to first draw the Venn diagram to illustrate this information, and then to find how many pupils have pencils only. So for this particular question, we are going to be using P as our pencils, Q as our pen, and R as our ruler. And our very first mandate is to define all of this information that we have here, which we are going to be doing right about now. That in the first case, the number of pupils, which is the universal set we are looking at, is 160. Okay, and then we are told that 75 have pencils, so the number of those with pencils is 75. And then the number of those with pens, which we are denoting as Q, so you see Q is denoting pens, is 87. All right, then the number of pupils that are actually having rulers were given as 93, so we can tag that as 93. Then we have the intersections, like here 25 have both pencils and pens, so the number of pencils intersect pen were given as 25. Okay, and that's not all. We're also told that 30 have both pencils and rulers, so P intersect R, number of those having pencils and ruler, is given as 30. And then 47 have both pens and ruler, so number of students with pens, which we denote as Q, and ruler, is given as 47. So these are the information that we are given, that we're expected to also put in the Venn diagram. And then we need to know that the fact that each pupil has at least one of the three items means that all of the pupil will be included either within P or Q or R or the intersection of them with one another. None is going to be outside that combination of P, Q, and R. So that is that information. And as a rule of thumb, I generally prefer that we should start at the intersection of the three subsets that we are looking at. And you can see in the details that we are giving, we are not giving the detail of those pupils that has all three items that we are looking at. So since we are not giving, we can do well to call that X. Okay. So having done that, we can work our way outwards since we are starting from the center. Now let's look at the intersection of each one of them. Like in the first case, we want to look at the intersection of P and Q. P and Q, you need to know that will denote this region. This is P and Q. These two is the one that is common to both P and Q here. But if you notice from that already, we have gotten X out. So the remaining here that is in green will be that 25 that they denoted as P intersect Q. This two is 25. But if we take X out of it, this remaining here that is still in green will have to be 25 minus X. So you can say here, what we have here is 25 minus X. And that same rule we can apply to other intersection points. Like for example, we have the number of P intersect R. This is P intersect R. It is given as 30. So here and here is given as 30. But since we are taking X out of the equation, intersection of Q and R was given as 47. If we take X out, this region will be 47 minus X. Okay, so this is actually a very good means that can simplify your work for you. Now, if you look at the question, we are not giving information about those that have pencils only, and also we are not giving the information about those that have pens only, also not giving information about those that have rulers only. Okay, since we are not giving any of those, I would like to call those regions. Let me call this A, that is pencil only, B is pens only, and then C will be rulers only. But don't forget, we are giving P itself to be 75. So P here, this is 75. Q we are given to be 87, okay, and then R we are given to be 93. So with this information that we have here, the onus will now lie on us to make use of all this information and get out the solution to get the number of pupils that have pencils only, and that pencils only will be A. Okay, since P is a pencil, A will be pencil only. They only have pencils, they don't have rulers, and they don't have pens. Okay, so having interpreted our question already, we are seeing that we have 4 variables, 4 unknowns, and these are tagged as here. We have A, B, C, and X. A, B, C, and X that we are looking for. And to solve this holistically, we need 4 formula A that will help us to actually solve this holistically, so that particularly what we are being asked, the number of pupils that have pencils only, which we have identified as A, we can get that out easily. But first, we need to formulate our formula A that will help us to solve this holistically. We are seeing that we have some subsets in this particular Venn diagram. In the first case, we have been given the total number of pupils that have pencils as 75. So if we add all the regions of pencils, A, 30 minus X, X, and 25 minus S, we can equate it to 75, and that will give us one equation. Okay, we can do the same thing with Q, those pupils that have pens, and we can do the same with R, those pupils that have rulers. That is going to give us a set of 3 equations, but our 4th equation will warrant that since we are given the universal set, and we are told that each pupil has at least one of the 3 items, already we know that outside of these 3 subsets, no pupil is going to be there, but we have the universal set. So if we add all the entries, this region, this, here, and here, if we add all of them, it's also going to give us 160, and that will be our 4th equation. So what we are going to do right now is just to put all those out and see where it's going to land us. In the first case, for the number of P, we have A plus 25 minus X here, 25 minus X plus this X then plus the last region 30 minus x. The total of them is actually the number of pupils having pencils, which is 75. So we are getting this from our number of pupils having pencils. And if we look at this critically, we can see that minus x and plus x, they will cut out. So we have four unknowns, a and minus x, a minus x, 25 plus 30, that is 55. When 55 move to the other side, we have 75 minus 55. So this will be equal to 20. I can call this my equation 1. And in the same way, we can do for Q. That look at the entries in Q. B, 47 minus S, 25 minus S, and X. They all add up to be 87. So I'm going to have B plus 25 minus X plus 47 minus X is equal to 87. I'm getting this as a reason of the number of pupils that are having pens. Okay, so if I want to also simplify this, I can see that minus x and plus x, they are cutting, and b minus x are b minus x is equal to 25 plus 47, 5 and 7 is 12, 2 and 4 is 6, plus 1, that is 7. So I have that as 72. When 72 moves to the other side, I have 87 minus 72, so that will be 15. So this is equation 2. Okay, and then in the third vein, if I consider those pupils with rulers, I will also add each of these entries. So I'm having c plus 30 minus x plus x plus 47 minus x is equal to 93. This is the number of students, number of pupils that are having rulers. And again, in trying to simplify, minus x and plus x, they are out. We are left with c minus x as our variable. Then 30 plus 47, that will be 77. And when 77 moves to the other side, that will be 16. So I have 16, and I can call this my equation 3. Okay, but that is not all. I already told us that we have 4 unknowns, so we need 4 equations, and that last one will be the addition of all of these entries, equating them to 160 as universal set. So in that case, we have, let me just put it together as a plus b plus c, a, b, c. Then we have x here plus x plus 25 minus x plus 30 minus x plus 47 minus x. Everything is equal to 160. And this is a statement of the universal set. So what I have here eventually is that, look at this. This is plus x, this is minus x. They take themselves out. So I'm left with a plus b plus c. Then I have minus x and minus x. So that will be minus 2x. Then 25 plus 30, that is 55. 55 plus 47, that will be 102. So I have plus 102 is equal to 160, such that a plus b plus c minus 2x is equal to 160 minus 102. That will be 58, and I can call this equation 4. So I have these 4 equations, and of course I have these 4 unknowns also that I can try to solve out to get the solution to this particular question. And I'm seeing a symmetry. Look at this. I'm having a plus b plus c here. Okay. Now, if I add equation 1, 2, and 3, I can get a plus b plus c already. So those 3, a plus b plus c, here it will be minus 3x is equal to the addition of all this. I can actually combine with this equation to first solve for x, and that is what we are going to do exactly right about now. Okay, so these are the set of equations that we have already. If I add these 3 equations together, equation 1, 2, and 3, we are going to have a plus b plus c. So we have a plus b plus c. Then minus x plus minus x plus minus x will be minus 3x. Then 20 plus 15, that is 35. 35 plus 16, that is 51. So this is 51. Let me call this equation 5, gotten from the addition of equations 1, 2, and 3. Now, if you look at this particular 2 equations, equations 4 and 5, you can see that, let me just say, I want to subtract them. Okay, here I'm going to be subtracting. I want to subtract equation 4 minus 5. A plus B plus C, we subtract A plus B plus C, and that will be null. Minus 2x minus 3x will give us something like this. I have minus 2x minus 3x. That's going to be 58 minus 51. Okay, so that is making our work look interesting, because this will be minus 2x plus 3x is equal to 58 minus 51. That is actually 7. So minus 2x plus 3x means that x is actually 7. So the number of pupils that have pencils, pens, and rulers, x, is actually 7. But that's not what we're asked to get. What we're asked to find is that how many pupils have pencils only. So the number of pencils only, we can see that we denoted it as A. And looking at this equation, we can see that equation 1 is saying A minus x is 20. So from that equation 1, we can say we have A minus x is now 7 is 20. Therefore, A is 20 plus 7, and that is 27. And our A, you can see, is the number of pupils having pencils only. So we hope this had actually gone a long way to help you understand how to solve this particular type of questions on set theory, particularly with Venn diagrams. You don't need to be stereotyped. You don't need to be adaptive to the question, and then use your ingenuity. Like here, we are coming with an understanding of the fact that to solve a number of equations, you will need the exact number of equations as the exact number of variables that you are trying to get. So we have 4 variables, and for us to be able to get that, we need 4 equations. So we're able to postulate the equations that we can get. We also need to get the other value, like B. You can see from here, from equation 2, B will be 15 plus 7. That will be 22. C will be 16 plus 7, okay, and that will be 23. So you can just get everything out, and you can get whatever they wanted to ask. Once you have all these variables, you don't know them, they are no longer unknowns, they are knowns to you, then you can be good and fine, and your work will be done and dusted. In this question on parallel lines and the intersect, we are asked to use the information in the diagram to find the value of x as shown here. So this is what we are looking for, that is x. And looking at this diagram, we can make use of understanding of corresponding angles and alternate angles, whichever one will be suitable for us to try and solve this question as appropriate. And this is what I just want to do. For this particular line, if I want to extend this from here, okay, what I will need to notice first and foremost is that this angle here is also going to be 47 degrees, because it is corresponding to this angle. This is corresponding to the angle at C, which we can say is angle ACD. Okay, if we're looking at this angle also, this is 83, okay, and it's also corresponding to this angle coming from up here to A to B. That 83 degrees is corresponding to the angle at A, okay. So if you want to get how that is, you can see at A we are having something like this, okay, in which it is also just replicated here. And then this 47 degrees is also, just look at this, it's also looking like that angle. They are having the same shape, they are facing the same sides, so they are corresponding angles to one another. And then at D, after having done all this, you can see that at point D, at the vertex D, you can see that 47 degrees plus x plus 83 degrees, they are angles on a straight line, and the sum of angles on a straight line is 180 degrees. So we are saying this because they are the sum of angles on a straight line, okay. Since we have that as our postulate, we can now say 47 plus 83, that will be 130. So x plus 130 degrees is equal to 180 degrees, and then x itself can be 180 minus 130, and 180 minus 130 is nothing but 50. So the solution to this question is that x is 50, and this is just one of the ways that you can choose to do it. You can also choose so many other means. You can move your angles here, you can find this angle, okay, and you can also find this angle, and you see that it will also record to the same, because here this 47, this is also 47, and then because this line and this line, they are parallel, this AD will be a transversal across them. So here, this will also be x. In this case, x here and x here, they are alternate angles, and 47 here and 47 here, and you still see that 83 plus 47 plus x, they will still give you 180, and you still arrive at x as 50. So whichever method you think is suitable for you, you can use to solve this question, but you eventually get that x is nothing but 50 degrees.
We had this question on bearing and distances, in which we are told that a boat sails 6 kilometers on a bearing of 040 degrees and then 8 kilometers on a bearing of 100 degrees. We have to find how far the boat is from its starting point and to calculate the bearing of the boat from its original position. Our answers will be to the nearest kilometers and degree. Let's look at the very first statement, that it is moving 6 kilometers on a bearing of 040 degrees. 040 degrees is going to be in the first quadrant, so we can have a diagram putting that in consideration, that we have north, south, west, and east. Here we are going to have east, okay? And then we want to look at a scenario in which the movement is on a bearing of 040 degrees. So this should be something like this. Now, from this new position, it also moves 8 kilometers on a bearing of 010 degrees. Here we can also consider our cardinal points, north, south, east, and west. And then we are moving on a bearing of 100 degrees. 100 degrees will just be a bit more than 90, and 90 is from north to east, which is a right angle. So we'll have something like this. But that is now 8 kilometers, so it should be longer than the 6 kilometers that we just drew. And then we can say maybe we want to finish up our diagram just like this. Okay, I think that's a good pictorial view of what we are looking at. So we can now label that, okay, this is starting point. Let me call that A. To this point, I can call that B. Then to the final destination, I can call that C. Distance between A and B, we are told is 6 kilometers. So this is 6 kilometers. Between B and C, we're given as 8 kilometers. Okay. Then the bearing, we are told that from A to B is on a bearing of 040. So we want to know that appropriately. Let's say this is from my north. So I'm going to have 040. So from here to this inclination is 040. Okay. And then in the other case, we have the bearing from B to C was 100 degrees. So from here to here, this is 100 degrees. So this is our diagram. What we're asked to look for first is how far the boat is from the starting position. That is distance CA. Because this is A is the starting position, is ending at C. How far it is this distance between A and C. Now, since it is facing the vertex B, this will be small b. Since A is facing this particular side, BC, 8 kilometers is going to be small a. Then since C is facing this particular side, AB, this 6 is going to be C, the side facing the vertex, okay? Now, looking at this diagram, we have a triangle in which you don't know any of the included angles. But for us to solve, we need to know at least one of those included angles. So we'll try and see how we can get that. But looking at the point B, this is looking at our sure bet, because already we have this as 40. And we know that by reason of the rules of parallel lines and co, that 40, if you come here and also come down, this is also 40 as alternate to this 40 that was the bearing of B from A. Then from north to south is 180 degrees, but already we have the inclination of C from B to be 100. So what will be remaining here will be 80, such that that 80 plus 100 will be 180 degrees angle on a straight line. So we can compute this particular angle at B at the addition of 40 and 80. So you can say this here is nothing but 40 plus 80, which is 120 degrees, the one facing this B. So we have this particular set of parameters, and we're going to see how we can solve them to get how far the boat is from the starting position. We are looking for this B, and we can see that we have the angle facing B, then we have the sides flanking those angles, 6 kilometers and 8 kilometers. In this particular case, our best bet is to use the cosine rule. And the cosine rule, if you are looking for B, is saying that B square is going to be A square plus C square minus 2AC cos the angle at B, which is cos B. So we have all of these parameters. A is 8 kilometers, C is 6. The angle at B is 120. So if you just put in all those parameters, we can say B square is going to be, our A square is 8 raised to power 2 plus C is 6. So we have that raised to power 2 minus 2 times 8 times 6 cos angle at B is 120 degrees. So this is the square of B. Mind you, you can now say we want to input that to the calculator. 8 raised to power 2 plus 6 raised to power 2 minus 2 times 6 times 8 cos 120 cos 120. So this is what? This is 148. So B raised to power 2 is 148, and B itself, this is B raised to power 2. Therefore, B itself is the square root of 148. And we can say that B will be, if we are to look for that square, we can say the square root of the answer that we just got, that is 2 root 37 or 12.1655, 12.17. So we can say B is 12.17 kilometers. But look at the question. We said we have to leave our answers to the nearest kilometer. So if we want to round this up, we can see that 1 is the number after the decimal place. We will round it down to 0, and then this will just be 12 kilometers approximately. So for my B, if I want to note it, I will not note it as 12. What we got is 12.17. So this is the solution to the first question to get how far the boat is from its starting position. In the second question, we're asked to find the bearing of the boat from its original position. That bearing, this is the final destination C. Its initial position, original position is point A. So the bearing we are looking at will be from the north to the inclination of C from that north. So we can call that theta. If you look at this angle very, very critically, you can see that theta we can actually get by adding 40 to the angle here. So you can get this angle at A, you can get this angle. Okay, we'll just know that our theta that we are looking for is going to be 040 plus that angle at A. So if you are to do that, we'll have it that A over sine A is equal to B over sine B by reason of the sine rule. And what we are looking for is actually sine A. So in that case, we can just say sine A is going to be nothing but, here we would have cross multiply. So we have A sine B over B. So sine A will give us this value that, what is the value of A? It is 8. Sine B will be sine 120 over B. B itself is 12.17. We use the original value we get, not the approximated value. Okay, so we can say sine A is equal to, so we can say sine A will be 8 sine 120 divided by 12.17, 0.5693. So this is 0.5693, and then A itself will be arc sine 0.5693, and that's going to give us shift sine. The answer we just got 34.7. This is 34.7. But like I said the other time, the angle we are looking for, that theta, is going to be 40 plus the angle at A. It will be 40 plus 34.7, and that will be 74.7. Now, we're told in the question that we should leave the answers to the nearest degree. And as a rule of thumb, you don't leave the bearing as decimal place. You don't even leave it as 2-digit numbers. You need to leave it as
3-digit numbers. So just like they are giving us in the question, you have 0 for 0. So like this, if you are to round this up, okay, 7 will round up to 1 and add to 4, that will be 5, so making it 75. But as a bearing, we need to write it as 3 digits, so we have 0.75 degrees. So this is the solution in the second case. And holistically, we've been able to look at this question of bearing and distance, get the diagram accurately, solve for the unknown distance by making use of the cosine rule, and look at the triangle, use the sine rule to solve for the included angle, and then just oppose out the bearing as requested, and we are good and fine. Here in this question on calculus now, we are asked to find the area enclosed by the curve y is equal to 2x squared plus 3, the x-axis and the ordinate x is equal to 2 and x is equal to 1. And this is just the view of what the graph will look like. I just extrapolated the value of y is 2x squared plus 3 when x is 0, when x is 1, when x is 2, and when x is 3, and then got this particular graph. So what we are being asked to get inherently is the area that is enclosed by that curve, this curve in red, okay, the x-axis at the horizontal, okay, and then the ordinate x is 2 here when x is 2 and when x is 1. So the shaded region here is the area that we are asked to get. Now, if you look at that region critically, you will discover that this is nothing but approximately the area of a trapezium, in which you can find as half multiplied by the sum of the parallel sides. Because I was able to extrapolate this, those parallel sides, when x is 1 and when x is 2, the value corresponds to y to be 5 and y to be 11. So it's something like 8 square unit that we're going to get as the area of the trapezium. But you know, that is an approximation. It's actually a curve we are looking at. So we'll just do well to look at means of calculating that as requested. So what we're expected to do is to find the area under the curve, and for this particular case, it's giving us the integral from the lower limit here, which is 1, and the upper limit, which is 2, of the function of x with respect to x, okay? Or generally people tend to say it is actually the integral of y dx. And what is our y? We have been given our y to be 2x squared plus 3. So what we are looking for inherently is area of the integral value of the function 2x squared plus 3, and we integrate with respect to x, okay? And we have our lower limit as 1 and our upper limit as 2. Now, generally, if you want to find the integration of a function, if y is, let's say, axn, okay, the integral of y dx is going to be that a, the coefficient, multiplied by x, then we increase the power by 1 and divide by the new power. So this is means of actually going about solving for integration of a linear function, and that is what we are going to make use of in this particular case. So by the time we want to make use of that, we can say our area is nothing but, now for us to find the integration, we still have 2, then we have x, we increase the power by 1, that's 3, because 2 plus 1 is 3, then we divide by that new power, which is 3, okay, plus 3 is a constant, and the integration of a constant will just be that we bring the variable into it, because this is like 3 times x raised to power 0, so we still have that 3, then x raised to power 0 plus 1 will be x raised to power 1, and then we can divide by 1, but we don't need to be writing 1, so we just have 3x, and then since we are looking for area, we don't need the constant of integration, we just bound it by the region 1 to 2. And then this is what we need to solve for. Generally, people tend to like, okay, first they take this expression, substitute 2 into it, then minus, they take the same expression, substitute 1 into it. But you can do that. What I want to do here is that it's actually a factor equation. So I have it as 2 raised to power 3, okay, then x raised to power 3. The first case, I have 2 raised to power 3 minus 1 raised to power 3. So already I'm taking care of both the upper limit and the lower limit like this, then plus 3, then what's the value of x? I have 2, and then the second value minus 1. You can use the other method and you see that we'll still arrive at the same answer, okay? So with that in mind, we can say 2 raised to power 3 is 8, 1 raised to power 3 is 1, 8 minus 1 is 7. So 7 times 2 will be 14 over 3 plus 3, okay? So if you are looking at this, we can say we want to find the LCM, which is 3. In the fourth case, we just have 14 plus Now 3 is as if you're having 3 over 1. Of course, 3 over 1 is still 3, and then we can have 3 times 3, which is 9. So 9 over 3 inherently is still 3. So we are on track to say that this is nothing but 14 plus 9 is 23 over 3, and we can just find the whole number. 3 in 23, that is 7. Okay, 3 times 7 is 21. So remaining 2. So we have this as 2 over 3 square units. And you can see that this is quite close to the value we got the other time, looking at the trapezium, that the area under the graph is 8 square units. But because that is approximated, and we are having that this is 7 whole number 2 over 3, which is still approximately 8 square units. Okay, so this is how you go about finding the area under the curve, and you'll be good and fine. Student, you can try out your hand on the other case in which you first express, like in the first case, you put 2 into this bracket, then minus the second case in which you put 1 into the bracket, and you are going to see that we are still going to arrive at the same answer. All right. In this word problem on equations, we are told that in a community, men contribute P naira each and women contribute Q naira each towards the community development fund. That's a good cooperative work. Okay. Now, in a week, you have 3 men and 5 women contributing a total of 9,500. Since each man is contributing P, and we're having 3 of them, then we are having 3P. And then since each woman is contributing Q naira, and we're having 5 of them, that means we have plus 5Q. What they contributed is nothing but 9,500. Okay. And then in another week, 5 men and 10 women contributed a total of 17,500. That means we are having 5 men plus 10 women contributing 17,500. So that's a very good interpretation of what we have. Our mandate is to find the value of P and Q. So that can come out here since we're having a simultaneous equation in P and Q already. And then we have to find the total amount that will be contributed by 8 men and 12 women. No problem. Let's just see how that can be solved. Yeah, we have these 2 equations that, as I'm looking at this as, of course, we call this week 1, and then this another week, let's say week 2. So inherently, we have these 2 sets of equations that we can say we want to solve. And I want to make use of simultaneous equation. And here, I can see that I have 5Q and 10Q. If I multiply equation 1 by 2, so I want to say equation 1 multiplied by 2, okay, that will make 5Q to be 10Q. Then I can subtract. So 3P times 2 is 6P. Plus 5Q times 2 is 10Q is equal to 9,500 times 2. That will be 19,000. So I can call this equation 3. And with what I have here now, since I have 10Q and 10Q, I can say here, I just want to subtract. I can say equation 2 minus 3, or even I can say equation 3 minus 2. But just so students, you can follow much more directly. Let me say equation 2 that is on top minus 3 that is below. 5P minus 6P, that will be minus P, okay? 10Q minus 10Q is 0. I don't need to write that. It's equal to 17,500 minus 19,000. That will be minus 1,500, such that P itself, dividing both sides by minus 1, will be 1,500 naira, okay? Then from here, I can now say, since I have P to be 1,500 from any of the equations, maybe from 1, I can say that 3P plus 5Q is 95. So I can say 3P plus 5Q is 95. Then if I put in the value of P, that would be 3 times 15 plus 5Q is 9,500. And then 3 times 15 is 4,005. 5Q will be 9,005 minus 4,500. So I have this to be 5Q is equal to, this will be 5,000. And then if I divide both sides by 5, Q will be 1,000. And I think this is a good means of sharing the responsibility that men are paying 1,500 naira each, while women are paying 1,000 naira each. So that is all about that. In the second case, we are asked to find the total amount that will be contributed by 8 men and 12 women. That will be 8P plus 12Q. That's what we are being asked. And if we put in the value of what we got, that will be 8 times 1,500 plus 12 times what's Q? 1,000 naira. So Inherently, this is going to be nothing but 8 times 1, 5, that will be 12,000 plus another 12,000. So the contribution by 8 men and 12 women will be nothing but 24,000. So with that, we've been able to solve this word problem that is involving contribution of both men and women. I would think it's a very good idea that men and women are pulling their resources together to develop the community, just like we are doing on this channel. All right.
In this question on longitude and latitude, we are told that an aircraft flies from point P, which is on latitude 12 degree north and longitude 11 degree west, to point Q, that is on latitude 12 degree north and longitude 11 degree east, in 2 hours, and then it changes its course and arrives at point S on latitude 44 degree north and longitude 11 degree east in 6 hours after leaving point Q. Our mandate is to calculate correct to 3 significant figures. First, the total distance covered, the average speed of the aircraft, and the time difference between Q and S. So let's try and locate the point P, Q, and S on our globe as given here. First, we are given the mandate that point P is on 12 degree north latitude. So normally we start from the origin, the center of the globe, and then we measure outwards. Like the latitude 12 degree north, we'll take it starting here as origin and go up, because ideally this is the north, south, east, and west. Okay, so we are taking 12 degree north, so we can append this as 12 degrees north, and then 11 degree west. West is to this side, so this can be our 11 degree west. Okay, that's the longitude. So the intersection between the longitude 11 degree west and the latitude 12 degree north will have to be our point P. So here you can just append this as point P, and then in the same way we can look at point Q. It is on the same latitude as P. That's why they are sharing 12 degree north and 12 degree north. But now Q is 11 degree east as the longitude. So this other one to the east we can take as our 11 degree east. And the point of intersection of this longitude and this latitude, which is here, that will have to be the point Q. And then we're also told that from Q, the aircraft changes its course and arrives at point S, that is now on latitude 44 degree north and longitude 11 degrees. So we are noticing that the longitude for S and the longitude for Q, they are the same. So it is still this 11 degree east. And by the time we are taking 44 degree north, that will be farther than 12 degree north that we had before. So we can take this as our 44 degrees north, and the point of intersection between this longitude 11 degree east and this latitude 44 degree north, this place, that will have to be our point S. So we have our diagram as shown here, and if you want to just look at what we are being asked, first we are being asked the total distance covered. That will be first the distance from P to Q as shown here, and then from Q to S as shown here. So the distance that is covered by the plane is first the distance covered from P to Q and then Q to S. And if you want to look at the means of finding that distance, let's try and finish up this diagram. Okay, so from here we can have some radius to the north and south pole, and this is actually radius r. Okay, this is also small r. But there's another radius we can look at from the center of the globe to the point on the longitude and latitude here. Okay, the point on the great circle, and then we can have this and this. So this other one, we are having them as the radius of the heart r, which was given as 6,400 kilometers. So our mandate here is to find the total distance traveled, and that will be the distance PQ along the parallel of latitude plus the distance QS along that longitude. So we can find that the total distance we are looking for is nothing but the length of the arc PQ plus the length of the arc QS. The plane starting from P moving to Q, that's PQ, then from Q moving to S, that is QS. So that is very interesting. We can now go to find means of finding PQ and QS, and this is what I want to show us. So then just follow this through. For the distance PQ, if you look at what we have something like this, that this is point P and this is point Q, and then we have some angle in between them,
and it's looking as if we are dividing that angle in two, in which here from the center to the left it is actually here, and we have measured 11 degrees first to the west, and then to the other side we have another 11 degrees to the east. So the total angle in this case, if you are to look at it, you can say we have some alpha that we are looking at. It will be the sum of these two 11 degrees plus 11 degrees, and that will be 22 degrees. So this is the angular difference or the angular sum, because we are even adding them. We're adding them because they are going in different directions. By the time we get to look at the second case, we'll see that we'll have to subtract because they are in the same direction. So that will cut out. So we are seeing this angle here, that it is nothing but 22. And then we identify this as R, and this is also R. So the first distance PQ that we are looking at will be nothing but alpha over 360 multiplied by 2 pi R. But now we are not giving R at all, because this R is the radius along the parallel of latitude. What we are giving is the radius R, the radius of the heart. Now, if you want to look at the two, this is going to come out very, very clearly now. If we take this as the center of the heart, the origin, and we have this, let's say this is some point T. If you look at that diagram critically, you are going to see that what we have is that this is point T, and then to the right, we have this as point Q, and then that T is also coming straight down to the center of the globe, and then we have this as the radius R that we are given. So we have this particular R here from T to Q is R, just like T to P is R, and already we have measured out the angle from that origin to the parallel of latitude. We got this to be 12 degrees to the north, okay? And then by reason of understanding of trigonometry, we know that this 12 is also the same as this angle here, that this is also 12 because it's alternate to this parallel of latitude that we're given originally. And looking at this now, what do we have? If nothing but we have SOHCAHTOA. This is actually SOHCAHTOA because it's a right angle triangle here, and we have the adjacent, we have the hypotenuse, and we have the angle. That is nothing but cos. So what we have here is inherently we have that cos theta, you can just take it as cos 12, okay? It's nothing but adjacent, which is R, over hypotenuse, which is capital R, so that the radius that we are going to be using here is nothing but R is equal to the capital R, that's the radius of the heart, cos the angle of latitude, okay? So if we have this, then our equation inherently will become something like this. So our equation now, instead of us just writing R, we can now say that is depicting that this equation is nothing that PQ is nothing but alpha over 360 multiplied by 2 pi. Instead of small r now, we have R cos theta, where theta is the angle on the parallel of latitude. So this is what we're going to be doing for PQ, and then we're also going to see what we can do for SQ, okay? Now, if you are to consider the distance from Q to S, what we have is something like this. We have this as the center of the globe, and then we have this particular arc coming like this, and we have this point first, point Q, and then on the other hand we have point S. Now, the distance between them is this QS here, but what we are looking for first and foremost is that we want to depict how we can find that angle between them. Now, from the center of the globe to point Q, we have been given that now we need to measure that angle as the parallel of latitude. This was given as 12 degrees, okay? But then from that center also to S, we gave it as 44 degrees. And now the angle between them, this angle, if I still maintain that, I'll call it alpha. You can see that alpha is going to be the difference between 12 and 44. That alpha here is going to be 44 minus 12, and that is 32 degrees. So this angle here is nothing but 32 degrees. And then in this particular case, we noted that this is R, which is also the same as OQ. OS and OQ, they are both R. So the distance QS for this particular case, our QS is nothing but alpha here over 360, because it's just the length of an arc multiplied by 2 pi R, and that R is the radius of the heart, which we are given as 6,400 kilometers. So we have all the parameters that we need
we have gotten the angular difference, we have gotten the angular sum, we have gotten the different angles that we need. We can just put them together and try and solve out this particular question now. Going back to the formula for our total distance that we are looking for originally, you can say that total distance is PQ. What is PQ? PQ, we said it is alpha over 360 multiplied by 2 pi r cos theta, and theta is the angle of the parallel of latitude. Alpha is the angular term of the longitude of P and the longitude of Q, okay, plus the distance QS. That is actually, let me call this one for 1, let me call this one for 2 over 360 multiplied by 2 pi r straight and direct. So if you want to put in those values just like we got initially, alpha 1 is 11 plus 11, which is 22 over 360 multiplied by 2 multiplied by pi, we're given as 3.142 multiplied by the radius of the earth 6,400, then cos the parallel of latitude, which is cos 12. So this is actually PQ plus QS, and QS is the alpha 2, which is the angular difference between 12 and 44. We got that to be 32 over 360 multiplied by 2 pi is 3.142 multiplied by r is 6,400. Okay, so we can make use of our calculator to get this, to say we are having first 22 divided by 360 multiplied by 2 times 3.142 multiplied by 6,400 cos 12. Okay, so this is 2404.035. 2404. So we have 2404.035 as distance PQ, plus in the other case we have 32 divided by 360 multiplied by 2 times 3.142 multiplied by 6,400. So that is what? 3574.898. And if you are to sum the two, so this is our answer plus the initial answer 2404.035. Okay, so what's that sum? 5978.93. So this is 5978.93. But we are asked to get that to the nearest, correct to 3 significant, but we have to get but we have to get that correct to 3 significant figures. So that means we need to look at 1, 2, 3 figures. Whatever is coming after, we need to round up or round down as appropriate. Now, 8 is what is coming under, and that is greater than 4. Numbers between 5 and 9, we round up to 1 and add to the number immediately preceding it. So we round 8 up to 1 and that to 7. That will become 5980 kilometers. So we have this as 5980 kilometers as the total distance that the aircraft covers in moving from P to Q and then from Q to S. So that's the solution to A part. Okay, so you can say we just got our total distance to be 5980 kilometers approximately. Now in the question B, we are told to find the average speed of the aircraft, and that average speed is going to be nothing but the total distance divided by the total time. Okay, the total time that the plane took in traversing all those journeys from P to Q and Q to S. Now, interestingly, we just got our total distance to be 5980 kilometers approximately. If you are working, you make use of the original value, not the approximate value. So, if that is going to be the case here, we are just going to have this as what's our original value from the calculator. We have 5978.93, 5978.93 divided by what's the total time. Initially, in moving from P to Q, it took 2 hours. Then from Q to S, it took 6 hours. So we have 2 plus 6 hours. So we have this, and we have this in kilometers. So if you want to look at that average speed, you can just say that speed is nothing but, what is our calculator? This is our initial answer. We can say answer divided by 2 plus 6 is 8. So we can just
get that to be 747.36659. Okay, maybe 367. This is 747.367. But again, we are asked to get it correct to 3 significant figures. And we want to do that. We are looking at 3 significant figures. 1, 2, 3. Any number after it, we are going to round up or down. 3, we need to round that down. And rounding it down will mean down to 0. It will not have effect on the other numbers. So the average speed is nothing but 747 kilometers per hour. So that is the average speed of this particular aircraft in journeying from point P to Q and then Q to S. Then finally, in the third question, we are asked to find the time difference between Q and S. Let's look critically at this longitude. You can see that Q and S are lying on the same longitude. And for locations that are on the same longitude, they are not going to have any time difference. So we can just say there is no time difference between S and Q as asked from the question. So that is why a location like Lagos and London, they're on the same axis of longitude, and that is why they are sharing that same time zone, and there's not going to be any time difference between them. So that is all we need to do. We've answered the question holistically and we are good and fine. Here in this question on graphical solution to quadratic equations, we are asked to copy and complete the table below for the relation y is equal to s squared minus 2x minus 3. And you can see this here is a table that we are to copy and complete. Then after doing that, we are to draw the graph of the relation using a scale of 2 centimeters to 1 unit on x-axis and 1 centimeter to 1 unit on y-axis. So our work is simplified because we're already given the scale to use. Then we have to determine the root of the equation s squared minus 2x minus 3. Okay. Then using the same as this, we have to draw the graph of y is 2 minus 2x and then deduce the root of the equation s squared minus 2x minus 3 is equal to 2 minus 2x. And finally, we have to find the minimum value of y is equal to s squared minus 2x minus 3. So let's take it piecewise. First, in the first question, we have to copy and complete the table. So this is the table, and there are a number of ways that you can go ahead to do that. You can either use your calculator, but in this particular video, I want to get our hands dirty. Maybe you can use a calculator to confirm. So there's this particular table of value that I'm going to find very, very useful. Why? Because all of the values of the particular equation in question, this equation, okay, all of the values are already represented there. You can see x is the variable that we have its value given to us initially, but then we're having s squared, okay, we're having minus 2x, and we're having minus 3. So those are the terms of the equation that I've already included here. And that is not the only case, because in this particular case, we're also asked to draw the graph for y is equal to 2 minus 2s. So we have y is 2 minus 2s for this particular y, but this one will correspond to this. I'm going to use 2 different ink so that you don't confuse them with one another. But since we are going to have 2 graphs, then we are also going to have 2 tables, and that is why this table is going to come in handy. All right, so just like we have it here, we can just use this set of values to compute what we are going to be having here. Like in the first case, when x is minus 3, x raised to power 2 is minus 3 times minus 3. Negative signs will multiply each other to give a positive sign. So minus 3 raised to power 2 is minus 3 times minus 3, which will be 9. So this is 9. Okay, minus 2 times minus 2 is 4. Minus 1 raised to power 2 is 1. 0 raised to power 2 is 0, 1 raised to power 2 is 1, 2 raised to power 2 is 4, 3 raised to power 2 is 9, 4 to the power of 2 is 16, and 5 to the power of 2 is 25. Okay, then minus 2x, again we need to know that we are having minus 2 multiplying each of the values of x that we have in this table. So minus 2 times minus 3, again like I said before, negative signs, they will multiply each other to give a positive sign. So here it will be minus 2 times minus 3, and that will be 6. Okay, minus 2 times minus 2 is 4, minus 2 times minus 1 is 1, minus 2 times 0 is 0, minus 2 times 1. Now, since all of these are positive numbers, a negative number multiplying a positive number will always give a negative number. So here, we're going to have minus 2. Minus 2 times 2 is minus 4. Minus 2 times 3 is minus 6. Minus 2 times 4 is minus 8. And minus 2 times 5 is minus 10. Okay? Then moving on,
this is just a constant. It's not having the variable x at all. So all across this row, we are going to have minus 3 as a constant that is featuring all across the range of values for x. And then to find the value of y for the equation y is equal to s squared minus 2s minus 3, what we do is we add these values that we have in red, we add them together. Like in the first case, 9 plus 6 is 15, 15 minus 3 is 12. So that is confirming that this value here is correct and we are on track, okay? 4 plus 4 is 8, 8 minus 3, that is 5, okay? 1 plus 1 is 2, 2 minus 3, that is minus 1, 0 plus 0 minus 3 is minus 3, again confirming that what we have is also on track. 1 minus 2 minus 3 is 1 minus 5, and that is minus 4, okay? 4 minus 4 is 0, 0 minus 3 is minus 3, 9 minus 6 is 3, 3 minus 3, that will be 0, 16 and minus 8 minus 3, okay, minus 8 and minus 3 will constitute minus 11, 16 minus 11 is 5, which is confirming that we're on track. Then we have minus 10 and minus 3 is minus 13, 25 minus 13 is 12. And if you look at these values, you will see that there is a symmetry, because like here we have minus 4 as the midpoint, then minus 3 to the left and minus 3 to the right. And here, look at this now. Now, the main fact that we understand that is a quadratic graph and it's supposed to be symmetrical is showing us that we have made a mistake here, okay? And what is that mistake? I think it is coming here in this particular value. Minus 2x will be minus 2 times minus 1, and that will be 2, not 1. So in that case, I need to erase this particular value of 1, okay? And then put in the right value of minus 2 times minus 1 is 2, such that here, these are little tricks that students, once you know them, you'll be able to actually work your way very effectively. 1 plus 2 is 3, 3 minus 3 is 0. So you can see that symmetry I'm trying to talk about, okay? So let me just rub off this because you don't need that. So you can see the symmetry I'm trying to talk about, that once you have minus 4 at the middle, minus 3 is flanking it, 0 is flanking that, 5 is flanking that, and then 12 is flanking that. Those are peculiar nature to a quadratic graph in which you can have a symmetric set of values, one in the positive direction, the other in the negative direction. So we are through with this particular equation, y is equal to s squared minus 2x minus 3. Now, we want to move on to this other equation that we have here, that y is equal to 2 minus 2x. Now, in the first case, you can see that this 2 is a constant, so we only have 2 all along that row. Since it's a constant, it's not going to be affected by the value of x, it's just 2 all along. And now we have minus 2x. But interestingly, look at this. This particular row, this row, is already giving us the value of minus 2x. So we just need to repeat that this will be 6, 4, 2, 0, minus 2, minus 4, minus 6, minus 8, and minus 10. Okay. And then to compute the value of y, for y is equal to 2 minus 2x, we only need to add the values in blue, okay? We are adding them because we already noted the negative sign here. So all we just need to do now is just to add. Now 2 plus 6 is 8, 2 plus 4 is 6, 2 plus 2, 4, 2 plus 0 is 2, 2 minus 2 is 0, 2 minus 4 is minus 2, 2 minus 6 is minus 4, 2 minus 8 is minus 6, 2 minus 10 is minus 8. Again, look at the consistency with this value. You can see that it is looking like an arithmetic progression with a common difference of 2. The first term is 8, and with 2 as a common difference, okay, yeah, minus 2 as a common difference, okay. So we're having 8 minus 2, 6, minus 2, 4, minus 2, 2, minus 2, 0, minus 2, minus 2, minus 2, minus 4, because it's a straight line graph, and that has to be linear, okay. So these two are the equation that we are requested to get. Here, this particular one is the table of value for y is equal to 2 minus 2x, okay. And then the one we did initially, the one in red here, is one for y is equal to s squared minus 2x minus 3. Students, there are some very key things you can already note from this particular question. For example, we're asked to, in this question, we're asked to deduce the roots of the equation where both of them are equal. We can look at the set of values and see if do we have any point at which both of them are equal, that the value of y in the first one is equal to the value of y in the second one. Okay, we cannot see it here, good, we'll get to see it on the graph. But interestingly, looking at this particular question here, that we are to determine the roots of the equation x squared minus 2x minus 3. If you look at this particular graph, you can see that in two places the value of y is 0, first here and then here. Okay, those two places correspond to where we have the root of the equation, and those roots will be -1 and 3. Okay, so if you understand your graph, you'll be able to note those ones already, but no problem, we're also going to see it directly. Now, the other thing I promise is that we're going to check with the calculator to see if what we got here is correct. So let me fire up my calculator here. Okay, so I'm going to fire up the calculator, and these are the two equations that we need, this one here and this one here. So we go to mode, and you can see on the scientific calculator 7 corresponds to table, and then in the first case is looking for the function of x. The function of x is x raised to power 2, and this is x on top of the close bracket button. So it's written in red. For me to get that, I press alpha close bracket, then raised to power 2, okay, then minus 2, again 2x, then minus 3. Okay, that's my equation. Then it's asking for g of x, meaning that do I have another function that is defined in variable x? Yes, I do. It is 2 minus 2. So I say 2 minus 2x. Okay, so I press equal to. The start value is asking me for the first value of x. In this case, it is -3. Okay, the end value is 5, and oh, interestingly, I have 5. Then the step, the incremental value, like the common difference. Now you can see it's also in the step of 1, like -3, -2, -1, 0, 1, 2, 3. So the difference in each subsequent values is actually 1. So 1 is okay. I can press equal to, and it's going to give me my table. Okay, so you can see 12, 8, 5, 6, 0, 4. If you just move down for x here, okay, for x is 1. Let's start from there since it's showing you already on the board. For x is 1. When x is 1, what's the first function? It is -4. You can see here is -4. And what is the second function? It is 0. Okay, when x is 2, you can see 2 here. We have -3 and -2. You can see -3 and -2. And when x is 3, you have 0 and -4. Look at it, 0 and -4. Okay, when x is 4, you have 5, which was predefined for us. We have 5 and -6, 5 and -6. And when x is 5, you have 12 and -8, 12 and -8. So just like that, you've seen the two methods that you can use to actually get a table of values. If calculator is allowed, you can go ahead and use your calculator to solve. If it is not allowed, then you can get your hands dirty and solve the question, because now you don't really have any excuse. So having gotten our table of values, we can now see how we can progress with this particular question. All right, so here we have our graph sheet, and then we have our table of values. The one in red is corresponding to x squared minus 2x minus 3. The one in blue is corresponding to y is equal to 2 minus 2x. And then we have been given the scale originally. We are told that 2 centimeters should represent 1 unit on the x-axis. That is the horizontal axis. Okay, 1 centimeter to 1 unit on the y-axis. That is the vertical axis. So we need to see where our origin is going to be. Now, for the values of y, we can see that the maximum is 12 and the minimum is -8. Okay, so we should find a way to represent that accordingly, that 12 and -8 should reflect on this particular graph, and it is 1 centimeter to 1 unit. So on the graph, where is 1 centimeter? From the tick here, from this tick line to this tick line, that's 2 centimeters. Okay, so half of it will be from here to here, so this will be 1 centimeter. So they say 1 centimeter to 1 unit. So it's as if you are saying 2 centimeters to 2 units on the y-axis, whereas on the x-axis, 2 centimeters is from here to here. So that's 2 centimeters to 1 unit on the y-axis, on the x-axis. Now on the x-axis, we have our least value to be -3, our highest value to be 5. How many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisions. And this graph is actually 10. Also I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is going to cater for x effectively. However, talking about y here we have values that we want to represent. Least is -8, highest is 12. Okay, and 2 centimeters. If you say you want to take minus 8 here, let's say minus 8, minus 6, minus 4, minus 2, 0, 2, 4, 6, 8, 10, 12. Okay, so this is minus 8, this is 12. That's good, but we can just take minus 8 here so that 12 will just land there, and I think that will centralize our graph better. Okay, horizontal axis, and then our vertical axis, and we can just label them that yes, this is 0, and this will be 2, 4, 6, 8, 10, and 12 on the y-axis. Okay, so we have minus 2, minus 4, minus 6, minus 8, and that is catering for our least value and our highest value. Okay, and then on the x-axis, the horizontal axis, we have 0, 1, 2, 3, 4, 5, and you can see this is better now, and minus 1, minus 2, minus 3. So we've been able to manage our space quite well with the way we didn't just centralize with a typical way in which you just say centralize everything. No, we cannot afford to do that in this particular case. So that's why just shifting the center to this particular location has helped us to map out correctly what we want to have. So in the first case, let's look at the equation, the quadratic equation, y is x squared minus 2x minus 3. When x is minus 3, y is 12. So here, this is minus 3, and I think I want to use blue ink for that. This is minus 3, okay? And then this is 12. The point of intersection is a point of interest for us, so I can just denote that as minus 3 and 12. And then when x is minus 2, y is 5, minus 2 and 5. 5 is between 4 and 6, and it is this thin line here. So I can say that this is minus 2 and this is 5. Okay, so I can just speed it up because we can easily trace them here. They are whole numbers. When x is minus 1, y is 0. So this is minus 1 and y is 0 is exactly on top of that minus 1. Okay, when x is 0, y is minus 3. This is 0 for x. Y minus 3 will be between minus 2 and minus 4. So we are looking at something here. Okay, and then when x is 1, y is minus 4. This is 1, and here is minus 4. You can just trace it like this. You can see, and then minus 4. That point of intersection is where we are looking at. Okay, so you can see it is here, minus 4. Then this is the symmetry I was talking about when we are computing the table of values. Now, when x is 2, y is also again minus 3. So this is the minus 3, 2 for x, minus 3 for y. Then when x is 3, y is 0. Here, when x is 4, y is 5. We got in 5 initially too. And you can see our understanding of how a quadratic graph normally looks like, how it's helping us to extrapolate our values quite easily and quickly. 5 and 12, 5 and 12. So we have that here. Okay, so having those points, what is now expected of us is to join them together. Students, you can make use of your French curve, or like we used to do in those days, you can make use of your broomstick. If you are using your French curve or your broomstick, you should have something that looks like this as a line of best fit, joining all of those points together. Okay, and then from the question, we're told that we have to find the root of the equation. So from the question, the root of the equation, the root of the quadratic equation of the equation x squared minus 2x minus 3. From the graph, you can see here, it is the point where the quadratic curve cuts the x-axis, and here it is minus 1 and 3. And actually, if you know how to read your table very well, you can see on the table of values, in this particular case, y is 0, and here y is 0, corresponding to the value of x to be minus 1 and 3. That is the correct thing. But as a rule of thumb, generally, you should ensure that you always label your graph. So here, you should write that this is y is equal to s squared minus 2x minus 3. Please, that will be very good, and it will earn you your full mark. Okay, so having done that, we are also asked to plot the table. We're also asked to plot the graph for the linear equation y is equal to 2 minus 2x. And for those, you can see is this second set of values for y, the one in blue, that we are going to use. So we can actually go ahead to also do that. When x is minus 3, y is 8, minus 3 and 8. I think by now we should be able to get that easily. This is minus 3 and this is 8. Okay, this point of intersection is our interest, and we can just note it, minus 3 and 8 here. We have minus 2 and 6, and you can see here is the point of intersection of the two. Okay, we have minus 1 and 4, that is here. We have 0 and 2, 0 on the x-axis, 2 on the y-axis, and you can see it's already forming a consistent straight line. We have 1 and 0, 1 on x-axis and 0 on y-axis, so that will be here. We have 2 and minus 2, that will be featured here. We have 3 and minus 4, okay. Then we have 4 and minus 6. Then we have 5 and minus 8. So already we have that as our set of points that we now need to join together. It's going to be a straight line, so you can just start by drawing a straight line. Just to get all the points in question, and that is as good as it gets. Okay, that's as good as it gets. Then, as a rule of thumb, I told us before, we should ensure that we always label our graph. So this particular graph is that we're having here, we have y is equal to 2 minus 2x, 2 minus 2x. Okay, so yeah, we've been able to come up with the other graph, and that is also a done deal. Next, we are asked to find the root of the equation s squared minus 2x minus 3 is equal to 2 minus 2 minus. So for s squared minus 2x minus 3 is equal to 2 minus 2x, the solution is given as. Now, what is going to be the solution to this particular question? If they are saying the two equations are equal, that means they are referring to the point where they overlap. Okay, and if you want to get that, if you want to get the point where they overlap, here we can look at the point of intersection here. Okay, and then we can trace to the x-axis, because at this point you can see that the quadratic graph and the linear graph, both of them are intersecting here and they're intersecting here. Okay, so at those 2 points, let's just trace it down to the x-axis and we'll find the solution set for such. So you can see I'm just using my very thin line. Okay, I think this is quite good now. So our mandate is to look at that particular point and try and see the value that we are having here and the value we are having here. Okay, so I will zoom in and looking at what we just did, we can see that this is minus 2, this is minus 3. Directly in between them is minus 2.5, meaning that the gradation here is minus 2.1, minus 2.2, minus 2.3, minus 2.4, minus 2.5, so that it will eventually end at minus 3. So is a single decimal point that is corresponding to each of the small boxes of our graph. Okay, so here we have minus 2.1, minus 2.2, minus 2.3. So here this is minus 2.3, and here we have 2, 2.1, 2.2. Is between 2.2 and 2.3. Okay, you can also say maybe that is like 2.2. Okay, it's closer to 2.2. So we can say that solution for s squared minus 2x minus 3 is equal to 2 minus 2. The solution is given as minus 2.3 and 2.2. Okay, so this is another solution that we're asked to find. The other one we have been able to find as this. Okay, here is another one, but we can check. Okay, that's the beautiful thing. If you know what we are doing, you remember that our calculator can be used to solve for set of equations like this, and so we are going to do that right now. Question to see what is going to give us. Okay, so here what I'm going to do is I'm going to write the equation like above. Our close bracket is x, so x raised to the power 2 minus 2x minus 3 is equal to 2 minus 2x. Okay, so I can use that shift calc, which is solve, to try and solve for x. Now we have two values, and I cannot just take 0 because it can either go in the positive or negative direction. For me to pick my initial iteration, I need to pick a number greater than the suspected positive value, and then another number less than the suspected negative value. So I'm going to pick, let's say, since I have 2.2 and minus 2.3, I can pick 4 and minus 4. Okay, so for the positive side, I want the initial value to be 4. So look at this. Is this not interesting? The calculator is telling me that the solution is 2.236, and of course we are looking at 2.2. The margin for error allows that we're actually right on track. Okay, but if you also want to solve for the other value, I can again do shift calc. But now if I want to use a negative number, so I want to say minus 4 should be the initial starting point of the iteration, and then look at this, it's giving me minus 2.236. So having minus 2.3 and 2.2 is quite on track. There is a margin for error that will be allowed in the exam, and this is showing that our solution is on track. Okay, and then finally we are asked to find the minimum value for the quadratic equation. And looking at this graph, look at the highest value we have for the graph within the range of values we have from x is minus 3 to x is minus 5. You can see that the maximum value is 12 when x is minus 3 and when x is 5, and the minimum value is actually here. It is here. Okay, and that is minus 4. That's the point at which the quadratic graph actually makes a turn and started going back to increase in value. So from the graph, the minimum value of y for the equation y is equal to x squared minus 2x minus 3 is nothing but minus 4. So with this now, we've been able to effectively look at the question, solve them, and then we're arriving at our answer as requested. All right. We have this question on matrices that we're asked to find the inverse of the matrix A, in which A is given as a matrix with elements 6, 11, 1, and 2. And we're to solve the matrix equation AX is equal to B, where X is XY, and B is 29, 5. Okay, very good and very interesting. I just want you to know that to get the inverse of the matrix, this 2 by 2 matrix is going to be 1 over the determinant of the matrix A multiplied by the adjoint of A. So how do we get the determinant here? So for us to get the determinant of matrix A, that is going to be the product of the elements in the leading diagonal, that's the product of 6 and 2, minus the product of elements in the other diagonal, that is 11 and 1. So what we are going to have is 6 multiplied by 2 minus 11 multiplied by 1. So this is 6 times 2 is 12, 11 multiplied by 1 is 11. So the determinant of A is 1. Okay, that's our very first step. Now, how do we get the adjoint of the matrix A? That is going to be, just observe this. While we have elements in the leading diagonal, we are going to swap their position. So we say this is 2 and 6. Then for the other diagonal, we need to put negative sign in front of those elements. So this is the adjoint of A, such that what we are looking for, the inverse of A, so this is not A, this is A inverse. Okay, so the inverse of A is going to be nothing but 1 over the determinant, which is 1, multiplied by this particular adjoint, that is 2 minus 11 minus 1 and 6. Okay, so this is nothing but 2 minus 11 minus 1 and 6. So this is A inverse, and we are good to go. Now in the second question, we are asked to solve the matrix AX equals to B, where X is xy and b is 29.5. So students, you can as well just multiply this matrix A with xy to get a set of simultaneous equation, equate the first line to 29, the second line to 5, and that will be good. But since we're having this opportunity to work with matrices and also have a question in which you want to solve an equation with it, I think I want to use the matrix method. And this is what you need to note is that given this equation ax is equal to b, we have ax is b. I can pre-multiply both equations by the A inverse so that I have A inverse multiplied by A multiplied by x is equal to A inverse multiplied by b. Now, why did I say I pre-multiply? I pre-multiply because for this left-hand side, A inverse and A, they are going to be the identity element I, which is just synonymous to 1, that's unitary, okay? But in this particular case, this is a point of interest. A inverse, we can see, is a 2 by 2 matrix, 2 rows and 2 columns. But B, we are given that B is 2 by 1, okay? And as a rule of thumb, whenever you are multiplying matrices, the number of columns of the first matrix here, that's going to be A inverse here. The number of columns, 1, 2, must be equal to the number of row of the second matrix, and that is B, 1, 2. So that is a rule that is helping us to pre-multiply. And since we are doing that, that means we can just say for this particular question, what we have is that A inverse multiplied by A, already I said is identity matrix I, which is just like 1. So here I can say X is just going to be, what's A inverse? A inverse is what we just got here as 2 minus 11 minus 1 and 6. And then what is B? B was given to us as 29 and 5. So what we have here is just to multiply out this in such a way that it can give us the value of x. So that is going to be, we multiply by multiplying the row, multiply by the column, first row, column, and then second row also with the column. Okay, so if we want to do that, that means what we are going to be having is something like this. We have 2 times 29, 2 times 29, 2 times 30 is 60. So if you take 1 out, it will also affect the product, so that will be 58, okay? Minus 11 times 5, that will be minus 55, okay? Minus 1 times 29 is minus 29. 6 times 5 have a plus 30. Okay, so this is nothing but 58 minus 55, that is 3. Minus 29 plus 30, that is 1. So this is what we have. And since x itself is actually xy, let me just move this. So we can say this is nothing but xy, such that x, the value of x is 3 and the value of y is 1. But since we are asked to solve the matrix equation x, so we can as well just leave it as this. And it's an understanding of the product of matrices that we can pre-multiply with the inverse of A to actually solve this that we are applying here, and you'll be good and fine, and your work is done and dusted. All right. Here in this question on arithmetic progression, we are told that the first and last terms of an arithmetic progression are 5 and 9 respectively. So we can just say we have our A, the first term is 5, then the last term L, that is 89. So if the sum of the AP is 611, the sum to some number is 611. We are now asked to find first the number of times in the AP and the common difference. Let's look at how we can solve this particular first question. There are two formulas that we can use to evaluate the sum, and the less common one is that the sum of the first n terms is n over 2 multiplied by the sum of the first term and the last term. If you recollect, the last term, which will be the nth term, will be a plus n minus 1d. So if this is adding to this a, we have it as 2a plus n minus 1d, and we still have n over 2. So that is the other formula that we have, that inherently Sn is also n over 2 into 2a plus n minus 1d. So this is generally what students make use of, but is also an expression of this, that the sum of the first n terms of an AP is n over 2, where n is the number of terms multiplied by the sum of the first term and the last term. So we will make use of this very first one here, and then we can say that we have the sum we are given as 611. We are looking for the number of terms n, So over 2 is A. What is A? A was given as 5, L was given as 89. So therefore, if you cross multiply, 2 times 611, okay, I can just say N in this case will be 2 times 611, 611 times 2 over 5 plus 89, that will be 94 over 94. And here we can cut, we can say 2 can go here 1, 2 in 94, that will be 47. Okay, 47 and 611. I think since 1 is there, 13 should be going. Like you say 47 times 13, 3 times 7 is 21, remaining 2. 12 plus 2, 14, then 47, good. So this is 1, 4 plus 7, 11, remaining 1, 5, 6, so good. This is quite good. So 47 can also go in 611, and that will be 13. So the number of terms that we are looking for is nothing but 13, okay? So that is the first solution. In the second case, we are asked to find the common difference. Since for this particular equation, we have been given the last term, we can say Tn is equal to, generally by our reason of equation, it is A plus N minus 1D. Now, in this particular term, we want to take the 13th term. The last term will have to be the 13th term. So here, we can say that T13, what were we given as T13 is 89, okay? Then A, we just were given as 5. We just got our N to be 13, and then D is what we are looking for. If we just bring in all of these parameters that we have, we can say 89 is equal to A is 5 plus N minus 1 will now be 12D, such that 12D will be, when we take 5 to the other side, it will be 89 minus 5, and that will be 84. Then D itself, in that case, will be 84 over 12. 84 over 12 is nothing but 7. So the number of terms for this particular AP is 13, and the common difference is 7. And with that, we've been able to solve this question as requested perfectly, and we are good to go. In this question, we have this ungrouped data set in which we are asked to construct a frequency table with a given class interval here, 1 to 20, 21 to 40, and subsequently we have 41 to 60, 61 to 80, 81 to 100, okay, because I'm seeing 90 here. Then we are to use an assumed mean of 30.5 to calculate the standard deviation of the distribution, and then find the probability that the student selected at random scored above 40 marks. So the first mandate for us is to get a frequency table which we are going to use to calculate the standard deviation of the distribution. And quite cut out for us is our work here, in which first and foremost we need to use the class interval 1 to 20. So on this score, we need to put this is 1 to 20, then 21 to 40, 41 to 60, 61 to 80, and then 81 to 100. And then we need to find the tally, and we need to do the tally just manually and drill down that what are the numbers between 1 and 20 that we can see here. In the first row, we have 12, we have 14, we have 20 itself, we have 11, and then we have 19 that will cross out to make it 5. Then we have again another 19 in the second row, and then we have 10 in the third row. So the frequency here is 7, okay. So for data entries from 21 to 40, we have, in the first case, we have 40 itself, we have 22, we have 34, we have 26, we have 32, that makes it 5, okay? And I think that is all on the first row. On the second row, we have 31, we have 35, we have 30, okay, that's all on the second row. On the third row, we have 21, we have 38, that means another 5, we have 24, we have 27, and we have 32. So we have 5, 5, and 3, so we have 13. So this is how you go about doing this, students. You could as well have marked it on the sheet, but if you are doing that repeatedly, you may get clogged. Or maybe you can use your pencil for each particular class interval, and then you erase it and go back. Okay, maybe you can do that for 41 to 60. So for 41 to 60, let's look. On the first row, are we having anything between 41 and 60, none. On the second row, yes, we have this to 60, we have this 41 to 60, we have this, and I think that is all. Okay, so for 41 to 60, we're having how many entries? 1, 2, 3, 4, 5. So you can just 1, 2, 3, 4, 5. So this is 5, and then you need to erase all of this. So that maybe you can just do that in your exam also. Now for 61 to 80, we are going to look at, okay, how many 61? On the first row, we have this, 61 to 80, okay, we have this, any other one, 61 to 80, okay, we have this. So we have 1, 2, 3, 4. So just 4 entries in those, 1, 2, 3, 4. So this is 4, and then 81 to 100. How many of such do we have? 81 to 100. I'm seeing only this 90, okay? And then we can just say this is 1, so our frequency is 1. So that's how you go about getting the frequency. And you can also sum the frequency, okay? Like 7 plus 13, that is 20, plus 5, 25, plus 4, 29, plus 1. This is 30. So summation F is nothing but 30. Okay. Now I want to get the mid value for this particular score. That's going to be the computation for X. So if you want to get that mid value, you can just look at here on the class interval 1 to 20. Just find the average. 1 plus 20 over 2. That will be 21 over 2, and that will be 10.5. And then sequentially, you're just going to have an increment of, the class size is looking like 20, so you have an increment of 20. So the next one will be 30.5 and co. So you just want to do that. You can say this is 10.5. For this one will be 30.5. Then we have 50.5. We have 60, not 60, not 60. We have 70.5, and here we have 90.5. Okay. Now we need to get the deviation, because for the formula for the standard deviation, it is summation FD square over summation F minus the square of summation FD over summation F, where D is the deviation between the mid value and the assumed mean. And if you recollect, we have been given the assumed mean as 30.5. So A was given as 30.5. So here, this D that we are looking at will be each of the data entry value for X minus 30.5, like 10.5 minus 30.5. We are going to put that down, and that will be 20, minus 20 to be precise, okay? 30.5 minus 30.5 is 0, 50.5 minus 30.5 is 20, 70.5 minus 30.5, 40, 90.5 minus 30.5, that is 60. Now we can find the square of our D, okay? The square of D, the square of minus 20 will be 400. Because we are making use of it here, we need summation FD square, okay? So the square of 0 is 0, the square of 20 is 400, the square of 40, that's 1,600, and the square of 60, that is 3,600. So now let's get the product of our F and D. This column and this column, that will amount to FD, and we'll do well to compute that because we need it in our equation. 7 times minus 20 is minus 140. We need to be careful here because we are looking at this and this. Okay, maybe that will be a very good guide. 13 times 0 is 0. 5 times 20, that is 100. 4 times 40 is 160. And then 1 times 60, that is 60. Okay, so we are good to go with that. We have gotten that as appropriate. Then we need to also get the summation of that particular data entry. Okay, we have minus 140, we have 160, so that will remain 20. 100 plus 20 is 120. 120 plus 60, this is 180. So this is 180, and 180 is actually this is summation FD, that's 180. Then we need to also look at F, the frequency, multiplied by the square of D. So we can take those two columns, 7 times 400, that is 2,800. 30 times 0 is 0. 5 times 400, that will be 2,000. Then 4 times 16, 4 and 16 is like 8 and 8, that is 6,400. then 1 times 3006, that is 3600. And again, we have gotten the column that is corresponding to FD square. We also need to sum it. Like here, I'm seeing 6,400 and 3,600. The two combined to be 10,000, plus 2,000 is 12,000, plus 2,800. This will be 14,800. And this is amounting to summation FD square. Okay. So once we are noting that, we just want to note that already. So at the base, what I'm having is that is the summation here. This last row is actually the summation. Like summation of F is 30, and then summation of FD, that is actually 180, and the summation of FD square is 14,800. We are using an assumed mean of 30.5. That's how we got all of this. So we can go back to try and solve for our standard deviation, to say that standard deviation will now be the square root of, let's impute all these values that we're having now. What's the summation of FD square? That is 14,800 over summation F we got as 30 minus the square root. What's summation FD? That is 180 over summation F, that is 30, but we are squaring all of this. So if we are doing this, we can say from here we can get our standard deviation to be, let me bring in our calculator now. So we are 14800 divided by 30. Okay, this is, or let me just write everything together. Minus 180 divided by 30, this is power 2. So this is 457.3. I'm going to find that square root. So this is the square root of 457.3. And if I'm to evaluate that, I'm going to say square root of the answer I just got. So this is 21.385353. I can just approximate it to 21.39. Okay, so this is 21.3853, which is approximately equals to 21.39. So this is the standard deviation for this particular data set as required. All right. So now in the second part, we are asked to find the probability of selecting a student that scored above 60 marks. Okay, that's what we are looking for in this second case. That is going to be the frequency of those that scored above 60 over the total frequency that we have. So frequency of those that scored above 60 divided by the total frequency will give us this probability. And if we are looking at the table, let's look at the table. We can see that here, those who scored below 60 are in this range 1 to 60. Okay, those who scored above will be from 61, and their frequency will be 4 plus 1. All right, so you can just say this is nothing but 4 plus 1 divided by what's the total frequency? 30. So this is 5 over 30, and 5 over 30 is nothing but 1 over 6. So the standard deviation is 21.39, and the probability of selecting a student that scored above 60 marks is 1 over 6. All right.
This is a question on the equation of a straight line, in which we are asked to find the equation of a straight line passing through the point A, that is defined as 6,5, and B, that is defined as minus 2,7. Let's first note that whenever we're having points on the Cartesian coordinate like this, it means we're having x, y. So for A, x is 6 and y is 5, and for B, x is minus 2 and y is 7. I want to show this on the Cartesian coordinates. So what we want to do is to find the equation of the straight line joining them, but we can as well just try to locate this point. Like A is 6,5. So on the x-axis, we have our scale to be 2 units on the graph. So 6 is here. So I have 6 here. And then 5 is here. 5 should be between 4 and 6. So in between here, that is 5. Okay, so if you want to get point A, it will be the point of intersection of these 2 points on the y and x-axis coming together just like this. We have this line going and this other one coming here
and that point of intersection, this is going to be the point defined as A, where A is 6, 5. You can see 6 on the x-axis, 5 on the y-axis. So in the same vein, for the point B, we have minus 2, 7 x for. So x is minus 2, this is minus 2 here, and y is 7. 7 will be between 6 and 8, so 7 will be somewhere here. And we can also trace the 2 points to intersect one another so that we can find the location of point B. So I think this is just a very good representation of what we are trying to have. So this here is point B that is defined as minus 2, 7. So now what we're asked to find is to find the equation of the straight line passing through them. So the straight line is going to look something like this. If I'm starting first from here and drawing my straight line, and then maybe I can also trace back to the other hand just to extend it a bit. So this is a good representation of what our straight line is going to look like. But for us to solve this, we are going to make use of the general form of equation when we are looking for the straight line passing through 2 points, and is the interpolation of y1 and y2, and we can take it like, say, y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. What you need to note is the consistency in this particular equation. Look at the first case. I'm actually having y1 as the number that I'm subtracting both from y and from y2. And in the second case, I'm also having x1 as the number I'm subtracting both from x and x2. So you could have said that y minus y2 over y1 minus y2. That's also consistent that you are subtracting y2. But whatever you just want to do, make sure you are consistent. And the consistency you use for y-axis, you also use for the x-axis. Okay, so for this particular case, in which we have a is 6, 5. So here we have for a that we have as 6, 5, and b that we have as minus 2, 7. We can say we want to define a to be 0.1, so this will be x1 and this will be y1. Okay, so x1 is 6, y1 is 5, and for b, minus 2 will be x2 and 7 will be y2. So now to use this in the equation that we have here, we can just have y minus y1. What's the value for y1? That is 5 over y2. y2 is 7 minus y1, which is 5, is equal to x minus x1. The value of x1 is 6 over x2, that's minus 2, minus x1, that is 6. Okay, so looking at this, I know 7 minus 5 is 2, minus 2 minus 6 is minus 8. So I have something like this. I have y minus 5 over 2 is equal to x minus 6 over minus 8. 2 can be used to divide both the denominator. So 2 here, 1, 2 in minus 8 is minus 4. So having simplified that, we can just cross multiply, and by cross multiplying, minus 4 will be multiplying this left hand side, and we can have minus 4 multiplied by y will be minus 4y. Minus 4 multiplied by minus 5 will be plus 20, because the negative numbers will multiply each other, and then the 5 and 4 will multiply to give 20 is equal to x minus 6. Okay, so here if I move 20 to the right hand side, I have minus 4y is equal to x minus 6 minus 20. Okay, so that means I have minus 4y is equal to x minus 26. And to actually have it as the general form, y is equal to mx plus c, I can just divide both sides by minus 4. Okay, so this will also be over minus 4 over minus 4, such that in that case minus 4 and minus 4 will cancel. So y will be here, I have is minus 1 over 4x, then minus 26 divided by minus 4, the negative signs will cancel out, so I will have plus 26 over 4. Let me look at that. That should be 6.5 26 divided by 4 is that 6.5 will be plus 6.5. And so this is quite good and I love this, but I want you to just notice something. Look at this. I have minus 1 over 4 as m if we compare to this. So we're having we have it as y is equal to minus 1 over 4x plus 6.5. Okay, in comparing to this. So first you can see that the slope minus 1 over 4, it implies that looking at this question, this graph is actually going in the negative direction. If it's a positive slope, then the graph would have looked something like this. But in this particular case, that's not what we are having. So it is actually a negative slope. And then 1 over 4 means that for a singular unit change in y, there is actually a 4 unit change in x. For example, if you want to look at the change between, say, 6 and 5, here for 6, if you trace the curve, it's here, okay, and then to 5, this is 5. Okay, now this is 5. 5 to 6 is a 1 unit change. So here this point is actually a 1 unit change in y. Okay, but look at it, the same, this from 6 down to 5 here, but the same for x. Here is actually the whole of year to year for x, and that is corresponding to 2 to 6, and that is a change of 4. Okay, here 6 minus 5 is just a 1 unit change, but here 6 to 2 is a 4 unit change, and that's why you have 1 over 4, meaning for a singular change in unit of y, there are 4 units change in x. It's negative because the graph is going in the negative direction and not in the positive direction like this. That's why it is negative. So since it's going in the negative direction, then it is negative. But for a 1 unit change in y axis, we have 4 unit change in x axis. So we have 1 over 4. And then the intercept, I love this sincerely. The intercept, look at this point where the line is cutting the y-axis, that's the intercept. It is C, and you can see this is 6, 7 and 8. In between 6 and 7, we can see that that's where the line is cutting the vertical axis, and that means this is, you can see, is the equal division. So it's actually 6.5 to reflect that intercept C, and that's how you actually go about defining your straight line graph, your straight line equation. Understanding how to interpolate really helped us to solve this question, and the correct answer from all that we have actually been working with is that the solution to this problem is that y is equal to minus 1 over 4x plus 5. All right, so this is the answer. In this question on integration, we're asked to evaluate the integral of 2x plus 9 with respect to x, and we have our upper limit to be 2 and the lower limit to be minus 1. So this is the general format of integration for a linear algebra. If we have the integral of a multiplied by x, I want to integrate that x raised to power n with respect to x, what we are going to have is we are going to have the a multiplied by x, then n plus 1 as the new power over n plus 1 as the denominator, then we can have a constant c. But for this particular question, in which we are even having a definite integral, it's definite because we know the lower limit minus 1 and we know the upper limit 2, then we can do away with the constant. So if you want to solve this particular question, we mean that the integral with the upper limit as 2, the lower limit as minus 1 of 2x plus 9 with respect to x is going to give us this. So for this particular case, we can take it piecewise and say, in the first case, if you are looking at 2x, that means we are having something like this: 2 multiplied by x. This x is having a power of 1, then we are supposed to add another 1 to it, so we have plus 1 over this power as the denominator, 1 plus 1. Okay, then plus, now when you have 9, ideally if you have just a singular 9, a constant, it's as if we are using 9 to multiply x raised to power 0, because x raised to power 0 is 1. Any number raised to power 0 by the laws of indices is 1. So 9 multiplied by x raised to power 0 is actually 9. We are not
changing anything from here. This is just consistent, but because we want to do this integration and we want to reflect that power, we can just say, so this is plus 9 multiplied by x raised to power 0. This is the original expression, but now we need to add 1 to the power and also divide by this power as the new denominator, 0 plus 1, and then we are taking this integral from minus 1 as the lower limit to 2 as the upper limit. So we don't need to consider the constant because it's a definite integral. All right, so if we want to solve this, this is just going to give us 2x multiplied by 2 multiplied by x raised to power 1 plus 1 will give us 2s squared. Okay, 1 plus 1 is 2. Okay, and here 9 multiplied by x raised to power 0 plus 1 will give us 9x, because it's just only 1 that is remaining over 1. And this is as good as we saying these two can cut these two, and 1 is not going to have any effect. We are still taking that limit from minus 1 to 2, such that what we have is now x raised to power 2 plus 9x, and we are taking that integral from minus 1 to 2. So now what this implies is that in the first case we can take 2 as a value for x, and in that case that will be 2 raised to power 2, okay, plus 9 times the value of x, that is 2, okay, minus, now student, you need to take note of this. You don't want to just use 1 as the value of x. In the second case it is minus 1, so you have minus 1 raised to power 2 plus 9 multiplied by x multiplied by minus 1. Okay, so this is what we just need to evaluate now. 2 raised to power 2 is 4 plus 9 raised to power 2 is 18 minus 1 raised to power 2 is 1. Okay, any negative number raised to an even power will be a positive number, so let's just note that as a rule of thumb. Then 9 multiplied by minus 1 is minus 9, so this is going to give us 4 plus 18 is 22. Okay, then minus 1 minus 9 is minus 8, so this is nothing but 22 plus 8, because negative numbers, negative sign multiplied by this negative sign will be a positive sign, so we have it to be plus 8, and 22 plus 8 is equal to 30. So for this particular question, look at how we've been able to solve this. First, by understanding the means by which we carry out derivatives. First, by understanding the means by which we carry out integration, we're able to actually find the integration of this, and then we take the upper limit 2 and the lower limit minus 1 and substitute them into the integration and subtract as appropriate to get our final answer to be 30. This is a question on set theory, and we're told that there are 100 tourists. Each of them traveled by one or more of the following means of transportation as shown in the Venn diagram below. So this is the Venn diagram. Now, if 52 people traveled by bus and 35 by train, we have to find the values of u, v, and w. This is u, v, and w, and then the number of tourists who traveled by at least 2 means of transportation. No problem. So now to find the values of u, v, and w, looking at this particular Venn diagram that we're given, to say we want to find, say, the value of u, look at where u is reflecting. U is reflecting in this particular bus, and we can see that we're told that 52 people traveled by bus. So if we have 52 people to travel by bus, that is actually going to indicate that in the Venn diagram, those that travel by bus, this u, 18, 5, and 12, and I can show that if I'm to look at this particular circle here and just indicate that here, you can see this region is actually the region that is corresponding to the people that traveled by bus, and all of them will be u plus 18 here, plus 5 and 12, plus 5 and plus 12. The addition of those will actually be 52 from the Venn diagram. So that means that u plus 18 plus 5 is 23. 23 plus 12 is 35. is equal to 52. So in that case, U will be 52 minus 35, and 52 minus 35 is 12 minus 5 is 7, so 4 minus 3 is 1. So U is actually 17. Okay, that's the first thing that we want to note. In the second case, we can also say that V, 6, 5, and 12, they belong to train, but we're also told that 35 people traveled by train. So we have 35 traveled by train. So 35 traveling by train is going to be reflecting in this particular diagram here. If you look at this circle that is in the lower region, okay, I can also highlight that. Say, let me just denote. You can see, okay, that is actually the region that corresponds to those that travel by train. It is V plus 6 plus 5 plus 12, that is equal to the 35 that travel by train. And if that's the case, then 6 plus 5 is 11, 11 plus 12, that is 23. Then V will be 35 minus 23, and 35 minus 23 is 12. So 12 people is actually corresponding to the value of V that we're talking about. Then W, if you want to look at W, we're just saying that we are not giving the total numbers of people that traveled by car, but we're giving the total number of tourists that we have, meaning that everything in this particular Venn diagram, the car, the bus, the train, all of them, the total number will constitute 100 tourists. So for that particular case, we can just say all we are going to have is, for us to get W, we add all of these entries together: W, U, V, 6, 5, 12, and 18, and the addition will be 100. So for that particular case, we can say W plus U, what is the value for U? That's 17, plus V, what's the value for V? That is 12, plus the entities that are actually overlapping, we have 6 plus 12 plus 18, and then 5 for all of the entries. That's going to give us 100. How am I doing that? Because this is the universal set. This is for the universal set, all of them together, and therefore we can say that W will be 100 minus all of these additions. So I can just bring my calculator to evaluate that. So we'll have something like this. We have 17 plus 12 plus 6 plus 12 again plus 18 and plus 5. Okay, what's that? That is 70. And then we can get, this is 100 minus 70, and 100 minus 70 is nothing but 30. So 30, 17, and 12 corresponds to the value that we're asked to find. U is 17, V is 12, and W is 30. Is our understanding of the segment of each of these sets that we have: 52 people traveling by bus, 35 people traveling by train, and the total tourists, all of them together, traveling with one medium or another, that we can add to actually get each of these questions that we are queried to find, and this will be the answer as requested. Okay, now in the second case, we have to find the number of tourists who traveled by at least 2 means of transportation. Now we need to be able to judiciously get this. At least 2 means that 2 or 3. The least value we can have is 2. Okay, we can have 2, we can have 3. Now the highest number here is 3, so it's only that 2 and 3 that we can have. So at least 2 means of transportation will imply that we have to note it from our diagram. What are the locations that we have at least 2 means? I want to use another color here. See here on this particular region, this region here, okay, that's 2 is corresponding to the car and the bus. So this region is the car and the bus. Okay, if we are also to look at this region, that's the car and the train. that's 6. Okay, and then we also look at this region. This is the bus and the train, that's 12. Those are took only 2, but there is this other region also, that this particular set of tourists, they took the car, they took the bus, they also took the train. So at least 2 means of transportation will mean that we have the tourists that travel by that as 18 for the car and the bus, plus 6 for the car and the train, plus 12 for the train and the bus, and then plus 5 for the whole of the car, the bus, and the train. And so if you want to add this, you can just say 18 plus 6 plus 12 plus 5, 18 plus 6 plus 12 plus 5, that's equal to what? That is 41. So this is 41, meaning that 41 tourists traveled by at least 2 means of transportation. And with that, we've been able to get all of the questions that were asked on this question in Venn diagram in set theory. I told that the marks obtained by some students in a test are shown in the table below. So these are the marks in the first row and the frequency of the students in the second row. Then we are asked to find the median mark and the summation of the median and the mean mark. So in this particular question that we have frequency being featured, we also find the median mark. We need to know the total number of students by adding all of these frequencies together. So we have 3, 5, 9, 12, 8, 6, 5, and 2. We want to add that. We have 3 plus 5 plus 9 plus 12 plus 8 plus 6 plus 5 plus 2. That's what? 50. So the total number of students as featured here is 50. Now we need to know this so that we can find the median mark, because the median mark will reflect at the 58 over 2 position. So median mark will be the mark at 50 over 2 position, and that is at the 25th point. Okay, because 50 over 2 is 25. So looking at these numbers, if we want to add cumulatively so that we'll get to 25, we can say 3 plus 5, that is 8. 8 plus 9, that is 17. So here is 17. 17 plus 12, that is 29. Okay, so this is 29. So the 25th position is falling in this particular column. So that mark is going to be at the location here. That's where it's going to feature. Okay, but look at this. Ideally, we have the total number of students as 50, meaning that the total number of students is even. And for us to find the median, we actually take the 25th and the 26th position. So it is going to be 6 at the 25th plus 6 at the 26th position, all divided by 2. But here is quite interesting. We have 6 to be reflecting in both. So the mean mark, the median, not the median. So the median mark definitely will be 6. Had it been that what we have is an interpolation between 6 and 7, we would have said we're adding 6 and 7, then dividing by 2 to get 6.5. But here, I think it's good to go. Our solution is that the median mark, so the median mark for this distribution in question 1 is 6. Okay, now in the second case, we're asked to find the summation of the median and the range. But first, we need to evaluate the range. What is the range? The range is the difference between the highest occurring mark and the lowest occurring mark. Here, in this case, you can see we have 10 as the highest mark, we have 3 as the lowest mark. So the range will be the highest mark minus the lowest mark. And for this particular case, that is going to be 10 minus 3. And 10 minus 3 is 7. But that's not what we are asked to find. We are asked to find the summation of the median and the range. So the median which we have evaluated before, plus the range that we just evaluated will be median is 6 and the range is 7, and the addition of the 2 will be 13. So 13 is the summation of the median and the range marks, and the median mark will obtain to be 6, and with that we have solved this question completely. In this question on probabilities, we are told that probabilities of Olu and Tony passing an examination are 2/5 and 3/4 respectively. We are to find the probability that both of them passes. Now that is very good, but looking at the information that we have here, we are told that Olu and Tony passing are probabilities 2/5 and 3/4 respectively. That means probability of Olu passing, if I call that P of O, is going to be 2/5 because we have it as respectively, and the probability of Tony passing, that's I want to call that P of T, is going to be 3/4. Okay, they respectively assign the first to the first name and the second probability to the second name. Now, the probability that both passes, probability that both pass is going to give us the product of these two. So it's going to be the probability of O multiplied by the probability of T. And as simple as that can be, that will be 2/5 multiplied by 3/4. So we can cut here, like 2 can go here, 1, 2 in 4, that is 2, such that we have 1 times 3 as the numerator, which is 3, and 5 times 2 as the denominator, which is 10. So the probability that both of them pass is 3/10. In this question on quadratic equations, we are asked to solve the quadratic equation x squared plus 3x minus 28 is equal to 0, but we are to use the factorization method. So it's just as good as it gets. We have s raised to power 2 plus 3x minus 28 is equal to 0, and we're asked to use factorization method to solve for this particular equation. Now, how do we use the factorization method? What we do as a rule of thumb is that we are going to look at the product. For this particular case, the x raised to power 2 and its coefficient multiplied by the last term c. Okay, so that was going to be 20 minus 28 times x raised to power 2. Please, students, don't forget it is minus 28 s squared, not 28. Okay, then the sum is going to reflect as 3x. This is just plus 3x. So what two numbers can we multiply together to give us minus 28 squared, and if we add them together it will give us 3x? That's the challenge that is before us that we can use to actually solve this question by using the factorization method. So let's look at the factors of minus 28x squared. Well, first let's just leave out the negative sign. We'll consider that later. We can say we want to have x and 28x. Okay, we can say we want to have 2x and 14x. Okay, we can say we want to have 4x and 7x. What other number? Okay, I think this will do with all of the possibilities that we want to look at. So you also want to consider that looking at x and 28x, is there any way that we can bring either negative or positive sign and yet add them to give us 3x? There's no way. So this is out of it. 2x and 14x, is there any way that we can also multiply this together to give 28x squared and then 3x again? Also no way. Okay, now looking at 4x and 7x, if you want to take the positive numbers for the two, 4 times 7 is 28, we are good with that. Then 3x, if you say you want to add them together, that will be 11x. But if you say you want to subtract them, like say we have 7x minus 4x, 7x minus 4x is actually 3x. So if I consider this to be minus 4x and 7x, then I know that the sum will definitely be 3x. What about the product? The product will be minus 4 times 7, which is minus 28, then x times x, which is s squared. So the product is giving us minus 28s squared, the sum is giving us 3s, then definitely this is what we should make use of. So these particular factors are going to help us to actually solve our question appropriately. And what we do once we have found that is that instead of 3x that we have in the middle, we put in these two factors that we have obtained as the replacement for 3x. So in that case, we are going to have s squared plus, instead of plus 3x, now I can say minus 4x plus 7x. And am I actually changing anything? No, because minus 4x plus 7x is like 7x minus 4x. and that is 3x. Okay, so I'm still on the right track, and I can say minus 28 is equal to 0. Now, looking at this, in the first case, I can see that x is a common factor between x squared and 4x. I can have x to come out of there. So from x squared, that will still remain x because x times x is x squared. Then from minus 4x, this will remain minus 4 because x times minus 4 is minus 4x. And in the second case, I can see that 7 is common to both. So I can say plus 7 into bracket. 7 in 7x will remain x, okay? And 7 is and 7 in minus 28 will remain minus 4 because 7 times minus 4 is minus 28 and 7 times x is 7x. So this is equal to 0. And with this, you can see that x minus 4 is common to these two terms. In this first case, it is in bracket. In this second case, it is in bracket. So I can just factor out x minus 4, okay? And then in the other case, I will have x remaining here and plus 7 remaining here. So this is equal to 0. And to solve this, that means we have x minus 4 is equal to 0, or we have x plus 7 is equal to 0. And for this, if I take minus 4 to the right hand side, x will be 4, and that's one solution. And in this case, x will be minus 7. That's the other solution. So look at how we have been able to solve this question just by understanding that we can take the product and the sum and evaluate them correctly to interpolate in the second term of the quadratic equation, and solving appropriately will arrive at our answer to be x is 4 or x is minus 7. So you have this question on fractions and algebra processes, and we're asked to solve for it given that 8x over 9 minus 3x over 2, 5 over 6 minus x. Okay, so it's just as good as we finding the LCM and cross multiplying in order to solve for this. And in that case, originally we have 8x over 9 minus 3x over 2 is equal to 5 over 6 minus x. Okay, let me just take x to the left hand side so that I will know that all my s are just on the singular place. So I have 8x over 9 minus 3x over 2. When minus s moves to this side, it will become plus x over 1 because x and x over 1 are actually the same thing. So this is equal to 5 over 6. Now on the left hand side, I can find the LCM. Okay, and the LCM of 9, 2, and 1 will be 18. 18 divided by 9 is 2. 2 times 8x will be 16x. Okay, then this negative sign minus 18 divided by 2 is 9. 9 times 3x is 27x. Okay, then 18 divided by 1 is 18. 18 times x, that will be 18x. This is equal to 5 over 6. Okay, some very good thing we can do. 6 can go here 1. 6 in 18, that is 3. So what we now have is all these expressions for x, 16 minus 27 and 18. We can just sum them. We can say 16 minus 27 plus 18. That's going to give us 7. So what is left here is 7x, and that means that we're going to have 7x over 3 is equal to 5 over 1. And for us to evaluate this appropriately, we can just cross multiply, okay, so that we have 7x is equal to 3 times 5 is 15. And if we divide both sides by 7, you can see that our x that we're looking for will be 15 over 7. Why? Because on the left hand side, 7 here can cut 7, and this will be our final answer. Here in this question on differentiation, we are asked to find the derivative of 4x raised to power 3 minus 2x plus 4, everything raised to power 5 with respect to x. So this is quite a very good question, and it should be straightforward for us. But for us to actually express it correctly, let's say we have y to be equal to the whole of this 4x raised to power 3 minus 2x plus 4 all raised to power 5. So what we are looking for is dy dx. But looking at this, because of this particular power, we cannot just say we want to expand the bracket or solve it directly. So what we'll make use of is the implicit function. So implicit function will help us to solve this better, because we can introduce another variable that can be a stopgap for us to actually solve it appropriately. And in that case, the implicit function is just telling us that if in this particular case we can say, instead of y to be the whole of this, we can say let u be all that we have inside there. U will be 4x raised to power 3 minus 2x plus 4. Okay, then we can now say that means y itself is going to be u, which is the whole expression in bracket here, raised to power 5. So if we are using this, ideally what implicit function implies is that for us to find the derivative of y with respect to x, it will just be that we up with the derivative of y with respect to u multiplied by the derivative of u with respect to x. So you can see it's just as if this du and the u, they are cancelling out. So you have dy dx is equal to dy dx. But no problem. Trying to employ this as a means of our solution, we mean that we now need to find the derivative of y with respect to u here, and then we also find the derivative of u with respect to s. And the question is, how do we find derivative generally? So if we have an expression like, if y is equal to a multiplied by x raised to power n, then dy dx, just as a general rule, is going to be that coefficient of x, we still write it a, multiplied by the power of x, which is n, then we reduce the power of x by 1. So this is the ideal way, the ideal formula to make use of when we are trying to actually find derivatives. So we need to apply this for both u and y. So in that case, first we can say we want to find dy du. Dy du will be, now look at u, that's what we are differentiating with respect to. It has a coefficient that is 1, so a in this particular case is 1, but it has a power that is 5, so we can bring that power to the forefront, and so we have 5, okay, multiplied by u, and then we reduce the power of u by 1, and 5 minus 1 is that new power, and we can say this is just 5u raised to power 4. Okay, and then here for u, we can just say we also want to find u dx, and here this is u, we want to differentiate u with respect to s. We take it piecewise, each of those entities, and in the first case we can see that we have 4, but then when the power comes down, we have 4 multiplied by 3, then we reduce the power of x by 1, and that will be x raised to power 2, because it is 3 minus 1 now. Okay, then the second term, minus 2 multiplied by, see, x is just having a power of 1 here, so we can say it's multiplied by 1. Okay, then x will reduce its power by 1, and that will be 0. And anything raised to power 0, any number at all raised to power 0 is actually 1. So this x raised to power 0 is not going to have effect. And then we can say for the third term, the derivative of a constant is always equal to 0. So we can say this is actually 0. We don't need to try and say we want to evaluate it. It's just as if here we're having x raised to power 0. Okay, so since we have just expressed that any number raised to power 0 is 1, so this is as if we have 4 times 1. But when the power comes down, it will be 4 times 0, and any other number multiplying that 0 will be 0. So this is the expression for du ds, and we can just write those out to say that now we have found dy du to be 5u raised to power 4, and we have found du dx to be 4 times 3 is 12. Okay, then we have 12s squared minus x raised to power 0 is 1, then 2 times 1 is 2. So what we need to now evaluate is that this dy ds we have expressed as dy du multiplied by du ds. And what is dy du? It is 5 multiplied by u raised to power 4, okay, then multiplied by 12s squared minus 2. All right, so we can say 2 is common here, and we can factor it out to be, now when that 2 come here and multiply 5, we have it as 10 multiplied by u raised to power 4 multiplied by we factor 2 out of here, so we have 6x squared remaining. We factor 2 out of here, so we have 1 remaining. But nobody gave us u in the original question. We are giving only this expression with respect to x, so we should not reflect u in the final answer. And for us to solve that, we can just say this is 10 multiplied by, what's the value of u? U is the whole of this expression here, this expression without this x, because x raised to power 0 is 1. So if you want to put that into our equation, we have it as 4x raised to power 3 minus 2x plus 4. Okay, then this particular 6x squared minus 1. You can leave your answer like this, but I'm also seeing that 2 is common to this particular expression of u that we just brought back. So I can say this is also 10 multiplied by the 2 that is common to them. You see 4, 2, and 4. So if I factored out 2 out of that, here I will have 2s raised to power 3 remaining. In the second case, I have minus x. In the third case, I have plus 2. Okay, all multiplied by 6s squared minus 1. So 10 times 2 is going to give 20. Okay, then multiplied by 2 s raised to power 3 minus x plus 2 multiplied by 6s squared minus 1. So this is the ideal way to carry out implicit function and solve differentiation with the appropriate step. And our final answer is given as this expression. All right. In this question on algebra processes, we are told to solve the equation 5 over 3 into bracket 2 minus x minus 1 minus x over 2 minus x is equal to 3. So how do we go about solving this question? One of the key things I would like us to pay attention to is the least common multiple for this particular expression, because if you can multiply both sides of this equation by the least common multiples, it will eliminate the denominator on the left hand side, which is carrying the variable x that we are looking for. So what is the least common multiples for this particular expression? It is 3 multiplied by 2 minus x. You can see 2 minus x is here. It can be found in this LCM. Then 3 multiplied by 2 minus x is even this same LCM. So if we multiply both sides of the equation by the LCM, we are going to have a very good expression like this. So we are using 3 into 2 minus x to multiply 5 over 3 into 2 minus x. That's the first term, okay? Minus, we're also using it for the second term, 3 into 2 minus x multiplied by 1 minus x over 2 minus x, all right, is equal to 3 into 2 minus x multiplied by 2 over 3. So if we have expressions like this, let's cut all that can be cut. 3 here can cut 3, okay? 2 minus x here can divide 2 minus x here. And in this first case, 3 multiplied by 2 minus x, we just cut out 3 multiplied by 2 minus x. So what we are left with is, in this first entity, we have 5, okay? Minus, in this second one, we have 3 multiplied by 1 minus x, okay, is equal to, here we have 2 minus x multiplied by 2, okay? So if you want to open this bracket, you can say this, you have 5 minus 3 times 1 is 3, okay? Minus 3 times minus x. The negative signs will multiply each other to become a positive number, okay? Then 3 multiplied by x will be 3x. This is equal to 2 multiplied by 2 is 4. Minus x multiplied by 2 is minus 2x. So having it like this, we can just collect like terms and move x to the left hand side, the other numbers to the right hand side. And so here we have 3x, which is the only entity that is having the variable x. Then when minus 2x move to the left hand side, it becomes plus 2x, okay, is equal to 4. Now 5 minus 3 is 2. When 2 moves to the other side, it becomes minus 2. So 3x plus 2x is 5x, giving us 4 minus 2, that is 2. And for us to just solve this, we can divide both sides by 5. So 5 on the left hand side will cut 5, such that our answer, the solution, is that x is equal to 2 over 5. So what really helped us to solve this question is for us to actually know that if you multiply both sides of the equation by the LCM, it will simplify our work, and that's exactly what we carried out. And you can employ this method to also solve questions like this when you come across them in your exam. In this question on mensuration, we are told that the volume of a sphere is 9 times its surface area. We have to calculate the surface area and the volume of the sphere correct to the nearest whole number. And we can take pi as 22/7. If you want to have a view of what this look like, this is like our sphere, and we're told that for this particular sphere, the volume is 9/3 times the surface area. But volume of a sphere is generally defined as 4/3 pi r cube, okay, while the surface area of a sphere is defined as 4 pi r square. So if these are the formula that we actually employ to evaluate the volume and the surface area, why not note that the volume is 9/3 times a surface area. V is 9/3 of surface area. Okay, so this is how we can now go ahead to try and see how we can solve this particular question. But we need to note that from the center of the sphere, okay, to the edge, any point on the circumference, that's going to be our radius. Okay, so this is the radius of the sphere, but we're not giving the radius, we're only giving a ratio of the volume to the surface area. But since we know the formula for the volume and the formula for the surface area, I think we should be able to get the surface area. But since we know the formula for the volume and the formula for the surface area, I think we should be able to get the radius, and from there compute the surface area and the volume as requested. So for us, if we just want to put in the formula for the volume and the surface area, we can say it is 4/3 pi r cube, that is equal to 9/1/3 is the same as, we want to express it as a proper fraction. 9 times 3 is 27. 27 plus 1, that is 28. So we have it as 28/3. Multiplied by the surface area, that will be times 4 pi r square. So looking at this particular expression, you can see that pi can cancel out, over 3 and over 3 here can cancel out, 4 and 4 can also cancel out. So here we have r raised to power 3, here we have r raised to power 2. If we divide both by r raised to power 2, okay, we can see that here r raised to power 2 and r raised to power 2 will knock out each other. Then r raised to power 3 over r raised to power 2 is as if we are having r raised to power 3 divided by r raised to power 2, okay, to be equal to 28. By laws of indices, you know this is the same as r raised to power 3 minus 2, because this division will turn to minus when if we take only one of the base and we are working with the power. So this is actually r raised to power 1, which is r, and it is equal to 28. Now, before we just jump ahead to say we want to get the solution to this, notice that we are not even told about unit at all. So students, is either you append an arbitrary unit, or for me, I will just say 28 units. Okay, so my unit can be meters, it can be centimeters, it can be inches, but I've noted that it is units. You can say, maybe for this level of your operation of mathematics, you can just say it is centimeters, and maybe the examiner will just, okay, no problem, you'll be okay with that. But make sure you put unit. The radius cannot be unitless. Okay, so now that we have gotten radius to be 28 units, we can now use the formula for the surface area and the formula for the volume to evaluate what we're asked to find here in the question, because nobody has us to find radius originally. So let me just clear my board. And from what we've done so far, we've been able to say that r, the radius, is 28 units. Okay, so now we can say in the first case we are asked to find the surface area. So the first question, surface area, already we said was defined as 4 pi r square. Okay, and that will be 4 multiplied by pi is 22/7, multiplied by r raised to power 2, that is 28 in 2 places. Okay, so here I can see 27 here 1, 7 28 is 4. So what I just have as the answer will be the product of 4 times 22 times 4 times 28. Okay, so that is 9856, 9856. Now, I use just ordinary units for my radius. Then this will be square units. Student, please just take note of this when you are working on this so that you can get your full mark. I don't mean that you are using centimeter, you can just say centimeter square. If you are using meters, you can say meter square. But for me, I'm saying that no matter the unit, I'm just saying the square of the unit. So I'm saying square unit. Okay. So and finally, in the third case, already this is just a whole number. We don't need to consult to be bothered about correct to the nearest whole number. So finally, we have to find the volume, and well noted that volume is 4/3 pi r cube. Okay, so that will be 4/3 multiplied by 22/7 multiplied by r, which is 28 raised to power 3. Okay, so we can also use our calculator to evaluate that. I have 4/3 multiplied by 22/7 and then multiplied by 28 raised to power 3. I can use shift s square to actually get this raised to power 3 on top of s raised to power 2. So I can compute that to say I want to get it in decimal place. So this is 91989 point. Now the bar on top of 3 means it is a repeated value of 3. That is 0.33333. So I just have 91989.3. So this is 91989.33. But if I want to express it correct to the nearest whole number, I know 0.33, I will just round them down to 0 because they are not up to 5. Numbers between 1 and 4, numbers from 1 to 4, we round them down to 0 and they will not have any effect on the previous number. But numbers from 5 to 9, we round up to 1 and add to the previous number. In this case, 3 is not up to 5, so we can just round them down. So I just have 91989. But now what's going to be my unit? It should be cube unit. You understand? Because I'm actually having the radius to the power of 3, so it is cube unit. And with that, you would have been able to solve your questions appropriately as requested in this particular question. All right. Here in this question on logarithm, we are told that if log to base 10 of 3x minus 5 raised to power 2 minus log to base 10 of 4x minus 3 raised to power 2 is equal to log to base 10 of 25, we are to find the value of x. So to solve this, there are some points that we need to note in this particular question. We can see that we have the power of 2 reflecting on the left hand side, and if you actually to bring the power down, you can have 2 log 10, 2 log 10, which will be good for us. But if we say we should actually try and lump these two logarithms together, we'll see that we are still going to have this power of 2, and to try and solve that, it will complicate matters because we still need to open up the bracket and then solve. But the ideal thing, or the best thing that we could have used, one of the simplest ways, is to just express the whole of the equation as log to base 10, but each one of them, both the left hand side and the right hand side, carrying the power of 2 such that we can knock out. So this is what we're going to do. We're going to have it as log to base 10 of 3x minus 5 raised to power 2 minus log to base 10 of 4x minus 3 raised to power 2 is equal to log to base 10. 25 itself is 5 raised to power 2, so we can have this as 5 raised to power 2. And with this, you can see that for each of the entries, we are having raised to power 2 reflected. And if you want to employ the law of logarithm that said that log to base a of m raised to power n is the same as n multiplied by log to base a of m. This is one of the laws of logarithm that we can use. And if you want to apply it here, we are going to have 2 log to base 10 of 3x minus 5 then minus 2 log to base 10 of 4x minus 3 is equal to 2 log to base 10 of 5. Okay. Now, another law of logarithm that we can use is that if we have the logarithm, two different logarithms that we're actually subtracting like this, like we have log A minus log B, this is the same as log A over B. Okay. Now we are taking a single logarithm now, and instead of having A minus B, we just have A divided by B. So this is also going to help us to actually try and solve this question, because in this case we can say that now we have 2 log 10, so that we will have it as just 2 log 10. But instead of writing this in two places, we just have it as 3x minus 5 over 4x minus 3. And what I'm just doing here is just the expression of this particular law of logarithm. So this is equal to 2 of log to base 10 of 5. Now, this is a good thing that we can do. We can see that this is 2 multiplied by log to base 10, and this is 2 multiplied by log to base 10. If those two logarithms are equal, then actually this expression are also equal. You can have it at 3x minus 5 over 4x minus 3 is equal to 5 or 5 over 1. Okay. So if you have that, we can now say we want to cross multiply here, such that we have 3x minus 5 is equal to 5 multiplied by 4x minus 3. And we just open up this bracket to try and solve the question, which if we are doing that correctly, what we are going to have is that we'll have on the left hand side, we still have our 3x minus 5. And on the right hand side, we open the bracket, 5 times 4x is 20x, and 5 times minus 3 is minus 15. So we have to collect the like terms. Let me just take 3x to the right hand side and bring minus 15 to the other side. Or even let me just do it straight. I can have 3x minus 20x is equal to minus 15. When this particular minus 5 moves there, it becomes plus 5. Okay. So here 3x minus 20x is minus 17x is equal to minus 15 plus 5 is minus 10. Okay. So for this particular case, we can divide both sides by minus 17, minus 17. So here, what we'll have is that on the left hand side, minus 17 will cancel minus 17. On the right hand side, the negative sign will cut out each other. So our x will be 10 over 17 as the solution to this particular question. It's our understanding of these two laws of logarithm that really helped us to solve this, instead of going the long way of trying to open this bracket and just unnecessarily wasting time. So this is the solution to this question on logarithm. In this question on the equation of a straight line, we are told that we should find the equation of a straight line which passes through the point 3, 2 and is perpendicular to the line 3x plus 5y is equal to 10. Hence, we are to determine the gradient and the y-intercept of the equation. We need to know that we are given a particular point on the line which we are to find this equation, but that line is perpendicular to another line 3x plus 5y is equal to 10. So we have two case scenarios here, and we can show this with this example, that let's say we have a particular equation here and another equation. So these are equations of straight line, but in the first case, the particular first equation is carrying equation y1 is m1 x1 plus c1, and the second one is carrying y2 is m2 x2 plus c2. Now these two equations, you can notice they are actually inclined at a right angle to one another, meaning that they are perpendicular to one another. And for that rule of perpendicularity to hold, what we notice is that mathematically acceptable is that m1 multiplied by m2 is equal to minus 1, meaning that the product of the slopes, the product of the gradient of these two equations is equal to minus 1. This satisfies the condition for perpendicularity. Okay, so in this particular question that we are given, we are told that, let's look at the other equation that we are given. We have 3x plus 5y is equal to 10. Okay, If we want to express this as y is equal to mx plus c, we can first rearrange to say it is 5y is equal to minus 3x plus 10. Okay, and if we divide all of the sides by 5, what we are going to notice is that here in the first entity, the 5 will cut. Here in the last term, 5 in 10 is 2, such that what we have is that y is equal to minus 3 over 5x plus 2. Now, if we are to compare this with y is equal to mx plus c, this is for this other equation that we are seeing. We can notice that for this particular one, the equation the slope m is equal to minus 3 over 5. Now, we can take this as m1, okay, because it's the equation that we know. But from here, we can see that m2 will now be minus 1 over m1. So, if we want to employ that to actually evaluate the equation of the straight line, in which you only know a point, we can say m2 for our equation we are looking for will be minus 1 divided by minus 3 over 5, okay, and that will be minus 1 times minus 5 over 3. So two negative numbers multiplying each other will become plus. So 1 times any number is any number. So since the negative signs will multiply each other to become plus, that means that m2 is 5 over 3. All right, now m2 is 5 over 3, and we're told that we have this equation passing through the point 3, 2. We now need to see how we can express these two conditions together to get the equation of the straight line. And this is what we have. Generally, we have change in y to be m multiplied by change in x, so that we can write it as y minus y1. We can see that's the change in y is equal to m multiplied by x minus x1. So the x can be the variable, the y can be the variable, but y1 and x1 will correspond to what we are given as 3 over 2. Okay, so for us to do that, we can just say we want to write it that y minus y1. y1 is going to be 2. Okay, so y minus 2 is equal to, what's the m that we just got? It is 5 over 3, okay, multiplied by x minus x1. x1 is going to be 3, because generally the expression is that we had x comma y, and what we are given is 3 comma 2. So x1 is 3 and y1 is 2. That's why we have this particular expression that we have. So since we have gotten this, we can just try and evaluate this and express them straight linearly, so that we can determine the gradient and the y-intercept and the equation of the line as requested. So I'm going to clear my board to further solve that now. So what we have is that we have y minus 2 is equal to 5 over 3 multiplied by x minus 3. Okay, so we just need to open up this, because you can cross multiply, and 3 will multiply the whole of this left hand side, and we have 3 multiplied by y minus 2 is equal to 5 multiplied by x minus 3. So if you open this bracket, 3 times y is 3y, 3 times minus 2 is minus 6 is equal to 5 times x is 5x, 5 times minus 3 is minus 15. So we want only y to be on the left hand side, so that it can correspond to the general equation y is equal to mx plus c. So it is equal to 5x minus 15. 1 minus 6 moves to the right hand side, becomes plus 6. So we have 3y is equal to 5x minus 15 plus 6 is minus 9. Okay, now for us to get this true, we can just divide each of the entities by 3. Okay, so we can see that here 3 will cut 3, 3 here 1, 3 in 9 is 3. So what we have is that we have it as y is equal to 5 over 3x minus 3. So this particular expression is the equation for the straight line which passes through the point 3, 2 and is perpendicular to the line 3x plus 5y is equal to 10. Now, we are told to find the gradient. This is the gradient. You see, if we compare this with y is equal to mx plus c, we can see from the comparison of this, m is the gradient, then we can just write it out that m, the gradient that we are asked to find, is what? Is 5/3, and then the y-intercept of the equation is this third term, it is c, and c, the y-intercept is -3. Student, notice that it's not 3, it is -3. You need to put your negative sign. And with that, we've been able to use our understanding of the perpendicularity of two straight lines to evaluate this particular question and solve and find the gradient and y-intercept as requested. So this is our final answer. Y is equal to 5/3x minus 3, and then the gradient is 5/3 and the y-intercept is -3. In this question on commercial mathematics, we are asked to find the compound interest on 8,000 naira for 3 years at 5% per annum. So we just need to know that we have been informed. So what we need to note is that we have been given the principal to be 8,000 naira. That's from the question. The time is 3 years, and the rate R is 5% per annum. But look at what we are looking at here. We are looking at the compound interest. So students, don't just think this is simple interest and you just go ahead to use the formula for simple interest. For compound interest, the amount after a stipulated time is given as the principal multiplied by 1 plus r/100 raised to power n. Okay, where n is the number of years, here it is t. The principal will have been given to be 8,000 and the rate is 5%. So if you want to just put in the values, we will say that will mean that we have 8,000 naira multiplied by 1 plus what's our r, that is 5/100 raised to power 3. Okay, so this is the same as saying we have 8,000 times 1 plus 5/100 is 0.05, okay, raised to power 3. So that is going to give us 8,000 multiplied by 1.05 raised to power 3. And if we are to put that into our calculator, we will have 8,000 times 1.05 raised to power 3 is the shift of s raised to power 2. Okay, so if you press equal to, so this is 9261. So the amount is 9,261 after 3 years. But look at the question we have. So we have to find the compound interest. That compound interest that we're asked to find is not the amount that we just evaluated. The compound interest is this amount that we just got minus the principal that was originally deposited in the account on whom we are finding the compound interest. So that compound interest is going to be the amount 9,261 minus the principal, which is 8,000. So this is where you actually get to understand the power of compound interest. If we subtract this, this will give us 1,261 naira as the compound interest on the amount of 8,000 naira reported for 3 years at 5% per annum. In this question on sequence and series, particularly AP, arithmetic progression, we are told that the 9th and the 12th terms of an AP are 50 and 65 respectively, and the mandate before us is to find the sum of the first 70 terms. So the question is, what's the formula for the sum of a particular number of terms? It is given as n/2 multiplied by 2a plus n minus 1d, okay, where n is the number of terms, a is the first term, and d is a common difference. But here, look at what we are given. We are given the 9th and the 12th term as being 50 and 65 respectively, and the nth term, formula for the nth term, is given as a plus n minus 1d. So equipped with these two formula here, we can go ahead to try and find the value of A and D from the terms that we are given, so that we can use those to evaluate the sum of the first 70 terms. So that's what we are going to be doing right now. I just want to divide my board. So in the first case, we are told that the 9th term is 50, okay, and then the 12th term is 65. That's what we mean by 9th and 12th being 50 and 65 respectively. So the 9th term, T9, is given as A plus, instead of writing n minus 1, we now know that it is 9 minus 1, okay. So 9 minus 1 is 8 multiplied by D is given as 50. And then the 12th term, T12, is given as A plus 12 minus 1D, and 12 minus 1 is 11D, okay. That is given as 65. So we have these two equations. We can call this equation 1, we can call this equation 2, that we need to solve by whatever means is appropriate or is suitable for us. For me, I can just say I want to subtract. If I say equation 1 minus equation 2, in this case I will have, taking it term wise, I will have A minus A, okay, then plus, here I have 8D minus 11D, and on the right hand side I have 50 minus 65, okay. That is gotten by saying equation 1 minus equation 2. A minus A, this will give us 0, so we don't need to be concerned about that. 8D minus 11D is minus 3D, is equal to 50 minus 65 is minus 15. And for us to get D, we can just divide both sides by minus 3. So if we are dividing both sides by minus 3 here will cut out. Here, in which we are having a negative number dividing a negative number, that will be positive. As if we are saying those negative signs will cut out, and 15 over 3 is equal to 5. So that means that D, the common difference D, is equal to 5. And from the first equation, from whatever one we want to make use, we can say from equation 1, from 1, A here is going to be 50 minus 8D. So A is 50 minus 8 times 5, because we have already gotten D to be 5. So that will be 50 minus 40, and that will be 10. Okay, so A is 10, D is 50, but we're actually asked to find the sum of the first 70 times. So S70 is going to give us n over 2, in which case n here is 70, will be 70 over 2, multiplied by 2a will be 2 times 10, plus n minus 1 will now be 70 minus 1, multiplied by d, the common difference, which is 5. So this is what we just need to simplify. 70 over 2 is 35, okay. 2 times 10 is 20, plus 70 minus 1 is 69. So we have 69 times 5 here, okay. And if we just want to expand that, that will be 35 multiplied by, let me just evaluate this with the calculator. 69 times 5, that's what? That's 345, plus 20, that will be 365. That's 35 times 365, and 35 times 365 is going to give us, these are our initial answer times 35, 12,775. So 12,775 is the sum of the first 70 times of the AP, in which the 9th term is 50 and the 12th term is 65. This is our correct answer. All right. In this question on calculus, we are told that a particle moves in a straight line and its velocity after t seconds is given by v is equal to t raised to the power 2 minus 3t plus 2 meters per second. Then the distance of the particle from a fixed point on the line is s meters after t seconds, and s is 40 when t is 6. We are to find the formula for s in terms of t. So the first thing you need to know as a student is that this is actually a question on calculus, in which you need to bring your ingenuity of the understanding of differentiation and integration into play. Like for example, look at what we are given. We are told that the velocity of a particular body is given as v is t squared minus 3t plus 2, and then distance of the particle. So we're looking at distance and velocity. Well, actually it should have been displacement, because if we are looking at velocity, then it is displacement that's relating velocity. If we are looking at speed, it is distance. But no problem, let's flow with the tide of what we're given. So originally, from our understanding of mechanics, physics, and commercial students as students, you also need to know this. Generally, the velocity is given as the rate of change of displacement with respect to time. So v is ds dt. But for this particular case, we are told that that ds dt is equal to t squared minus 3t plus 2 meters per second. All right. But what we are needing to find, what we need to find from this particular question is the formula for s in terms of t. So if we have an expression like this, this is a differentiation expression. We want to find s, then what we do is that we carry out integration with respect to both sides. So we say the integral of ds dt with respect to t, is equal to the integral of t squared minus 3t plus 2 with respect to t. So the fact that we are carrying out integral of this left hand side means that this is going to give us s is equal to the integral of t squared minus 3t plus 2. Can put everything in brackets, and we're integrating with respect to t. So this is what we need to do. This is what we need to evaluate. And generally, using the formula that if we want to find the integral of an expression in which a is the coefficient and x is the variable raised to power n, this is giving us a multiplied by n, then multiplied by that variable x, then we reduce the power of that variable by 1 and divide the whole expression by the new variable, which is minus 1. So if we want to evaluate for this particular expression, we can say s is equal to, in the first case, t raised to power 2. As if the coefficient of t is just 1. Here, a is corresponding to 1, so we don't need that. Then t raised to power 2, we need to add 1 to that to carry out the integration, then divided by the new power, which is 2 plus 1. Then minus 3 is corresponding to a in the second expression. Then t standing alone is just as if we are having t raised to power 1. Then we add the new power and divide by that new power. We add 1 and divide by that new power, which is 1 plus 1. Then plus 2. When you have 2 standing alone, it's as if you're having multiplying by t raised to power 0. And because t raised to power 0, any number raised to power 0 is 1. So we can just say it's like we have this as t raised to power 0, but we add 1, so plus 1 over this new power, 0 plus 1. Now when we're working with this, we had the constant of integration plus c, because maybe there is some other number that is not reflecting in that integral. So this is how we go about it, and if we simplify that, that will be s is equal to t raised to power 2 plus 1 is 1 over 3 multiplied by t raised to power 3, minus, here we have 3 over 2 multiplied by t raised to power 2, plus, here we have 2t, because 0 plus 1 is t, 0 plus 1 here is over 1, so we're okay with that, plus c. So now that we have this expression, you understand why we are being told that when s is 40, t is 6. So we need to input that so that we can find the value of this constant c. So we can say when s is 40 and t is 6, then that means that 40 is equal to 1 over 3 multiplied by 6 raised to power 3 minus 3 over 2 multiplied by 6 raised to power 2 plus 2 times t, which is 6, plus c. So looking at all this, that means that just use our calculator to express this. You can say this means that 40 is equal to, so you can say this is 1 over 3 multiplied by 6 raised to power 3, and you can see how I'm actually putting this to reflect that I'm multiplying them, then minus 3 over 2 multiplied by 6 raised to power 2, okay, then plus 2 times 6 is 12. Okay, we want to evaluate that. So all of this is 30 plus C. Therefore, C is 30 moving to the other side will be 40 minus 30, and that is 10. Then in that case, that means that the expression for the displacement S, we can now say is 1 over 3 multiplied by 3 raised to power 3 minus 3 over 2 multiplied by 3 raised to power 2 plus 2t plus 10, because we just found the value of C, the constant, to be 10, and this is going to be our final answer.
So here in this question on construction in mathematics, we're asked to use a ruler and a pair of compasses only to construct an inscribed circle in a triangle ABC of sides AB given as 8.5 centimeters, AC as 7 centimeters, and angle CAB as 60 degrees. Then we have to measure the radius of the circle and calculate the area of the inscribed circle. So our first mandate is to actually get our triangle constructed, then we inscribe a circle inside it. And to do that, this is what I'm going to do. I'm just going to walk through how we can successfully construct both the triangle and the circle before I will now make a walk through the actual construction. So first and foremost, in this particular question, and generally in questions like this, whenever we are told that we are to construct, I make it a rule of thumb, is been a personal preference, that I should start with the angle, because once I've been able to get the angle, then I can mark off the measurement of the sides that are given, like in this case 8.5 centimeters and 7 centimeters. So I should start with angle CAB. CAB means that the angle is taken at the vertex A of the triangle. C is flanking it and B is also flanking it, but it's at the point A that angle is located. So if I have my line of reference like here, okay, first I will just need to locate the vertex A. So if I say this is going to be my vertex A, then I want to construct angle 60 degrees. Generally, I will just make a semicircle, okay, and with the radius that I use, I will just mark off that semicircle like this. Now that same radius being used to mark off, first from here, the sharp point of the compass will be here, and then I will mark off using the same radius that I used to draw the semicircle like this, and then the line that I will draw from the point A through this will be at 60 degrees here. So if I want to just draw that line, I know that this is point A to any of the other point. Like for example, if I want to measure 7 centimeters, I would have marked that up with the compass on the ruler. So I can mark up the point that is corresponding to 7 centimeters on that, and then from A, I can just say I want to draw a straight line that pass through that angle 60 to that particular point that I mark off. So I can label this appropriately to say here this is point C, okay, and here this is 7 centimeters. Then to get point B, which is 8.5 centimeters from A, again I will take the compass and measure off 8.5 centimeters, then put the sharp end of the compass here, and then make an arc on this other line. Okay, so that is 8.5 centimeters, and this is point B. And then to finish up my diagram, I can join the point C and point B together. I'm still going to show this. I just want you to have a feel of what it's going to look like. So this is a triangle that we're asked to construct, but we now need to go ahead to also construct a circle. Inscribed means that the circle should be inside this triangle and it should touch each of the sides of the triangle. And how do you go about to do that? First, we are going to take two angles and bisect them, and the point of intersection of the bisection of the two angles is going to be the incenter of the circle. Okay, it's called the incenter. It's going to be the center of the circle. So if I take this point here on the 60 degrees that I marked before, and I just use an arbitrary radius to mark off an arc, and then also go to this point and mark off another arc. Now the line coming from point A and passing through those two arcs is going to bisect this 60 into 2 equal parts. So this is 30 and this is 30, but we don't need to reflect that. What I did there, I will also do to some other
vertex. So at C, if I'm to consider that I have this angle at C, so I can take the sharp point of the compass here and mark off a radius like this, and also using the same radius, go to this other end and mark off another arc. So from here, I can now say I want to bisect the angle at C by drawing a line from the center of C through those two arcs, and I will have something like this. Now, this is the good thing here. This point where those two bisections meet, this is going to be the center of the circle that I want to draw. But that's not all. I still need to get the radius of the circle. And to get the radius of the circle, I can pick any of the sides, maybe this side or this side or this side. And I will just use this particular in-center as reference to bisect that line, and then the line coming from the in-center to that particular line will be the radius that we're asked to measure. So if I put the sharp point of the compass here and I mark off a particular arc here, and with the same radius mark off that another arc here also using that same radius, then I will still come here, okay, I will mark off an arbitrary radius and also come here and mark off another arbitrary radius. So what I've done now, I can now use a straight line to join from the in-center to that particular perpendicular bisector of the side AC of the triangle. So from this side of the triangle to the center, this distance here is going to be the radius of the circle that we're asked to find. Okay, so this is going to be the radius R. This is the R that we're asked to find, and we can now put the sharp point of the compass here at the in-center, and then the pencil of the compass can be here, and then we can now draw a circle that is going to join each of the side of the triangle. So it's going to be something like this, and with this we would have finished the question as we asked to find. And since we would have measured the radius, then we can find the area of the described circle by making use of the formula that the area of a circle is equal to pi r squared, and that r already we have gotten like this. So this is what we are going to do, and I'm going to just show us as I do them practically. I just need us to have this understanding, and we can go ahead and see for yourself right now. So first we need to draw our reference line, and then after having done that, we need to locate the point A where our angle will be taken from. So let's say this is point A, noted in red. Then we can bring in our compass to draw a semicircle, which is a 180 degrees angle. That's the angle on a straight line. But using the same radius, we can go to one side of the semicircle and mark off angle 60 degrees. Now, what we have just done has been able to divide this whole angle into 60 and 120 degrees, and we need to make use of this 60 degrees to get the inclination of A to C. But we know that AC was given as 7 centimeters, so we can mark that off on the ruler and take our compass to the point at A, and then draw an arc that is going to pass through that angle 60 degrees to meet that particular arc that we just drew, such that we can get our AC. So this straight line is now passing from A to C through an angle of 60 degrees. Okay, and then we are also told that AB is 8.5 centimeters, so we can take our compass and go to get 8.5 on the ruler, and then go to A so that we can draw an arc to mark off point C, just as shown in the diagram now. And then having done this, we can now say we want to complete our triangle by joining C and B with a straight line. And so this is as good as it comes. This is our triangle that we are given, and we can label the point A where we took our angle, the point C, and then we have between, and then we have point B just as given in the diagram. And then the distance between A and C, line AC, is 7 centimeters. Then line AB is 8.5 centimeters, and the angle that we are given as CAB is 60 degrees. So we have been able to successfully complete our triangle as requested. Now we can go ahead to say we want to draw the circle, and now we can look at angle 60 degrees, and we can bisect it by taking those 2 points, and we are going to take a straight line to that arc together. But we can also look at point C as explained before, and then first we want to draw the angle at C, so you can just draw this angle, and then at each point of those angles we can put our compass there and draw an arc, say here, and then go to the other point maintaining the same radius, and this is how we bisect an angle. Okay, so you can also draw another arc, and then these two angles, the angles at A and the angle at C that we have constructed, we can just draw a straight line to bisect them as shown. This is the bisection of angle C, and then we can also go to bisect the angle at A. Just take a ruler through from the point to the arcs that we just constructed, and then if we just locate it appropriately, now that is also the bisection of the angle 60 degrees. So now the intersection of those two bisectors is going to give us the incenter, which is going to be the center of the circle that we're asked to inscribe in this particular triangle. But before we can actually before we can construct the circle, we need to find the perpendicular bisector of one of the sides. I will take the side AC, so I can just take an arbitrary arc and mark off the line AC on these 2 points, and then I'll take the compass to each of those 2 points again and draw another arc at the top just as being shown, and then go to the other point, draw another arc. So the point of intersection of these two arcs in blue to the incenter of the circle, I will need to actually construct a straight line. So that's a straight line. Now from the side of the triangle to the incenter is going to be the radius of the circle that we're asked to construct. So I can now take my compass to the center like that and just bring the pencil side to that side of the triangle and complete the circle, and our work is done. So the final thing is for us to get the radius of the circle, and it's still the radius that is on the compass, so I can just mark it off on the ruler and I can see if I'm doing that correctly. This is 2.123, that's around 2.3 centimeters. So that's what I can use to get the radius, and I can use to compute the area of the circle as requested. All right, so from our foregoing we can say that this is our R, and we have been able to get the radius R to be 2.3 centimeters. So here this is the answer to A, and here this is B, and then C. You know that the area of the inscribed circle is defined as pi r square by reason of the formula for the area of a circle, and pi is 22/7. R we have obtained to be 2.3 raised to power 2 to input in the formula, and to evaluate this we can use our calculator to say we want to have 22/7 multiplied by 2.3 raised to power 2, and that will be in decimal place 16.6257. This under the bar will be repeated, so we can just say 16.63 because we can round 5 up to 1 and add to the initial number 2 to make it 3, so it is 16.63 centimeter square. And you can see our understanding of how to construct a triangle and how to construct an inscribed circle in that triangle and help us to solve this question fully and totally just like this. So if you want more questions on construction, you can just check our playlist, and it's going to help you to be able to carry out this type of questions and solve them judiciously in your maths exam. In this question on word problem on equations, we are told that a woman is 4 times as old as her daughter. Okay, that's presently in this time. In 5 years time, the square of her age will exceed the square of her daughter's age by 120 years. So we need to know how to interpret that. We have to find the age of the daughter. Okay, no problem. Our mandate is to work with the daughter and find what her age is going to be. So this is a classical question on equation in which if we say let mother's age be y, let mom's age be y, and daughter's age and let the total be x. Today, we can see that today, as in this particular year, the woman is 4 times as old as her daughter. So y is 4 times as old as x. Okay, then in 5 years time, so 5 years later, 5 years from now, student, this is where we really need to take note of what we are doing, because in 5 years time, the age of the mother will now be y plus 5, and we are told that the square of that age, so that is y plus 5 raised to power 2. You see in 5 years time, the square of her age, so this is going to be the square of her age in 5 years time, is equal to it will exceed the square of her daughter's age by 120 years. But what's going to be her daughter's age in 5 years time is also going to be x plus 5. Okay, so the age of the mother is going to exceed the square of the daughter's age, so we have the square of that age by 120. Wow. Once we miss this step, definitely we are not going to get our correct answer. So this is the interpretation that this in 5 years time, the square of the mother's age, now the mother's age will be y plus 5, so that square will be the square of that daughter's age plus 120, because we are told that she would have exceeded the square of her own age would have exceeded the square of her daughter's age by 120 years. So we need to take note of that. But now we can see that we just have 2 equations, but look at this, we are asked to find the daughter's age, that is x. X is what we are looking for. So here in this particular expression, we can just say we want to substitute since we have 2 equations, substitute y is equal to 4x in this second equation in 2, if this is 1 and this is 2. So to do that, we can just say instead of y, wherever we see y, we're going to use 4x. So we have it as 4x plus 5 raised to power 2 is equal to x plus 5 raised to power 2 plus 120. So we need to just open up these brackets. Okay, so in the first case, 4x plus 5 will be 4x plus 5 multiplied by 4x plus 5, that's 4x plus 5 raised to power 2 is equal to x plus 5 multiplied by x plus 5. Okay, then this 120 plus 120. All right, so we just need to open up this bracket now, and we need to multiply piecewise. 4x times 4x will be 16x squared. Okay, 4x times 5 will be 20x. Again, we have 5 times 4x, that will be another 20x. Okay, then 5 times 5, that will be plus 25. That's the left hand side. Okay, this is going to give us equal to x plus 5 raised to power 2 will be x plus 5 times x plus 5, and we need to take it piecewise again. X times x will be x squared, x times 5 will be 5x, then again 5 times x will be another 5x, and then 5 times 5, that will be 25, and then we still have this 120 to add to it. So this is what we need to now simplify that. Here we can have this as 16x squared, 20x plus 20x is 40x, then plus 25 is equal to, here we still have x squared, 5x plus 5x is 10x, 25 plus 120 is 145. This is already looking like a quadratic equation. Okay, so we can just move everything to the left hand side, and if we do that, we are going to have this as 16x squared minus s squared. Okay, I'm just taking this to the other side, plus 40x minus 10x, okay, plus 25. Now when 145 moves to the other side, it becomes minus 145 is equal to 0. All right, so 16x squared minus s squared is 15x squared, plus 40x minus 10x is 30x. Okay, then 25 minus 145 will be minus 120 is equal to 0. We can see that 15 is common to all of them. If we divide all through by 15, by 15. 15 here will cancel 15 here, 15 here 1, 2, 15 here 1, 15 here 8. So what we have is, eventually we have x squared plus 2x minus 8 is equal to 0. So this is the quadratic equation that we need to solve. So we arrived at x squared plus 2x minus 8 is equal to 0 as the quadratic equation that we need to solve in order to evaluate this question. Now, I want to use factorization method. And what the factorization method will enhance for me is that it will help me to get some two entities that I can use to replace this middle entity so that I can solve this straight. But I need to consider the product of minus 8 and s squared. So minus 8s squared is my product, and the terms I'm going to be using must sum up to be this middle term. It must sum up to be 2x. So what two numbers can I multiply together to get minus 8s squared and sum together to get 2x? Okay, so since the sum is a positive number, so the higher number must carry the positive sign and the lower number must carry a negative sign. So if I say I'm looking at 4x and minus 2x, you can see 4 times minus 2 is going to give me minus 8. X times s is s squared. Then 4x plus minus 2x is going to give me 2s. So these are the two entities I need to use, and if I'm to use that, I will just say my equation becomes s squared plus 4x minus 2x minus 8 is equal to 0. And you can see it's still consistent with what I'm coming from, because 4x minus 2x is actually 2s. So in these first two terms, I can say that x is common to them. If I bring that out, then here it will remain x because s times x is s squared. And in this second term, it will remain 4 because x times 4 is 4x. And here in this second and in this third and last term, if I factor out minus 2, here it will remain x because minus 2 times x is minus 2x. And here it will remain plus 4. You need to take note of this sign because minus 2 times plus 4, the negative sign will multiply the positive sign to give us a negative. 2 times 4 will give us 8, and so this is equal to 0. And in these two entities, I can see that x plus 4 is common to both of them. And in the first case, it will remain x. In the second case, it will remain minus 2 is equal to 0. So it's either x plus 4 is 0 or x minus 2 is 0. In this case that x plus 4 is 0, we'll have x to be minus 4, and here we'll have x to be, when minus 2 moves to the other side, it becomes 2. But look at this, we are working with age, and age cannot be negative. The age of a person cannot be a negative number. So noting this, you can eliminate that x cannot be minus 4, and in that case, the daughter's age, which we appended to be x, is going to give us the answer as 2 years. So that's what we are asked to find, not the woman's age. If we wanted to find the woman's age, we could have said that would be y is equal to 4 times x, and that would have been 8 years. Now, that's not realistically correct, but it's a mathematical model, and we're asked to also solve it, and the answer that we got is 2 years. Okay. In this question on change of subject and algebra processes, we're told to make y the subject of the formula t is equal to w plus wy squared over pz, and then hence we should find the value of y if p is 5, z is 10, t is 9, and w is equal to 3. So we are going to take some processes to try and evaluate this particular question here. And you can see first we're given that t is equal to w plus wy squared over pz, and our mandate is that first we are to make y the subject of the formula. So y here should be standing alone at the right hand side is equal to some other expression as we are going to find as appropriate. So first and foremost, we want to eliminate the term containing y. So if I move this term to the left hand side, I can say I just have wy squared over pz. I'm just rearranging, not moving it to the left hand side, equal to, when w cross over to this side, it become t minus w, or I can say the whole of this over 1. Why am I saying that? Is because I can see that easily I can cross multiply to have wy square multiplying 1 is still wy square, okay, is equal to pz multiplying the whole of this numerator will be pz multiplied by t minus w, okay. And now I want to have only y at the left hand side, so I can divide both sides by w. In that case, I can say this is over w and this is over w. If I had that, this w will cancel this w, so that what I have is only y squared. And to have y alone, then I can find the square root of both sides to say y is equal to the square root of pz multiplied by t minus w over w. Okay, so that's the expression for y as the subject of the formula that we are given, that we just express like that. But now we are told that if p is equal to 5, z is 10, t is 9, and w is 3, we have to find the value of y. In that case, y will be, we just need to substitute all those values, that p is 5 multiplied by z, that's 10, multiplied by t minus w, t is 9, minus w is 3 over w, that is 3. So if you want to express this, this is the square root of 5 times 10 is 50, 9 minus 3 is 6. Okay, so this is 50 times 6 over 3. And 3 can go here, 1, 3 is 6. This is 2. So y is equal to the square root of 50 times 2, that is 100. So if this is the value of y, therefore y itself is square root of 100 is plus or minus 10. Okay, so to get your full mark, it's better you just append it as plus or minus 10, because minus 10 raised to power 2 is 100 and 10 raised to power 2 is also 100. So the solution to this particular question is that y is 10, and in this particular case, the expression for y as the square root of the formula is square root of pz multiplied by t minus w all over w. All right. So here in this question on statistics, we are told that the frequency distribution of scores obtained by 50 students in a class test are given in the table below. So these are the scores on the first row and the frequency of the scores on the second row. We are to determine the value of t. You can see t reflecting in the frequency, okay, and then we are to find the frequency of the model class, and finally we are to evaluate the variance of the distribution. In the first case, for us to find the value of t, we are noting that we are told the total number of students. Look at this, that 50 students are what the table is all about, okay, and then for this particular case, to find the value of t, that means that the summation of all the frequencies, 3, 10 minus t, 3t, 8, 2t plus 2, and t plus 2, will sum up to be 50. So with that, we should be able to find the value of t by saying that summation f is going to give us 3 plus 10 minus t, okay, plus 3t plus 8 plus 2t plus 2 plus t plus 2. Each of those entries of the frequency is going to add up to 50. So if we just want to evaluate that, 3 plus 10 is 13, 13 plus 8, that is 21, 21 plus 2, that is 23, 23 plus 2, that is 25. So we have 25, okay, minus t plus 3t is 2t, 2t plus 2t is 40, 40 plus t is 5t. So we have 25 plus 5t is equal to 0, such that 5t will be 50 minus 25. I know 50 minus 25 is 25, and then t will be 25 over 5, and that will be 5. So the t that we are given in this particular frequency table is that it has a value of 5. Okay, so that's the value of t, and the first question is done. In the second question, we are asked to find the frequency of the model class. The frequency of the model class will be the highest frequency in the table, so we need to evaluate the values of t in each of these inputs so that we can get the one that is highest. So we don't have any problem with 3. 10 minus t will be 10 minus 5, so this will be 5. Okay, 3t will be 3 times 5, so this will be 15. 8 has nothing to do with t. 2t plus 2 will be 2 times 5, 10 plus 2. So this will be 12. Then t plus 2 will be 5 plus 2. And this is 7. And if we are to look at each of these entries, we have 3, 5, 15, 12, 7, and 8. The one with the highest frequency is definitely the one carrying 3t. So the frequency of the modal class from that foregoing, the frequency of the modal class from the table, as we just evaluated it, is going to give us 3t, which is 3 multiplied by 5, and that is 15. So the first question is done with, the second is done with. We can now move on to find the variance. All right. So the question before us is, how do we find the variance of a distribution like this? The variance is generally given as the sum of the product of the frequency and d square, where we are going to talk about d very soon, over the summation of the frequency. Okay, now d is actually going to be each of those values minus the mean of the set as given. So we want to just interpolate this table so that we can get all those values appropriately. Here we have the scores, and this is how you go about also trying to evaluate your table when you are given the question. Then we have the frequency. Then we are going to look at the midpoint of that particular score. You know, it's a range from 5 to 9. We get the midpoint of that value, and then we also look at the product of the frequency and the mid score. Then we find d, which is the difference between that mid score and the mean of the distribution, and then we find d square. Okay, then we can also evaluate the product of the frequency and the square of d. So let's populate this table as requested. The scores, we have 5 to 9, we have 10 to 14, we have 15 to 19, and just like that, 20 to 24, 25 to 29, and finally 30 to 34. Okay, the frequency was given, we have 3, 10 minus t. Remember, our t was gotten to be 5, so the frequency here is 5. 3t, that was 15. 8, then 2t plus 12, that will be 2 times 5 plus 2, that is 12. And then t plus 2, that is 5 plus 2, and this is 7. Okay, then the midpoint, let's look at this together. We have 5, 6, 7, 8, and 9. These are going to be the scores that are embedded like in the first set. But where is the midpoint? Yeah, these are just a total of 5 entries. We have 2 here. We have 2 here. You can see 7 is the midpoint of that particular data set. So if 7 is the midpoint, that means 7 is what we are going to reflect on our table. Okay, so this is going to be 7 here. And then between 10 and 14, the same thing. You have 10, 11, 12, 13, 14. Which one is the midpoint? It is 12. Okay, and in short, as a rule of thumb, if you are consistent, you will notice that is an additional value of 5 units to each of them. Like this is 7 plus 5, 12, plus 5 again, 17, plus 5, 22, plus 5, 27, and plus 5, 32. You can confirm by carrying out all of this. Like for example, let's take 30 to 34. So we have 30, 31, 32, 33, and 34. So where is the midpoint in this particular case? You can see it is 32 as we correctly stipulated on our table. Okay, so now that we have that, we can go ahead to say we want to evaluate the product of the frequency and the midpoint. Okay, the mid score. 3 times 7, that is going to be 21. Okay, 5 times 12 is 60. 15 times 17, we don't need to crack ourselves unnecessarily. This is 255, is 255. Okay, 22 times 8, that's 16. Another 16, that's 176. Let's look at that. 22 times 8. Okay, on the right track. 12 times 27, 12 times 2, 7. That's 324. This is 324. And 7 times 32, 7 times 2 is 14, remaining 1. 7 times 3 is 21, plus that 1, that is 22. Okay, so then we now need to find the value of d the difference between the mean score and the mean. So first we need to find the mean, and the mean for a distribution like this is the summation of fx over summation of f. Okay, so this particular one will mean that we need to add all these fx together, okay, to find the summation here, and then we also need to add all of the f. In short, we have been given the sum of the f. We are told that it is 50, so this particular summation f is 50. All right, then we need to find summation fx. So we can bring in our calculator to say we want to evaluate the summation fx. That will be 21 plus 60 plus 255 plus 176 plus 324 plus 224. Okay, then you need to check, did I make any mistake? I hope I got all the entries correctly, and if you are certain of that, you are going to get your answer. In this particular case, this is 1060. So here I'm going to have this to be summation fx is 1060. Okay, here I can just say I'm appending the summation for each of the entry. Okay, so summation fx over summation f will be nothing but 1060 over 50, and this will be 106 divided by 5. 106 divided by 5 will give us x bar, which is the mean, to be, let's say this, 106 divided by 5 is equal to 21.2. so this is 21.2. that's the score that is going to represent our mean score here. So for each of these entries, we are going to find x minus x bar. Okay, so for your calculator, you can just bring this in and say, let's say 7 minus 21.2. okay, yes, so this is equal to what? This is minus 14.2. so d here is minus 14.2, and then in the next case 12, you can just change the first entry. Here you want to say 12 minus 21.2. okay, this is minus 9.2. this is minus 9.2. okay, I'm also going to show us a symmetry. In the third case, we want to say 17 minus we want to say 17 minus 21.2. that's going to give you minus 4.2. so this is minus 4.2. now look at this, 14.2, 9.2, 4.2. again, you should have noticed that this is also a difference of 5. okay, it's a difference of 5. so between 14.2 and 9.2, there is 5 unit difference. Between 9.2 and 4.2, there is 9 unit difference. But if you just want to be on the safe side, you can continue inputting those values just manually. Okay, so in the next case, we have 22 minus 21.2, that is 0.8. this is 0.8. then here 27 minus 21.2 will be 5.8. you can just confirm that. okay, and here 32 minus 21.2 will be 10.8. all right, so good and wonderful. We need to now find the square of this difference. So actually you can say 14.2 or minus 14.2 raised to power 2, because when you are finding the square of a negative number, it will be a positive number. So you can just say it is minus 14.2 raised to power 2, and you can see that's a positive number. That's 201.64. so here we have 201.64. I will just carry out the other ones without putting the negative sign. 9.2 raised to power 2, that is 84.64. 4.2 raised to power 2, that is 17.64. okay, then 0.8 raised to power 2, that is 0.64, then 5.8 raised to power 2, 33.64, and then 10.8 raised to power 2, 10.8 raised to power 2 is going to be 116.64. So this is 116.64. Okay, but that's not all. We're actually going to be multiplying the frequency with this d that we just obtained, and that will be the final step. All right, we won't do anything more than that. So 3 times 201.64, 3 times 201.64. okay, just ensure you don't make mistake in trying to input your value. This is 604.92. so this is 604.92, and then in the next case 84.64 times the frequency for that is times 5, that's equal to 423.2, 423.2. okay, then next case 15 times 17.64, 15 times 17.64, 264.6. you just need to be careful that you don't miss any digits. And in the next case 8 times 0.64, 8 times 0.64, that's 5.12. okay, this is 0.20, 0.60, since all of them are carrying two decimal places. So in the next case here, we'll have 12 times 33.64, 12 times 33.64, that is 403.68, 403.68, and then finally 7 times 116.64, 7 times 116.64, okay, 816.48. so this is 816.48. okay, but then what we need for the variance is the summation of this fd square. So finally, on our not finally, but for this table anyway, for the summation of our fd square, we'll have it as 604 point, no, we'll have it as 604. Johnny Surude, I'm coming, please. We'll have it at 604.92 plus 423.20 plus 264.60 plus 5.12 plus 403.68 plus 816.48. just ensure you didn't make any mistake, and once you've confirmed that, you can find the value. And here I'm having it as 2518. so here the summation fd square is 2518, and then I can go ahead to carry out my variance to be summation fd square, which is 2518 over summation f. Summation f is 50. okay, so that I can evaluate to be 2518 divided by 50, and voila, 50.36 is the variance. So 50.36 is the variance for this particular question, for this particular frequency distribution that we're given to evaluate. So this is how you generally go about carrying out the steps to actually get your variance. You need the mean, you need the midpoint, okay, the mid score. Here we're having score, so you need the mid score, you need the frequency, you need the product of the frequency and the mid score, you need the deviation, which is the difference between the mid score and the mean. Then you need the square of that deviation and the product of the frequency and deviation square. Then you sum everything and divide by the sum of the frequency to get your variance. All right.
In this question on graphical solution to quadratic equation, we are asked to copy and complete the table of values below this one here for the equation y is equal to x squared minus 2x minus 3. And then using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 5 units on y-axis, we are to draw the graph of that quadratic equation. Then using the same scale and axis, we should draw the graph of y is equal to 1 minus 3x. So this is a linear equation as opposed to the quadratic equation that we are looking at before. Then from the graph, we should find the root of the equation x squared minus 2x minus 3 is equal to 1 minus 3x and the minimum value of y and the corresponding value of s. Good. This is quite cut out for us as our work to do. And what I would like to do first is, in the first case, we should copy and complete the table of values below for y is x squared minus 2x minus 3. So we are to complete this table, well noted. But looking at the question C, we are asked to also draw the graph of y is equal to 1 minus 3x. So we need a table for this in filling this particular table that they asked us to do. But we also need to generate the table for this equation. So I'm going to show you manually how to go about doing those stuff. If you are looking for a quick way to do that using your calculator, you can check our other videos on graphical solution to quadratic equation, trigonometry functions, in which you will directly use your calculator to just fill in the values for the y on the table. But here, let's do this manually so that you can also master how to do that. So here, I have the table, the template for the table that I want to use, and I'll be using blue ink for the quadratic equation y is equal to x squared minus 2x minus 3, and then this brown ink for the equation y is equal to 1 minus 3x. So what are we doing here? We are taking the entities for the quadratic equation x squared, we have x squared, minus 2x, and minus 3, and minus 3. So we will take all those values and then we are going to sum them to get the value for y. And we'll confirm with the values that we are given already. So like in the first case, when x is minus 2, x squared will be 4, okay? Then minus 2 times x will be minus 2 times minus 2. That will also be 4 because minus will multiply each other to be plus. Then 2 times 2 will be 4. Minus 3 is going to be a constant all through. So I can just append that as a constant all through. You can see it's not depending on the variable. It's just a constant that is minus 3 all like that. So I'm still coming to, okay, I can just even add this straight. 4 plus 4 is 8. 8 minus 3 is 5. So the value of y here is 5. When x is minus 1, x squared is 1 because that is minus 1 raised to power 2. The negative sign will multiply each other to be a positive sign, and 1 times 1 is 1. Minus 2x will be minus 2 times minus 1, and that will be 2, okay? Then x squared, when x is 0, x squared will be 0, minus 2x will also be 0, and you can see the constant minus 3. When we add all everything, it will be minus 3. Here, 1 plus 2 minus 3. 1 plus 2 is 3. 3 minus 3 is 0, okay? Then here, when x is 1, x squared will also be 1. Minus 2x will be minus 2 times 1, and that will be minus 2. So the sum of 1 minus 2 and minus 3 will be 1 minus 2 is minus 1. Minus 1 minus 3 is minus 4. So this is minus 4. When x is 2, x squared will be 4. Minus 2x will be minus 4. And then we have minus 3 as a constant. The addition of the 3. 4 minus 4 is 0. 0 minus 3 is minus 3. Okay. So you can see how this is going now. When x is 3, x squared will be 9. Minus 2x will be minus 6. 9 minus 6 is 3. 3 minus 3 is 0. And so that is a good test that all the values we have here are actually on point because we are also consistent with the minus 3 and 0 that were given originally. So we also need to evaluate for the case in which we are looking for y is equal to 1 minus 3x. So 1 is a constant, is not depending on x. We can just have that a constant all through. Okay. When x is minus 2, minus 3x will be minus 3 times minus 2. The negative sign will multiply each other to be positive. Then 3 times 2 will be 6. So this will be 6. When x is minus 1, minus 3x will be minus 3 times minus 1, and that will be 3. When x is 0, minus 3x will be 0. Any number multiplying 0 is 0. When x is 1, minus 3x will be minus 3. When x is 2, minus 3x will be minus 6. And when x is 3, minus 3x will be minus 9. So for us to find y for this particular linear equation, y is equal to 1 minus 3x. We just sum this value in brown. So 1 plus 6, that will be 7. 1 plus 3, that will be 4. 1 plus 0 is 1. 1 minus 3 is minus 2. 1 minus 6, this is minus 5. And 1 minus 9, this is minus 8. So these are the set of values that we are going to use to compute our graph as requested in the question, and that's what we are going to do right about now. So here we have our table of values, and we'll be given the scale that 2 centimeters should represent 1 unit on the x-axis and 2 centimeters to 5 units on the y-axis. For me, I'll be taking from here to here as 2 centimeters. Okay, so that will be what we'll be representing on the x-axis 1 unit. Okay, and on the y from here to here, that's my 2 centimeters, and it will be representing 5 units on the y-axis. So I just want you to take note of that so that we can be on the same page when I'll be constructing my diagram. Now for the values of x and y, we can see that from x we have minus 2 to 3. It's as if we are even having minus 3 to 3. So that should actually be centralized. And for the y, look at this, the highest value is 7, the lowest value is minus 8. We are also having it just as if it is centralized. So we can look at the center of the graph to take our origin from there. So that's what I'm going to do now. I'm going to say here I can just look for a means of centralizing the y-axis and the x-axis. So there and here, so I can say I have this to be my y-axis, that's the positive y, and here will be the positive x. Okay, now for my 2 centimeters to represent 1 unit, I'm going to have 0 at the origin. This is 2 centimeters, so this is 1 unit, another 2 centimeters, 2 units, another 2 centimeters, this is 3 units. Here I have minus 1, minus 2, and minus 3. Okay, then on the y-axis 2 centimeters to 5 units, so here this will be 5, and next I'm going to have 10, and here I will have this will be minus 5, and this will be minus 10. So that is a good representation of what I want to do. I can now go ahead to juxtapose those values, and I'm going to also be consistent with the ink. Blue will be for the quadratic equation and brown will be for the linear equation. So for the quadratic equation, when x is minus 2, you can see this is minus 2 here, x is minus 2, so here y is 5, so y is 5 here. What I just need to note is the point of intersection of the two, so I can just trace that from 2, okay, and then from 5, this point of intersection here is going to be the point that is relating x minus 2 and y is 5. When x is minus 1, y is 0. So x is minus 1 here, but y is 0, so it is with the origin. So this point is a point of interest. When x is 0, y is minus 3. Now this is what we need to do. Look at the division of boxes I have here. I have 10 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can see that 10 divisions is corresponding to 5 units. Okay, because that's what we are told, 2 centimeters to 5 units, and 2 centimeters consists of 10 divisions. So what is going to correspond to what divisions is going to correspond to 1 unit? I can just cross multiply, and the division that will correspond to 1 unit I can see will be 10 over 5, and that will be 2. So 2 divisions like here, 1, 2, then this is 1, another 1, 2, this is 2, 1, 2, this is 3, 1, 2, this is 4. So I have minus 1, minus 2, minus 3, minus 4, like this. So I did that for us to just be on the same page. So now the next value we have, when x is 0, y is minus 3. So x is 0, y is minus 3, minus 1, minus 2, and minus 3 here. So this point is a point of interest that we are looking for. Okay, when x is 1 here, y is -4. -4 is just going to be here just before 5, so x is 1 and y is -4 here. Okay, and then when x is 2, y is -3. Again, we are going back to -3 here. X is 2, y is -3. Okay, and then when x is 3, y is 0. X is 3 and y is 0. So just this particular final point on our graph, that is what that is going to look like. So I can just note the inclination. This is coming from here to 1, and then this is 3 to 0 and 3 to 2. So those are the values that we needed for this particular quadratic graph, and we can now go ahead and just join those points together. You can see that is already looking like a curve. You can just make use of your French curve to get all of these together, and I'm going to also try my very best to ensure that I link them together as appropriate. So let's see how that will go. So for the other linear graph, when x is -2, y is 7. So this is -2, 5, we have 6, we have 7 here. Okay, so I can just note that as being here. Then when x is -1 here, y is 4. 4 is just 2 boxes before 5, so this is 4. When x is 0, y is 1. X is 0 here, y is 1, is just here. Okay, and when x is 1, y is -2. When x is 1 here, y is -2. This is -2. I will say marked just before here. When x is 2, y is -5. This is 2 and this is -5. And when x is 3, y is -8. 3 minus 8, this is -5, -6, -7, and -8 here. Okay, so what you just need to do is to join them with a straight line, and I think that is good. But then our quadratic graph is not extending to the point that it needs to extend to, so we still need to actually take it further. I like the fact that this is appearing like this, so you know that you still need to finish up your curve to continue beyond the value that you are giving. And what I will normally do, what I will recommend students to do is that when x is -3, what is the value for y? So for the quadratic graph, we have y is equal to s squared minus 2x minus 3. So when you want to just look for some other value, like when x is -3, so that we can actually find the point of intersection with this linear graph, what will be the value for y? Y will be -3 raised to power 2 minus 2 times -3, then -3. -3 raised to power 2 is 9, then -2 times -3 is +6, then we have -3. So 9 plus 6 minus 3 is 9 plus 6 is 15. 15 minus 3 is 12. So what we have on the graph will be that when x is -3, y is 12. So 12 is just going to be here, that is 11, and here, that is 12. So this point is what we are looking at, and we can just extend this particular curve to that point, and that will be a better means of getting that value rather than just drawing the line as if it's a straight line. Okay, so if you are to do that, we just have something like this. And I think that is quite interesting. Okay, and I think that is just fitting in with the previous curve that we have. So now you can see that we have 2 points of intersection that can help us to solve for the question that we're asked, that we should find the solution when the quadratic equation is equal to the linear equation. So as a rule of thumb, it is good that you should always label your graph. So here, this is the graph for y is equal to 1 minus 3x. That's the one in brown. And for the one in blue, it is y is equal to s squared minus 2x minus 3. Now, furthermore, we have to find the roots of the equation that is given as what I'm going to write right now, the equation x squared minus 2x minus 3 is equal to 1 minus 3x. Now, if you look at this particular graph, you can see that this is just a statement of where the two graphs, where they are equal, and that is why they are saying the quadratic graph is equal to the linear graph. So that is the point in which we have the two graphs crossing each other. Here, this is the first one, and here, this is the second one. Okay, and what for us to just get that, what we need to do is to trace down to the x-axis, and we'll find that particular value. So in the first case, we just need to look at this red and trace down, just straight down to the x-axis. And in the second case, we also need to take this and move it to the x-axis. So the point of interest, that is the root of the equation, is this point and this point. And if you look critically, we are having the whole of this to be a unit. So if this is minus 2 and this is minus 3, we have a gradation of 0.1. So minus 2.1, minus 2.2, minus 2.3, minus 2.4, minus 2.5, minus 2.6. So this is, they are minus 2.6, and on this other side we have 1, 1.1, 1.2, 1.3, 1.4, 1.5, and 1.6 and 1.6. So those are the roots of the equation that we can get for the expression x squared minus 2x minus 3 is equal to 1 minus 3x. Okay, then finally we are also asked to find the minimum value of y, so, and the corresponding value for x. So minimum value for y, minimum value of y, I think for the quadratic equation, for x squared minus 2x minus 3 is, look at this curve. You can see that this is the least value and is corresponding to minus 4. In short, from the table, if you consider this, you can see that it is when x is 1 that y is minus 4 for the particular quadratic equation, and that means that minimum value of y is minus 4, and the corresponding value of x, and the corresponding value of x is just obtained as 1. Okay,
Here in this question, we are to measure the marked angle. So you can see this line and this line inclined to one another with this angle theta. And for us to measure the marked angle, we just need to bring in a protractor, which is just as shown here. And then we put the origin, the 0 point of the protractor at the point of intersection of the two lines. And then we can go to the edge of the protractor and read off the angle measured. So from here, this is 0, 0 here on this baseline. Then we can move counterclockwise. This is 10, 20, 30. And we can see that 40 is exactly on that particular line that we're trying to measure. So with that, we can just say the measured angle that we have here is nothing but 40 degrees. And with that, our full mark is assured in that particular case. So here, in this second question, we have to work out root 5 times 6 square. 6 square is 36, so we have it as 36 root 5. But we have to give our answer correct to 2 decimal places, so we can use our calculator for that. So we have 36 root 5, and what's that going to give us? This is 80.4984. This is 80.4984. But for us to put it correct to 2 decimal place, that means that after the decimal mark, we need to look at 2 digits. So we have these 2 digits that we are considering. But for us to conclude, we need to look at the digit immediately after that, which is 8. Then what do we do to 8? We need to round it up to 1 and add to the previous number. So I can say this is just 49. If I add 1 to it, that would be 50. So what is going to be my answer will be 80.50 as a reason of rounding up 8 to 1 and add it to 49. So we have it as 80.50 as the answer, correct to 2 decimal places. Now, in this third question, we are being told here that a journey starts at 21:15 one day and ends at 04:33 the next day. We are to calculate the time taken in hours and minutes. So if we are looking at the start of the journey and we are looking at the end of the journey also, we are being notified here that it's starting at 21:15 and ending at 4:33. So we have a particular time in which we are going to arrive at 24 hours, or let's say we cross over to the next day. So this is 21:15 and this here is 0 hours, and then this is 4:33. For us to get the time taken in hours, it will have to be the time between 21:15 and 0 hours, which is like a combination of 24 hours, and then from that 0 hour to 4:33. From that 0 to 4:33 is just 4 hours 33 minutes. But here, for 21:15 to this 0 hour is as if we are having 24 hour minus that 21:15. But noticing that for this particular minute, we are working in base 60, okay, and then this we are working in hours. Now 0, we cannot just say 0 minus 15, so we need to take one from here, but that one that we are taking will amount to 60. So 60 minus 15, that will be 45, and then this will remain 3 minus 1, that will be 2. So this is this first phase of the journey. If I call this just x, so this is x, all right, but then we still have this, let me call this y, okay. That other time y will now be from 0 to 4:33, so that will amount to 4:33. If we need to add again, this particular case we are adding them, we are still working in base 60 for the minute. So here we have 45 plus 33, 45 plus 33, that's going to give us 78, but our base value is 60, so we can say we subtract 60 from that 78. So this we have 18 minutes, but because we have scaled beyond 60, that means coming here we have additional 1 to add to the hours. So 2 plus 4 is 6, plus that 1, that will be 7. So inherently what we are having is that the time taken for the journey in hours and minutes is 7 hours 18 minutes for this particular journey, okay. And now in this other question, we are told that we are to find the total surface area of this particular cuboid. So if you take this as the length, this as the breadth, and this as the height, the total surface area in such a case like this is giving us 2 multiplied by the product of the length and the breadth, LB, plus the product of the breadth and the height, BH, plus the product of the height and the length, HL. This is coming into place because we have 2 sides always facing each other. So this side here will be facing its other side there, then this side here will be facing this side, then this top will also be facing the bottom. So it's the total surface area, the addition of all those areas, and then we're having 2 of each. That's why we have it like this. So if you want to just put that into, say you want to use it to calculate this, in this case we have 2 into length times breadth will be 7 times 4, plus the breadth times height will be 4 times 5, then plus the height multiplied by the length will be 5 multiplied by 7. Okay, so this we can nearly say is 2 multiplied by 7 times 4 is 28, 4 times 5 is 20, 5 times 7, that is 35. Okay, so we are having this as 2 multiplied by the addition of all this, 28 plus 20 plus 35. Okay, so this is 83, and 2 times 83 will be 166. So 166 centimeters square is the total surface area of this particular cuboid in this case. For this question, our mandate is to write down the gradient of the line y is equal to 5x plus 7. And if you recollect the general form of a straight line equation, it is y is equal to mx plus c, okay? And m is the gradient, where c is the intercept on the y-axis. If you are to compare, you can see that that gradient m is nothing but 5. So 5 is what we are being asked to just write down. Now we are to find the coordinate of the point where the line y is equal to 5x plus 7 crosses the y-axis. So if we are looking at our graph somewhere like this, a straight line like this, then the point where the line y is equal to 5x plus 7 crosses the y-axis will be this particular point, the intercept on the y-axis. And at that point, what we need to note is that the value of x is equal to 0. So if we are to use that here, we can say that y is equal to 5 multiplied by 0 plus 7. Of course, that will be 0 plus 7, and that will be 7. So that coordinate will be x is 0 and y is 7. Okay, so you can go and look at this question on construction. Here in this question, we're told that using a ruler and compasses only, we are to construct this triangle that is drawn. Okay, we are to leave in your construction axe, and then the side of length 12 centimeters has been drawn for you. So let's confirm if this side of 12 is truly 12. So we can bring in our ruler and just check from end to end. So that is 12, and that is good and fine. So let's now measure 9.5 centimeters here. We can come here to say this is the origin, and then we can scale to the 9.5 mark, and this is looking like a good fit. So you can go to the beginning of the 12 centimeter line and just align it. Then we can mark that arc that is 9.5 centimeters. Okay, and then after having done that, you can go back to measure the 8 centimeters from the other side. So you can move to 8. You can take that as a 8 centimeter mark. So we can move to the other end and then place the compass in such a way that we can now use it to cross that other arc that was coming. And this is as good as it gets on our construction. Having done this, what is left is now for us to bring in the ruler and join from the end in such a way that we can complete our triangle, something like this, and then we can bring in our line to just draw from that origin to the intersection of that arc, and then again we'll do the same on the other side. So we can just join on those points as requested. Okay, and I think with this we would have been able to answer this question just as is expected of us in constructing this diagram using a ruler and compass only. Okay, so we can move on to our next question. Okay, so here we are being told that for this particular question we have to write down the inequality in terms of n shown by this particular number line. First, we have to know that this is an empty circle, so what we're going to have is greater than because it's moving in this direction. Okay, so I didn't mean that we have a shaded circle and it's moving in this direction. We could have had greater than or equal to, because that shaded, we are among that we have or equal to assigned to it. But for this particular case, in which it is just moving to the right hand side, you can see it is positive values greater than minus 1. So we have 0 which is greater than minus 1, 1 which is greater than minus 1, and it is an empty circle. So we all need to say n is greater than minus 1 is the inequality for this number line that is shown. All right. Here in this question, we are told that on the grid, we are to draw the image of the triangle A after a reflection in the y-axis. So how do we get this? Let's look at the y-axis. This is the y-axis, this straight one. I just want to depict it now. So here, that is the y-axis that is just shown in red. So you are to have a reflection in the y-axis. That means this y-axis is going to act as a mirror for this triangle A. And of course, for the mirror, one of the properties that we know is that the object distance and the image distance, they are normally equal. So like this vertex here, the distance that is occupying is 0.11. Reflecting about y will be that it will still be 1 and minus 1. So here is going to be that point. Okay, so we have 1 point here, and then here it is 3 and 5. So since it's reflecting in the y-axis, that 5 will still be maintained, but 3 will not become minus 3. So we are having this particular point minus 3 and this particular point 5. So we have this as this vertex. Okay, and then this other one, it is 4, 2. So we have minus 4, 2. So these are the points that we need to join together that will give us what we are looking at. So something like this, and then join to here, and then join to here. That is going to give us the image of triangle A reflected in the y-axis. Okay, now for this second one, we are to draw the image of triangle A after a translation by the vector minus 3, minus 4. Let me say green ink for that. let's say we have this as the triangle A, okay? So let's say this is that triangle A that I want to refer. I just want to use it to explain to you, okay? Now, if you are to translate it by this vector -3, -4, -3 on the x-axis means that it will move 3 points on the x-axis. So we have 1, okay, 2, okay, and 3. That is -3 on the x-axis. Then -4 on the y-axis, we have 1 from 5 to 4, from 4 to 3, that is 2, from 3 to 2, that is 3, from 2 to 1, that is 4. So this is the translation of that triangle here by the vector -3, -4. What are we having in this particular case? What we are having is that inherently we are moving it via this step 1, 2, 3 on the x, which is the implication of this -3, and then 1, 2, 3, 4 on the y, which is the implication of this -4. I just did it like that so that students, you can have a feel of what we are doing here and it will not be ambiguous to you. So this shown in green is the translation by the vector -3, -4. Let me just now put it appropriately in blue so that you can see. So I can just denote it to say this is what we are having as appropriate, okay? So that is a good means for you to get what you are expected to get, and that is the triangle that we are expected to get, okay? Now, in this third case, we are asked to describe fully the single transformation that maps triangle A onto triangle B. No problem, we can just go ahead to say we want to try and map this triangle A to this triangle B, and just follow along. This is what I want to do. From the vertex of A, I'll just draw a straight line to that similar vertex on B, okay? And then this, I will also draw a straight line to that similar vertex on B, okay? And then the third vertex, I will also draw with a straight line to that similar vertex on B. And then we can look at what we can get in this particular case. Now, looking at this diagram, we can see that those vertex, they are actually meeting here at point 9, -1. You see x is 9, y is -1. That is the point of intersection. But let's look at the scale of this A to B, because B is looking like a smaller version of A. All right. So for the width of A, let's just take width and the height. We are having 1, 2, 3 for the width of A. Look at B. We have 1, and this is just 1.5. So that's giving us like something like 0.5. But let's look at this other height. So we have 1, 2, 3, 4 for A. What about B? We have 1, 2. So definitely 0.5 as a scalar factor is correct. So what we are having with what we have done so far is that how we can define the transformation that maps A to B is nothing but a linear magnification with a scale factor of 0.5 and the origin located at point 9, -1. Once we've been able to state this, we are good to go and our full mark is assured in this particular question, okay? So here we are to factorize completely 12a raised to power 3 minus 21a. First, we can see that we have a in the two terms, so we can bring a out. 12 and 21, what is the common factor that we can get from there? I think it is 3, so that if you are taking 3a out of 12a3, we have 4a raised to power 2. And if we are taking 3a out of 21a, that means we are having 7 remaining, so that 3a times 4a squared, 3 times 4 is 12, a raised to power 1 times a raised to power 2 is a raised to power 3. Then 3 times 7 is 21, then a, it can reflect. So here, the complete factorization will give us 3a into 4a squared minus 7 as a solution in this case. For this question, why would that the nth term of a sequence is n raised to power 2 plus 7, we have to find the first 3 terms of this sequence. So when n is 1, which is warranting that we're talking about the first term, what we have is that n squared plus 7 will be 1 raised to power 2 plus 7, and that will be 1 plus 7, which is 8. So our first term is 8. So when n is equal to 2, what we're going to have is 2 raised to power 2 plus 7, and 2 raised to power 2 itself is 4. 4 plus 7, that's equal to 11. So we have our second term here to be 11. And when n is equal to 3, what we're having is 3 raised to power 2 plus 7, and that will be 9 plus 7. 9 plus 7 is nothing but 16. So what we have as our answer is 8, 11, and 16 as the solution to this particular question. Now, for this question, we are told that these are the first 4 terms of a different sequence. So, since it's a different sequence, we are going to have a common difference. And that common difference, we can say the common difference D is going to be the difference between the consecutive times. So, here it will be 7 minus 15, and 7 minus 15 is minus 8. Or we can say it can also be minus 1 minus 7, or even minus 9 minus minus 1. So, it's still going to give us, like in the case, minus 1 minus 7, that is still minus 8. So it is consistent all through. Now we are asked to find the nth term of the sequence. That nth term, Tn, is given as a plus n minus 1d. Okay? And the common difference we have found to be minus 8. A is the first term, which in this case is nothing but 15, so that we can say our nth term is going to be a, which is 15, plus n minus 1. We are actually going to find it in terms of n, since we are looking for the nth term, okay, multiplied by d. The d is minus 8. So if we are to open that bracket, we are having Tn is 15, n multiplied by minus 8 will be minus 8n, minus 1 multiplied by minus 8 will be plus 8. So this will be 15 plus 8 is 23, then we have minus 18. So that's going to be our final answer. And you can always verify, for example, when n is 3, this is the first one, second one, and third one, we are going to say minus 8 multiplied by 3, that is minus 24. 23 minus 24 is minus 1. So we are definitely on the right track. So this is our solution to this question. Okay? Here we have the statement that as the temperature increases, people eat more ice cream. What type of correlation does this statement describe? What we notice is that there is an increase in temperature, and there is also an increase in the consumption of ice cream by people. So since it is increase to increase, definitely this is nothing but a positive correlation. So increase in temperature, people buy more ice cream to cool off, and that type of correlation is a positive correlation. Okay? And then we can look at this question in which we are told that Sanjay invests $700 in an account paying simple interest at a rate of 2.5% per year. We have to calculate the value of his investment at the end of 6 years. Okay? For us to get the value of his investment, first we need to look at the simple interest, which is given as principal times rate times time over 100. Now, the principal here was the original amount that he invested, which is $700. So we have $700 multiplied by the rate we are given as 2.5, and then the time period is 6 years over 100. So we can have these zeros cutting out. So our calculator will tell us 7 times 2.5, not 25, 2.5 times 6. What's that going to give us? 105. So simple interest that he had is $105, but that's not going to be the value of his investment. That value that we are looking at is going to be that principal plus that simple interest. So that's going to be, the principal is $700 plus the simple interest, it just got to be $105. The addition of these two is nothing but $805. So $805 is what is going to be the value of his investment at the end of 6 years. Okay? And then for this particular question, we have Mira investing $700 in an account paying compound interest at a rate of R% per year. Now, at the end of 17 years, the value of our investment is $1,030.35. We have to find the value of R. So this is a classical case of compound interest in which the amount at the end of the specified period will be the principal multiplied by 1 plus the rate over 100 to the power of n, where P is the principal, the original investment, which is 700 here. R is the rate that we are looking for. N is the number of years, which is 17 years. The amount that it got later is 1,030.35, which is A. So me, I just like to make the unknown sort of the formula in this case. So I can say, yeah, if I divide by P, then what I'm going to have is something like 1 plus R over 100 to the power of N is equal to A over P. And for me to knock out the power of N, I can multiply by 1 over N. This I can also say raised to the power 1 over N, so that this will cut out, and then I can have 1 plus R over 100 is going to give me the nth root of a over p. Okay, but r is what I'm trying to make this the formula. So r over 100 can be subtracting 1 from both sides, the nth root of a over p minus 1. Okay, so that r itself from here, r itself can be 100 multiplied by the nth root of a over p minus 1. Okay, so this is what I need to put into my calculator now. Let me write that n. So I want to write it clearly that this is the nth root of a over p minus 1, then all multiplied by 100. So if I want to bring in all those parameters, I have 100, then the nth root, that will be the 17th root of a. What's the amount? That is 1030.35 over the principal, that is 700 minus 1. So this is what I need to put into the calculator. Okay, so I have 100, then I want to open the bracket, find the nth root, which is just on top of this x to the power. So I have shift this, then that is 17. Then I can come into my root. I have a fraction there. The amount is 1030.35. The denominator is 700. Okay, then I can go out of the fraction, then I can go out of the root. I want to say minus 1, then I can close that bracket. And very good practice to check if you didn't make any mistake. You can say this is equal to what? 2.3. Okay, 2.3 will be sufficient for us. So this is 2.3, and then we can say r is nothing but 2.3. You can choose to work all this out, but I just love making the unknown the formula, and then I just plug in the values, find the answer with the aid of the calculator, and it is done and dusted. Okay, here we have this question on simple indices in which you have h raised to the power 2 times h raised to the power 5. To solve this, you can just take one of the h's and add the power of the 2 since they are multiplying. So this will be nothing but h to the power of 7 as our final answer. In this particular case, we have this expression to simplify. And if you have 7 over x to the power of minus 3, this is inherently saying we have 1 over 7 divided by x to the power of 3, okay? And 1 divided by any number will mean that 1 multiplied by the reverse of that fraction. So here, this will be nothing but x over 7 to the power of 3. So we can separate to say, we want to say x to the power of 3 over 7 to the power of 3. So we see how as x to the power of 3. What is 7 to the power of 3? 7 to the power of 3 is 343. This is over 343. And I think this is as far as we can go, and that can be our answer in this particular case. Okay, so here we are looking at this question in which we have a to the power of 8 divided by a to the power of p is equal to a to the power of 2. Now, also using the law of indices, we can just take 1a, then since it is division, we have 8 minus p. Division will translate to subtraction when we have collapsed the base. So we have a raised to the power 2. Since the bases are equal, then the powers must be equal. We have 8 minus p is equal to 2. Or if you arrange, p will be 8 minus 2, and that will be nothing but 6. So here, p is 6 as the answer to this particular question. Okay, so here we have a circle, and we have to find the circumference of the circle given that the radius is 4.7 centimeters. We know that the formula for the circumference of a circle is 2 pi r. So here it will be 2 multiplied by 4.7 multiplied by pi. So if you want to use our calculator, we have 2 times 4.7 pi. So that's what? 29.5309. That's 29.5309. But we have been told to just leave our answers to 3 significant figures. So I say it's just 29.5 centimeter as the circumference of this circle with radius 4.7 centimeters. Okay, so here, without using a calculator, we have to work out 2 whole number 1 over 3 times 11 over 14. We have to show our workings and give the answer as a mixed number. in the simplest one. So this will give us 2 whole number 1 over 3 times 11 over 14. And if we want to solve this, this is just the same as 2 times 3, 6. 6 plus 1 is 7. 7 over 3 multiplied by 11 over 14. So we can cut 7 can go in 14 too. So we have it as 11 divided by 3 multiplied by 2. This is 6. If you have 11 over 6 and want to simplify this, we know that 6 can go in 11 in one place. 6 times 1 is 6. 11 minus 6 is 5. So 5 over 6 will be the remaining fraction. So the simplest form we can express this is one whole number 5 over 6, and that is that for this question. For this question, we have this graph that is just given to us plain like this, and we are told that in the first case, A is a point, so A is minus 6, 5, and B is a point minus 2, 3, so B is minus 2, minus 3. We are to find the equation of a straight line L that passes through point A and point B. We are to give our answer in the form y is equal to mx plus c. Let me just show students, let me just show you this. If you are to take a straight line from A, we are to pass it through point B, just straight like that, you can see what this is giving us. Now this is a straight line that is actually passing through minus 7. So if you want to deduce, we can say we want to take maybe some appropriate triangle. Let me say at point B, we just want to do something like this. This is B, we move it to this, just to draw this particular triangle in which we can say we have some change in x here and we have some change in y here. The change in y will be how many units? 1, 2, 3, 4. So we have change in y to be 4. Change in x is what? 1, 2. That is interesting because we can look at this and say that from our observation of the graph, we have this slope to be now the slope is moving in the negative direction. From the left to the right is moving downwards, so that's going to be a negative slope, and it is the change in y which is 4 while the change in x which is 2, and that will be minus 2. Okay, and then the intercept on this y axis, you can see it is minus 7, so I can say c, which is the intercept, is minus 7. And I'm saying this because I have the concept and understanding that from y is equal to mx plus c. If we put in m to be minus 2, c to be minus 7, then this equation will be y is equal to minus 2x minus 7. That is what is going to be the equation of the line passing through points A and B. But that is very good. Let's go ahead and see if we can just solve this by making use of our normal calculation. Here, the concept of the slope can actually help us, in which you can say that slope can be the difference in y. So we have y minus y at point A over x minus x at point A is a constant value that can give us y at B minus y at A over x at B minus x at A. And if you are observant, you'll notice the consistency with which I'm working here. So if you are to solve this, I can say y minus, what is y at A? It is 5 over x minus, what is x at A? It is minus 6. So you don't write 6, you write minus 6. Okay, and then this is, what is y at B? That is minus 3. Y at A, that is 5 over what is x at B? That is minus 2. And x at A, that is minus 6. Again, you write minus 6 and not just 6. So that what we have here will be y minus 5 over x minus minus 6 will become x plus 6 because the negative signs will multiply to give us a positive value. Then this is going to be minus 3 minus 5, that will be minus 8. Minus 2 minus minus 6 will become minus 2 plus 6, and that will be 4. So we have minus 8 over 4, which they can cut so that we have this to be minus 2 over 1. And if we cross multiply, we can say it is giving us y minus 5 is equal to minus 2 into x plus 6. Opening up this bracket to give us y minus 5 is equal to minus 2x. Minus 2 times 6 will be minus 12. So if you rearrange, it will be that y is equal to minus 2x minus 12 plus 5. So this is going to give us nothing but y is minus 2x minus 12 plus 5 is minus 7. So just like we got initially that y is minus 2x minus 7, again we are arriving at this point to say y is nothing but minus 2x minus 7, and that is the solution to this question. Okay, then moving forward, we are seeing here that we are to find the equation of the line that is perpendicular to this line L and it passes through the origin. So we have the origin 0, 0, but then we are told that it is perpendicular to L. Let me go and show you something again on the graph. We know that for the perpendicularity of two lines, the product of their gradient m1 and m2 is going to be minus 1. So if you are taking this as m1, we can say m1 is already minus 2. Okay, so in that case, m2 is going to be minus 1 over m1. So that m2 is going to be minus 1 over minus 2, and that is going to be 1 over 2. So I can see that the second gradient is 0.5, which is 1 over 2. Okay, and then we are told that it's also passing through the origin, which is 0, 0. That means inherently, if I want to scope that, I can look for 1 over 2 is telling me that the change in y over change in x is in this ratio. For a singular change in y, I'm going to have 2 changes in x. So if I want to reflect that, okay, let me say I even want to consider here 2 unit change in x will be from 2 to 0 here. Okay, so we have here, that is 2 changes in x. Corresponding to 1 change in y will be just here. So this point will be a very good point for us to consider. And then also that it's passing through the origin. So I can pick here and say I want to just pass through the origin just like that. So this is going to be as shown for the line perpendicular to this particular line passing through A and B. Okay, and once we have it like this already, we can also say we want to find the equation just as postulated. But let's go ahead and just solve it on our question paper. That yes, we know that the slope, the m2 will be minus 1 over m1, and that will be minus 1 over minus 2, since this m1 is minus 2, so this is 1 over 2. Then that concept of our change in y over change in x, which is still valid, is going to say that y minus y1 over x minus x1 is equal to the slope. That slope is m, it is equal to 1 over 2. So y1 is 0, x1 is 0, so we can say that means y minus 0 over x minus 0 is 1 over 2, such that y over x is equal to 1 over 2, or we can say y is equal to 0.5x. And you can see, if you compare this to y is equal to mx plus c, if you say this is plus c, you can say it's plus 0 because c is not reflecting, it is 0. So it is consistent that when x is 0, y is 0. So this equation is going to be the equation of the line perpendicular to this other line that we drew and also pass through the origin. Diagram shows a rectangle OPQR with length 11 cm and width 4 cm. OQ is a diagonal and OPX is a sector of a circle with center O. We are to calculate the percentage of the rectangle that is shaded. For us to get that percentage of the rectangle that is shaded, we need to first get the area of that shaded portion. Okay, and if we want to get the area of that shaded portion, here we can see that is the area of the rectangle, the big rectangle, minus the area of the sector of the circle OPX. So that's the area of the shaded region. Now in this case, area of the rectangle is nothing but length times breadth, and that length is 11 cm, that breadth is 4, so this is 11 times 4, which is nothing but 44 centimeters square. Okay, then for us to find the area of the sector from this particular diagram, is going to be theta over 360 multiplied by pi r square. So let's define our parameters. This we have to be the theta. Okay, so this is angle theta, and then we're also furthermore talking about the radius. That's going to be the distance from the center of the circle to any point on the circumference. So OP or OX, and here we have RQ as 4. So this is also 4 centimeters. So this 4 is also this particular OS. So we have R as 4 centimeters. But then for us to get theta, for theta we can see that this point, this line PQ, which is 11 centimeter, is one facing theta, so that is opposite to theta, and then 4 centimeter is adjacent to it. So we can say we want to use SOHCAHTOA. SOHCAHTOA can help us to say we have the opposite to be 11 centimeters, and then we have the adjacent to be 4 centimeters. What is relating opposite and adjacent? It is tan. So we can say tan theta is equal to opposite, which is 11 over 4, such that by the time we are solving this, we can say theta itself is arctan 11 over 4, okay? Arctan the whole of that, and we want to bring in our calculator. We can have it that we want to do arctan in fraction, 11 as the numerator, 4 as the denominator, and then what's that going to give us? 70.01. Okay, we can just say 70. So this is 70 degrees. And then, that being the case, we cannot, of course, we found R to say R is 4 centimeters. So we can find the area of the sector of that particular circle to be theta, which is 70 over 360, multiplied by pi, multiplied by R square will be 4 raised to the power 2. So we can find this to say this is nothing but, let's use our calculator now. We have 70 divided by 360 multiplied by pi, then multiply by 4 square. Okay, so this is 9.77 centimeters square, such that the area of the shaded portion will now be the area of the rectangle, which is 44, minus the area of the sector, which is 9.77. So that's going to give us what? 44 minus this answer, that's 34.23. This 34.23 centimeters square. But we are not asked that area, only as the percentage that is shaded. So that percentage shaded will be that portion of the shaded region, 34.23, over the total area of that particular rectangle over 44 multiplied by 100%. So this is what we need to put into our calculator to say we have 34.23 divided by 44 times 100. What's that going to give us? 77.79. Okay, so this is 77.79 percentage. But to put it in 3 significant figures, that will be 77.8 percentage. That is going to give us the answer to this question. Okay. Yeah, well, I told that Mrs. Coley buys a jacket, 2 shirts, and a hat. The jacket costs X dollars. The shirts each cost $24 less than the jacket, and the hat costs $16 less than the jacket. Okay. Now, Mrs. Coley spent exactly $100. We have to write down an equation in terms of X and solve the equation to find the cost of the jacket. Okay, so if you are saying that the cost of the jacket cost is actually X dollars. Now we are told that the shirt, each of the shirt costs $24 less than the jacket. $24 less than the jacket will mean X minus 24. But then we are talking about 2 shirts. So the shirt will amount to 2 multiplied by X minus 24. And then the hat, that's the third entity. What about the hat? We are told that the hat costs $16 less than the jacket. So that will be X minus 16. Okay. So now from what we are told that Mrs. Coley spent exactly $100. So the addition of these 3 will amount to 100, so that we can have X plus 2 into X minus 24 plus X minus 16. The addition of everything is going to give us 100. So we have to write down an equation in terms of X. That is it. Or we can say we want to simplify for that to say this will be X plus 2X, then plus this X again, then minus 2 times 24 is 48, then minus 16 is equal to 100, so that X2 and X will give us 4X minus 48 and 16 with 14, that's minus 64, is equal to 100. And then we can have 4X to be 100 plus 64, which is 164. And then if we divide both sides by 4, 4 can cut 4 in 16, this will be 4 1. Okay, so x itself will be nothing but $41. So $41 will amount to the cost of the jacket. Okay, in this question, we are told that y is inversely proportional to the square root of x plus 4. So if you want to express that, we can say y inversely proportional means it is 1 over, okay, square root of that square root. I can either write the square root like this. I can say it is to the power of half. So I want to use the power of half. So I can say it is x plus 4 square root. Okay. So if you want to introduce the constant of proportionality, you can say this is nothing but that y is equal to k over x plus 4 raised to the power 1 over 2. Now we are told that when x is 5, y is 2. So for x is 5, y is 2, we can have it that means 2 is equal to k over, what's the value for x? That is 5 plus 4 raised to the power 1 over 2. So this is 9. That means we're having 2 is equal to k over 4 plus 5 plus 4 is 9. So we have 9 raised to the power 1 over 2. That means that k is 2 multiplied by 3, because 9 raised to the power half is the square root of 9, which is 3. So k is 6. So this equation inherently means that what we have is y is equal to 6 over x plus 4 raised to the power 1 over 2. So now we have to find y when x is 77. So for x to be 77, that means y is going to be 6 over 77 plus 4 raised to the power 1 over 2. 77 plus 4 is nothing but 81. So we have 6 over 81 raised to the power half, which is 6 over 9. 81 raised to the power half is square root of 81, which is 9. So 3 can go here. 3 in 6 is 2, and 3 in 9, that is 3. So y will be 2 over 3 when x is 77. Okay? And then here, oh, very good. We have to solve this simultaneous equation, and we must show all our workings. Okay, so if I call this equation 1 and I call this equation 2, from that equation 1, I can say I have y to be 11 minus 3x, and if I'm to use this in equation 2, I'll just use this equation in 2. Then I'm going to have s squared minus 2 multiplied by y, which is 11 minus 3x, is equal to 18. So I just need to open up this and try and solve this to get my final answer. Okay, so in that case, I'm going to have s squared minus 2 times 11 is 22, minus 2 times minus 3x will become plus 6x. Okay, then when 18 goes to the other side, I have minus 18 is equal to 0, so that this will be s squared plus 6x minus 22 minus 18 will become minus 40 is equal to 0. Okay, so now to solve this by factorization method, I can say I'm looking for a product that is minus 40 s squared. Okay, and then I'm looking for a sum that is 6x. So what two number can I actually multiply together to give me minus 40s and add together to give me 6x? So since the sum is positive, then the larger number should be positive. Think 10x and minus 4x is going to give us, because 10x and minus 4x will be minus 40x squared, and 10x minus 4x is going to give us 6x. So here I can write and say s squared plus 10x minus 4x minus 40 is equal to 0, and then for the first two terms x is common, so I have x plus 10 remaining. For the last two terms, minus 4 is common, again x plus 10 is remaining. Now in this expression now, x plus 10 is common, so if I have x plus 10 here, then in the first term I have x remaining, in the second term I have minus 4 remaining, is equal to 0. So this will warrant that it's either x plus 10 is 0, or I have it that x minus 4 is 0, in which case here x will be minus 10, or I will have x to be 4. So that is first thing that we need to see and know. But then look at what we have initially. Y is 11 minus 3x. So when x is minus 10, y, which is 11 minus 3x, will now be 11 minus 3 times minus 10. So this will be 11 Minus 3 times minus 10 will become plus 30, and that will be 41. Okay, so we have the first point to be x is minus 10, y is 41, and then in the other case, when x is equal to 4, then y will be 11 minus 3 multiplied by 4. So that will be 11 minus 12, which is minus 1. So if you want to look at the solution in this particular case, when x is minus 10, what's the value for y? Y is 41. And when x is 4, what's the value for y? Y is minus 1. So this is the solution to this question, and just showing all our working, being consistent with what we need to do and able to solve it, and that is done with this question. In this question, the diagram shows an open rectangular box A, B, C, D, E, F, G, H, just as shown here. Now, AB is 18.6 centimeters, BC is 9 centimeters, and CG is 14.5 centimeters. Now, a straight stick AGM rests against A and G and extend outside the box to M as shown here. So our mandate is to calculate the angle between the stick, this stick, and the base of the box. So I just want to give you a pictorial view of what this is normally looking like. If you are to depict the base of the box in that brownish color, okay, first and foremost, that stick that is inclined in the box will be making an angle with the diagonal of the base of this particular rectangular box. Okay, so what we are looking for, the angle between the stick and the base of the box, you can say is given as theta. So this angle theta is what we are looking for, and for theta, this side, this is the opposite. So this side GC is the opposite to that theta that we are looking for. And for us to find the theta, then since we have this opposite, we need to get either the hypotenuse or the adjacent. Now, from the information that we are given, we have these sides of the base of the rectangle. We have this side AB as 18.6, we have BC as 9. If we can find this side X, which is AC, then that means that we have gotten two sides of the triangle AGC. We have the opposite, then we could have gotten the adjacent. Then we can use the trigonometry identity to find the value of theta. You can say that from triangle ABC, we are seeing that Pythagoras theorem is coming into play because x here is the hypotenuse of that triangle. So we can say s square is equal to 18.6 square plus 9 square as a result of Pythagoras theorem. Okay, so once we can postulate that, we can say that means that s square is equal to 18.6 raised to power 2 plus 9 raised to power 2. This is 426.96 such that x itself is going to be the square root of 426.96. and what's that going to give us? So root answer that we just got 20.663. This is 20.663 centimeters. So that is that. But then we can say that from the triangle now ACG, Sokatua can help us to actually get this, that we have theta, we know the opposite, we have the adjacent as x, so we can say tan theta, which is the one relating opposite to the adjacent, equals to the opposite, which is GC, over this adjacent, which is AC. So that GC is 14.5, that AC is what we just got as 20.663. So once we have that, we can input into our equation to say theta itself is going to be arctan 14.5 over 20.663. So this is what we need to use our calculator to try and evaluate arctan 14.5. We are dividing it by 20.663. Okay, we want to close the bigger brackets. Okay, so this is 35.05, 35.058, 877 But then we have been told that for angles we should round up to 1 decimal place. So this will be 35.1 degrees as the value of theta in this question. Okay, now we are given that AM is 30 centimeters. We are to show that GM is 4.8 centimeter correct to 1 decimal place. So let's look at the diagram. AM is 30. So here AM is 30. Okay, then we are to show that GM, this GM, the shorter exterior here, this exterior, this is the GM. We are to show that it is equal to 4.8 centimeters correct to 1 decimal place. From here, what can we see? We can see that normally AM, the whole of that length, is AG plus GM. So I can say that AM from here is actually AG plus GM. So since you are being asked to show that GM is 4.8, we just need to say that means GM is nothing but this GM is AM, which is the whole length that we are giving, minus AG, and that AG is nothing but the hypotenuse in this particular case. So we have the opposite as 14.5. We have the base here, which is the adjacent, as x. Definitely we can find the hypotenuse either by making use of Pythagoras theorem, or want to say that we want to make use of trigonometry identity, SOHCAHTOA, anyone. Then if you can get that GM to the value by subtracting AG from AM to be 4.8, then our work is done and dusted, and we have proved what we are asked to do. Okay, so let me just clear this to say I want to go forth to look at that triangle and recollect. I'm just seeing this triangle here, something like this. So if I call that side AG, and you know it's still extending to another point M here, so we have this as C. We have gotten this to be X. This is the theta that we just got, and here this is 14.5. okay, X we got to be 20.663. okay, so we want to prove that GM is equal to 4.8 centimeters, but we are saying that GM itself from this diagram is equal to AM, which is 30, minus AG. That AG, let's still have it as AG. So let's find the value of AG from here, and of course maybe we want to use trigonometry identity, or want to use Pythagoras theorem. Okay, here we can just say AG, which is y, okay, y square is equal to 14.5 square plus 20.663 square. Okay, so what's our value for that? 14.5 square plus 20.663 square, 637.21. this is 637.21. so y itself, which is AG, is going to be the square root of 637.21. and what's that going to give us? So square root of the answer, 25.24. this is 25.24. okay, so in that case you can just say our GM from where we are coming from will be 30, which is AM, minus this AG, which is 25.24. so what's that going to give us? We have 30 minus 25.24. so this is 4.76. this is 4.76, and of course 4.76 is approximately equal to 4.8 centimeters. So we can see that we have been able to prove that GM from our calculation is 4.8 centimeter as requested from this question, and with that our question is done and dusted on this particular solution. Okay, for this question we're told that the diagram shows a trapezium OPQR. O is the origin and OR is equal to A, then OP is equal to B. Now RQ is equal to 3 over 5 of OP. So if you want to denote that, we can say this is 3 over 5 of OP. OP is B, so you can say this is 3 over 5B. Then we have to find PQ in terms of A and B in its simplest form. Okay, PQ is our mandate. PQ from here to here, that is our mandate that we need to find. Now what we need to understand to solve this question is that PQ that we may be looking at is nothing but OQ minus OP. So let's look at that. So this is PQ. It will be OQ minus OP. It is the position vector of Q, which is OP, minus the position vector of P, which is OP. That is PQ. All right. So now that we have that, do we have OQ initially? No, but we have OP. We have OP defined as B. But now we need to find OQ. And looking at this, you can see that OQ will be you moving from O to R, then moving from R to Q. So that means that what we are looking for, PQ, is nothing but first OR plus RQ, and if you observe and you look as if this R, we can collapse, so say this is OQ, okay? So just note that you can use that as a guide in solving this, then minus OP. I think now we have all the parameters that we need, so we can say that to solve for PQ for this particular question, what we are going to have is nothing but OR, which is A, then plus RQ, which is 3 over 5B, right? Then minus OP, which is B. And if we want to solve for this, we can see that this is nothing but A is still there. For this other one, we can say it is plus. We have 5 at the denominator, and then we have 3B minus 5B, so that 5B over 5 is 5, then 3 over 5 will be 3 over 5B. So this is nothing but A minus 2B over 5. So as requested of us for this particular question, PQ is A minus 2B over 5. All right. Now in this next question, and we are told that when PQ and OR are extended, the intercept at W, we have to find the position vector of W. Okay, so let's go ahead and extend PQ and OR. Hopefully this will be able to take it, or let me just duplicate it and take it down. Okay, so here is the replica of the diagram. We're told that when PQ and QR are extended, they intersect at W. So let's just do the extension OR. So we can start at O. We just want to extend in that line. Okay, then PQ, we just also want to extend that. This is their point of intersection. Let's call that W. Okay, we have to find the position vector of W. From this particular diagram, I can postulate readily that I can have something like this angle here and this angle here. You can see this line being parallel to this line. Render these two angles to be equal. So this angle and this angle, they are the same. Interestingly, I can also say that I'm having this angle and this angle here. They are also the same. Okay, the same way. They are corresponding angles. Look at them facing the same way. And then, as good and as easy as it gets, this particular angle at W, this angle at W is common to these two triangles that we are looking at, WRQ and WOP. So inherently, I can just say triangle WRQ is just similar to triangle WOP. And if that is the case, the ratio of their sides is also going to be equal. So if I call this point, if I call this Y, I can now say that means that Y over A plus Y, this Y for triangle WRQ, then A plus Y for triangle WOP is going to be a constant relating to 3 over 5B, this side for triangle WRQ, over B, which is the side for triangle WOP. Okay, that is actually a constant that I can relate with because these triangles, they are similar. And all I just need to do here now is just, let's say I want to cross multiply. Okay, and since they are constant, I'm also seeing that this B is going to cut out. Okay, so crossing multiplying, I'm just going to have that Y is equal to 3 over 5 into A plus Y. Okay, so that what I'm having is Y is equal to 3 over 5A plus 3 over 5Y. Y minus 3 over 5Y is going to give me 3 over 5A. And that means that Y minus 3 over 5Y is 2 over 5Y. That's going to give me 3 over 5a, meaning that y itself is going to be, this 5 is going to cut out, it's going to be 3 over 2a. But then the position vector of w is actually a plus y. So that position vector for w, OW, is going to be a plus 3 over 2a. And that is nothing but, this will be 2 over 2. That will be 5 over 2a as the position vector of w. So once you get that, then you can know that you are good to go. And just for the sake of explanation again, we are relating vectors and similarity of triangles here in such a way that we can actually find the proportionality between them. And for this particular case of w, we just bring in those similar triangles and we're able to find the position vector of w as nothing but 5 over 2a. I'm an advocate for sticking with instructions, and the very first set of it is that you have to write your name and your center number in the spaces that are provided, which I'm also complying with here. Okay, so once you do that, you will be on the way to getting your mark done and dusted. And then we have this instruction set. So looking at the instruction set that we have, you have to answer all of the questions, use blue or dark blue pen, then use pencil, HB pencil for diagrams, and so on and so forth. But for me, the highlight is particularly here. Okay, these three are actually okay for me. In the first case, show all your working clearly. Don't be ambiguous in any of your working. And then if you are going to be rounding up any number, so you round up to 3 significant figures, or if it is in degrees, you have to round up to 1 decimal place, unless another level of accuracy is specified in the question. So please, students, let's just take note of this. When we are working, we are going to be showing them and applying them as appropriate. And finally, if you are using pile, it's either I'll use our calculator value or we use 3.142. And with that, we should be able to be good and fine to say we want to launch forth into this particular question, noting that the total mark for this paper is 130, and then the mark for each question is shown in the bracket to the question. Now, you need to be quite observant of this, so that sometimes you just get to see some question, then maybe you are stuck, but perhaps it's just one mark, then you can just gloss over and go to other questions, so that you don't just get stuck on that particular question set. So with this preparation, I think we are prepared to go ahead and delve into this question. I hope you have gotten your paper, your pencil, your biro, and your calculator, because I want us to do this together. So let's go ahead and solve our questions for this exam paper together. Yeah, now first question, we are told that a company employed 300 workers when it started and now employs 852 workers. Our mandate is to calculate the percentage increase in the number of workers. For us to solve this, the percentage increase that we are asked to get, we can solve by making use of the change in the number of workers over the original number of workers multiplied by 100%. Okay, and in this case, that change is the difference between the total workers now, which is 152, minus the total workers that started initially, that is 300, over that original number of workers that started multiplied by 100%. Okay, so what we can have here is 852 minus 300, that is going to give us 552 over 300, and then multiply by 100%. Of course, these zeros we actually cut out, so we are having inherently 552 divided by 3. Then we can use our calculator to say we have 552 divided by 3. What's that going to give us? This is 184. So what we have as our answer is 184%. Okay, so yeah, of the 852 workers, we are looking at this question B. The ratio of part-time workers to full-time workers is 5:7. We have to find the number of full-time workers. So again, what we're having here is that we have a total of 852 workers, but we have a ratio of part-time workers to full-time workers is equal to 5:7. So if the ratio of these two sets is 5:7, we can say the total ratio is actually the sum of that 5 and 7. So that is 5 plus 7, which is 12. Okay, now for us to get the number of full-time workers, so full-time workers is going to be the fraction of the full-time worker, which is 7, because say part-time to full-time is 5:7. So full time is 7 over the total ratio, which is 12, multiplied by the total number of workers we are talking about, multiplied by 852. This is what we need to put into our calculator now to say we have 7 over 12 multiplied by 852. Okay, so that's 497. So this is 497 as the total number of full-time workers that we have in this company. All right. Now, for this question, we are told that the company makes 40,600 headphones in 1 year. We have to write this number in words. Okay, that's quite interesting. We just need to write 40,600 in the space provided, and I think that's a bonus mark. Okay, then we have to write this in standard form. So we have 40,600. Now, for us to write in standard form, we are going to move the decimal place. So it's as if we have this as 0.0, but then we're going to move the decimal place backward, and that will be 1, 2, 3, 4. So only 4 will be remaining, and we have moved it back 4 times. So we can say times 10 raised to power 4. So if we want to write it out in this form, we can say this is 4.06 times 10 raised to power 4 as the standard form of this particular value that we are given, 40,600. Yeah, for this question, we are told that in 1 month, the company sells 3,000 headphones, and of these, 48% are exported, 3/8 are sold to shops, and the rest are sold online. We have to calculate the number of headphones that are sold online. Okay, let's see if we can get a pictorial view of what we are talking about here, if it's going to help us get what we are expected to get in this particular case. Okay, so we are saying that we are looking at this total number of headphones. Initially, we are told that first 48%, so 48 should be somewhere here. So we have this as 48%. They are exported. Then 3/8. So we have the whole can be 8. So 3 division there. Maybe we are looking at something like this. So this is 3/8 are sold to shops. So this is export. This is shops. Then the rest are sold online. So this is the online sales. I can call that X. All right. We have to calculate the number of headphones that are sold online. So this whole is actually nothing but what? 3,000 headphones. Okay. Very good and very fine. So for us to get the number of headphones that are sold online, let's take this as a whole fraction, that this whole is just synonymous to, let's say, a 1 as a whole entity. But now for us to get X, we can see that 48%, let me peg it like this. We see that 48%, which is 48/100, plus 3/8 plus X, all of these, they add up to the unitary value of this sales, which I'm taking as 1. Okay, that one is actually 3,000. All right, so if that is the case, I can get an expression for X to say that my X in this particular case is going to be 1 minus the sum of 48/100 plus 3/8. Okay, so I can peg this as 1 minus 48/100. Maybe that will be 4 can go in both. That will be 12/25 plus, okay, when I'm opening the bracket, this will become minus 3/8. So X itself, I can take as a fraction in which to find this LCM, I can say I'm using 200. I can say this is just 200 minus 25 in 200 is 8. 8 times 12, that will be 96. Then minus 8 in 200 is 25. 25 times 3, that is 75. So this is what I need to punch into my calculator, that 200 minus 96 minus 75 is equal to 29. So this is 29/200 is a fraction that is equivalent to online sales. So that online sales is going to be 29/200 multiplied by the total sales we are talking about, which is 3,000. So we can just cut these two so that we have 29 times 30/2. So I'm having 29 times 30 divided by 2. What's that going to give me? That's 435. So 435 is what we are having as the number of headphones that are sold online. That will do it to just write that here, that 435 is what is going to be the number of headphones that are sold online. So here we are being told that 1 year the sales increased by 15%, the following year the sales increased by 18%. We have to calculate the overall percentage increase in sales. So if we said the original sales, if we peg that as, let's say, is Y. So in the first year, the 15% increment will amount to the fact that what we're having is, originally it is 100%. With the 15%, we need to add 15 to it over 100 of x. So this is nothing but 115 over 100 of x, which is nothing but 1.15x after the first year. Okay. Now, in the next year, we're having another 18% increment. So this is quite interesting now. The other 18% increment will mean that just like we do here, that means we're having 118 over 100, but that is going to be the increment on 1.15x. So we have it on 1.15x. All right. So if we want to do this, we can make use of our calculator to say 118 times 1.15 divided by 100. That's equal to what? 1357. Okay, that is 1.357x. And now we want to reverse engineer. That means we are saying that the percentage increment is actually equal to 1.357, means we are saying 100 plus 35.7 percentage increase in x. So it's as if we are having 100 over 100, which is the unity, plus 35.7 over 100 of x. So with this, we know that, of course, this is the whole entity. So the additional is the 35.7 over 100 of x, so that that increase that we are looking for is nothing but 35.7% increase. I hope this is quite simplified enough for you to understand, students, that is just that increment. Look at it, say overall percentage increase. Okay, so that increase is just going to be the multiplication of that 15% by 18%, but scaling it over 100, that will be 35.7, and this question would have been dusted and answered as requested. We had this question on graph in which you are told that the table shows some values for equation y is equal to x squared minus 1 over 3x defined in such a way that x is not equal to 0, because if x is 0, this will be undefined because we have 1 over 0. Okay, so x is not 0 at all. Then the y values are rounded to 1 decimal place. Okay, so from the instruction set that we had before, we are told that we can round up to 3 decimal places or 1 decimal place for degrees, but here we are being specifically told that we are to round up to 1 decimal place. So we just stick with this and not with what the instruction was saying initially. Our first mandate is to complete this particular table that we have been given. Now, this is what I love to do. I will just say I want to start fresh. This equation, y is x squared minus 1 over 3x. I will just say I want to do that. Alpha, which is written in egg, and close brackets, you can see we have x that is also written in red. If I press that, it will give me that x. So I can raise it to the power of 2 minus, now I have a fraction. 1 is the numerator and 3x, 3, again I want to write x, which is alpha, close bracket, is that 3x. So this is how I normally generate my table in this particular kind of case. So I can just say that for me to get the value, I can only calc. So it's prompting me asking for the value of x. Let me start with minus 1 that we have has been done already. So I have x is minus 1. What's that going to give me? So this is 4 over 3, and if I put it in decimal place, oh, this is interesting. This is 1.3333 because that bar on top of 3 shows that it's a repeated value. So it's 1.333. But like they said initially, it said it had been rounded to 1 decimal place, so they only wrote 1.3. Now, since I can see that my calculator is giving me the right value, I cannot solve for this. That let's calc from when x is minus 0.75. What's that going to give me? I want to write it in decimal. Okay, this is 1.0069444444. But again, we are looking for 1 decimal place, so that would just be 1.0. Then for the case in which x is minus 0.5, I want to calc to say minus 0.5 is the value for x, and we are press equal to, this is the value in decimal place. Okay, this will now be rounded up to 0.9 in one decimal place. So we have 1.0 and 0.9. So I can say here I have 1.0, and here I can say I have 0.9 as the values for y for the values of x that were given in the table. Okay, so now on the grid we have to draw the graph of y is equal to s squared minus 1 over 3s for minus 2 to minus 0.1, and the one for positive values of x has been drawn already. So if we look at that particular graph, okay, we are seeing that the one for positive values of x, the one to this right hand side, has been drawn already. We have to take the ones for this left hand side, and we are going to be using the table that we got there to actually compute our value. So let's look at this holistically and see how we can solve it. So we are going to be extrapolating these values. In the first case, when x is minus 2, you can see this is minus 2 here. Okay, y is 4.2. Now this is quite interesting. For this particular vertical axis, for example, from 3 to 4, we have 10 boxes, and of course we have from 3 to 4. So that means each one is taking 0.1 as the value. So in that case, we have 3.1, 3.2, 3.3, 3.4, 3.5 as the middle, 3.6, 3.7, 3.8, 3.9, and 4.0. So the 0.1 that is the division in this particular case. So when we are looking at 4.2, so this is 4, we have 4.1, this is 4.2. Our mandate now is to get the point of intersection when we move 4.2 to meet up with 2.0, just like this. And our interest is the point of intersection. So this is how we're going to be doing all the other ones. But students, you can practice with this. I'm not going to be drawing the lines again. I'm just going to locate the point of intersections, and that will be good and fine. Okay, so let me just say what I want to input here is here. That's going to be x is minus 2 and y is 4.2. In the second case, x is minus 1.5. So this is 1 minus 1, this is minus 2. In between them will be minus 1.5. I have that. And then y is 2.5. 2.5 will be directly between 2 and 3. So here, that will be 2.5. Okay, so I can say I'm looking at here as a point of intersection of the two. When x is minus 1, y is 1.3. I believe you can get it now. Minus 1 for x and 1.3 for y. That is going to be here. Okay, and then x is minus 0.75. So this is minus 1, this is 0, this is 0.5. So in between them here, this will be 0.75. And then I want to just oppose that with 1.0. This is going to be that value there. And then 0.5, which I identified as here before, and 0.9 will be here. Okay, then minus 0.25 will be between 0 and 0.5 here, and then 1.4 should be here. So I'm looking for the cross section of the two together. I'm having something here. Okay, and then minus 0.1, that will just be for x. Minus 0.1 will be 2 boxes here, and then 3.3 will be here. So the intersection of the two, we are having something here. So those are the lines, and I think since we are done with the table, I can just scroll down so that I can look at my graph holistically. Okay, so all that is left is for me to just join all of these points together with a French curve, and that will give me the graph that we are requested to draw. Okay, so I'll just be doing that right now. So just to make sure that this is showing, I will use blue write up. Okay, students, just use your pencil and you should have something like this as that particular graph that we're expected to construct. Okay, and like we're stipulating that for this particular graph, x is not equal to 0. You can see here we're just moving towards 0 for the x-axis. There's no value for y when x is 0. It is undefined. That's why you can see the y is just moving on. Here on the positive side is going down, on the negative side is going up, and then we don't have values for y. So that is consistent with what is expected for us. So here we are told that by drawing a suitable line on the grid, we are to solve the equation x squared minus 1 over 3x plus y is 0. We need to recall that the value of y itself is x squared minus 1 over 3x. So this equation, what we are having here is that we can see that this whole is y. So if we want to put it as y, we can say y plus 1 is equal to 0, so that we have that y is actually minus 1. We subtract 1 from both sides. Now, for us to solve this by drawing a suitable line on the grid, that means y is a constant that is defined as minus 1. It's not dependent on x at all. That's why the variable x is not featuring here. And that means that we need to look for the point where minus 1 is on y. So this is minus 1. I'll just draw a straight line across that to define this particular equation. And we want to do that, we can just draw that straight line to say it's nothing but this. And then, as a rule of thumb, students, we need to always ensure that we label our graph. So here, I would just like to write that this is x squared minus 1 over 3x plus 1 is equal to 0. Okay, the other one that have been done, and then we know that this other one, okay, is the one that we have been asked initially. I think we are good and fine with it. So this is what we are expected to use to solve the equation. How do we solve the equation? That means we are being requested to look at the point of intersection of this line y is equal to minus 1 with the curve that we have initially. And we can see that here I want to use red in there just for the sake of explanation. Here we can see that that is a point of intersection, and for us to get that, we can just trace it up to the x-axis to say we are looking at something like this. Okay, so this value here, that is going to be the solution that we are being requested to find. And if you have to observe it, now we are saying that in this particular case, since this is 0, this is 1, here this middle will be 0.5. Okay, so what happening is this is 0.1, this is 0.2, this is 0.3, a little bit to the right hand side of 0.3, this is 0.4. So we can say this is nothing but like 0.3. Okay, so that's what we are going to actually feature as a solution here. That is like is 0.3, right? So there, that is 0.3. But now, as a rule of thumb, I can also use my calculator to confirm, to say that, look at this, just look at this. What we're having is that, okay, this, let me just add it, plus 1, we're saying is equal to, and for me to get that equal to, is an equality sign. It is this given in red. I will press alpha calc. You can say it's equal to 0. So instead of pressing calc now, I want to solve for this particular equation. I want to say shift calc, which is solve, written in gray. So it wants to solve for x, starting its iteration value from minus 0.5. No, I want it to start its iteration value from 0. So I can press equal to what? Wow. And you can see it's telling me that the solution to this is x is equal to 0.304. And like I was observing on the graph, is actually a bit to the right hand side of the graph. So we are quite on track to say the solution is 0.3. So I can come back to my worksheet to say from the linear graph, the solution is at x is equal to 0.3. So here, x is nothing but 0.3, which was obtained from this graph, and I'm able to actually reflect it appropriately here as shown in red. Here we'll be working with functions, and we are first asked to find g of f of 3, given that f of x is 1 plus 4x, and then g of x is x squared. Here in this particular case, we have to find g of f of 3. First, we should find the f of 3, and for us to do that, we just say f of 3, and here we can see that f of x is defined as 1 plus 4x. So we can say we are replacing x with 3 here, so we have 1 plus 4 times 3, which is going to be 1 plus, first, we evaluate the one that is multiplication from BODMAS or PEMDAS. So that will be 1 plus 12, which is equal to 13. So g of f of 3 will inherently mean we are looking at g of 13. And what is G? The operation G is actually the square of the variable we are talking about. So this will be 13 raised to the power 2, and that is 169. So the answer here is 169, right? In the second case, f of g of x. So first we need to carry out g of x. So what's g of x? That have been defined initially as s squared. So f of g of x will mean that we are carrying out f on s squared, and that means that whatever we find x, we're now going to put s squared in that case. So this will be 1 plus 4 multiplied by, instead of x, we have s squared, and this is the best we can do with this. So our final answer is 1 plus 4s squared. Okay, and then in this other question, we are looking at the inverse function of the function of x. So in this particular case, it's as if you recall your indices, maybe you're having x raised to the power minus 1 multiplied by x, or okay, don't let me use x, let me say I want to use a. You have a raised to the power minus 1 multiplied by a. You know, this is just as if you are having 1 over a multiplied by a, which is 1. Implying that if you are finding the inverse of a function on the function, you are actually annulling that function itself. Whatever operation you are trying to carry out, you are annulling. So this is going to be nothing but x. Okay, or maybe I can look at the example on matrices in which you have the inverse of a matrix multiplied by the same matrix. Is going to be an identity element. So eventually you're just going to see that the inverse of the function of a function of x is nothing but x. So here x is still going to be the answer. They're just trying to test your understanding of the concept of inverse of functions and co. Now in this case, we have to find the value of x when f of x is 15. And recall that we are giving that originally f of x, we are told that it is 1 plus 4x. Now we are told that that f of x is nothing but 15. So now we have to find the value of x. This implies that what we're having is 1 plus 4x is equal to 15, so that 4x will be 15 minus 1 if we subtract 1 from both sides. So 4x is equal to 14, and to solve this, we can divide both sides by 4, and then we can see that on the left hand side 4 will cut, such that we are having x is 14 over 4, which will be 7 over 2, or in decimal place x will be 3.5, and that is as good as this question gets. Okay, for this question, we're told that in this triangle ABC, AB is 45, AC is 29.5, and BC is 35.3. Then angle CAB is 51.6 degrees. We have to calculate angle ABC. First, let's identify this angle ABC. This is ABC. So inherently, this angle here, that is what we are requested to find. This is the angle that we are looking for in this particular question. And how do we find this angle? We can see that for this particular triangle, we know all the sides. We know one of the angles. We are looking for this other angle. I think the sine rule will be ideal for us here, because we can relate the sine of the angle over the side opposite it to one another as a constant ratio. So in this particular case, since I have A and the side facing it, and I'm looking for B, though I have the side facing it, then I can say sine of the angle of A over the side facing A, which will be small a, is equal to the sine of the angle of B, which is ABC that we are looking for, over the side facing that angle over B. So here, if I want to use this, that means I can say, what is sine A? That is sine 51.6 over A, the side facing it. This is 35.3 over 35.3 is equal to sine B, which we are looking for, divided by the side facing it, which is B, 29.5. So in this particular case, all I just need to do is cross multiply, such that I'm going to have sine B is equal to 29.5 sine 51.6 divided by 35.3. You can see how I'm taking time to just explain all my steps. And in this case, I will have sine B to be, let me use my calculator now, 29.5 sine 51.6, okay, divided by 35.3. What's that going to give us? 10.6549. 6549. And then with this, I can get B to be the arc sine of that value, 0.6549. So I can still bring my calculator to say arc sine, the answer that I just got, what's that going to give us? 40.914. But recall, in the instruction set, we are told that when we are working with decimal, we round up to one decimal place. So here, my answer is going to be 40.9. So B is nothing but 40.9 degrees. So I can just state that out, that the answer is 40.9 degrees. That is angle ABC. Okay. Here we have to find the area of triangle ABC. Let's look at the parameters that we have and the formula that we can make use of. Okay. The area ABC. Okay. Since from what we have, okay, we also got this as 40.9 degrees. Okay. Now, if we say we want to use half multiplied by the product of the sides and the angle between them, here we have this side, we have this side, and we have the angle between them. So we can say we want to use half. This is B because it's facing this apex B, and then this is C because it's facing this apex C. So I can say half BC sine A. So that means formula I want to use is half BC sine A as the area of this triangle, and B is 29.5, C is 45, A is 51.6. I think that would be good for us. Okay, so I can say the area of this triangle is equal to half BC sine A, and okay, let me just call it area. So that area is going to be 1/2. B, just like we have identified now, is 29.5 centimeters. Then C is 45 centimeters. Then sine A will be sine 51.6. I love to actually make use of the values that are given in the question already, so that I will not be having problems with approximation, or if I had missed the previous question, I will not use that wrong value to actually get the subsequent values. But here, I'm using raw data that we have been given, so the margin for error will be drastically reduced. So I can just say I want to say 1/2 is 0.5 multiplied by 29.5, not 295, 29.5 multiplied by 45, then sine 51.6. Okay, so this is 520.176. Now recall that if you are working with normal operations, we are asked to round up to 3 decimal places. So this will be 520.175. I'll round up to 1 and add to the previous number. So I have 520.177. So this is 520.177 centimeters squared. But since in our instructions set we have been told that we should round up to 3 significant figures, then we can say this is nothing but 520 centimeters squared. So our final answer will have to be 520 centimeters squared. We have here another question on triangles and co, in which we are told that this diagram shows a quadrilateral PQRS that is formed from 2 triangles PQS, this one here, and then triangle QRS. Okay, now triangle PQS is isosceles. That is good. That means this side and this side, they are equal, and you can say 32 centimeters and 32 centimeters. Okay, then PQ, PS, they are equal, 32. And angle SPQ is 56 as given. Then QR is 47. QR here is 47. And angle SQR is 60. Okay. First, we have to find SR. So where is XR? This is SR. Okay. So if I'm to look at that SR, okay, since it's facing this Q, let me just call it Q. Alright. How can we get this particular Q? Okay, if we can get the value of SQ here, this SQ, since it's facing R, let me call it R. If I can get R, I can make use of the cosine rule to say that for this particular question, Q square is going to be, okay, since 47 is the one facing S, I can call this S. Q square is going to be R square plus S square minus 2RS cos the angle Q. This angle 60 that is facing Q. So that is the guide to the cosine rule, and this is the cosine rule that can inherently help to solve this question. Now, this is just the method I want to choose. You can look at some other means. Maybe you can try your hands on that so that you can get to master proficiency in solving questions like this. But I think I can get this side SQ, which I've defined as R, from this diagram, because here this triangle is tagged as isosceles triangle. If I said I would like to just say I want to bisect it, just bisect this triangle into two equal parts. So if I look at this angle here and this angle here, they are going to be equal because they are the base angles of isosceles triangle. So I can see that this angle here and this angle here, they are equal. That is good and fine. But beyond that, since I've called SQ, I'll call it R. Half of it, this R over 2, I can get by making use of SOHCAHTOA, because this line in purple is actually dividing this to a right angle triangle. Since it is isosceles and I'm bisecting it into 2, this will make it a right angle triangle. And so I can use SOHCAHTOA to say for the triangle PS to this point, okay, that's the right angle triangle in which I know this longest side, the hypotenuse. This will now be 28 degrees, which is half of 56. So I'm looking for the opposite to 28, R over 2, and then I have the hypotenuse. So I can say from SOHCAHTOA, it's telling me that the one relating opposite to hypotenuse is sine. So it's telling me that sine 28 is equal to the opposite to that, the side facing it, this side which is facing it, is R over 2 is equal to R over 2 over the hypotenuse, which is 32. So I can solve for R over 2 here to say R over 2 is equal to 32 sine 28. And what's that going to give me? 32 sine 28. This is 15.023. So this is 15.023. Then I can find my R from here. R will be 15.023 times 2. Okay? So I can just inherently just write that out. So having this now, I can go ahead to try and solve for SR, this SR, which is Q, to say that with all the parameters that I have, I can say Q square is equal to, what's the value for R? That is 30.046 raised to power 2 plus S square, that is 47 raised to power 2 minus 2 times RS, 2 times 30.046 multiplied by S, that is 47, then multiplied by the cosine of angle Q, which is 60, cos 60. Okay, that cos 60 will be half. So we can just say we want to make use of our calculator that, okay, 15 raised to power 2, we have it as 30.046 raised to power 2 plus 47 raised to power 2 minus 2 multiplied by 30.046 multiplied by 47, then cos 60. Okay, I think you can check to ensure that you got all the parameters right, and you can press equal to. So this is 1699.600. So this is Q square is equal to 1699.600, such that Q itself is equal to square root of 1699.600. Okay. So we will take our calculator, the square root of the answer that we just got, that is 41.226, 41.226 centimeters. From here, we should round it up to 3 significant figures. So that will be 41.2 centimeters, because 2 is now up to 5. So we'll round it down to 0 and that to the previous number, so that SR, which is Q, okay, we can append as 41.2 centimeters, and that will be our final answer in this particular case. So moving on with the question, our next mandate is to calculate the shortest distance from P to SQ. And if you are to look at the diagram, that shortest distance from P, this is P, to SQ, this line, you can see that it is the line drawn in purple, in which we have this as 32 centimeters. We have this angle 28 degrees. We have R over 2, which we have gotten as 15.023. But do we really need that? Let's just look at this triangle and see how we can solve it effectively in this question. Okay, so if you are to look at that extrapolated image, this is what we are having, and that's what we are looking at, in which we are looking for x, that is the distance pt, the distance from the P to the line SQ. Okay, so it is pt, which is denoted as x here, and we are to make use of SOHCAHTOA. We can see that looking at angle 28 degrees, the hypotenuse in this case is 32, and the value we are looking for is the distance between P to this T, which is x, that is the adjacent. Okay, the adjacent is x, which is what we are looking for. So what is relating the hypotenuse and the adjacent? We can see that it is cos. So here we can say cos 28 is the adjacent, which is x, over the hypotenuse, which is 32, such that x will be 32 cos 28, and we can just try to find out from the calculator. So we have 32 cos 28, and what's that going to give us? 28.254. So this is 28.254 centimeters. But again, we have to get this to three significant figures. 5 will round up to 1 and add to 2, so that will make it 28.3, such that our final answer will be 28.3 centimeters as the shortest distance between P and SQ. So that is that for this wonderful question on the figure that we are given here, making use of the cosine rule and SOHCAHTOA to solve as appropriate. All right.
Here in this question, we're told that the table shows information about the mass in grams of each of 120 letters. So we have this mass in grams and the frequency, that's the number of times they are actually occurring. So first we have to calculate an estimate of the mean mass. Now to get an estimate of the mean mass, and I love that they are telling us that it's an estimate. Okay, so you can say it is going to be giving us x bar is equal to sigma fx, which is summation of the product of the frequency and the data entry over summation f, the total of the frequencies. Okay, so in this particular case, I think why they are telling us the estimate is that ideally 0 less than m less than or equal to 50 will mean that we are taking a data entry from say 1 to 50, and if you are looking at this and you want to find the median, that would have been 25.5, but that will be quite equivalent to be putting 5.5. So I think that's why they are talking about the estimate. So in that particular case, we can just take 25 as a midpoint of this data value. So in the first case, this will be 25. Here it will be 75. In this third case, 100 to 200, that will be 150, and then 200 to 500, that will be 350. So that is something we need to know, that these are not linear. Okay, it's not the same width that we are having in each of these data entries. So for the first one, you can say the product of the frequency and the data entry will give us 25 multiplied by 43. In the second case, we are going to have 75 multiplied by 31. In the third case, we are going to have 150 multiplied by 25. And finally, in the last case, we are going to have 350 multiplied by 21. Okay, so all of this, we are saying we are dividing by the sum of the frequencies. So we have here 43 plus 31 plus 25, and then finally we're adding 21. So this is what we need so that we can get our answer holistically, and we can bring in a calculator to evaluate this. Okay, so say in the first case 25 times 43, our calculator will use PEMDAS or BODMAS by itself, so we can just put in
these values straight, it will take care of the order for us, plus 75 times 31. We just need to ensure we don't make mistake in inputting the values, plus 150 times 25, then plus 350 times 21. So what's that going to give us? 14500. So this is going to be 14500 divided by the sum of all these frequencies, 43 plus 31 plus 25 and plus 21. Okay, so this is 120. So that our estimate of the mean will be 14500 divided by 120. Okay, so this is 120.83333. So you can just say this is 120.833. We can put that as our answer as 120.8 grams. Okay, Iraj draws a histogram to show this information that we have already. Then it makes the height of the first bar to be 17.2 centimeters. We have to calculate the height of each of the remaining bars. So I've come up with a sketch of what that histogram is going to look like. Students, you don't need to actually get this done in an exam. I just want to use this as a means of explaining the concept behind what we are going to be working with here. So in the first case, we are told that it makes the height of the first bar 17.2 centimeters. So for that particular bar, the masses that we have is ranging from 0 to 50, and the frequency is 43. So we have frequency on the vertical axis and the mass on the horizontal axis. So 43 is taking 17.2 centimeters. That inherently means that there is a particular scale that can actually relate 43 to 17.2 when we have a class width of 50. Okay, so I just want to show you that so that we can use that as an information to help us solve this question holistically. Now, in the second case, for the data set, we have the frequency to be 31. So this is 31, and that is from 50 to 100. And then in the third case, now this is where it gets interesting. 100 to 200 will be two divisions of 50. So we have 100 here. This will be 150, and then next that will be 200. So that is taking a frequency of 25. And in the same way, in the last case, we're having from 200 to 500, taking a frequency of 21. And that's why we have this long division, 200, 250, 300, 350, 400, 450, and 500, having a frequency of 200. And then we need to get the height of each of the remaining bars that we are going to be doing and working with it. So if we are going to be doing that, there's a formula that is generally used, that the frequency density in histogram, the frequency density is given as the frequency divided by the class size. This particular formula is what is going to help us to solve this question holistically. And if we'll be making use of it, we are going to look at that particular first case in which already we have been given what is being used. So we can say the frequency density is going to be, for this case, we have 43 as the frequency. Okay, then the class size is from 0 to 50. So we can say this is 50 minus 0. Then we are multiplying it by a factor that is helping us to get that bar as 17.2 centimeters. That factor is a scaling on the graph sheet that Iraj used to draw that. Okay, so we can say this is the frequency density, and we have been given as what? 17.2. So from here we can solve for x to say that therefore our x is going to be, this is just for 3 over 50, that will be 17.2 times 50, and we are dividing by 43. So this is the multiplying factor that we are using in this case to get the height of each of the bars. So we want to do that, we can say 17.2 times 50 divided by 43. What's that going to give us? Good. So x is actually 20, and then if x is 20, what we need to do to get the height of each of the remaining bars is to use this same formula for the frequency density, but now we use s as the extrapolated value to factor in the height of each of the bars. So in the first case, for 50 less than m less than or equal to 100, we are going to have the frequency density to be, what is our frequency? In this case, it is 31. What is our class size? That is now 100 minus 50. 100 minus 50, multiply by the scale factor of 20. If you want to use our calculator, we can say this is 31 divided by 100 minus 50 is 50, then multiply by 20. So what is going to give us? This is 12.4. So this is going to be 12.4 centimeters. Okay, for 100 less than m less than or equal to 200, we need to note that now the class size is going to change. Our frequency density will be, what is the frequency for that case? It is 25. So we have 25 over 200 minus 100, then multiply by 20. Okay, so if you want to get that again, we can use our calculator. We have 25 divided by 200 minus 100 is 100, then we're multiplying by that 20, and that's going to give us 5. Okay, so this is 5 centimeters. And in the third case, we're having for 200 less than m less than or equal to 500, what is going to be our frequency density is the frequency, in this case is 21, divided by the class size 500 minus 200, that is 300. Then we are multiplying by that multiplying factor, which is 20. So again, we have it 21 divided by 300 times 20. What are going to give us? This is 7 over 5, which is 1.4. So this is 1.4 centimeters. So students, I hope you are able to pick a very good understanding of this. And with what we have been given, we have enough data to now say that the height of the bar for 50 to 100, that is obtained as 12.4 centimeters. For 100 to 200, that is obtained as 5 centimeters. And for 200 to 500, that is obtained as 1.4 centimeters. I took my time to actually get this pictorial view so that you will understand it, and I hope it is clarified in this case now. Okay, so moving on now, we are to complete the cumulative frequency table as given here. Okay, so we have those frequencies, but now we are looking at the cumulative frequency, meaning that we need to add cumulatively each of the frequency for the data set. In the first case, we are given the frequency as 43, so this is 43. In the second case, it will have to be 43 plus the frequency of that second class, and that frequency is 31. So we have 43 plus 31, that will be 74. In the third case, we need to add 74 to the frequency of this third data set. So that will be 74 plus 25, and that is going to give us 99. And then in the last case, we are going to still add 99 to the frequency of that last data set. That will be 99 plus 21 as a frequency in this last case, and that will be like 100 plus 20, that will be 120. So this is our cumulative frequency table, and then we can see what we are going to still work with. I think in the next question we are being asked to draw the cumulative frequency table, and then what we just need to note here is that since we are given m is less than or equal to 50, we have our upper class boundary defined already in this particular case. Okay, it's defined, so we can take 50 as our upper class boundary, 100, 200 and 500 as the upper class boundary that we'll be working with, and then we have this as our cumulative frequency. So we want to make a simple guide of what we have 50 and 43, we have 100 and 74, we have 299, then we have 500 and 120. So this is our table of values that we're going to be making use of. In the first case, this is m, and the second case, this is f. In short, this is cumulative frequency, not just f. So this is what we are using, and I'll take that to help us get the construction of the cumulative frequency curve. So here it is. We are being asked to draw a cumulative frequency diagram, and I'm giving the graph sheet already, in which we have the horizontal and the vertical axis. On the vertical axis, we have the cumulative frequency. On the horizontal axis, we have the mass. And here, just like I captured those data entry, this is going to be what we are using. We have the masses and we have the cumulative frequency. So we are going to be extrapolating these values together on the graph sheet and then plotting the curve that will join all of the data entries as appropriate. So that's what we are going to be doing right about now. So we are trying to look at the scale that we have here and the values that we are going to be inputting from 0 to 20. Yeah, 0 to 20. We have like 10 box division. So these are 10 boxes. and then that means that each box is going to have a value of 2 units. So we have 2, 4, 6, 8, 10. And you can see that is half, so that this is 12, 14, 16, 18, and 20. So it is 2 values that we have for each of the small boxes. Okay, and then on this horizontal axis we have 0 to 100. I can do this like this, that means this is half, which is 50. Then each one we have to take 10 units. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So once that is clarified, we will know how to get our data extrapolated together. But this is the very first step. You can just do this mentally, and then we'll try and see how to solve the question as appropriate. So having that in mind, we can now say when m is 50, m is giving us 50 at its value. So where is m? 50 is here. Okay, and then the cumulative frequency is 43. We can just have something like this. This is 50 from the mass, and then 43 on the cumulative frequency graph will be 40, 42, 44. So 43 will be in between 42 and 44. So we have something that is like this. Okay, and we are looking at the point of intersection of the two. So this is what you are supposed to just trace for each of the data entry. I'm showing this as a guide so that subsequently you can just know that, okay, this is what DevTut is doing, and I can replicate that from my end. I'm only going to indicate the point of intersection. So I can say here I'm having 50 and 43. So that is somewhere here. Okay. And then in the second case, I'm having 74 and 100, or I'm having 100 and 74. So this is 100, very clear on the horizontal axis. Then 74 on the cumulative frequency. 60 is here. This will be 70, 72, 74. Okay, so this is going to be their point of intersection, and I can just note that straight, that here, that's what I'm having there. And then in the third case, the mass is 200 and the cumulative frequency is 99. So this is 200. I hope you can get it straight now. 99 will just be between 98 and 100. So we're having something like this. Okay, just in between. Then we have 500 and 120. So this is 500 and 120. This is the easiest of them all. So these are the points that we have. Our mandate will now be to join all of them together with a curve as appropriate. So we get to put in our French curve. We are going to have something like this as the curve that is joining all of these together. Okay, so that's how the graph is going to look like. Then we have this set of questions that we can look at holistically to solve, and let me just capture it so that I'll be able to just move on my graph sheet to solve them. In the first case, we are looking at the median. We have to evaluate the median. We have to get the upper quartile, that will be Q3. We have to get the 40th percentile, and then the number of letters with a mass m, where 250 is less than m less than or equal to. So we are looking for frequency for the case in which we have 250 to be less than m to be less than or equal to 400. So this is our guide. We can now go to our graph to try and solve this as appropriate. Now I want to just use red ink. Students in the exam, use your pencil on the graph sheet, but for the sake of explanation here, let's try and see how we can make this pop out so that you can see for better understanding. Okay, so in the first case, to find the median, we are having a total cumulative frequency of 120. The median will be half of that, so we are looking at 60, and then we need to just look at the extrapolation of that particular 60 on the cumulative frequency and get the value of the mass. Okay, so we can just go to 60 here and say we want to trace to the graph. You can see, and then we want to come down to see what that value is. So from the scale that I actually explained the other time, we can see that here half of this is 50, 60, and this is 70. So the median will have to be 70 grams. Okay, so what I did initially was to say for the median, we are looking at half of the total cumulative frequency, which is 120. That is on the 60th position, and that value is corresponding to 70 grams as given from the graph. Okay, Now, for the other one, the upper quartile is actually the 3/4 position of 120. So here, if you are to cut 4 here 1, 4 in 120, that is 30. So we are looking at the 98th position on our cumulative frequency. We want to see what that value will correspond to. So we can say we are looking at the 90th position will be between 80 and 100. So we are looking at something like here. This is in between 80 and 100. So we can draw our straight line again to meet the curve, and then from there we can also go straight down to see what that is going to amount to. If we are actually on point, we are going to see that again this is 100, 200, in between them is 150. We're having it just a bit to the right of 150, so maybe we can say 151. So this is like 150, like let me just say 153 grams. So that's going to be the upper quartile. And then we also asked to evaluate the 40th percentile. Okay, so 40th percentile, we warrant that we are looking at 40/100 of again 120. Okay, so we can have this cut out, the zeros, and then that means we are here looking at 4 times 12. That is the 48th position. And again, we go to the graph. This is 40. We have 42, 44, 46, 48. That is what we are going to be using. Okay, so if we want to get that, we'll also trace from that particular point to the curve. Okay, and then we bring the same down. So initially we're having this as something like 153. Here we're having it as, this is like 50. Again, let me just say this is like 53. It's not directly on that line. You can just get to look at this from your question too. Okay, from your graph that you are constructing. For me, this is looking like 53. So I can say 53 grams. Okay, and then finally we have to look at the number of letters whose mass m lies between 250 and 400. In this particular case, we have to have some reverse engineering. So we are looking at 250, which is here, and then we are looking at 400, which is here. We want to get the frequency that corresponds to those class range. We are looking at something like this, from 250 to the curve, and then also from 400 to the curve. We want to get the corresponding frequency range. Okay, I think we are quite on point here. So we are looking at this region that is covering that range of value which we trace coming from 250 to 400, just this region. So we have the masses already. We're only looking for the frequency that corresponds to that. And you can see here, if this is 100, this is 102, 104, this is 106. So we have the lower as 106. We have the upper as just before 120, and that is 118. So for the frequency corresponding to 250 less than m less than or equal to 400, we are having this to be the difference between 106 and 118. So that will be 118 minus 106, and 118 minus 106, that is going to give us 12. Okay, so these are the set of answers, solutions to what we are being asked. In the first case, we are looking for the median, and I've gotten that to be 70 grams. Then we're also looking at the upper quartile, that will got to be 153 grams. Okay, and then we are looking at the 40th percentile, that will got to be 53 grams. And then finally we are looking at the number of letters with a mass m, where m is between 250 and 400, and we got that to be nothing but 12. So this is actually the solution to this as extrapolated from the cumulative frequency diagram. And if you have been able to do this, then it would have been good and fine. Just know that your exact values may not be what we have here. It can just be an approximation to it, since we're actually looking from the graph and not calculating outrightly. So that will be fine and good for us.
Here in this question, we're told that the interior angle of a regular polygon is 156 degrees, and we're to calculate the number of sides of this particular polygon. So the sum of interior angles of a polygon is generally given by the formula 180 multiplied by n minus 2, where n is the number of sides. But of course, we also know that this same formula is equal to the value of the interior angle multiplied by that number of sides. So what we need to do in this particular case is to equate these two to say that we have 180 into n minus 2 is also equal to 156n, such that if we open up the bracket, we are going to have 180n minus 2 times 180 is 360 is equal to 156n. So if we just rearrange, just subtract 156n from both sides, then add 360 to both sides, we are going to have 180n minus 156n is equal to 360, so that 180 minus 156, let's look at that from the calculator. We have 180 minus 156, that's 24. So we have 24n is equal to 360, and we can divide both sides by 24 so that we can find the value of n by dividing this we cut, and then we have n to be 360 over 24, which we can also look at our calculator. 360 divided by 24, so that is 15. So we can have that our n is nothing but 15, and here we will just append that as 15 and we are good and fine. Okay, in this question we're told that ABC lie on a circle. So this is ABC, they lie on this circle which is having its center at O. Then angle OBA is given as 52 degrees. We have to calculate angle ACB. So let's just identify that angle. ACB is here, ACB. Okay, so that is our angle of interest here that we need to calculate in this particular question. And looking at what we have, we can see that this AO and OB, they constitute the radii of the particular circle we are looking at here. So this is from the circumference to the center. This is also from the circumference to the center. So this triangle AOB is an isosceles triangle in which the base angles are equal. So this is also going to be 52 degrees. Okay, I hope that is just clear that this angle here is also 52. And we're saying that because angle OBA is equal to angle OAB, which is 52 degrees, because they are base angles of isosceles triangle. They are the base angles of our isosceles triangle AOB. Okay, so since that is the case, this particular angle, we can get angle AOB, because we know that AOB plus this 52 and this 52, they constitute angles in a triangle. So we can say angle AOB, the angle at the center, plus the 52 angles that we had already, they will actually constitute 180 degrees, because they are the sum of angles of a triangle. And sum of angles of a triangle, they add up to 180 degrees. Okay, so I'm particularly writing out the reason why these are so that you can actually see that is no magic, right? So that means if I call this angle X, if I call this X, I can say that means that X is equal to 180 minus the sum of 52 in two places. So that would be 180 minus 104, which is 180 minus 104, and that will be 76 degrees. So this angle at the center is 76 degrees. But then finally we can see that ACB is angle at the circumference, AOB is angle at the center of the circle. They are both being subtended by this chord AB, and then from the rule of the circle theorems, we can see that angle ACB, which we are looking for, is going to be half of angle AOB, because it is angle subtended at the circumference as compared to angle subtended at the center of the circle. So that is 1 over 2 of X, which is 1 over 2 of 76, and that will be 38 degrees. Okay, and why am I postulating this? Because it is angle subtended at circumference
is half angle subtended at center of the circle. So if we can get all of this, that means our angle ACB that we're looking for is nothing but 38 degrees. Since x is 76, then that would be half of that. So angle ACB that we're looking for is nothing but 38 degrees. All right. So yeah, in this question, we're also looking at PQRST, which lie on a circle. So we have PQRST, the line on this circle. WSR is a straight line. WSR, that's a straight line there. And angle WSP, this angle here is 112 degrees. We have to calculate angle PTR. So first, let's identify PTR. So this is P, this is T, this is R. This angle here is the angle of interest in this particular case. So if you are noting that, I can call it, let me call that angle X, okay? So how can we find this angle S? Something I'm noticing is that if we want to start from the data that we are given, we are seeing WSP to be 112. This angle here, if I call it Y, I can say that this angle Y that I just identified plus WSP is actually angle on a straight line. So I can say the angle Y plus WSP, which is 112, they add up to 180 degrees because they are angles on a straight line. Angles on a line, and the sum of angles on a line is 180. So Y will be nothing but 180 minus 112, and that will be 68 degrees. Okay. So moving on from there, we can see that this X that we're looking for and this Y, they are angles in the same segment of this particular circle. So we can say that angle PSR, which got to be Y, is the same as angle PTR, which is what we are looking for, that we tag as X, and the value is nothing but 68 degrees because they are angles in the same segment of this particular circle. So once the angles in the same segment, they are going to be equal, and with that, we've been able to solve this question to say that angle PTR is nothing but 68 degrees. So that is that about this question. So we can try moving on to the next question. Okay, to this other question. Okay, this is quite interesting now. Let's see how we can maximize the screen. We are told that GK and M lie on a circle with center O. So this is G, K, and M. They lie on this circle which has its center at O. Then FGH is a tangent to the circle at G. So this is FGH is a tangent just touching the circle at its circumference and then making a right angle with the radius or the diameter of the circle. And MG is parallel to OH. That's why they have this small arrow notching both of them. So we have to show that angle GKM is mathematically similar to triangle. Okay, we have to show that triangle GKM is mathematically similar to triangle OHG. And we have to give a geometrical reason for each of the statements that we are going to be making in this particular case. Okay, that's quite interesting. Let's look at this and let's postulate what we can get. I can readily see that angle OGH, this is going to be a right angle. Okay, and then this is also going to be a right angle. But like we have been asked, we need to state the reason for which we are saying all of this. In the first case, I can say angle OGH is 90 degrees, and then it's because it is the angle in between tangent and the radius of the circle. Okay, and that same angle is also, we can also see the angle KMO. I can also say that angle KMO is also equal to 90 degrees. And why is that? Is because it is the angle that is subtended by diameter at the circumference. By diameter at the circumference of the circle. Okay, once we have that, we are saying that both of them, they are equal. So I can say OGH is equal to KMO, and of course both of them have 90 degrees as their value. Is that all? That is not all. I can see from this particular image that because we have these parallel lines MG, okay, and OH, this angle here and this angle here, they are alternate angles to one another, so they are going to be equal. See, this line KG, or we can say this line KOG is actually a transversal between these two parallel lines MG and OH. So this angle and this angle, they are equal. So if I'm to call this, let me say I'm calling this X, I can also say this is X, right? Or better still, let me use theta. So if I'm calling this theta, I can also say this is theta. So from what I'm postulating, I can readily see that angle MGO is also equal to angle GOH, and I'm pegging this as 90 degrees, not 90, and I'm pegging this as theta, and I'm saying these are alternate angles. Okay. If we further look at this diagram, we can see that this remaining angle here, since we have looked at this angle as a right angle and this one as theta, then this angle here will be nothing but 90 minus theta, so that the sum of the three of them will be 180. And the same also applies here, that this angle here will also be 90 minus theta, so that the sum of the three angles, it will also be 180. So I can still include that to say from this diagram that we are looking at, we are also seeing that the third angle is 90 minus theta, 90 minus theta. But I think even with what we have, that is sufficient, because we are now seeing that from this particular diagram and the postulate that we are making, we are having two triangles in which two of their angles, they are equal. And that means we can say we have two angles in triangle KMG and triangle OGH to be equal. Okay, so we can say we have triangle GKM is similar mathematically to triangle OHG. And why? Because we are seeing that there are two, in short, we can say there are three angles that are equal in this particular case. We have the right angle triangle at M and at G. We have angle theta at G and at O. And we have the other angle 90 minus theta at K and at H. You can also pick any side, and once you're able to justify this, then you've been able to prove this as requested, and your full mark is assured. In this question, we're told that two rectangular picture frames are mathematically similar, and then the areas of the frames are 350 centimeters square and 1134 centimeters square. The width of the smaller frame is 17.5 centimeters. We have to calculate the width of the larger frame. So if you want to look at what we have here, this can be a pictorial view for us that can be a guide into what we are looking at. In the first case, we are having the area of the smaller one to be 350 centimeters square, while the area of the larger one is 1134 centimeters square. Okay, now the width of the smaller frame, this is 17.5 centimeters, and then we have to find the width of the larger frame. If we call this X, now we can look at this. Since we are told that they are similar, that means there is a multiplying factor that can be common to both. And ideally, if we want to find the area, we know that area in this case, maybe we call this A, I will call this B. The area for the smaller one will be 17.5 times A, and then the area of the larger one will be X multiplied by B, and the product of these particular two elements, the sides, will be, in the case of the smaller one, that will be 350 centimeters square, and in the case of the larger one, that will be 1134 centimeters square. We can do this because we are told that they are similar. Okay, and now since they are similar, and what we are looking for is ideally focusing on X, but we know that 17.5 and X, if you look at them and take A over B as a constant, that means that you can say 17.5 over X will be amounting to the square root of 350 over 1134. Now we're able to say this because A and B, they are unknowns for us, but we know that we cannot just relate this left hand side in centimeter to this right hand side in centimeter square without squaring it.
that is where the matter of the square is coming into play. So here, if we just say we want to cross multiply, and solve the question, we can have the value of x to be 17.5 multiplied by the square root of 1134 over 350. So this is what we need to put as our final answer. So we can bring in our calculator to say we are looking at 17.5 multiplied by the square root of, now we have a fraction, 1134 divided by 350. Okay, so what's that going to give us? This is 3 over 2, which is 31.5. So this is nothing but 31.5 centimeters as the value of x. So it's as a reason of the fact that they are similar that we brought in this relationship, but we cannot just relate the length, which is in centimeter, to the area, which is in centimeter square. We need to bring in the square root, and then that will enable us to solve this question fine and wonderful. Okay, so here we're told that a picture in a smaller frame has length 15 centimeters and width 10.5 centimeters, both correct to the nearest 5 millimeters. So we need to just note this very, very critically, that if we are giving that is to the nearest 5 millimeter, that means what we are having is plus or minus 2.5 millimeters as the bounds for the length and the width that we're having. But look at this, we are giving the length and the width in centimeters. This is in millimeter. Then we should convert to centimeters. That would be 0.25 centimeters. So if you are looking at the area, which is actually the product of the length and the width, for example, 15 centimeters, we have both a lower limit and an upper limit. So that upper limit will be 15 plus 0.25. So we have it as 15.25 centimeters. And then the lower limit will be 15 centimeters minus 0.25 centimeters. That will be 14.75 centimeters. And in the same vein, for the width, which is 10.5 centimeters, the upper limit will be that 10.5 plus 0.25. That will be 10.75 centimeters. And the lower limit will be 10.5 minus 0.25, which will be 10.25 centimeters. So these are the upper and the lower limit for the width, which is 10.5 centimeters. Now that we are being asked to find the upper bound for the area, then that means we are going to multiply the upper bound of the length and the upper bound of the width. So this is what we are looking for. I didn't mean that we are looking for the lower bound of the area, then we could have multiplied these particular lower bounds for the width and the length as appropriate. So since this is what we are looking for, we can say our area, which is the upper bound, is going to be 15.25 multiplied by 10.75. Okay, so we can use our calculator to say we are looking for 15.25 times 10.75. What's that going to give us? 163.9375. Okay, this is 163.94 centimeters square as the upper bound for the area of this particular picture. Okay, so here we are looking at this question too, and we are being told that in a sale, the price of a large frame is reduced by 18%. So look at the word. We are looking at a reduction by 18% in this particular case, okay? And then party pays $166.05 for 5 large frames in the sale. But to calculate the original price of one, okay, we are looking for just one large frame. Very good. We can just relate this, that when we are talking about the reduction by 18%, that means originally we have 100, but now since we are reducing it, that is minus 18. Okay, this is over 100 of the price, which we can call X, is equal to, now we are told that party pays this amount for 5 large frames, but the amount for one will now be that amount over 5. So we can have 166.05 divided by 5 large frames that we are talking about. So if we are to solve this, we can say this means 100 minus 18. What's 100 minus 18? That will be 82x over 100 is equal to 166.05 divided by 5, such that x in this case, if we cross multiply, will be 100 times 166.05 divided by 5 times 82. So we can find the value of that, we say 100 times 166.05 divided by, I want to put this whole denominator in a bracket so that it's not mistakenly taken as the numerator. So I have 5 times 82. Okay, so this is 81 over 2, which is 40.5. So x is nothing but $40.5, and that will give us the solution to this question as appropriate. So finally, we can look at this question in which we are told that party advertises a large frame for a price of $57 or 48.20 euros. Now the exchange rate is $1 to 0.88 euros. We have to calculate the difference between these prices in dollars and cents correct to the nearest cent. So let's look at this. Since we are given that $1 originally is 0.88 euros, and then we have to find the differences between these prices in dollars and cents. That means our money should be to convert these euros to dollar and then look at the difference between that dollar equivalent and this 57 that we are given. So we can say S dollar is going to amount to 48.20 euros, such that from here we can have x to be cross multiplying like this, x and this, then 48 and this, it will be 48.20 multiplied by 1 divided by 0.88. So that will warrant that I can get x to be 48.20 divided by 0.88. So this is 54.72. This bar means it is 727272. So I can say 54.77. Okay. So this is 54.77. Then the difference that we are looking at will now be the difference between this 54.77 and this 57. So that will be $57 minus this 54.77, which is the amount when we converted. So we can look at 57 minus the answer we just got. So what's that? This is 2.2. Okay, 27 is being repeated, so I can say 2.23. $2.23. So that difference in price is $2.23. And with that, we've been able to solve this question as requested of us. In this question here, we're told that Japan runs a distance of 12 kilometers and then cycles a distance of 26 kilometers. His running speed is x kilometer per hour and the cycling speed is 10 kilometers per hour faster than his running speed. So we need to know that it is faster. Okay, so it takes a total time of 2 hours 48 minutes. That's the total time that he took for his journey. Now in the first question, I've been told that an expression for the time in hours that Japan takes to run the 12 kilometers is 12 over x, which is consistent. Okay, so we have to write an equation in terms of x for the total time it takes in hours. Let's note that the time in hours. So if you want to look at this to try and solve it, for me, I just love to represent all of this in pictures so that I can have a very good feel of what we are talking about. Here in this case, let's say we have this as the distance with which he is running, okay, and then we have this as the distance with which he is cycling, which is like 2 times the other distance. So here you can have him just running. So he's running like this, and here we have him is cycling. So let's take it that he's just having his cycle and cycling like that. So he's running at x kilometers per hour, and that distance was given as 12 kilometers. So from here to here, that is 12 kilometers. And then in the second case, we are told that his cycling speed is 10 kilometers per hour faster than his running speed. That means it will be x plus 10 kilometers per hour because it is 10 kilometers faster. So we needed to add 10 to the x with which he was running initially. Okay, and for that, the distance that he covered were given as 26 kilometers. Okay, so this is what we have. Ideally, we know that speed is distance over time, but we are told that the expression for the time in hours that Japan takes to run the 12 kilometers is 12 over x. So we can say t then is going to be if you reverse this, it will be distance over the speed. Okay, so for this particular case, the time that it took for this phase of the journey in which it was running, this time will be, in the first case, the distance, which is 12, over the speed, which is x, that is for the phase in which he is running. In the second case, that distance will be again the distance, which is 26 kilometers, over the speed, and that speed we are given as x plus 10 kilometers per hour. Now we are told that this is amounting to 2 hours 48 minutes. That is the total time that it took. So we can say this is equal to 2 hours 48 minutes. But then look at this, we have 48 minutes. We should be able to convert that to hours. And this is what I want to say. I can say the total time is actually 2 hours 48 minutes. But we know that 60 minutes make 1 hour. So I can say 48 over 60. All right. And for this, I can cut 12 can go here 4 and 12 can go in 60. That is 5. So the total time that we have is actually 2 whole number 4 over 5. And if we are to express this as a whole fraction, this will be 2 times 5 is 10 plus 4. That is 14 over 5 as the total time. So the addition of the time it took in running, which is 12 over x, plus the time it took in cycling, which is 26 over x plus 10, is going to be nothing but 14 over 5. So what we are asked to get here will be 12 over x plus 26 over x plus 10 is equal to nothing but 14 over 5. So that is the equation in terms of x for the total time that it takes in hours. Okay. So here we have to show that this equation simplifies to 7x squared. Okay, so we are just to go ahead to simplify this. So if you look at this, you can see that 12, 26, and 14, 2 is common to all of them. So if we are to divide all through by 2, we are going to have 6 over x plus 13 over x plus 10 is equal to 7 over 5. So this is what we have. And if we are to get the LCM, we can say, therefore, this is giving us LCM on the left hand side will be the product of x and x plus 10. Then we have factoring out x from here, we have 6 into x plus 10. And then factoring out x plus 10 from here, we have plus 13x. This is going to give us 7 over 5. So we can do well to just cross multiply this so that we are going to have, okay, let's say we have, so that we are going to have 5 times the whole of this numerator. 5 times 6, that will be 30 into x plus 10, okay, plus 5 times 13x, 5 times 13, that's 65, plus 65x is equal to 7 into x times x is x squared, x times 10, that is 10x, okay. So we can just try and simplify this now. To say we want to open the bracket, we have 30x plus 300 plus 65x is equal to 7x squared plus 7 times 10x is 17x. Okay, so you have to rearrange and just take everything to one single side. I'm going to have 7x squared plus 70x. Here, 30x plus 65x is 95x. If I'm to subtract it from both sides, it will be minus 95x. Then this 300 will turn to minus 300. When we subtract from both sides, this will be equal to 0. So we can simplify this to say this is going to be nothing but 7x squared. 70x minus 95x is minus 25x. And then we have minus 300 is equal to 0. So this is what we are asked to show. And we can see that from here, we're able to arrive at the equation as requested. Here, we're asked to use the quadratic formula to solve the equation 7x squared minus 25x minus 300 is equal to 0. And we must show all our workings. So we know that as a rule of thumb, for a quadratic equation, x, the solution is given as minus b plus or minus the square root of b squared minus 4ac all divided by 2a. In which, for this particular case, if you look at this, the general equation is as squared plus bs plus c is equal to 0. So if you compare this to this equation, we can see that a is amounting to 7, B is minus 25. Students, don't make that mistake. It's not 25, it's minus 25, and C is minus 300. So if we are to put in all those values, we can say x is equal to minus B will be minus 25. Be careful with your signs, okay? Plus or minus square root of B square will be minus 25 raised to power 2, okay? Then minus 4, A is 7, and C is minus 300. Okay, so good and fine. We are dividing this with 2A, that is 2 multiplied by 7. Okay, so if you want to solve this, we are going to have it that this is the x here will be minus multiplied by minus will give us plus. So we have 25 plus or minus square root of 25 square, 25 raised to power 2 is 625. Then this minus and this minus we multiply to be plus, and then we have 4 times 7 times 300, 8400, all divided by 14. Okay, so this we can simplify to be 25 plus or minus square root of 8400 plus 625 plus 625, 9025 over 14. So we are showing all of this because they asked us to show all of our working. So the square root of the answer we just got is 95. So this is 25 plus or minus 95 over 14. So if it is plus, that will be 25 plus 95, and that will be like 100 plus 20. So it's either we have 120 over 14, or we have minus 70 over 14. Okay, so we can just cut in this particular case. What can go here? Between 120 and 14, 2 can go. So x will either be 60 over 7, or x here, 70 over 14 will be minus 5. So you can see the consistency with which we work this out, and we just shied away from using our calculator. You can actually use the calculator to solve this. To say you are going to the equation mode, which is 5. So this is 5. And then we're having a quadratic equation, which is amounting to 3. So that is 3. What is A? That is 7. What is B? It is minus 25. Okay. And what is C? It is minus 300. So if we input that, we can solve for this. And you can see x1 is 60 over 7. We are on track. And then again, x2 is minus 5. We are on track. So you can always use that to confirm the solution to your question, and then you know that you're on the right track to excellence as you abide by all these principles as appropriate. So moving on, we are now being asked to calculate the number of minutes Tapan takes to run the 12 kilometers. Okay? If we recollect, we are given that time in which he is running to be 12 over x hours. Okay? But then this is to be expressed in minutes. So for us to convert hour to minute, this is what I would like to do. 12 over x hour means that we're having 1 hour, but then I want to convert this 1 hour to minutes. So to minutes, it will be that this is over 1, because 60 minutes makes 1 hour, such that I can now have this hour and this hour is knocking out, and this will be 12 multiplied by 60 over x minutes. Okay, so if I have this, all I just need to do is now that, look at these values. Can our minutes be negative? Our minutes cannot be negative. Our minutes will need to be positive. Okay, so we need to say that that time that it took to run is only going to be 12 multiplied by 60 divided by 60 over 7. So this is 12 times 60 over 1 multiplied by 7 over 60. So this 60 and this 60 will cut. 12 multiplied by 7, what is that going to give us? That is going to give us 84. So this is 84 minutes. Then we can put that as the answer here, that this is 84 minutes as the time that Dapan takes to run the 12 kilometers. In this question, we are told that the volume of a paper cone of radius 2.4 centimeter is 95.4 centimeter cubed. So this particular cone the radius here, the radius of the base is 2.4 centimeter and the volume is 95.4 centimeter cube. Then the paper is cut along the slant height from O to AB. So along the slant height from O to AB, the paper is cut. Then the cone is open to form a sector OAB of a circle with its center at O. We have to find the sector angle x degrees. So if you want to see the transformation that happens when we cut this paper cone from O to AB, it is just as shown here, okay? And what is happening is that this slant height is going to become the radius of the sector of the circle. So if I call this R, this is also R, as the slant height of the paper cone, which is also amounting to the radius of the sector of the circle, okay? Now, if this is the height of the cone, we are not given that, but we are given the radius of the base circle of the cone, and that radius, the perimeter, is given as 2 pi r. I'm using small r for this particular 2.4 centimeter. Now that perimeter is going to translate into the length of the arc AB of the sector of the circle. So I can say that is also equal to x over 360 multiplied by 2 pi r, which is this radius of the sector of the circle, okay? So having that, we are trying to find the sector angle x degrees, but for us to do that, we need to actually find r. Since we know that AB is equal to 2 pi r, this AB for the sector is also this AB for the circle. So we can equate those two if only we have the value of r. And for us to get the value of r, we can look at the paper cone to say, since we are giving the value for the volume, then we have this particular radius of the base circle as 2.4. If we can get the horizontal height of that cone, then this we know is also r. We can use Pythagoras theorem to find r, so that we can use r in this particular case. So once we have that understanding, we can go ahead to say we want to try to solve this question to give us the solution that we need as appropriate, okay? So first we can say that we have, from the information that we have the volume of the cone to be 1 over 3 pi r square h. Okay, so volume we have been given already 95.4 centimeter cube. R we have also been given as 2.4 centimeter. Then h is what we are looking for. From here you can say h is nothing but 3 multiplied by volume over pi r square. So if you want to evaluate that, you can say that h is going to be 3 multiplied by 95.4 divided by pi multiplied by r, which is 2.4 raised to power 2. So we can use our calculator to evaluate this now, okay? So we are saying we are looking at 3 times 95.4 divided by 2.4 square. Okay, let me just put that in bracket so that I don't get confused. 2.4 square multiplied by pi, which is shift exponent here, okay? So what's that going to give me? 15.82. So I can say my h from here is 15.82 centimeter, okay, from that volume. Then having gotten that, I can see that from this triangle, h is the horizontal side here, 2.4 is here, then r happens to be the hypotenuse of this right angle triangle. So let me just get that out. So what we are having at least something like this, in which we have r here, we have 2.4 here, h, which we have gotten to be 15.82 is here, and by Pythagoras theorem we can say that r square is equal to h square, which is 15.82 raised to power 2 plus 2.4 raised to power 2. So that r square, so we can use our calculator for this to say we have 15.82 raised to power 2 plus 2.4 raised to power 2. What's that going to give us? 256.0324. So that r itself will be the square root of that value that we got, 256.0324. And from our calculator again, we can say the square root of the answer, that's 16.0. Okay, we can just say this is 16. So this is approximately 16 centimeters. Okay, now since we have now gotten our r, we can now look at this sector to say the Formula for this sector, x over 360 2 pi r that we just got is also equal to 2 pi small r, that is the perimeter of the circle AB. So if we want to equate those two, we can say moving forward, we now have that perimeter of the base circle of the cone is equal to the length of arc of the sector of the circle that will be formed. Okay, and looking at this, I can see 2 pi is common to both. Okay, then r we know, small r we know, we are looking for x, and as easy as it gets, we can say that means that our x will be 360 multiplied by the small radius over the capital R that we just got. Okay, so since we have defined all these parameters, that means inherently what we're having is that x is nothing but 360 multiplied by 2.4 divided by 16. So this is what we need to put into our calculator: 360 times 2.4 divided by 16. Okay, so this is 54 degrees. Okay, it is the sector angle, so it is in degrees. So our final answer that we're asked to get is 54. And again, the explanation is that for the transformation of this particular cone to this sector, slant height of the cone is going to become the radius of the sector, and then the perimeter of the base circle of the cone is going to become the length of arc of the sector of the circle. If you just equate the parameters that we have, the volume of the cone, we're able to get h. We use Pythagoras theorem to get that slant height, which is r, that is also the radius of the sector of the circle, and then we use that to equate the perimeter of the circle AB to the length of arc AB of the sector, such that we got our final answer to be nothing but 54 degrees. All right. For this question, we're told that an empty fuel tank is filled using a cylindrical pipe with diameter 8 centimeters. Now, fuel flows along this pipe at the rate of 2 meters per second. Okay, so we should know that there is a difference in unit. Initially, we have diameter 8 centimeters, but now we're giving the flow rate at 2 meters per second. Okay, now it takes 24 minutes to fill the tank. We have to calculate the capacity of the tank, and then we have to give our answer in liters. A typical diagram of what this is going to look like is just as shown here, in which we have this particular cylindrical pipe that is filling the fuel tank with fuel as appropriate, and then the diameter is 8 centimeters and the fuel is flowing at a rate of 2 meters per second. First and foremost, we are giving this time in minutes, but we are giving the rate in meters per second, so we should take our minutes to seconds. So that time that we're looking at is 24 minutes multiplied by 60 seconds, and that will be, I think, 1440 seconds. Okay, you can confirm that with the calculator. But now, if we notice this, we are giving the flow rate of this fuel in this cylindrical pipe, and then if you want to take that as a volume, we need to say that the rate of flow in the pipe with respect to volume is going to be pi r square L, and I'm using that because it is meters per second that we have, so it's a flow rate. Now that r will be half of 8 centimeters, which will be 4. Okay, then that meters per second we should take to centimeter. So if we want to do that, that means what we're having here is pi multiplied by the radius, that will be 4 raised to the power 2, multiplied by the L. That L will now need to be 200 instead of 2 meters, will now to be 200 centimeters. Okay, so if you have to get this, I think this will be 4 raised to the power 2 is 16, so we have 16 times 200 pi, and that will be 3200 pi centimeter cube. Now we have it as per second because it's a flow rate. Now I'm using that flow rate because once we want to look at the time, then we can get the original capacity of the tank. So the volume of the tank is now going to give us the flow rate in the pipe multiplied by the time that we have. So such that what we're going to have is that, what's that flow rate that we got? 3200 pi centimeter cube per second. Then what's the time that we have? We have it as 1440 seconds, and I deliberately put in the second so that you see that this second and this second, they are going to cut out, and then our answer is going to be in centimeter cube, which we are even asked to convert to liters. Okay, so but first in centimeter cube we have 3200 pi, okay, multiplied by 1440. What is that going to give us? 144,76458.95. So we have 144,764, yes, I think 58.95, but this is in centimeter cube. For us to take it to liters, we need to divide by 1000, because it is 1000 that constitute, it is 1000 centimeters that constitute 1 liter. So once we are saying this is, and then it have to be 1 liter, okay, because it is 1000 centimeter cube that constitute 1 liter. So once we are doing that, we can say yes, what we got now divided by 1000. So this is first step. I want to get it straight. So 14476, but again we're asked to always leave our answers correct to 3 significant figures. So that means 1, 2, 3. We need to consider the fourth number 7. We'll round it up to 1 and add to the initial number. So we have 14500 14500 liters as the capacity of this particular tank in liters. And with that, we are done with this question as appropriate. For this question here, we are tasked with the mandate to expand and simplify this expression, and let's just take it piecewise. First, these two, okay, so we are going to multiply x with each of these. So we have x multiplied by x is going to give us x squared. X multiplied by minus 2 is minus 2x. Then 1 multiplied by x is x. 1 multiplied by minus 2 is minus 2. Then we have open up the first set of 2 brackets. Then we can add the third one. That again, x squared multiplied by x, that will be x cubed. X squared multiplied by 3, that will be plus 3x squared. Minus 2x multiplied by x will be minus 2x squared. Minus 2x multiplied by 3 will be minus 6x. Then x multiplied by x, that is x squared. And x multiplied by 3, that will be 3x. Then finally, minus 2 multiplied by x is minus 2x. And minus 2 multiplied by 3 is minus 6. Such that if you are to take the like terms, we only have x to the power of 3. Okay, then 3x squared minus 2x squared, that will be x squared. Then plus x squared, this will be plus 2x squared. And then for x, we have minus 6 and plus 3, that is minus 3x. Okay, and then minus 2x, that will be minus 5x. And the only constant that we have here, that is minus 6. This is the barest minimum we can get to, so we can just write our answer as x raised to the power 3 plus 2x squared minus 5x minus 6 as the answer to this question. Then here we have to make g the subject of the formula in this particular case. And first we want to flatten out so that we can cross multiply. Here we have m into g minus c is equal to 2fg. Then we are making g the subject of the formula, so we should try and see how to isolate g out. This will be 2fg. Collecting like terms, we'll have mg minus 2fg is equal to mc. Then g is common here. G into m minus 2f is equal to mc. Then if we want to make g the subject of the formula, we can divide both sides by m minus 2f. So we can have g to be mc over m minus 2f. Okay, so that is how far we can go. We can just write that out as mc over m minus 2f as the answer when we make g the subject of the formula from this particular expression. Here we have to simplify this expression, and we can just see that from this, let's see what we can factor out from both the numerator and the denominator. In the first case, 4x squared and minus 16x, we can see that 4x is common. 4x is common. If you have taken 4x out of 4x squared, that will leave us with x. Then if you have taken 4x out of 16x, that will leave us with minus 4. Then here x squared minus 16, this can be taken as the difference of two squares, in which a squared minus b squared is a minus b multiplied by a plus b. So if you can take this sum of two squares, we can apply it in this case to say this is actually x squared minus 4 squared. Okay, so if you want to expand that, we can say this will give us 4x into x minus 4, and then the difference of two squares will be x minus 4 multiplied by x plus 4. And this can cut out such that our final expression can be 4x over x plus 4, which is going to be our final answer in this particular case. The probability that Shalini is late for school on any day is 1/6. And then we have to complete the tree diagram for Monday and Tuesday. So this is Monday, yeah, and this is Tuesday. Now, if the probability for lateness, if it is 1/6, the only other possibility is that he is not late. So the late prime will be 1 minus 1/6, and that is 5/6. So it's either it's late, in which the probability is 1/6, or he's not late, he arrived early, that will be 5/6. So this can help us to compute this particular tree diagram. So for him to be late, that will be 1/6. Not late, that will be 5/6. Then on Tuesday, for him to be late, still be 1/6. Not late is 5/6. Late is 1/6, and not late is 5/6. Okay. Then in this question, we have to find the probability that Shalini is late on Monday, but is not late on Tuesday. Okay, we need to be careful about this. Late on Monday will be 1/6. Okay, that is for Monday. And then not late on Tuesday, that will be 5/6. So the probability that is combining both of them, you can say that he is late on Monday but not late on Tuesday, will be the product of these two, and that will have to be 5/36, as the probability that Shalini is late on Monday but is not late on Tuesday. All right. For this question, we have it that the Venn diagram shows the number of students in a group of 50 students. Okay, so we can say that the universal set is 50 students, and who wear glasses, that is G, who wear trainers, that is T, and who have a mobile phone, that is M. So we have G, T, M. Now we have to use set notation to describe the region that contains only one student. Okay, if we look at the graph, where is the region that has only one student? We are seeing it is this. So that region that we are looking at is the one corresponding to only one student. Okay, and if you are to look at that, we are going to see that it is the complement of the union of G, T, and M. So if you have the union of G, T, and M, that is the one that is still in white here. The complement, the one outside of it, is the one shaded in blue. That is the region that has only one student. So if you want to append that in set notation, we are going to say this is going to be G union T union M. Those are the regions that are having these circles, but the complement of it is the one outside. So this is how to write it in set notation. Okay. For us to find the number of students that is being denoted with this T complement intersect G union M, T complement itself will be this region outside of T. You can see T is not being taken at all. Okay, that is T complement. Now, G union M, the G union M will be something like this. This is G union M, the whole of G and the whole of M. Okay, that is the G union M. So we have to find the number of students that is actually intersecting in this particular two shaded regions that we have. And obviously, from what we have even shaded as a means of guide, we can see that is 0, 19, and 9. So if you want to do that, you can just say this is nothing but here it is 0 for G alone, plus 19 for this region here, and then plus 9 for M alone. That will be 19 plus 9, and that answer will be 28. So the number of students in that category is 28. Okay. Now, one student is picked at random from the 50 students. We have to find the probability that this student wears trainers but does not wear glasses. Okay, we have trainers but not glasses. We need to look at our graph again. We should be considering somewhere here. Trainers, where is the region for trainers? This is the region for trainers. Okay, but then we are now being told that not glasses. Okay, then we need to exclude glasses out of it. So glasses is out. We have trainers only. Okay, so the student may be wearing trainers and also having a mobile phone, but is having trainers but not wearing glasses. So you can see that we have excluded the glasses out of it. So that number, as you can see here, is corresponding to 14 and 3. But since we are just picking this student out of the total number of students, which is 50, the probability will be 3 plus 14 over 50. So that is what we are going to be doing to solve this question. That this is nothing but 3 plus 14 over 50, and 3 plus 14 over 50 will give us 17 over 50 as a probability that this student that was picked wears trainers but does not wear glasses. So we have this as 17 over 50. Okay. Here we have that 2 students are picked at random from those wearing trainers. Originally, they are wearing trainers, so they are being picked from those wearing trainers. We have to find the probability that both students have mobile phones. So if you look at our graph, our Venn diagram again, we are going to see that, okay, where are those that are having trainers? If we want to identify that, we have these as trainers. Those are trainers. Now we're being told that we have to find the probability that both of them, they have mobile phones. For that particular case, the total possible outcome would be the sum of all of them, because this is constituting all that have mobile phones, all that have trainers. So that would be 2 plus 2 plus 3 plus 14. This would be 14 plus 3, 17, 18, 19, 20, 21. Okay. So if we are looking at those that have mobile phones, that would be 2 plus 14, which is 16 over 21 for the first case. And then in the second case, we need to duplicate that number. So if we want to solve it, we are saying that from that particular data that we have, that probability that we are looking for will have to be 16 over 21 for the first student. We are saying that we are picking them at random. After picking the first student, the possible outcome remaining will be 15 over 20. We have duplicated the total number that have mobile phones from 16 to 15. I duplicated the total number that are wearing trainers from 21 to 20. So this is going to be the probability that we are looking for. And we can cut 4 here 4, 4 here 5, 5 here 3, 5 here 1, 3 here 1, and 3 in 21 is 7. So this will be 4 times 1, that is 4, 7 times 1, that is 7. So 4 over 7 is going to be the probability that both students who are picked at random from those wearing trainers have mobile phones. And with that, we've answered this question on probability and will be good and fine. Here we are to solve the equation tan x is equal to 11.43 for the value of x ranging from 0 degrees to 360 degrees. Now, before we first go ahead to try and solve this, we should know that we have angles that we can have as either A, C, T, or S, denoting the regions that are positive. Here in the first quadrant, all is positive. In the second quadrant, cosine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, sine is positive. So that will be a guide for us, and we know that we are moving in this direction anytime we're actually moving on those quadrants. So let's try and see how we can solve this question that we have tan x to be 11.43, and in this case, x will be arctan of 11.43. So we can put that into our calculator that we are looking for, arctan 11.43. So what's that going to give us? 84.999. Okay, and we are looking at 3 significant figures. Okay, this will be 85. So you can say this is approximately 85 degrees. But now we need to consider our quadrant. In this particular case, we are working with tan and the value is positive. Where are the two regions where tan is positive? It is here where all is positive, and here that we are looking at. So we can say we are looking at something like this, in which we either have our tangent, our theta, to be here. Okay, so this can be
our answer. Or it can also be here. Here can also be the region of interest in which that angle is denoted there. And that second angle, if you want to look at it, this will have to be from the starting point up to this horizontal line, that is 180. So here, if you want to sum everything, to be 180 plus theta. So if you are looking at our solution to the question, we can say that it's either x is equal to 85 degrees, or we have x to be 180 plus 85 degrees. Okay, so if you are to solve for that, we can say that our x will be 85 degrees, or for this second case, we can say our x is 180 plus 85, that would be 265 degrees. So we can put that as our answer, that x is 85 degrees or x is 265 degrees. So we can move on to this, our next question. Okay. In this question, we're asked to sketch the curve y is equal to x raised to the power 3 minus 4x, and we have been given the plane to work with. And for us to do this, that means that we need to look for the solution to this particular curve. And we'll normally obtain that solution when the value of y is 0. That's why we actually compute it on the x-axis. Okay, so we can say when y is equal to 0, we know that that will give us x raised to the power 3 minus 4x is equal to 0. And then if you factor out x, this will be x into here, x squared will be remaining out of x3. Then minus 4 will be remaining out of the other one. But we know that minus 4 is actually 2 raised to the power 2. So we have this to be 0. So that what we are looking at is nothing but here difference of 2 squares, which is x minus 2 multiplied by x plus 2. So that we have it as x into x minus 2 into x plus 2 is equal to 0. And then the solution to this will mean that is either I have x to be equal to 0, or x is equal to 2, or x is equal to minus 2. That's the solution for all of this. X is either 0, or x minus 2 is 0, so that x will be 2, or x plus 2 is 0, so that x will be minus 2. So these are the solution points, and I can say we are looking at x is 0 here, then x is here, x is minus 2, and then here, let's say x is plus 2. So those are the values for x. But we need to find the corresponding values for y. And for us to get that, we need to say that at the turning point, we have it that the y dx is equal to 0. And if you have the function that we are given that y is equal to x cubed minus 4x, such that the differentiation of y with respect to x, in this case, will be 3x squared by differentiating x raised to the power 3 minus 4 by differentiating minus 4x. Okay, and that we are going to equate to 0. This is the differential value of y with respect to x. And then if you have to solve for this, let me pull my, so we have to solve for x here. We can see that means we have 3x squared is equal to 4, and then x squared itself will be 4 over 3, such that x will be plus or minus the square root of 4 over 3. And if you have to use our calculator on this, we have square root of 4 as the numerator, 3 as the denominator. What is this going to give us? 1.1547. This is 1.1547 as the value of x at the turning point. So that means we have, let's say we have 1 here, we have 1 here. Somewhere just after that, that's where we're going to have those turning points. But then, what are the corresponding values for y for those turning points? So you can say when x is, let's take the positive value, is 1.1547, we are going to find the value of y to be in the original equation. What is y? Y is x raised to the power 3 minus 4x. Okay, so using the value of x, we can just say that's going to be, I will just compute this on the calculator, that I'm having s raised to the power 3 minus 4x, and I want to calculate this for values of x to be 1.1547, 1.1547. What's that going to give me? This is minus 3.079, or let me say minus 3.08. So that is minus 3.08, such that I have that point as 1.1547, minus 3.08 as the value of y for x when x is 1.1547. And then when x is minus 1.1547, the value of y also in this equation, we can get that to say we want to calculate this, but now we want to put minus 1.1547 as the value of x. So this is going to be 3.07 now, 3.08. Y is 3.08. So I have another point, 1.1547, 3.08 as the other turning point in this case. So looking at the graph, I can just say that I want to take 3.08. Let me just say here, this will be 3.08. Then just here, minus 3.08 as those values. So if I'm to extrapolate those values that I'm seeing, I'm going to say that in the first case, we have x is 0, that is here, x is 2, that is here, x is minus 2, that is here, and for those horizontal values of x, y is 0. But then to get the turning point, we are saying that for those turning points, when x is 1.1547, y is minus 3.08. So we have this and this point. Okay. And then when x is minus 1.1547, y is 3.08. We have here and this point. And it is just a sketch. So our mandate will be to join all of these together to get our appropriate curve in this particular case. I'm going to just be doing that right about now. So if we compute that appropriately, we are going to have our curve joining all of those points like this. And in this manner, we have been able to sketch the graph for the curve y is equal to s raised to power 3 minus 4s as requested of us, and our full mark will be assured as appropriate. Okay, here again on curves, we are given that a curve has equation y is s raised to power 3 plus ax plus b. Now the stationary points of the curve have these coordinates 2, k and minus 2, 10 minus k. We are to work out the value of a, the value of b, and the value of k. Okay, very good and very interesting. We just need to know that for what we are given that y is equal to x raised to power 3 plus ax plus b, we should know that the differential value of that with respect to x at the turning point is equal to 0 at turning point. Okay, these turning points are the stationary points. So if we get that, we can now say that means let's differentiate this. That dy dx that we are talking about is actually 3s squared. Of course, if we differentiate ax, that will be a. Then that is what we are given to be equal to 0. But looking at what we have it that, but we have these 2 points, 2, k and minus 2, 10 minus k as those stationary points. So first, let's say when x is equal to 2, here in this first case, then we are going to see that 3 multiplied by 2 raised to power 2, because we are putting that as the value for x, okay, plus a, that is equal to 0, such that here 2 raised to power 2 is 4, 4 times 3, that is 12. A is going to give us nothing but minus 12, okay, and then we have it that y is equal to k, because this is x is 2, k is still k, that's the value for y, then a is minus 12, we have gotten that. Then in the second case, when we have x to be minus 2, what are we going to have at the turning point using this differential equation? We are going to have 3 multiplied by minus 2 raised to power 2 plus a is equal to 0, and then again we are still saying that a here, it will still be the same answer, it will be minus 12, because minus 2 raised to power 2 is 4, 4 times 3 is 12. When we subtract 12 from both sides, here will remain a, this will be minus 12. But here the interesting is that y will now be 10 minus k, just as we are given originally, okay? So if you want to now substitute these values back in the original equation, we can say that at x is equal to 2, if you want to put the value for y, Of course, at x is 2, this is x is 2. What is the value for y? In the original equation here is k, so we can say k is equal to, instead of x now, we have 2 raised to power 3 plus ax. What is the value for a? We got a to be minus 12. Okay, multiply by x. What's the value for x? That is 2. Then plus b, which we don't know yet. Okay, let's say we collect like terms. So we have k minus b is equal to 2 raised to power 3 is 8. So we have it as 8. Then minus 12 times 2 is 24. So here we have it that k minus b is equal to 8 minus 24 is minus 16. All right, let's still keep that equation. And then in the second case, at the point when x is equal to minus 2, if you want to use in this original equation, we are going to say that what is the value for y? We gave our x is minus 2, but y is 10 minus k. So we have 10 minus k is equal to the value of x minus 2 raised to power 3 plus a. You can see we also got a to be minus 12. That's quite consistent. Okay, multiply by x now. That value of x is minus 2, then plus b, which we are looking for. Again, if you say we want to try and collect like terms, here minus k and b. Okay, let me just move k to the other side so that I have k plus b will now be, here I have 10, then this is minus 2 raised to power 3 is minus 8. Then if I take it to the other side, it will be plus 8. Then minus 12 multiplied by minus 2 is plus 24. If I take it to the other side, it will become minus 24. This is just some simple simplification so that we have k plus b is equal to 10 plus 8 is 18. 18 minus 24, this is minus 6. And you can see we have these two sets of equation 1 here, and we have this equation 2 here, that we can attempt to solve to try and find the value of k and b. Already we have a to be minus 12, but now we need to find k and b. And looking at what we have as k minus b is equal to minus 16, and k plus b is equal to minus 6. If I'm looking at these two, I can say I want to add the two of them together. K plus k will be 2k, minus b plus b will be 0. This is equal to minus 16 plus minus 6. That's going to be minus 22. And then from here, I can say k is minus 22 over 2, which is minus 11. So having gotten the value of k to be minus 11, from this second equation, I can say k plus b is equal to minus 6, such that b will be minus 6 minus k. So that b will be minus 6 minus 11. So this will be minus 6 plus 11, and that will be 5. Such that here, what we are requested to find, the value of a, we got to be minus 12. A is minus 12, all right? The value of b we got to be 5. B is 5. The value of k, we got to be minus 11. And we use the understanding that even though we have all this information that we are giving, we know that consistently at the turning point, at the stationary point, the value of the differential value of that function is going to be 0. And then we just substitute in those values and then go back to use the value for x and then y to expand so that we have our equations, which we eventually solve to give us a to be minus 12, b to be 5, and k to be minus 11. In this question, we are asked to evaluate correct to 2 decimal places 75.0785 minus 34.624 plus 9.83. So if you want to carry that out, we can just say this is the same as, first, let's carry out this operation, okay, so that we could not be confused by trying to lump everything together. So we can say 75.0785, okay, minus 34.624. Now, so these are 3 digits to the right of the decimal place, and because it's not having any additional number, this particular location is as good as if we are having 0, so that we can carry out the operation seamlessly. Now we have the same number of decimal places in the first case as in the second case, so we can just go ahead to subtract that. 5 minus 0, that is 5. 8 minus 4, that is 4. 7 minus 2 is 5.
Now 0 minus 6, we need to borrow 1 from this 5, okay? So if you borrow 1, this will remain 4. So this will be 10. 10 minus 6, that will be 4. Okay, now we have 4 minus 0, that is 0. 7 minus 3, that is 4. So now we have 40.4545, but we also need to add 9.83 to that. So we just want to add 9.83. Again, we are seeing that these are just 4 decimal places, whereas these are 2 decimal places. We can just make that up by adding zeros to that, such that we can now add all of this together. So 5 plus 0, that will give us 5. 4 plus 0, that is 4. 5 plus 3, that is 8. 4 plus 8, that is 12. So we have 1 remaining that we can bring here. 1 plus 9, that is 10. So we have 0, and we can add that 1 to 4. 1 plus 4, that will now be 5. So 50.2845 is the answer that we're having here. But look at the options. We only have them in 2 decimal places, and we are told to evaluate it correct to 2 decimal places. So the solution we have here is 50.2845 that we want to put in 2 decimal places. And for us to do that, now we can see if it's 2 decimal places, we just have this as our interest. But before we can conclude, we need to know how to deal with this 4, because we need to round it up or we round it down. Now, as a rule of thumb, any number between 0 to 4, they are generally taken down to 0, okay? And numbers between 5 and 9, they are rounded up to 1. And if you round it up to 1, we now add it to the entry just before the number that we are looking at. But in this case, we have 4. So since 0 to 4, we are going to round down to 0, okay? Then that means that this will not have any effect on the next number in consideration, which is 8. And in that case, our answer correct to 2 decimal place will now be 50.28. I didn't mean that this is 5, then we would have taken it to 1 and add it to 8, and that is going to give us 9, and that correct option would have been B. But in this case, since we have 4, okay, and we are rounding up 4 so that we can actually put them in 2 decimal places, then we are going to round 4 down to 0, and 0 plus 8 will be 8, and then the other numbers, they will retain their position. So the correct option out of all these that we're having is option C, 50.28. Alright, that's the correct answer. If x is defined such that x is constituting elements that are less than 7, okay, so that's what the meaning of this statement is. And y is defined such that y is a factor of 24. If these two sets, if they are subsets or subjects of the universal set 1, 2, 3 to 10, we are to find x intersect y. So first, let's take our universal set, because all of the elements we are going to be considering, they need to be under that universal set. So the first thing we need to do is to first define our universal set, and if we are told that it is 1, 2, 3, so we can say it is 1, 2, 3. So these 3 dots means that we should continue listing those elements in that sequential order. So we say 4, 5, 6, 7, 8, 9, and 10. Okay, so we are ending at 10 here, so we are also stopping at 10. Okay, so that's very good. But then we also need to define the other factors. Like in the first case, we are told that x is defined such that x is less than 7. So if we want to define the set x, and we're told that it is less than 7, and of course all the elements will need to be included in the universal set. So what are the numbers in this universal set that are less than 7? So we can take 1, 2, 3, 4, 5, 6, and is 7 going to be included? Of course not, because we are told numbers less than 7. I didn't mean that it is less than or equal to 7, then 7 would have been included. But since we are told it is less than 7, 6 will be the last entry. Okay, then y.
we are told that y is defined so that y is a factor of 24. So we need to ask ourselves, what are the factors of 24? So we want to find the factors of 24, okay? So we can use numbers that we know can be used to divide 24. We have 2 in 24, that is 12. 2 in 12, that is 6. Okay, 2 in 6, that is 3. Then 3 can be used to divide 3. We have 1. Okay, so it is the interpolations of these numbers, including 1, okay, that we are going to consider to get the factors of 24. First, okay, of course, all of these numbers here, like 1, 3, 6, 12, and 24, they are going to be factors of 24. But recall that we are actually limited to numbers from 1 to 10 inclusive. So we have 1, 3, 6, and 12. Okay, so let's note that. What about these two? We have 2, sure. Then here we can say we have 2, good. Okay, but we can also do combination of 2 and 2, that is 4. Okay, but we can also even do a triple combination, 2, 2, and 2, that is 8. All right, or we can also do 2 and 3. Of course, 6 is already reflecting. Then maybe 3 and 4, that will be 12. That will also be greater than the elements in the universal set. So with this, that means we need to look at the constituent elements to be 1, okay, and 2, then 3, 4, 5 is not going to be there because look at all this. 5 is not reflecting at all. Of course, we also have 6, okay. Then since we are combining 2 in 3 places, we also have 8. Is there any other numbers? 9 cannot go, and of course 10 is not part. So these are the constituent elements of the set Y. Okay, so now that is good. So far so good. But we're asked to find X intersect Y. So if you want to find X intersect Y, let's look at the two sets, and we are going to be looking at the elements that are common to the two. That's why we are saying intersect. Okay, the elements that are common to the two. If it is union, we are going to take all of the elements without repeating any. But here we are talking about intersect. So what are the elements that are common to both X and Y that we have defined under this universal set? You can see we have 1. Okay, 1 is there. We have 2. Okay, those are common. We have 3. Those are common. We have 4. Okay, those are common. We have 5 in X, but we don't have 5 in Y, so that is not part of it. We have 6 in X and we have 6 in Y, so these are common. 8 is in Y, but it is not in X. So we've been able to identify the elements that are in the set X intersect Y, and they are 1, 2, 3, 4, and 6. All right. Okay, so 1, 2, 3, 4, and 6 are the elements that satisfies the condition X intersect Y, and we can see looking at the options that we have, option B is corresponding to that. 1, 2, 3, 4, and 6. So option B is the correct solution to this question. In this question, we're asked to simplify 16 over 9 raised to power minus 3 over 2 times 16 raised to power minus 3 over 4. All of these in bracket raised to power 1 over 3. Now, this is a classical question that is going to test our understanding and our application of the rules of indices. And now, if you notice, we are having a fractional power. Okay, we're also having negative power. So, two rules that will help us to be able to solve that is, first, if you have a number, let's say a number A raised to power a negative power, okay, this is the same as if we are having 1 over A raised to power m. Okay, so if you have a negative power, that means you should use that number to divide 1, like we have 1 over A raised to power m. So in the second case, the other rule that will help us when we're having a fractional power, and you are having something like A again, let's say A raised to power m over n. In this case, this is the same as, look at the power, we have n as the denominator. That means we have to find the nth root of A, okay, and then we'll still raise it to the power of m. So those are the rules that will help us to solve this question, and I just want to divide my board so that you can see how best we can solve this. And I'm going to be showing some tips
that will really help you to solve questions like this. And the very key tip I want you to just pick is this: don't try solving all these questions by writing them out line by line. You can take them piecewise. All right, that's where we have the beauty of BODMAS or PEMDAS. You can take things out and first of all, like here we have a bracket. Okay, you can try and evaluate this first expression and then evaluate this expression, then put everything, the result, into this bracket and apply this outer power. It's better that way because we'll be less prone to error. So in this particular case, first we have 16 over 9. Okay, 16 over 9 raised to power minus 3 over 2. Like I explained, using this law of indices, this will be 1 divided by 16 over 9 raised to power 3 over 2. I can take out the negative power because now I'm saying it is 1 divided by the expression that I have. So I've taken care of the negative power. And this is nothing but the same as 1 multiplied by, we now reverse the order, 9 over 16 raised to power 3 over 2. Okay, now we are making some progress. Let's also take it further. If we now want to apply this particular law, and I will take it piecewise, okay, so this will mean that I have this number as, because I'm having 2 as the denominator, so it will be the square root of 9. So I have the square root of 9 over the square root of 16 raised to power 3. Okay, so I've taken care of the denominator in the power by finding the square root of the numbers in that bracket. So I know the square root of 9, I know that to be 3, and the square root of 16, I know that to be 4. So this is 3 over 4 raised to power 3, and I can just express it out. 3 raised to power 3 is 3, multiplying itself in 3 places. 3 times 3, 9, times 3, that's 27, okay, over 4 raised to power 3 is 4, multiplying itself in 3 times 4 times 4, that is 16. 16 times 4, that is 64. Okay, so I can note this, that for this first expression in our question, I have 27 over 64, but that's not all. I also need to work on 16 raised to power minus 3 over 4. So I can say for the second expression, 16 raised to power minus 3 over 4. This just going directly will just be 1 over 16 raised to power 3 over 4. Okay, so I've done it just like this. Then I'm going to have this as 1 over 16 raised to power 3 over 4 will be the fourth root of 16 raised to power 3. Now the fourth root of 16 is asking me for a number that I can multiply by itself in 4 places to give me 16. I know it is 2 because 2 times 2 times 2 times 2 is going to give me 16. So this is the same as 1 over 2 raised to power 3. Okay, 2 raised to power 3 is 8. Okay, so this is 1 over 8. All right, so no problem with that. I can now say that I want to use this to try and solve the question as appropriate, that I can now bring everything into this bracket. So I have something like this. The first expression I got to be 27 over, wow, okay, look at this. I'm noticing something. I'm seeing this to the power of 3 and saying this to the power of 3. I want to raise everything to 1 over 3. So let's just use this fraction to the power of 3 because the powers are common and they can cut out themselves. 3 and 1 over 3 can easily cut out themselves. So I can just use that to say I have this as, instead of writing 27 over 64, let me just put this. I have this as 3 over 4 raised to power 3. Okay, multiplied by the second expression is 1 over 2 raised to power 3. Okay, then all of them are raised to power 1 over 3. Now I can expand this to say I can factor out this power, or even just this power, bring it to multiply each of the entry by opening that bracket. So I will have 3 over 4, okay, raised to power 3, okay. But now when this 1 over 3 is coming, I can say times 1 over 3. This is beautiful, okay. Then multiply by 1 over 2 raised to power 3, okay, then times 1 over 3 also, okay. Yeah, I can say it's 1 raised to power 1 over 3, but I know 1 raised to power any number is 1, so I don't really need that. And I'm doing this because, like I said before, I can observe that this 3 can cut this 3 and this 3 can cut
this 3. And with that, my solution will be 3 over 4 multiplied by 1 over 2. Here, 3 times 1, that is 3. 4 times 2, that is 8. And looking at the options, you can see option C, 3 over 8, and that is the solution to this. So the advice I want to just give you as students is that you don't need to start expressing these out line by line, line by line. You may miss one or two things by doing that. Just take it piecewise, and you can now open it up and solve everything just like we did. And practicing with this type of questions, you will get to build your proficiency in solving questions like this on indices as you come across them. In this question, we're asked to find the least value of x, which satisfies the equation 4x is equal to 7 under modulo 9. Now, the question is, what's our understanding of modular arithmetic? If you really want to get a good grasp of it, there's a video that has been done by Daytooth Academy in which we took time to explain in-depthly how to solve this question. It's a theory question, so we really took time to trash it out. You can check that for your better understanding in the link that is flashing in the video above, or you can check in the description below. But now let's talk about modulo 9. Now, when we're having modulo 9, it's as if we're having something like this. We'll have something like 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so for this particular case, whenever we're to get to 9, we'll round off at 9 because that's the modulo in which we are actually working. So if you have to continue what you are doing, so instead of saying 9, you round off here at 9. So this will be 10, this will be 11, this will be 12, this will be 13, this will be 14, 15, 16, 17. You can see 18 again will also be rounding off at this particular point. Okay, so that will be the cap of what we're actually working with. So if you have to look at this, you can say 10 is congruent to 1 because both of them under modulo 9, they're actually carrying the same value. 11 is congruent to 2, 12 is congruent to 3, 13 is congruent to 4. We cannot write 10, 11, 12, 13 when we're talking about modulo 9. So we will continually write 1, 2, 3. So the loop has been completed, and we just need to take that loop again and again under modulo 9. Now, the question here is that we have to find the least value of x, which satisfies the equation 4x is equal to 7. This is actually what I want you to get. Now, when we're talking about mod 9, the ideal thing for you to do is to look at a division by 9. Okay, consider division by 9. And with the division by 9, you now note down the remainder. So, and get the remainder. I'm just using this as a means of refreshing or understanding of modular arithmetic. Like now, look at this. If I'm talking about 13, okay, if I want to actually talk about 13, I can say that what is 13? I know that 13 to be, now we're talking about 9, 13 over 9, that will be 1, okay, and 13 minus 9, which is the remainder, will be 4 over 9. So looking at this particular little explanation, 4 is the expression of 13 under modulo 9. Okay, so 13 is congruent to 4 in modulo 9. This is how you actually write out the expression. But now, if I have 4 and I need to consider that, what I now need to do is that, okay, I'm saying that 4, I will need to add it to 9. All right, I will need to add that particular 4 to 9 for me to get the expression I'm working when I'm working with modulo 9. So for the particular question that we're looking at here, we're now saying that 4x is equal to 7 under modulo 9, and we cannot say it is, look at this, it's not 4, because if x is 1, we could have said 4 times 1 is 4. So now we are not taking the base value of our modulo, we are looking at the next iteration. That's why we can look at 7, and they said the least value, so it's the next iteration that will take the least value. The second iteration will be a number greater than that least. So since they are talking about the least value of x, then this particular 9, this particular 7, we need to actually add to 9, because like the case of 13 and 4 that I'm talking about, if you add 4 to 9, you're actually going to get 13. So for this question, what we now have will be that we have it as 4x is equal to 7 under mode 9 is nothing but saying we have 4x is equal to 7 plus 9. Okay, that is the least value. I didn't mean that is the second value. We will now say it will be 7 plus 18, just like I indicated there. If it's the third value we are looking at, it will be 7 plus 27, those multiples of 9. Okay, so here we are having 4x is equal to 7 plus 9. That means that we have 4x is equal to 7 plus 9 is 16. And if we divide both sides by 4, we'll see that our x that we are looking for, x will be, this 4 can cancel this 4. 4 here 1 and 4 here 4. X will be 4. So looking at our options, you can see option D is one carrying that 4, and that will be the correct solution to this particular question. What you need to pick if you really want to get this is that when you are actually working in mode 9, that mode you can add to solve this type of question anyway. You can add 9 to 7, that will give us 16. So you can solve for x appropriately. Alright, so 4 is the answer to this question. In this question, we have to express 1 plus 2 log 3 to base 10 in the form log q to base 10. Okay, and we have all these options that they were given in log to base 10. And what we need to note, the key point for us to be able to solve this question is that 1 can be expressed as the logarithm of a particular number to the base of that number. So if we have log of 2 to base 2, that is 1. If we have log of 30 to base 30, that is also 1. But in this particular case, look at what we are working with. We are working with log to base 10. So for our particular question here, we can rewrite this equation to be, instead of 1, we can say that is log to base 10 of 10, because log of a number to the base of that number is 1. Okay, then plus 2 multiplied by log of 3 to base 10. Okay, now you want to express it in this, that means you need to eliminate this particular 2. And another law of logarithm is telling us that this 2, that is the coefficient of log of 3 to base 10, we can take to the power of that logarithm, such that we have it as log of 10 to base 10 plus log of 3 to base 10 raised to power 2. Okay, so this will be log to base 10 of 10 plus log to base 10, 3 raised to power 2 is 9. And then the other rule of logarithm that will help us is that when we have two logarithms that are being added together with the same base, you can just take a particular base and multiply those numbers whose logarithm we are finding by saying 10 times 9. And this will be log to base 10 of 90. So this is now exactly in the order that we're asked to find log to base 10 of q, and here you can see log to base 10 of 90. And looking at the options that we have, this is option A, log to base 10 of 90. Alright. Here in this question, we're asked that if 1012 to base 2 plus 12 to base y is equal to 23 to base 5, we have to find the value of y. Okay, now the rule of thumb for us to follow here is that we should just convert everything to base 10. Let's flatten out this expression, and then we'll be able to solve for y as requested. And to flatten it out, to convert to base 10, we need to take 101 to base 2, convert it to base 10, 12 to base y, convert it to base 10, and 23 to base 5, convert it to base 10. And this is what we do in that case. Since this, let me write it out like this. We have 101 to base 2 plus 12 to base y is equal to 23 to base 5. Okay, now this is what we do. We just multiply each of the entries, multiply by the base, and then we duplicate the power, and I'm going to show that in this case we have 1 times y plus 2 times y, and then to the right hand side we have 2 times 5 plus 3 times 5. Okay, this is the conversion that will really help us to solve this type of question whenever we come across them. All right, so what we now need to do is look at this. Look at 101 to base 2. We start from the right hand side, okay, 1 on the right hand side, and we multiply it by that base, but now we take it in increasing order of its power. Like in this case, we have 2 raised to power 0. For this one, we have 2 raised to power 1. For this one, we have 2 raised to power 2. The same thing we do to y, okay. First, we start from the right hand side, okay. 2 is on the right hand side, okay. So y will be raised to power 0. Then here, the second one, y will be raised to power 1. And then, for the right hand side also, we start from 3. The 5 will take the power of 0, and this 5 will take the power of 1, okay. So if we have that, we can now say we want to go ahead to solve the question. This is 2 raised to power 2 is 4. 4 times 1, that is 4, plus 2 raised to power 1 is 2. 2 times 0, that is 0, okay, plus 2 raised to power 0, any number raised to power 0 is 1. Then 1 times 1, that is 1, okay, plus y raised to power 1 is y. Y times 1, that is y, plus, like I said before, any number raised to power 0 will be 1. So y raised to power 0 is 1. 1 times 2 is 2, okay, is equal to 5 raised to power 1 is 5. 5 times 2, that is 10, plus 5 raised to power 0 is 1. 1 times 3, this is 3. So we can just see 4 plus 1, that's 5 plus 2. We have 7 plus y is equal to 10 plus 3. 10 plus 3 is 13, okay. So if we work on that, we can say y is equal to 13. When 7 moves to the right hand side, it becomes minus 7, so that y is nothing but 13 minus 7. 13 minus 7 will give us 6, okay. So for this particular question, y is 6. So option C is the correct answer. 6 is the value of y for this question. All right. In this question, we are told that an amount of 550,000 naira was realized when a principal X was saved as 2% simple interest for 5 years. We have to find the value of X. What we need to take note of is that the amount that was realized is actually the sum of the principal, okay, plus the simple interest that was generated. All right. So because initially the principal was there in the account, and then the simple interest was accrued to it, such that it is now a total of 550,000 naira. And 550,000 naira is the principal which we are given as S plus the simple interest. So we'll still come back to that. But generally, we know that the formula for our simple interest is the principal times rate times time over 100. So for this particular case, we want to put that into consideration. What's the principal that we're giving? We're giving X to be the principal. The rate, that's 2% times 2, okay? And the time was given as 5 years, okay? So over 100. So this will be 2 times 5 is 10. So this will be 10x over 100. And over 100, and we can just divide so that this will be x over 10, okay. So that is the simple interest. But recall, look at this. But from this particular first expression that we are told, I've been able to clarify that the principal plus the simple interest is what amounts to 550,000 naira. Okay, now what was the principal that we are given? We are told that it is x. So principal is x. What's the simple interest that we are looking at? It's x over 10. This is x over 10 is equal to 550. This is the key thing that we need to note in this question so that we would not mix it up. So in this case, for the left hand side, we find the LCM. We will find this to be 10x plus x is equal to, for the right hand side, we have 550,000 naira over 1. So if we can just cross multiply this, okay, we are going to have, let me just roll this, we are going to have 10x plus x will be 11x is going to be 450,000 times 10. That will be 5.5 million. Okay. And then to get x, we can just divide both sides by 11, so that the x will be this 11. This 11 can cancel this 11, and then this can be used here. 11 in 55, that is 5. Then we have all the other zeros remaining, so that the value of x that we're asked to find is 500,000 naira. Okay, that's the value of x. What we just need to note so that we don't get to miss this question is that the amount we are talking about originally is actually the addition of the principal and the simple interest. So if we add those two, it's going to give us the amount that had been realized, which is 450,000 naira, and solving for that, our x will be 500,000. And looking at the option, we can see option D is the correct one that is giving us our answer. We are given that root 3 plus root 5 over root 5 is equal to x plus y root 15, and we are to find the value of x plus y. Students, whenever you are coming across questions like this, please note what you are asked to find. We are asked to find x plus y, not just x and not just y. So we need to actually go ahead and solve this question, and we are given root 3 plus root 5 divided by root 5, and to solve this particular question, it just be good for us to say break it down to this root 3 over root 5, okay, plus root 5 over root 5. Immediately we do that, you can see that you can see that the symmetry is coming out already, because like in the first case, if you multiply both numerator and denominator by root 5, okay, and then root 5 over root 5 is just 1, because this numerator and denominator are the same, so they will cancel out. Then in that case, we can see that what we're having is root 3 multiplied by root 5 is root 15, okay, then over root 5 multiplied by root 5 is just as if you're having this root 5 raised to power 2, and we are still having our plus 1 here. So this is the same as root 15 over square root of 5 then raised to power 2 is just 5, because it's like you're having 5 raised to power 1 over 2 multiplied by 2. So this power can cancel out, and this will just give us 5. Okay, so that's just similar thing there. Then we can say this plus 1. If we just rearrange, this is the same thing as 1 plus 1 over 5 multiplied by root 15. And you can now see that this is exactly looking like x plus y root 15, in which, look at it, we can now say our x is equal to what is 1, and y is equal to 1 over 5. But what are we asked to find? We're asked to find x plus y. Please don't just make the mistake that now I've gotten the answer but it's not there in the option. No, we're asked to find x plus y. So therefore x plus y will be 1 plus 1 over 5. That's one whole number, 1 over 5. And looking at the options, we can see option C is giving us that. So option C, 1 over 1 over 5, is the correct solution to this particular question in surd. In this question, we are told that if x is equal to 3 and y is equal to minus 1, evaluate 2 multiplied by x squared minus y raised to power 3. At first glance, this question looks like, why are they asking this kind of simple question? But there's something you need to watch out for. Look at what we're asked to find. We're told that, okay, first x is 3, y is minus 1. But what we need to find is, we have to find 2 into x squared minus y raised to power 3. Now, if we just substitute the values that we should put there, we can say this is 2 into x is 3, so we have 3 raised to power 2 minus, what's the value of y? Y is minus 1 raised to power 3. Okay, now this is the correct way to express this, and the question now is that how do we express minus 1 raised to power 3? That's where student most likely will make mistake. As a rule of thumb, let me just know that minus 1 raised to power 3 is minus 1 times minus 1 times minus 1. Okay, in the first case, a negative number multiplying a negative number will give us a positive number, so we have this to be 1 times, because this minus 1 times minus 1 is 1. That's a positive number. Then we still have 1 times minus 1. So now a positive number multiplied by a negative number is going to give a negative number. In short, as a rule of thumb, a negative number, okay, a negative number raised to power an odd number will always give you a negative number. Just note this, please. Whenever you're working, put this at the back of your mind. If you have a negative number and you are raising it to an odd power, that's always going to give you a negative number. So if you are to actually watch that, then this particular question will yield 2 multiplied by 3 raised to power 2 is 9, okay, minus 1 raised to power 3, we have gotten it to be minus 1, okay. And now again, look at this. We are now having our question to be, what we are having is this. We have 2 multiplied by 9, minus times minus is now going to give us plus, so we have 2 multiplied by 9 plus 1, that will be 2 multiplied by 10, because by reason of BODMAS or PEMDAS, we need to carry out the operation in the bracket first, okay. So 10 times 2, that is now going to give us 20, and from the options we can see option C is 20, and that is the correct solution to this question. We just need to note how we carry out the power of our negative number, and we'll be done and dusted with this type of question. All right. In this question, we are to solve 3x minus 2y is equal to 10 and x plus 3y is equal to 7 simultaneously. All right. So I think I would love to use substitution method. It's been a while that I lay attempt on that. But in the first case, we have 3x minus 2y. You can use whatever method is quite easy for you just to solve it. Well, x plus 3y is equal to 7. So if I call this equation 1, I call this equation 2. This is what I'm going to do. From equation 2, I can find the expression for x to be, when this minus 3y, when this 3y moves to the right hand side, it becomes minus 3y. Okay, so I can use this. If I call this equation 3, I can use that equation 3 in 1. Okay, I use equation 3 in 1 to yield 1 will now be 3 multiplied by, instead of writing x now, I will write 7 minus 3y. All right. Okay, then this minus 2y is equal to 10. If I open this bracket, 3 times 7, that is 21. 21 times 3 times minus 3y is minus 9y. Okay, then this minus 2y is equal to 10. Then if I want to take that further, I just rule my board to say, now minus 9y minus 2y is minus 11y. Okay, this is 10. When 21 moves to the right hand side, that will be minus 21, so that minus 11y is equal to minus 11, and if I divide both sides by minus 11, this is interesting. Okay, I can see that minus 11 cut minus 11, minus 11 cut minus 11, so that y is equal to 1. Please notice that negative numbers dividing each other, and that's why I'm having a positive number. Okay, so y is 1, but from this particular expression that I figure that I can say x will be 7 minus 3 y. So if I want to put in the value for y, that would be 7 minus 3 multiplied by 1. So that would be 7 minus 3 times 1 is 3, so that x is 4. So I have the two values here. Y is 1, x is 4. And looking at the options that we're given, you can state the value for x first. X is 4. So of course it's not option A, it's not option B, it's not option C. X is 4, okay. Y is 1, okay. That is option D. And if you just want to confirm, you can take any of the equation. Like in the first case, 3x will now be 12, okay, minus, that will be 12 minus 2 times y. Y is 1, that will be minus 2. So this is 10, which is corresponding to 10 here. In the second case, x is 4, okay, plus 3 times y. Y is 1, so that is plus 3, and that will be 7. And of course, this is also correct. So the correct solution to this question here is option D. Here in this question, we're told that the implication if x then y is equivalent to what? Which of the following options is equivalent to the statement if x then y? Now, this is a classical question on logic, and particularly it is a question that is aimed on implication of logic. Now, we'll take just a case scenario that will help us to correctly interpret this and pick the correct answer. And that is, let's consider a case in which it is raining. So if we are taking x to be the consideration that it is raining, and considering y, we can take that y will be that I am drenched, okay, drenched with the rain. So if we want to get our truth table, we can look at our truth table. Like here we have x, then we have y. Then we need to consider this implication x, if x then y, okay. That's the appropriate interpretation. So if you just want to look at this, we look at case scenarios, the possible case scenarios that can take place with all this consideration. And okay, let's say initially if x is true, or in the second case is true, or if it is false, because these are the combinations that we can have. So in the first case, if x is true and y is also true, okay, if x is true and y is false, if x is false and y is true, if x is false and y is false, okay. So these are the considerations that we need to look at to be able to correctly scope this question, so that we can really get the correct solution out of all this. Now, this is what is going to happen. Looking at this definition that we're having, if it is raining, okay, if x, then I am drenched. Of course, that is true. So if x, then y is true, okay. If it is raining, then I am not drenched. That is not possible. If it's raining and I'm in the rain, then definitely I'm going to be drenched. So this particular case will have to be false, okay. So in the third case, if it is not raining, I am drenched. I may be drenched through some other means. Maybe there's a vehicle that splashed some water to me. Maybe I was passing through a water tank that just got full and was pouring over me. Then it's possible that this statement is true, okay. Then if it is not raining, I am not drenched. Of course, that is also true. If it's not raining, of course, there is no way I'm going to get drenched. Then this particular speculation that if x and y is going to be true. So we have this truth table that we can consider if we look at all these options that we have. Originally, the correct answer will be this option A, but I just want to spell it out by examining the truth table for not y. If not y, then not x, okay. So let's look at that. Now we want to consider if not y, okay, then if not x, then we are looking at the truth table. If not y, then not x, okay. So these are the other factors that we need to look at to consider to be able to solve this correctly. And yeah, let's try and do that. So if I am not drenched, okay, let me just populate this first. So in the first case, we are looking at if not y to be true, true, false, and false. Then if not x, you have true, false, true, and false. So in this particular first case, if I'm not drenched, then it's not raining. Of course, that is going to be true. Okay.
Now, in fact, we don't need to stress ourselves. As a rule of thumb, just look at these two. Look at this. In the first case, we have true, true, true. So this is also being replicated there, true, true, true. In the second case, we have true, false, resulting in false. So this true and false will also result in a false. Okay. False and truth will result in a truth. Okay. And false and false will result in truth. False and false result in truth. All right. So now, having come up with that table, now if you need to just consider this particular table here, this table, and look at this table, you can see that actually the true table is the same for the two. We have TTT here, TTT, TFF, TFF, FTT, FFT, FTT, and FFT. So that means that for the question that we're being asked, we can see that if X then Y is equivalent to, if not Y, then not X. And that is why option A is the correct one. It's a classical question on logic, and this is the right approach to take to solve it. In this question, we are told that the first term of a geometric progression, that is a GP, is 3, and the fifth term is 48. We are to find the common ratio. The formula that will help us to eventually solve this is to find the formula for the nth term of a geometric progression, and that is given at a multiplied by r raised to power n minus 1, where a is the first term, okay, is the first term, and r is a common ratio, which we are asked to find in this particular question. So we are given two case scenario. In the first case, we are told that the first term is 3, so already we are told a is 3, all right. Then we are told that the fifth term is 48. Fifth term will around that T5 is equal to 48. But originally, by reason of this formula, we know that T5 actually should yield AR raised to power 5 minus 1, because it's the fifth term, that's why n is 5. So this implies that we have 48 is equal to, what's the value of A? That is 3, then multiplied by R raised to power 5 minus 1 is 4. Okay, so if you divide both sides by 3, we'll see that to the right hand side the 3 will cut, and then 48 over 3, that will be 16. So we can say our R raised to power 4 is equal to 16, such that R will be the fourth root of 16. The fourth root of 16 means that we are looking for a number that we can multiply in 4 places to yield 16, and that is 2, because 2 times 2, that's 4, times 2, that's 8, times 2, that's 16. You can see this is 2 in 4 places. So the fourth root of 16 is 2, and that warrants that for the question, the solution, the common ratio we're asked to find is 2, and that's option A. All right.
In this question, we are to solve for this inequality that 1 over 3 multiplied by 5 minus 3x is less than 2 over 5 multiplied by 3 minus 7x. So we can just directly write this as a numerator over denominator, like here. 1 times the whole of this will still retain that, so we'll still have 5 minus 3x. Then the denominator, that is 3, is less than 2 times the whole of the numerator, so we have 2 times 3 minus 7x over 5, which is the denominator. And with this is well simplified so that we can just cross multiply. Okay, so if you are to cross multiply, in that case we are going to say this 5, that is the denominator on the right hand side, will multiply this numerator on the left hand side. So we have 5 multiplied by 5 minus 3x is less than, here this 3 that is the numerator on the left hand side will multiply the whole of this 3 that is the denominator on the left hand side will multiply the whole of the numerator on the right hand side. So we have 3 times 2 already, that is 6, then multiply by 3 minus 7x. Alright, so Can I just open up the bracket? 5 times 5, that is 25. 5 times minus 3x is minus 15x. And this is less than 6 times 3 is 18. 6 times minus 7x is minus 42x. And we can easily just collect the like terms, like minus 42x will come to the left hand side, 25 will go to the right hand side. So in that case, we will have minus 15x plus 42x is less than 18 minus 25. You can see the inequality sign is not changing because we are not dividing by a negative number. The only point in which this inequality sign will change is if we are dividing or multiplying both sides by a negative number, but so far we don't need to carry out that. So we have minus 15x plus 42x, that will be 27x, okay, it's less than 18 minus 25, that will be minus 7. And to solve this, we can just divide both sides by 27 and we can see if we are to do that, this 27 here will cut out this, and then our x will be less than minus 7 over 27, okay. And looking at the options that we have, we can see that that is option D, corresponding to x is less than minus 7 over 27. So that's the correct answer to this question. In this question, we are told to make m the subject of the relation k is equal to the square root of m minus y over m plus y. Now, if you want to make m the subject of the relation, that means that we should write the relation in such a way that we are having only m on the left hand side to be equal to all the other variables in whatever form they are going to be relating with one another. Okay, so looking at this question, we are giving this that k is equal to the square root of m minus y over m plus 1. The first thing we need to do is, for us to be able to extract m, we need to knock out this particular square root, and to do that we need to square both sides. So if we are squaring both sides, we can say we are bringing power of 2 to k, we are also bringing the power of 2 to the right hand side. So these two will cancel out this square root, such that we are going to have k square is equal to m minus y over m plus 1. Okay, it's as if we are having k over 1, such that we can say we want to cross multiply, and by cross multiplying we are now going to have it as k raised to power 2 multiplied by m plus 1 is equal to 1 multiplied by m minus y is m minus y. Okay, that's not done, we are still going to continue that. Then now if we open this bracket, you can say we have m multiplied by k raised to power 2, because k raised to power 2 times m is the same as this, okay, then plus k raised to power 2 times 1, that is k raised to power 2 is equal to m minus y. In this particular case, let's collect the like terms, okay, the ones that are similar, let's bring them together, and we are going to have something like this. Let m move to the left hand side. We have m k square minus m, okay, is equal to minus y minus k raised to power 2. Because when this k raised to power 2 moves to the right hand side, it becomes minus, okay. So now looking at this, you can see that on the left hand side, m is common to both, so I can just write a singular m. Then I will have this m multiplied by k raised to power 2 divided by m, it will be remaining only k raised to power 2, okay, minus m divided by m, that will be 1, okay, is equal to minus y minus k raised to power 2. So for me to just eliminate and have only m, I can divide both sides by k raised to power 2 minus 1, so that m will now be minus y minus k square over k square minus 1. But looking at the options that we have, is there anything looking like that? Really, we can consider that it is D, because look at this. This is the key thing. If I factor out minus here, and I have this as y plus k raised to the power 2, okay, over, in this particular case, I can say this is also minus multiplied by 1 plus k square, okay, or let me write it in the order that it's given. Minus 1 multiplied by, yes, is 1 minus k raised to the power 2. So that these two negative numbers, these two negative signs, they will just cancel out, and then m will be y plus k raised to the power 2 over 1 minus k raised to the power 2. It's because we don't have this format of the answer in the options that we are given. That's why we needed to factor out the negative number to have a similar relation in the options that we are given. And looking at all the options, we can see that option B, no, I was saying D the other time, that's not it. Option B, y plus k raised to the power 2 over 1 minus k raised to the power 2 is the correct answer. And that's how you carry out questions on subject of relation or change of subject of formula, just like this. So the option B is the correct answer. In this question, we are to find the quadratic function whose roots are 1 over 2 and minus 1 over 3. That implies that since we are using x as a variable, that statement implies that we are being told that x is equal to 1 over 2 or x is equal to minus 1 over 3. And this is the starting point for us to actually bring these two together. And this is what we do. We take this half and this minus 1 over 3, move them to the left hand side and multiply the two factors together, so that we have here, it will be x minus 1 over 2 is equal to 0, because when 1 over 2 moves to the other side, it becomes minus, okay? Or we have here x plus 1 over 3. When this minus 1 over 3 moves to the left hand side, it becomes plus, so that is equal to 0. So for us to just get the quadratic function, we need to combine the two. It's like we are reverse engineering the solution to quadratic equations that we normally do. So in that case, we just say this is x minus 1 over 2 multiplied by x plus 1 over 3 is equal to 0. Okay, so we can open our bracket now. X times x, that will be s squared. Okay, x times 1 over 3, that will be plus x over 3. Okay, then minus 1 over 2 times x, that will be minus x over 2, because 1 times x is x, then 2 at the denominator. Then minus 1 over 2 times 1 over 3. The negative and the positive number will multiply to give a negative number. Okay, then 1 times 1 is 1, 2 times 3, that is 6, is equal to 0. Before you say you want to go ahead and trying to find the LCM, this is the ideal thing to do. Just multiply both sides by 6. Okay, so this also multiply by 6. We know any number multiplied by 0 will still be 0. So in this case, we can just say this is 6s squared. Okay, then here 6 multiplied by x over 3. The 3 will cut 6 to give us 2, so we have plus 2x. All right, then here 6 divided by 2, that will be 3, so we have minus 3x, because we still need to maintain this negative sign. Okay, then here 6 multiplied by minus 1 over 6, that will be 1, so we have minus 1 is equal to 0. And if we just simplify this, we can see this is just 6s squared, then 2x minus 3x, that will be minus x, then we still have minus 1, and that is equal to 0. And this is what we need to look for in the options. Which one is carrying 6s squared minus x minus 1? That's option D, and that is the solution to that. Okay, in this question, we are given that x is directly proportional to y and inversely proportional to z. X is 15 when y is 10 and z is 4. We have to find the equation connecting x, y, and z. Now, this is a question on variation, okay, and here we are told that x is directly proportional to y and inversely proportional to z. So s is the parent figure here, and we're told that it is directly proportional to y, but inversely proportional to z. That means it is y over z. So here, what it meant is that an increase in y will result to a corresponding increase in x, but an increase in z will reduce the value of x, whereas a decrease in z will increase the value of x. So this is the direct proportion between x and y, and this is the inverse proportion between x and z. Okay, but now we are told to find the equation connecting x, y, and z given this, but we have a case scenario in which we are told that x is 15 when y is 10 and z is equal to 4. For us to turn this variation into an equation, we need to introduce a constant of proportionality, and we can call that k. Okay, so you can say x is equal to k multiplied by y over z. All right, so this is the equation, this is the relation that we need to find out to answer the question correctly. But before that, we need to find the value of k, and to get the value of k, we just need to input those parameters that were given, that x is 15 when y is 10 and z is equal to 4. So if we put all these parameters into this particular equation, we will have 15 is equal to k multiplied by y, that's multiplied by 10, over z, that is 4. Okay, so in this case we can say 2 can go in 10 and 2 can go in 4. We are going to have 5 over 2, and if we solve this, we can say we now want to cross multiply such that we have k will be 15 times 2 over 5. 15 times 2 over 5, we can still use 5 to cut, so our k is equal to 3 times 2, that is 6. But what we need to note is this particular relation, and if we want to put the value of k now, we can just say the equation connecting x, y, and z is given as x is equal to the value of k, that is 6, okay, multiplied by y over z. Okay, and looking at the options that we have, we can see that option A corresponds to this answer, that x is 6y over z. That's the solution. Here in this question, we're told that two buses start from the same station at 9 a.m. and they travel in opposite directions along the same straight route. Now, the first bus travels at a speed of 72 kilometers per hour and the second travels at a speed of 48 kilometers per hour. We are to find the time when they will be 240 kilometers apart. Okay, now let's try and interpret this question correctly so that we'll be able to answer it as appropriate. Here, if we have the straight road, okay, and we have two buses, okay, there's a small representation, and then the other bus moving in the other direction. Okay, let's just take that as representation of our buses. Now, we are told that at 9 o'clock, okay, so let's say initially this is the initial starting point, and the time now is 9 a.m. at this point. Okay, so one is traveling at a speed of 72 kilometers per hour. So here we can say he is going at 72 kilometers per hour, and then the other bus is going at a speed of 48 kilometers per hour. So we need to find the time when they will be 240 kilometers apart. When they will be 240 kilometers apart means that at this point, the distance between the two buses is going to be 240 kilometers. Okay, so distance between the first bus and the second bus. So distance between the first bus. So distance between the first bus and the second bus is going to be 240 kilometers. Okay, so we need to find the time when this will be taking place. Okay, so What we need to know is that in the question we are given the speed and we are looking for the time. There is a formula that relates the two together, that speed is actually distance over time. Okay, that's the definition of speed. Physics students will easily relate with this, but of course it's also applicable for those of us who are not physics students. But now, since they are starting from the same position, they are going to spend the same time on the road. So for the first one, we can say, let's look at, if we call this the bus 1, I'll call this the bus 2. Okay, now if speed is distance over time, then the distance traveled will be speed multiplied by the time. Now what we need to note in this case is that it is the same amount of time that each of the buses will take. So the time it will take for the first bus to cover whatever distance it has covered, and the time it will take for the second bus to cover whatever the distance it has covered is going to be the same. But now the distance is going to be different because they are running at different speed. But we know the total speed to be 240 kilometers. So in that case, if we use t as a time, then we can say that the distance covered by the vehicle A will be 72 multiplied by t, okay, and the distance covered by the second bus will also be 48 multiplied by t, and the total of those two distances will have been given to be 240 kilometers. Now, this is the interpretation that will really allow us to be able to solve this question as appropriate. So 72 plus 48, 2 plus 8, that is 10, remaining 1. 7 plus 4 is 11, plus that one is 120. So we have 120t is equal to 240. Okay, so that t, the time, will be 240 over 120, and that will be 2 hours. Remember, we're talking about hours, but they didn't ask us the amount of time. They said at what time would they be 240 kilometers away. Remember, they started by 9 a.m. So if they start by 9 a.m., then the time they will be 240 kilometers away, the time that they will be 240 kilometers away will be 9 a.m. plus that 2 hours that we just got. Okay, and 9 plus 2, that will give us 11 a.m. and looking at the options we have, you can see option C, that is 11 a.m. We just need to understand that speed is distance over time, and in that case, distance will be speed multiplied by time. Okay, and the total distance from by the two will be the speed of each one multiplied by the time. And since they are taking the same time, so we can use t for that, and solving for t, we can add that amount of time, which is 2 hours that they spend on the road, to the time that they started, which is 9 a.m., and we'll get 11 a.m. So option C is the correct answer. In this question, we are told that a solid cuboid has length 7 centimeters, width 5 centimeters, and height 4 centimeters. We have to calculate its total surface area. For us to really get this, it will be good if you can just have a view of what the cuboid looks like, because it will really help to actually clarify and solve this type of questions. So if we have, let's say we have just a diagram like that, and we're having the other side trying to depict the diagram for a cuboid. Okay, it's a solid shape, and so this is what generally we have. And you can see we have, like, I can say we have 3 sides. So if you have, this is 1, 2, and 3. So now this is what I want you to note. If you can take this particular place, if you say this is the length of the cuboid, here we have the length, this is the width, and this is the height. You can see that this is a replication of these 3 sides. The cuboid is a replication of these 3 sides. So if we really want to find out the total surface area of a cuboid, it's going to be 2 multiplied by the length and the height. Okay, because here we have length, width, and height. So let's just wait with that. Let's be consistent with that. So it's going to be the length times the height, okay, the length times the height, plus the height times the width, the height times the width, plus again the length and the width, the length and the width. All right. Now, because we are just showing 3 here, we also have a replica of that at the other side. If I can just show that, let's say I just want to show that very, very faintly. We have something like this. Okay. So this is actually the representation of the keyboard. Okay. So the total surface area is 2 times the length and the height plus the height multiplied by the width plus the length multiplied by the width. So that's what we just need to input into this particular formula for us to get the total surface area of this keyboard, and that's going to give us 2. What's the length? The length is 7 multiplied by, what's the height? That is 4. Okay, so we have this first, plus the height multiplied by the width. The height is 4 multiplied by the width is 5. Okay, plus again the length is 7 multiplied by the width we are given to be 5. So this is the consistency that will give us the correct solution, and we are going to have 2 multiplied by 7 times 4 is 28, okay, plus 4 times 5, that is 20, plus 7 times 5, that is 35. So we need to add these 3 entries. 28 plus 20, that will be 48, and 48 plus 35, we want to evaluate that. 8 plus 5, that is 13, remaining 1. 4 plus 3, that is 7 plus 1, that is 83. So this is the same as 2 times 83, and 2 times 83 is 2 times 3 is 6, 2 times 8, that is 16 centimeters square. Okay, so if you look at the options that we're giving, we can see that option B is corresponding to this answer, that it is 166 centimeters square. All right. In the diagram, PQ, line PQ is parallel to line SR. So this is PQ and this is SR, and we're told that they are parallel. That is what these double arrows are also indicating. Okay, you can see the same double arrow on PQ is also on SR. That is telling us that these 2 lines are parallel, meaning that they can never meet at any point. They are only running parallel to one another, but we have to find the value of x in this particular location. Now, depending on your choice, there are a number of ways you can go about trying to solve this. For example, you can choose to draw another parallel line here, okay, and say this line is also parallel to the 2 lines PQ and SR. And in that case, if it is parallel, look at this angle X and this particular angle here, they will also be equal because these are alternate angles. You can see they form something like Z. Okay, so one here, another here. These are alternate angles, and also in the same respect, this 68 and this angle here, they are also equal just because they are also alternate angles. And you can see now you have this to be 68, you have this to be X. If you look at this particular point, all of these angles, they meet at the point, and we know that the sum of angles at a point, it is 360 degrees. So we can say 68 plus X plus 246 is equal to 360 degrees, such that in that case you can now say X will be 360 degrees minus the sum of 68 and 246. We have 246 and 68. 6 plus 8, that is 14, remaining 1. 4 plus 6, that is 10, plus the other 1, that's 11. Then 2 plus 1, that's 3. So 360 minus 314 degrees, and that will give us nothing but, so that will be 46 degrees, which is option B. Okay, now that's one way to go about it. Alternatively, let me also show us another way. Alternatively, you can say, look at this particular this particular line, we can say we want to extend it to Q. So from S, I can just say I want to extend this line and just go about it like this. So now, looking at this, I'm now having a triangle PQ to this particular point, and now on this line emanating from S to this, we know this is 180 degrees. So in that case, this angle is going to be 246 minus 180. So I cannot say that 246 degrees minus 180 degrees. 6 minus 0, that is 6. Then I need to borrow 1 here. 14 minus 8, that is also 6. So this particular place is 66 degrees. All right. But then that's not all. I can also look at this angle 68 here, and I can say this place is also going to give me 68. Why? Because this angle that I'm shading in red and this angle here, they are alternate angles. So if I'm doing that, I can now say, look at this now. I have 3 angles. I have X, I have 66, and I have 68. And they constitute angles of a triangle. And the sum of angles of a triangle is 180 degrees. So that X plus 66 plus 68, and say just 66 and 68, 68, okay? 6 and 8, that's 14, remaining 1. 6 and 6, that's 12. That will be 134. So plus 134 is equal to 180 degrees. So X will be 180 minus 134. And you want to solve that, 10 minus 4, because I'm taking 1 from it to add up to this. 10 minus 4, that is 6. So this is remaining 7. 7 minus 3, that is 1. And you can see, again, we also arrive at option B as the correct answer. So these are just various ways you can go about. But once you just understand the concept of parallel lines and the transversal and the angles included there, you'll be able to just solve these questions easily as you go. And the more you practice, the better you are going to become. So the answer to this question is option B. So in this question, we are told to find the equation of the line which is parallel to this equation 2y is equal to 3 into bracket x minus 2 and also passes through the point 2, 3. Now, as a rule of thumb, whenever we are talking about two lines that are parallel or even perpendicular to each other, in the first case, if we are talking about parallel lines, okay, for parallel lines, the slope of the two, we amount that the slope of the first line is equal to the slope of the second line, okay? But for perpendicular lines, for two perpendicular lines, there is a relationship between their slope also that is giving us the product of their slopes, m1 and m2 is equal to minus 1, all right? But generally, there's a general format for the equation of a straight line that is giving us y is equal to mx plus c, where y and x are the two variables. M is the slope, okay, that's the gradient of the line, and c is the intercept on the y-axis, okay? So that's a guide for us to be able to solve this question. But here we are given an equation 2y is equal to 3 into x minus 2. If you can express that equation like this, we can easily get the slope, and then we can compute this particular point that we are giving with the slope to get the equation of the line that we are being asked for, okay? So let's just take this particular one first. Maybe I will need to just bring my board into 2. I will have quite good amount of space to work with. So now, in the first case, we are giving 2y is equal to 3 into x minus 2. Now, if we are to just open this bracket, we'll have it as 2y is equal to 3 times x is 3x. 3 times minus 2 is minus 6. Such that if we want to write only y to stand alone, we can divide both sides by 2. So, in the left hand side, we have only y remaining. On the right hand side, we have 1 over 2 into 3x minus 6. meaning that we divide each of these entities by 2, and in that case y will be 3 over 2x, then minus 6 over 2, that will be minus 3. Now comparing this to the equation of the straight line, that general equation, y equals to mx plus c, we can see that from here our m is equal to 3 over 2. The intercept is minus 3, but we don't need that. But now, having found m to be 3 over 2, in the question we're giving point 2, 3, okay? So we're giving x1, y1 to be 2, 3, and already we have found our m to be 3 over 2. If you want to use the general format of the equation of a straight line, the slope format, you can say y minus y1 over x minus x1 is equal to m, okay? Therefore, if you just put in all these values, y is the variable minus y1, the value of y1 is now 3, okay? This is x comma y, so y in this case is 3, okay, over x minus the value of x1, that is 2, that is equal to the slope that we got, which is 3 over 2. So all we need to do is just to express this particular equation linearly by cross multiplying, so that we can get our options out of all these that we are given. So if you want to just do that, you can see that we have 2 multiplied by y minus 3 is equal to 3 multiplied by x minus 2. Let's just open the bracket. This will give us 2y minus 2 times minus 3 is 6 is equal to 3 times x is 3x, then 3 times minus 2 is minus 6. Wow, interestingly, okay? This is quite interesting because this minus 6 and this minus 6, if we move any to the other side, that will become positive and they will knock out. So we have 2y is equal to 3x, therefore y will be 3 over 2x. Now, what's the implication of this? Look at this. That means that the intercept c is 0, and that is just a clear indication that it is passing through the origin, okay? There's no intercept on the y-axis. It's just a straight line passing through the origin, and that is 3 over 2x. And looking at the options that we are given, you can see option C is equating to that. Y is equal to 3 over 2x, and that is the solution to this particular question. In this question, we are being asked that the expression 5x plus 3 over 6x into bracket x plus 1 will be undefined when s equals what? Okay, now whenever we are coming across questions like this, the expression will be undefined when the denominator is equal to 0. Okay, is when the denominator is equal to 0, that's when the expression will be undefined, because we'll have, in that case, we just have something, a number over 0, and this will be like infinity. That is not defined, that's not specific. It's just a number that is quite large. We don't know the number, it's just undefined. So yeah, for this particular expression here, that means we need to say 6x into bracket x plus 1 is equal to 0. Okay, and in that case, it's either we have 6x to be 0, or on the other hand, we have it that x plus 1 is equal to 0. If 6x is 0, and of course 6 is a number, we don't know what x is, then x will definitely be, in that case, 0, or here x will be minus 1. So the solution is that x will be 0 or minus 1 for this particular expression to be undefined. And if you look at the options, you can see option B is pointing out to that it is either x is 0 or x is minus 1 that will make this expression undefined. So option B is the correct answer. A man is 5 times as old as his son. In 4 years' time, the product of their ages would be 340. Now, if the son's age is y, we have to express the product of their ages in terms of y. So we have 2 case scenarios that we need to look at. First, today, in this present age, and notice that we have been given that the son's age is y. So son, let the son be y. Then we are told that the man is 5 times as old as his son. Then let's just say then the man is 5 times as old as the son will mean 5y. Okay, if the son is y, the man is 5 times as old as his son. Okay, so we have defined that. But we're also told that in 4 years time, so 4 years later, just like all those films that we used to watch, I say 4 years later, 3 years later. Now they're looking at 4 years later, the product of their ages would be 340. Now, what's the product of their ages? The product of their ages will be the multiplication of the two ages, but in 4 years time, the son will be y plus 4, because he would have added 4 years to his age, and then the man will also be 5y plus 4. So that 5 multiplied by y will not be tenable in 4 years time, because both of them would have added 4 years to each of their age. So now we are told that the product of those ages will be 340. So that is in 4 years time. So meaning that the product of the son y plus 4 multiplied by the man 5y plus 4, that product is going to be what? We say it will be 340. So what we have to do is to express the product of their ages in terms of y. So you can see already we are having the format of the options that we are given. We just need to open up this bracket by saying y multiplied by 5y, that will be 5y squared. Okay, y multiplied by 4 will be 4y. Okay, 4 multiplied by 5y, 4 times 5 is 20, and we'll still retain that y. Okay, then 4 multiplied by 4, that will be 16, is equal to 340. Let's just move everything to the left hand side and simplify further. So here we can have this as 5y squared, 4y plus 20y will be plus 24y. Okay, then plus 16 minus 340 is equal to 0, because we have moved 340 to the left hand side, so it will become minus. All right, so if you just want to totally simplify this will just be 5y squared plus 24y. Now if you have plus 16 minus 340, that will be minus 324. I'm spying on the options that we're having already, and I can see that this particular expression is nothing but what we are given in option D. 5y squared plus 24y minus 324 is equal to 0. What we need to note is that I think particularly this particular explanation we need to keep in check after we have gotten the fact that the man is 5 years as old as the son today. Then in 4 years time, we need to add 4 to the age of each of them, and opening up the bracket to give a product of 340, we can solve the question and we're as good as done. All right. In this question, we are to simplify a over b minus b over a minus c over a. Look at this: a, b, c, b, a, b. Interesting. Okay, so we have a over b minus b over a minus c over b. A simple slam and dunk question on fractions. So let's find the LCM. Looking at the denominators, you can see we only have a and b as featuring there. So if we put AB as the denominator, and you can see that's consistent with all the options we have. So AB divided by B, the B will cancel, remaining A. So A times A, that will be A squared. All right. Now AB divided by A here, that is this denominator divided by this denominator here, that will be AB over A. The A's will cancel, that will be only B. So B times B will be minus B squared. All right. Now AB over B here, the B's will cancel, remaining A times C will be minus AC. Okay, so if we look at the options that we have, wow, this is quite slam and dunk. Option D is corresponding to that correct answer, and that's why we have a square minus b square minus ac over ab. That is the solution to this question. In the diagram, XYZ, this is XYZ, is an equilateral triangle of side 6 centimeters, and T is the midpoint of XY, okay? We have to find the tangent of angle XZT. Let's identify all this information that we are being given. First, we are told that this triangle is equilateral, meaning that this side, and this third side, they are equal, okay? However, we are told that T, this point T, is the midpoint of XY. So, this point T being the midpoint means that it divides this line into two equal parts. So, the length of this will also be the length of this, alright? Now, we are told that each of the sides is actually 6 centimeters. So, if we are to label that, we have this as 6 centimeters, we have this as 6 centimeters, and then here is also 6 centimeters, but now we have been told that they are divided into two equal parts. So, this will be 3 centimeters, and this will be 3 centimeters, alright? Then, we are to find the tangent of angle XZT. So, let's find that X, this is X, then Z, this is Z, then T. So, the tangent we are supposed to find is this particular one. We can call it theta. Alright. Now, we can see that this is a right angle here. Already, this is a right angle in which we can use the trigonometry identity SOHCAHTOA to find the tangent. Okay. So, to get the tan of the angle we are looking for, we can say it is tan theta. But from trigonometry identity, we know SOHCAHTOA, tan is opposite over the adjacent, okay? And for this particular question, the opposite is 3, but now look at this, we don't know the adjacent. This is the adjacent. The longest side is the hypotenuse, the side facing the angle is the opposite, and this third side is the adjacent. We don't know. We can call that x, okay? This is x, so let's say 3 over x. Now, how do we find our x? We can use Pythagoras theorem, okay? By Pythagoras theorem, let me just abbreviate that. By Pythagoras theorem, we know that the square of the hypotenuse, 6 raised to the power 2, is the sum of the square of the opposite, 3 raised to the power 2, and the square of the adjacent, x raised to the power 2, okay? So if we are to solve that, that means that x square is 6 square minus 3 square, alright? 6 raised to the power 2 is 36. 3 raised to the power 2 is 9. 36 minus 9, that is 27. So s itself is going to be the square root of 27. And square root of 27 is the square root of 9 times 3, which is 3 root 3. Because the square root of 9 is 3, okay? So that square on top of 9 have been taken care of. We just only have this other root that is remaining, okay? So now we have gotten x to be 3 root 3, but nobody asks us for that. Then we can say the tan theta, which is the tangent of the angle XZT that we are asked to find, is going to be 3 over x. Now we can say that x is 3 root 3, okay? Now if we are to do this, we can say this 3, we cancel this 3, such that the tan of the angle we are asked to find of angle XZT is equal to 1 over root 3, alright? And looking at the options, we can see option A, that is 1 over root 3. This is quite interesting, okay? Is our understanding of SOHCAHTOA and our understanding of the Pythagoras theorem that was applied there that helped us to solve this question correctly to get our answer as 1 over root 3. A fence 2.4 meters tall is 10 meters away from a tree of height 16 meters. We have to calculate the angle of elevation of the top of the tree from the top of the fence. A picture is worth 1,000 words. So this is like a pictorial view of what we should be looking at, okay? And in looking at it like that, we have this, let's say this is our horizontal ground, okay? We are told that the fence, which is 2.4 meters tall. So here, this is the fence, this is the fence. It is 2.4 meters tall. So this height is 2.4 meters. Okay, and then it is 10 meters away from the tree. So the distance between the fence and the tree here is 10 meters. Okay, but the tree is of height 16 meters. So from the ground level up, from here down, this was given as 16 meters. Okay, now we are told to calculate the angle of elevation of the top of the tree from the top of the fence. So what we're being asked is this, that if somebody is now making some observations from the top of this fence, let's say somebody is observing just like this, is looking at the top of the tree. So if you are looking at the top of the tree, normally the eye should look just straight, okay, but that is to the horizontal, that is without the angle of elevation. But now if we are bringing the angle of elevation in, that means the person will be looking from here to the top of the tree. Okay, so now looking at this, we are to calculate the angle of elevation of the top of the tree, of this tree top here, but from the top of the fence. This is the top of the fence, and this is the angle that we're asked to find. Let's call that theta. I want to tone down this particular diagram so that we can see our information clearly. Okay, so yes, this is what we have. Now let me just complete this diagram, because if from the ground level here to the top of the tree is 16 meters, and already from the ground level to the top of the fence is 2.4 meters, then we can find this particular place to be 16 minus 2.4. So 16 meters minus 2.4 meters, that will be 13.6 meters. Okay, and here this particular distance from the position of the observer to the same level on the tree, it's going to be 10 meters, just like the 10 meters that we have gotten here. So we are looking for this particular angle. So relating the angle to the known that we have, this will be the opposite. This side is the opposite to that angle. This 10 meters is the adjacent to the angle. Okay, so what is relating the opposite and the adjacent? From our SOHCAHTOA, we recollect SOHCAHTOA, we can see that is the opposite and the adjacent, that tan theta is equal to the opposite over the adjacent, such that our tan theta in this particular question will be, the opposite is what? Is 13.6, okay, over 10. 13.6 over 10 is 1.36, and then theta in that case will be arctan of 1.36. So we need to bring in our calculator. So we are looking for arctan 1.36. Okay, so this is 53.67. So this is 53.67 degrees. And if you look at the options that we have, we can see option B is corresponding to that, and it is the fact that we are able to interpret our question correctly and juxtapose the right angle triangle from that particular interpretation of the question. That is what enabled us to be able to say, yes, this is a right angle triangle, and then in that case we can use the trigonometry identity SOHCAHTOA to find the angle in question. So the correct option is option B. Fatih buys milk at X naira per tin, okay, and sells each of the tin at a profit of Y naira. If she sells 10 tins of milk, how much does she receive from the sales? Okay, this is a classical question on commercial mathematics. And looking at this per tin, let's take it piecewise. Per tin, for a tin of milk, we have been told that the cost price is X naira. Okay, that's why we're told that Fatih buys milk at X naira per tin. Okay, then we're told that the profit for a particular thing, just one thing, is y naira. Okay, now we need to know the selling price so that we can know how much she receives from the sales, and we know that by reason of our understanding of profit and loss, the profit is the selling price minus the cost price. Okay, in this case we are giving profit to be y. Okay, we are looking for the selling price minus x. So if we just rearrange this, the selling price will be x plus y. Okay, that is in naira. All right, so let me just put that in naira. But this is for 18. This is for 18 now. But we are told that she sells 10 things of milk. Okay, so 10 things of milk, for 10 things of milk, the amount she received from the sales, which is her selling price, will be 10 multiplied by that selling price for a singular entity, which is x plus y. Okay, and you just open the bracket and bring in the unit. That will be 10 multiplied by x plus y. That is the amount she made from the sales of the 10 things of milk. So the correct option, looking at all the options we are given, is option D. Okay, if tan y is positive and sin y is negative, in which quadrant would lie? Now this is talking about trigonometry identity, in which you have our 4 quadrants that students normally take as all students take coffee, and it is depicted like this. Just have a representation of our quadrants, in which we have this as the origin, and this is the positive y, this is the positive x. Okay, then we take our angle starting from the x-axis and going in this anti-clockwise direction. Okay, now this is what we need to note. In the first quadrant, look at this. You can see that we're using the positive values of x and positive value of y. All right, so all trigonometry identities are positive in this place. So we say all. Okay, all are positive here. In this second quadrant, maybe you can just take time to check this out. You will see that we have a positive value of y, but x will be a negative value of x, and down here we'll have a negative value of y. So it had been proven, it had been obtained that in this second quadrant, it is sine that is actually positive. Okay, then in this particular third quadrant, it is t, tangent, that is positive, and here in the last quadrant, the fourth quadrant, it is cosine that is positive. So these are the positive values of what we are looking at, and we want to work with that. We cannot look at it to answer this particular question, all right, in which we are told that tan y is positive. Now generally in this first quadrant, this is the first quadrant here, let's say 1, 2, second quadrant, okay, third quadrant, and the fourth quadrant. So looking at the question we are given, we are told that if tan y is positive and sin y is negative. Okay, now in this first quadrant, all are positive, so that will not be answering the question that we are being told, because we know that yes, here tangent is positive, but sine we are being told that it is negative, but here in the first quadrant it is positive, so it's not in the first quadrant. Okay, then in the second quadrant we see that the sine is positive, so it's not meeting this criteria because they are saying sin y is negative. But here in the third quadrant, you can see tan is positive and every other one is negative, so of course sine will be negative. So this third quadrant satisfies the condition that if tan y is positive and sin y is negative, that means in this particular case our solution will be option C. It will be option C. A very good acronym for you to understand this is to say that all students take coffee. Okay, all students take coffee. This is a very good acronym to understand, being that in the first quadrant all are positive, in the second quadrant sine is positive, in the third quadrant tangent is positive, and in the fourth quadrant, cosine is positive. That is following the migration of the quadrant from the first quadrant anti-clockwise in that direction. Some other people tend to use acts, okay, like Acts of the Apostles in the Bible, but you know this is in the reverse direction, so you need to be careful whenever you are looking at Acts, because here we have A, okay, C, T, and S. That is in the clockwise. This is for the clockwise, but we're actually taking it anti-clockwise. So the correct option here is option C. The dimension of a rectangular base of a right pyramid are 9 centimeters by 5 centimeters. If the volume of the pyramid is 105 centimeter cube, how high is the pyramid? So we need to have a good understanding of what a right pyramid is looking like, okay? And that is a pyramid in which the apex is pinnacle, okay, is directly above the center of its lower dimension. So if we want to depict that, we have something like this. Let's say we just have the base as was given in the question, and then here this is the midpoint, okay, and just trace that up, and now say we are looking at, so we can take this as the base, okay, that's the base, and that base we have been told that it has some dimensions, that it is 9 centimeters by 5 centimeters. So if you want to label appropriately, we can look at that labeling and say this is 9 centimeters and this is 5 centimeters, okay. You can see the apex, the peak of the pyramid, is directly above the center of the base dimension, okay. But we are told here that the volume of the pyramid is 105 centimeter cube. So volume of this pyramid was given as 105 centimeter cube. But what is the formula for the volume? It is 1/3 multiplied by the area of the base shape, okay, multiplied by the height of the pyramid. And in this particular case, we are looking for what? We are looking for the height h, okay, the height from the centroid of the base shape to the apex of the pyramid. So that's what we are looking for, but we are told that the volume is 105 centimeter cube. So if you are to just put in that value directly, you can say this is 105, or just as a rule of thumb, like I love to do, I can make h the subject of the formula, that in this particular case h will now be 3 multiplied by the volume. I love doing this because it makes my work easy, over the area of the base, okay. Now we are told that v is 105. We can calculate the area. So if you have to substitute, you can just say h is 3 multiplied by the volume we are given is 105. Then the area, this is a rectangular base, so the area of the rectangle is length times breadth, which is 9 multiplied by 5. So you can say this is 9 multiplied by 5. And with this, you can just go ahead and cut out 3 here 1, 3 here 3, 5 here 1, 5 in 105, that is 5 in 10 is 2, 5 remaining, okay, this 5, so 5 in 5, that is 1. So our h, you can see, is given as 21/3, and 21/3 is nothing but 7. So 7 centimeters happens to be the height of this right pyramid, and looking at the options we are given, that will be option D. All right. Each interior angle of a polygon is 168 degrees, and we are to find the number of sides of the polygon. Now, as a rule of thumb, there is a general formula to get the sum of the angles of a polygon. Now, look at this question. We're told that each interior angle of a polygon, each one of them being 168, means that it's a regular polygon. So the number of sides is also going to give us the number of interior angles of the polygon. But we know that the sum of angles, some of the interior angles, okay, some of the interior angles of a polygon is given as n minus 2 multiplied by 180 degrees, or some people prefer to just factor out the 2 in this particular 180 and say it is 2n minus 4 multiplied by 90 degrees. Whichever one you choose is the same thing. This is just same as, okay, you are only factoring out 2 from 180 and bringing them inside. But now we are told that each of the interior angle is 168 degrees, so the total angle will be 168 multiplied by the number of interior angles, which is also n. So for this particular question, we can just say 168 multiplied by n, okay, is also equal to what we can compute from this formula, that n minus 2, okay, multiplied by 180 degrees. So we just need to open up this bracket and solve this directly for us to have 168n is equal to n times 180, that is 180n, minus 2 times 180 is 360 degrees. Okay, so if we take 360 to the left hand side so that it will be positive, and we take 168 and to the other side, we can have this to be 180n minus 168n is equal to 360 degrees. Now 180n minus 168n, we have this 2, 10 minus 8 is 2, we have 7 minus 6, that is 1. Okay, 12n is equal to 360, such that our n will be 360 degrees over 12, and 12 can go here 1, 12 can go here, we have 30. So the number of sides of the polygon as requested is going to be 30, and in that case option A, 30, is the correct solution to this question. In the diagram, line MN, this is MN, okay, is parallel to line PQ, this is PQ, and that parallel properties of the two is being indicated by these double arrows that are shown on the two lines. Okay, now we're told that angle MNP, so this angle here is 2x, and angle NPQ, so this angle here is 3x minus 50 degrees. We have to find the value of NPQ. Okay, there are quite some ways you can go about solving this, but ideally this is just a simple slam and dunk question on alternate angles, because since MN and PQ are parallel, then this line joining the two of them is a transversal, and this is actually featuring two angles, 2x and 3x minus 50, that are alternate angles. Okay, both of them, they are alternate angles. So angle, I'll just say angle MNP and angle MPQ are alternate angles. Okay, so the implication of them being alternate angles means that they are equal to each other. So we can say angle MNP is equal to angle NPQ. And now that they are equal means that what is MNP? That's 2x. And what is NPQ? That's 3x minus 50. So if you are to just collect like terms, take minus 50 here and take 2x to the other side, you can just say that means that 50 is equal to 3x minus 2x, and 3x minus 2x is x, so 50 is x, or we can say our x is 50 degrees. Okay, but look at the question. Nobody asks us to find the value of x. What are we asked to find? We are asked to find the value of NPQ. So NPQ. Okay, so the question that was asked, angle NPQ, that was given as 3x minus 50, will now be, let's substitute the value of x, that will be 3 multiplied by 50, okay, minus 50. 3 times 50, that is equal to 150 degrees, minus 50 to give us 100 degrees. Okay, so angle NPQ that we're asked to find is 100, and looking at the options, you can see that is option D. The student may not want to make the mistake that I've solved for x is 50, but looking at all the options, the answer is not there. Let me just move on with my no. You need to get the complete picture of the question you are being asked, and here we are told that we should look for MPQ, which is 3x minus 50, and the solution is 100 degrees. The length of an arc of a circle of radius 3.5 centimeters is one whole number 19 over 36 centimeters. We are to calculate, correct to the nearest degree, the angle subtended by the arc at the center of the circle. If you just want to have a feel of what this is to look like, so that's the circle in question, and we are told that we have the radius of the circle. So if you want to look at that particular radius, okay, so those are the radii, and we can say we are giving this to be 3.5 centimeters, but that the length of this arc is one whole number 19 over 36 centimeters. For me, I will just convert that to a proper fraction to say that one whole number 19 over 36 is the same as 1 times 36. That will be 36 plus 19 over 36. This is the same expression, and we can evaluate it to say 36 plus 19 and 46 plus 9, that's 15. So this is 55 over 36. So the length of this arc, if we call this point A and point B, the length of this particular arc AB, okay, that was given as 55 over 36. So what we're asked to find now is to evaluate the angle in this particular case. If I call that angle theta, that's what we're asked. Now, the general formula for the length of an arc is given as theta over 360 multiplied by 2 pi r. Okay, so for me to be looking for the theta, I can just put in the values and evaluate that directly, or alternatively, I can make theta the subject of the formula to say that my theta will now be 360 multiplied by the length of the arc, okay, over 2 pi r. Now let me just try and put in all those values. 360 times the length of the arc, that's 55 over 36, 55 over 36, okay, now times 1 over 2 pi r, we have 2 times pi originally is 22 over 7, but because we are dividing it, we are now putting it as a denominator. That will now be 7 over 22, okay, then multiplied by the radius. The radius was given as 3.5. So this is what we just need to try and see if we can just evaluate and carry out. Let's try and do this manually. 36 here 1, 36 in 360, 10, okay. We have, this is 2 and 3.5 will multiply to give 7, okay. So we have 22, 55 and 10. 11 can go in 22, 2. 11 can go here 5. 2 can go here 1. 2 can go in 10, 5. So theta that we're looking for, is 5 times 5, and that will be 25 degrees. You can see how optionally changing the subject of the formula can help to input all of these values correctly, and you can use your calculator. You see that we are actually going to get the same answer as this, that theta is 25 degrees. But working maybe in an exam like JAMB TME, you don't need to bring your calculator. Just work directly, put in your values, and you will get that the correct answer to this question here is option C, 25 degrees. In the diagram, line PU is parallel to line SR. So this is PU, okay, and SR, they are parallel. So you can see the triple arrows that are showing that these two lines are parallel. PS and TR, they are also parallel. PS and TR, okay, you can see the double arrows, they are showing that they are parallel. And line QS and UR, QS and UR, they are also parallel, okay? So we need to demystify that so that this doesn't look confusing. That's why you're having a single arrow there. So we identified all the parallel lines. We are told that UR is 15 centimeters, UR, that's 15 centimeters, SR is 8 centimeters, SR is 8 centimeters, PS is 10 centimeters, PS is 10 centimeters, and the area of triangle SUR is 24 centimeters square. So SUR, okay? Let me just try and see if I can note that out just lightly. So here triangle SUR, okay, that area was given as 24 centimeters square. We have to calculate the area of PTRS. Let's identify PTRS. That will be, this will be PTRS, okay, that's a parallelogram, okay, but we are given this particular triangle that we know the area of the triangle, SUR that we identify was given as 24 centimeter square, but we have to look for the area of the parallelogram that was given as PTRS. Now, how do we use all this formula and all this information that we are given to solve for this? Now, recall this, that the area of a triangle, in this particular case, this type of triangle, is given as half multiplied by the base multiplied by the height. The base of the triangle here is 8 centimeters, and the height, I think if we can get the height, that will help us to solve for the area of the parallelogram, because look at this. From U coming down to this other line, okay, that is the height. I can take it as being at a right angle. Okay, I can say this is H. Okay, so looking at that from here, I can say that my H will be 2 multiplied by the area over the B. Okay, so B will be given as 8 centimeters. That's SR, because we are talking about triangle SUR. Okay, so this base is 8, such that our height will be 2 times area. The area was given as 24 over 8. So we can cut 8 here 1, 8 here 3. So H is nothing but 6 centimeters. Okay, but nobody asks us to find A. We are the ones trying to put that into the correct perspective. What is the area of the parallelogram? The area of the parallelogram, this is interesting, is given as the product of the height and the base also. Okay, so here you can see, look at this parallelogram. We have PTRS. The base is 8 centimeters, not the slant height. Okay, these are the lines that we are taking as parallel to each other, and we are looking at this particular height H of the parallelogram, which is also the same as this. I don't want to make it too complicated, but we can see that this is also that H. All right, so is this H that we are multiplying with this base side. Okay, so if you want to just put in that correct value, we just got the value of H to be 6. So that area that we're being asked is going to be 6 that we just got multiplied by B, which is 8, and 6 times 8 is nothing but 48 centimeter square. Okay, and looking at the options that we have, we can see that option number B is 48 centimeter square, and that is the solution to this particular question. Understanding the formula for the area and the parallelogram will really help us, and it has helped us to solve this question correctly. In the diagram, PRQ is a circle with center O. Okay, if angle OPQ, this angle here is 48 degrees, we have to find the value of M. So our task in this particular question is to find the value of angle M here. Okay, no problem with that. Now, looking at this, we'll identify that, look at this, this OQ and this OP, they both constitute the radius of this particular triangle OPQ, okay? And because they are both radii, we can see that they are forming an isosceles triangle, okay? So OQ, line OQ is equal to line OP, because these are radii of the circle. They are radii of the circle, the same circle. They are coming from the center of the circle to the circumference of the circle. Now, if they are radii like this, that means that triangle OPQ is isosceles. Now, these are quite interesting points to note, because if they are isosceles, then we know that the base angles are going to be equal, because that's the property of isosceles triangle. And here we have been given one of the base angles as 48, so this other angle will also be 48 degrees. Okay, you can see a methodological approach that I'm taking to actually demystify this question. Now, if this is 48 and this is 48, already by reason of the properties of triangles, we can say M is equal to 48 plus 48. Why? Because these are the sum of the exterior angle. M is exterior angle, is the exterior angle of that triangle, and is equal to the sum of the two opposite interior angles. The sum of two opposite interior angles. Okay, so if you want to employ that, you can just say, as good as it is, M will just be 48 plus 48, and that will be 96 degrees. Okay, and that will just be option A as a solution to the question. Alternatively, we could have said, okay, let's find this particular angle here. Okay, this angle, and that will be that angle. If I call this theta, I know then theta will be 180 minus the sum of 48 and the other 48. Why am I saying that? Because the three of them, they are angles of a triangle, and the sum of angles of a triangle is 180. So theta will be 180 minus these other two. Okay, in that case, I will get theta to be 180 minus 96. That will be 84. But then M, after doing that, I can now say M plus theta is equal to 180 degrees. Why? Because look at M and theta, they are angles on a straight line, and the sum of angles on a straight line is 180 degrees. Therefore, our M will be 180 minus theta, and theta will just go to be 84. And in the same way, you will see we arrive at the same answer, that M is also 96 degrees. So these are just various ways that the more you practice, the better you become, the more proficient you get to solve questions like this. You can look at it from various angles as befits you, and you'll be able to also carry out the questions as appropriate. So the correct answer is option A. All right. Here in this question, we're told that the pie chart shows the population of men, women, and children in a city. Okay. Now, if the population of the city, the total, is 1.8 million, okay, we need to find how many men are living in that particular city, how many men are in the city. So here we can see the pie chart, and there are also quite a number of ways you can choose to go about it, but this is what I want to do. By reason of the understanding of angles at a point, we know that the angles at a point, they add up to 360 degrees. Okay, so we can say 120 degrees plus 169. If I call this theta, the angle for men, plus theta, the sum of the three will be 360 degrees. All right. However, I can say theta in that case will be 360 minus the sum of 120 and 169. That will be 189. So if I'm to get that, 10 minus 9 is 1. Here I have 5 remaining. If I take 1 from 3, that will be 15. 15 minus 8, that is 7. Okay. No, this is supposed to be 2, not 189. I'm adding 120 and 169, so that is 2. So this is 2. You just have this as 71 degrees. So this theta is given as 71 degrees. Now, the total population was given as 1,800. Now, this is what I would really love to do. The total population corresponds to the whole of this pie chart, and that whole of the pie chart is relatable to 360 degrees. So I can say 360 degrees is relatable to 1.8 million. Okay, but now I'm looking for the number of men in which I found the angle to be 71 degrees. I can relate that to men, and for me to have this, I can just say I want to cross multiply this such that men will be 71 times 1.8 million 3, okay, divided by 360 degrees. This is quite a good way to go about it. You could have said that yes, you want to calculate it as a ratio of the total, but it's actually going to amount to this eventually. Okay, so 36 here, 136 in 180, this is 5, 1, 2, 3, 5,000. Okay, so 71 times 5,000, 71 times 5,000, 1 times 5 is 5. Okay, 5 times 7 is 35. Then we have how many zeros? 1, 2, 3, 1, 2, 3. All right, you can see how to evaluate this without using the calculator at all. So looking at the options, you can see option C amounts to 355,000, and first getting the angle corresponding to men and then relating it as a ratio to the total angle, which is relatable to the total population, you can see that we are able to get the number of men in the city to be 355,000. All right. The mean of the numbers 15, 21, 17, 26, 18, and 29 is 21. We are to calculate the standard deviation. For us to be able to solve this, we need to understand the formula for the standard deviation. That the standard deviation is given as the square root, actually the square root of the variance, and that variance is given as the sum of the square of the difference between each data entry and the mean over the total number of entries. Okay, so S bar, that is the mean. So X is each of the consecutive terms in the data that we are giving. Then we square that difference, okay, and we sum them, and then we divide by the total number of elements. So all we need to carry out is a means of identifying this that we'll be needing in the equation. And if I'm to draw my table, I have X, I have X minus the mean, then the square of X minus the mean. And my data entry, we have 15, 21, 17, 26, 18, and 29. We are going to be summing whatever we got, so we can just do that. Now, our mean was given to us as 21. That's to make our life easy. We don't need to complete that again. So 15 minus 21, that will be minus 6. 21 minus 21 is 0. 17 minus 21, that will be minus 4. 26 minus 21 is 5. 18 minus 21, that will be minus 3. Then 29 minus 21, that will be 8. Okay, so if we are to square these entries, minus 6 raised to power 2 is 36, 0 raised to power 2 is 0, minus 4 raised to power 2 is 16, 5 raised to power 2 is 25, minus 3 raised to power 2 is 9, 8 raised to power 2 is 64. So if you want to just add this, 36 and 16, that will be 4, then 12, that will be 52. 52 and 25, that will be 77. 77 and 9, that will be 86. Then 86 plus 64, then 14, 15. Okay, so that's 150. So here, the sum of this, summation of this data value is 150. So now, you can just go ahead to plug in the correct values for our standard deviation. That will, in this case, be the square root of the sum of this data entry that we have. That's 150 over the total number of entries, that's n. We have 1, 2, 3, 4, 5, and 6 over 6. Okay. Now, the square root of the division of 150 by 6 will yield 25, and the square root of 25 is going to give us 5. So, looking at the options, we can see option C, that is 5, and that is the correct solution to this question. In the diagram, O is the center of the circle. So O here, this is the center of the circle. Okay, you need to note that so that we will identify that line RP is not passing through the center. Then SOQ is the diameter, SOQ, that's the diameter, and angle SRP is 37 degrees, SRP. So this angle here is 37 degrees. We have to find angle PSQ. So PSQ, this is the angle we are asked to find. This angle here, let's call it theta. That's what we're asked to find. Now, how do you go about solving this particular type of question? Looking at this circle, I can readily say that SRP and SQP, they are actually equal, that this angle is also 37 degrees. Why am I saying that? I'm saying that because I know that by reason of the properties of the angles in the same segment, angle SRP is equal to angle SQP. Why? They are angles in the same segment of the circle. Angles in same segment of the circle. Okay, and angles in the same segment, they are equal. So that's why you can see, look at the first one, it starts with from SRP, and the second one SQP. Okay, so the angles in the same segment of the circle, they are actually equal. Then in the second case, I can say that the angle SPQ, that's going to be a right angle, that's 90 degrees. Why? Because it is an angle that is subtended at the circumference by the diameter of the circle. Okay, you know, we are told that SOQ is the diameter of the circle. So this is the angle that diameter subtends at the circumference. Is a variant of the other theorem that the angle subtended at the circumference is half the angle at the center of the circle. And here at the center, you know, is a straight line, that's 180. So here will be 90. So I can say this is a right angle. All right. So the reason here is that it is angle subtended by the diameter at the circumference of the circle. So if we are actually getting all this, our work is quite done for us. We cannot say that from the triangle SPQ, we've now found two angles. We have this to be 37, we have this to be 90, and we know that the sum of angles of a triangle is 180 degrees. So we can say theta plus 37 plus 90 is equal to 180 degrees, because those are the sum of angles of triangles. Sum of angles of triangle. I'm writing all this so that it will just be a priority in our heart to understand the reasons why we are postulating all this and we are coming to the conclusion that we are arriving at. So theta will be 180 minus the sum of 37 and 90. That will be 127. And if you are to carry out that, 180 minus 127 will be 53 degrees. So this is the way I choose to go about something. You can look at some other means that you can also employ. Just be consistent in using the circle theorems correctly, and you will see that your solution will come out for you. So here, correct answer is option C, 53 degrees. In this question, we are to find the sum of the interior angles of a pentagon. So the question we need to ask ourselves is, what is a pentagon? Okay, now generally a pentagon is given as a polygon that has 5 sides. Now we are not being told that it's a regular pentagon, so the sides may not be of the same length, but we are to note it, it will be 1, 2, 3, 4, and 5 sides. Okay, so what we are being asked in the question is the sum of the interior angles. This angle, this angle, this angle, those are the interior angles
of the polygon, that if we add everything together, what is that going to give us? Now, there is a general formula that is used to get the sum of the interior angles of a polygon, okay, and that is given as n minus 2 multiplied by 180 degrees, okay, or like some people like to do, they said it is 2n minus 4 multiplied by 90 degrees. It's the same thing, because from 180 we just factor out 2, so we have 2n and minus 4, and then we have 90. So in this particular case, what we need to identify is what is n. N is the number of sides or the number of interior angles, and for a pentagon that is 5. So in that case, the sum that we're being asked to get, the sum will just be 5 minus 2 multiplied by 180 degrees, and 5 minus 2 is 3 times 180. So what's 3 times 180? 3 times 0 is 0. 3 times 8, that is 24. We have 2 remaining. 3 times 1 is 5 plus that 2, that is 540. So 540 degrees, option C, is the correct solution to this particular question. The diameter of a sphere is 12 centimeters. We have to calculate, correct to the nearest centimeter cube, the volume of the sphere. Okay, if you want to look at this question, this is a pictorial view of what a sphere look like, but we are being told that the diameter of the sphere, that is a run of length from this particular side here to this other side, that was given as 12 centimeters. Okay, if that is 12 centimeters, half of it from the edge of the sphere to the center of the sphere, that will be 6 centimeters, and here the other one will also be 6 centimeters. So for this particular sphere, we can say we have identified our diameter to be 12, that's 12 centimeters. Therefore the radius, which is 12 over 2, half of the diameter, will be 6 centimeters. Okay, that's the very first one we need to do. Then the other question is, what is the formula for the volume of a sphere? Okay, volume of a sphere. The volume of a sphere is given as, so if we are to use that formula, we'll say the volume here will be 4 over 3 multiplied by pi, that is 22 over 7, multiplied by r, that will be 6 raised to the power 3 over 1. Okay, so we can put that into the calculator and say this is 4 then over 3 multiplied by 22 over 7, okay, then multiply by 6 in 3 places. Alright, so this is expressed in decimal place. This is 905.1428. This is 905.14. Okay, but look at the question. We're told to calculate correct to the nearest centimeter cube. If that's what we need to do, then we need to approximate this to the nearest whole number, and 1, if we want to round up 1, that will be 0, and we'll add it to this particular 5, so that we have our answer to be 905 centimeter cube. Okay, so the correct option here is option C, 905 centimeter cube. A bus contains 12 identical balls, of which 5 are red, okay, 4 blue, and the rest are green. We are to use this information to answer questions 39 and 40. So here in question 39, we are told that if a ball is selected at random from the box, what is the probability that it is green? Okay, a pictorial view of what we are talking about is being shown here, in which we have 5 red balls, 4 blue ones, and 5 and 9 constitutes 9. Okay, so since we are told that the total balls that are being featured here are 12, that means the number of the green will be 12 minus 9, and that makes the green balls to be a total of 3. Okay, so that's as it is depicted in the diagram. Now we're told that if a ball is selected at random from the box, what's the probability that it is green? Okay, now generally probability is given as the desired outcome, okay, is the ratio of the desired outcome over the total possible outcomes, okay, over the total possible outcomes that you can imagine from the scenario in which you are looking here. But now in this particular question, we are being told to ask the probability of picking a green ball. Okay, now what's the number of green balls that we have there? We have gotten the number of green balls to be 3. Okay, that will be 12 minus the addition of the other 2. That's 3. Then the total number of balls that we have, what's that? That is 12. We are told in the question. So in that case, the probability of picking a green ball, will be the desired outcome, that is green, which is 3, okay, over the possible outcome. We have a total of 12 eyeballs. So any of them could have been taken from the box. So that would be 12. And if you want to evaluate this, you can just divide 3 here, 1, 3 in 12, that is 4. Therefore, that probability is 1 over 4. And looking at the options, you can see option D, that is 1 over 4. All right. So here in question number 40, still following the information that we are given initially, we are told that if 2 balls are selected at random, one after the other, with replacement, this is what we just need to take note of. We'll say is with replacement. What is the probability that both are red? With replacement means that you first pick the ball, then before picking the second, you return it back into the box. All right. So if you want to evaluate that, we have gotten the formula for probability, but here we're looking at probability of picking red balls. Okay, so in the first case, probability of picking red first, okay, that will be the number of red balls, which is 5, over the total number of balls, which is 12. All right. Then, after taking that red ball, we are told that we also replace it before taking the other one. So the probability of picking red second in this particular scenario will also be the total number of red. Now, since you replace it, the number had been returned to 5. Okay, so that's still 5 over the total number. Since we replace it, the total number also had returned to 12. Okay, now I didn't mean that we are told that it is without replacement. This second case would have been 4 over 11 if it is without replacement. Okay, so that's what you need to note if you are coming across this question in some other exam and we are being told that it is without replacement. All right, so it will be 4 over 11 because the red balls had diminished by 1, the total had also diminished by 1. Okay, but for this particular one, let's just go ahead. We are now told that what's the probability that both are red if we have 2 case conditions here, okay, the first and the second. So the probability that both are red will be the product of these 2 probabilities, 5 over 12 and 5 over 12. And if we want to evaluate that, 5 times 5, that is 25, and 12 times 12, that is 144. And looking at our options, we can see option A is corresponding to 25 over 144, and that is the solution. In the diagram, PQ is a straight line, so this line PQ is a straight line. Now, if M is half of the sum of X, Y, and Z, we are to find the value of M. What will help us first is that we should note that M was given as 1 over 2 of X plus Y plus Z, okay? And all that we have on this straight line, they only constitute X, Y, Z, and the M that we have been given. But now we know that as a general rule of thumb, the sum of angles on a straight line is 180 degrees. So using that postulation, we can say that X plus Y plus Z plus M, the sum of all these angles on the straight line, is equal to 180 degrees. Now look at this. Look at this. We have X, Y, and Z already here. We also have them here denoted in M. So from this particular from this particular postulate that we have been given, that m is half of those, we can see that this x, y, and z, this x, y, and z, their sum is going to be, if we cross multiply here, we are going to have 2m. Okay, and now using that 2m in this particular equation, we can say instead of x, y, and z, we know that is 2m, so we can just say it is 2m plus m, that is going to give us 180 degrees. It's just a simple matter of substituting for the value of the sum of x, y, and z as 2m, and then here we can see that 3m is equal to 180 degrees, and if we divide both sides by 3, we can just cut out to know that this 3 will cancel here. 3 here, 1, 3, 180 degrees, that's 60 degrees. So the value of the m that we're asked to find is nothing but 60 degrees. And looking at the options that we're given, we can see that is being reflected in option B, 60 degrees. Here in this question, we're told that the points on a linear graph means that it is a straight line graph, as shown in the table, this particular table with these values that we have. We are to find the gradient or the slope of the line. Okay, as a general rule of thumb, if you are having the Cartesian coordinates, okay, if you have the Cartesian coordinates and we have a straight line, if you just have a straight line like that, then this gradient or the slope will be depicted as the change in the y-axis, change in this y-axis over a change in this x-axis. So you can say generally the gradient is given as change in the y-axis over change in the x-axis. This implies that if there is a change, then there is an initial value and there is a final value. So the difference between them is what is being referred to here. So we have y2 minus y1 over x2 minus x1. So if you look at the particular question we are given and we say we want to iterate that this is 1, 2, 3. So we can say this is x1, okay, this is y1, this is x2, this is y2. Because it's a straight line, whichever values we want to take, they are actually going to be quite good for us in this particular question. In short, we can say we want to say the second set of values minus the first set of values, or the third set of values minus the second set of values, or even we can say we want to take the third set of values minus the first set of values. It's going to be the same because it's linear. So it's the rate of change on the y-axis that is also constant with the rate of change on the x-axis. So any set of values that I want to use will be suitable for us. So in this particular case, if we want to find that gradient, say m will be, let's say we want to use okay, looking at the question, I'm saying that the first and the third, they look quite easy. We don't have 0.85 in between them, so we can easily subtract. We can say I want to use as y3 minus y1 over x2 minus x1. That's going to give me y3 is going to be 6.5, okay, minus what is y1, that is 3.9 over what is x3 is 7.5 minus what x1, 6.2. okay, so if I want to just find this, I will say 6.5 minus 3.9, 15 minus 9, that will be 6. Then is remaining 5 here. 5 minus 3, that will be 2, so I have this as 2.6 over, in this particular case, 5 minus 2, that's 3, and then here 7 minus 6, that is 1. You can see 2.6 divided by 1 over 3, you know 1.3 can go here 1, 1.3 can go here 2. So that is meaning that my slope m is equal to 2 over 1, and that is equal to 2. So if you look at the options, you can see option B is giving us 2 as the correct answer. You can choose to use any of the interpolation of the points. Yeah, I'm using y3 and y1. You can choose to use y2 and y1, then x2 and x1, or y3 and y2, then x3 and x2. You will see that you will get the same answer. But this is the understanding behind this type of question, and the correct answer is option B. In the diagram, O is the center of the circle, so this is the center of the circle O, okay. Then PQ and RS, this is PQ and this is RS. They are tangents to the circle. We are to find the value of M plus N. So this is M, the angle between the tangent and this particular chord, and this is N, the angle between the tangent also and this other chord. So now we have to find the value of M plus N. There are quite a number of ways you can go ahead to try and solve this, okay. You can say, for example, the angle between a tangent and the radius of a particular circle is going to be 90 degrees, okay. So this particular angle will be 90 minus M, and then the same thing also goes for here. The angle between the tangent and the radius of the circle from O to this point, the angle between them is 90 degrees. So this point you can take to be 90 minus N, okay. Now this being this particular line from this tangent to this other tangent passing through the center of the circle constitutes the diameter, okay. It's dividing the circle into two equal parts. Then if that is the case, this angle here will be 90 because this is the angle subtended at the circumference by the diameter of a circle. So if this is 90, the other two, these two, 90 minus M and 90 minus N, they are also going to be 90 because in short, this angle, and this one, they constitute angles of a triangle, and the sum of angles of a triangle is 180 degrees. So if we sum them, you can actually find the value of M plus N. That's one way, but that's not what I want to do here. I want to just use a particular theorem that will help us to solve this question directly, and it is the alternate segment theorem, okay. The alternate segment theorem. And what's the postulation of this particular theorem? Is one of the circle theorems, and it is saying that the angle between a tangent, okay, and the chord of a circle, so this angle M, is equal to the angle in the alternate segment. So meaning that since this is a tangent, okay, and this is a chord, this angle here is also equal to this angle here. This is also M. That's interesting, okay. Then in the other case, since we are also having the same feature here, the angle between this tangent and this chord that is given as N is also equal to the angle in the alternate segment, is also equal to this angle that is given as N. All right. So that is the implication of the alternate segment theorem. That is one. Then secondly, looking at this particular circle, the line from the two tangents, the line here from PQ and RS, they pass through the center of the circle. So that makes that line the diameter of the circle. And if this is the diameter, then the angle in this particular place, this angle here is going to be a right angle. Why is that? Because it is the angle subtended at the circumference by the diameter of a circle. So that's another theorem. Or you can say, okay, the angle at the center is 180 degrees, okay, but here this is the angle at the circumference. That's going to be half of 180. So this is going to be half of 180, which is 90. So now we have this particular triangle that we cannot say, yes, we understand that the sum of angles of a triangle, here, this triangle, here, we have it as N plus M plus this right angle plus 90 is equal to 180 degrees. And what postulate is that? That is the sum of angles of a triangle, okay? A sum of angles of a triangle, such that N plus M is going to be 180 degrees minus 90 degrees. So, and look at that. Is that not what we have to find? That's what we have to find. So 180 minus 90, that is 90 degrees. And right, and so you can see, looking at our options, that is option B, 90 degrees. It's the understanding of the circle theorems that will help us to know what will be best for us, what will be easiest for us to use, and give us less headache to just come out with our answer as appropriate. In the diagram, O is the center of the circle. So this O, that's the center of the circle. Then if angle NLM, this whole angle, okay, if it's 74 degrees, and angle LMN, this whole angle, if it is 39 degrees, and then angle LOM, this angle is x. We have to find the value of x. So how do you go about solving this question? First, we need to just understand quite a few things. First, we are seeing a triangle and it is inscribed in a circle, so we can use the properties of triangles and circle theorems to solve this question effectively. Now, if we can get this particular angle LNM, okay, we can use circle theorems to postulate the value of x, because x will be twice of that angle according to the circle theorem that says that the angle subtended by an arc, this arc LM, at the center of the circle is twice that subtended at the circumference of the circle. So if we can just get this angle LNM, we can be able to actually solve for x. Now, if we are to look at triangle NLM, this triangle NLM, we can see that the sum of 74 degrees, 39, and this angle, which I'm going to call theta, their sum, we can say that 74 degrees plus 39 degrees plus theta is equal to 180 degrees. Why am I saying that? Because they constitute the sum of angles of a triangle, and sum of angles of a triangle is always 180 degrees, such that in that case theta will be 180 minus the sum of 74 and 39. So 74 plus 39, 4 and 9, that is 13, remaining 1, 7 and 3, that is 10, plus that 1, that is 13. Okay, that is 11. So we have 180 minus 113. 180 minus 113 will be 67. That will be 67 degrees. Alright, so that's the first thing that we are able to get from the properties of triangles. But that's not the whole of our question. We have to find the value of x. Now, if this theta is 167, we can say x, angle x, which is angle LOM, that is angle x, is equal to 2 times 67 degrees. Why are we saying that? Is it because angle subtended at circle center at O is twice angle LNM that we just found to be 67, and that is one of the postulates of the circle theorem, is that the angle subtended by an arc, you can see this is an arc LM, that's the arc, this arc LM, okay, the angle that this particular arc subtends at the center of the circle, that is at x, is 2 times the angle that subtends at the circumference. You can see for both angles we are starting at LOM, okay, and the other one LNM. So in that particular case, our answer that we're asked to find x will be 2 times 67, that will be 134 degrees. All right, and looking at the options that we have, we can see option A is corresponding to that, and that is the answer to this question.
Which of the following is not a sufficient condition for two triangles to be congruent? Okay, so we need to understand what is being meant by the word congruent. Okay, and I have this beautiful set of rules from onlinemathlearning.com that I've brought in that will help us to actually understand this. Now, congruency is being defined as a similarity between two triangles in which you can look at the features of the sides and the angles of those two triangles to see if they are equal to one another. Okay, if they are similar, if they have shared properties that we can postulate from them. And looking at all of this, we can see that first, if all the sides of the triangles, if they are equal, like here, the longest side is equal to the longest side, this side is equal to this and these are equal, then we say that the three sides, SSS, they are equal. So that fulfills the condition for congruency. If on the other hand, we have two sides, okay, you can see these two sides and the included angle, that's why they said SAS, the two sides and the angle between them, and that's why you are seeing this angle between them. If they are equal, then the two triangles are congruent to one another. In the other case, we have two angles, okay, like here we have this angle and this angle and this angle, and you see, and then there is a common side that is also equal. So these two angles are equal, and then this side
that is standing between those two angles, they are also equal, then the condition for congruency is being met. Now, on the other side, if you have two angles and the side that is actually flushing the two of them, here we have this angle, and this is the side that is flushing the two of them, okay, they are also, these two triangles, they are also congruent. And then for the right angle triangle, of course, if they are both right angle triangles, then angle 90 is being included, okay. Then two sides, like here, the hypotenuse and the adjacent, they are also equal. So for these 5 cases, congruency is going to be met. However, if we have two sides, okay, but the angles is not the included angle, like here, look at this, we have 6 and we have 11. Also here, we have 6, we have 11. But the angle in question, look at this angle here. This included angle here is not the same as this included angle here. So the sides and an external angle, if it is an external angle, then the condition for congruency is not being met. And looking at all the options that we are given, you can see AAS, we have AAS, that is met. SSS, of course, that is straight. SSS is met. SAS is met, but SSA, the two sides and an angle to the side, then in that particular case, it is not going to meet the condition for congruency. So option D here is the correct answer. A woman received a discount of 20% on a piece of clothes she purchased from a shop. If she paid $525, what was the original price? So this is a very good question on commercial mathematics, but I would like to take a proportional or a ratio approach to try and solve this. Now, we are told that the woman received a discount of 20%. Now, it's a discount, meaning that originally, if the original amount is tagged at 100%, okay, a discount, 20% discount, 20% discount means it was a reduction of the price, will amount to 100 minus 20, okay, and 100 minus 20, that will be 80%. So what she's paying is 80%. Now we are told that what she paid was actually $525. So $525, in that case, $525 is amounting to 80%, okay. So we are looking for the amount that corresponds to 100%. This is actually the very wonderful fast method to try and solve this question, particularly when you are doing aptitude test. Okay, I remember those days they used to offer aptitude test. You need to find a quick way to be able to solve these questions instead of using cost price, selling price, percentage discount or whatever. This is quite a very good means, and here we can just cross multiply to say, now that means that with this our x will be 525 times 100, okay, times 100% over 80%. So percentages will cut out, and then I can just also try and knock out 10 year is 8, 10 year is 10. So our x, the value of x, which is the original price, will be 5,250 over 8. Okay, so if you want to just evaluate that, we can bring in our calculator to say 5250 divided by 8. What's that value in decimal place? That's $656.25. So that's $656.25. Okay, and looking at the options that we have, just walk through the options. You can see this is option C that is corresponding to our answer, $656.25. It's just the good understanding of discount, appreciation, depreciation, or particularly here that I can relate to ratio and just get out the answer directly. So the correct option is option C. The interquartile range of a distribution is 7, and if the 25th percentile is 16, we are to find the upper quartile. If we have our distribution in something like this, okay, we can actually have a feel of our data entry, and we can just have some divisions in which we are looking at First, we are looking at this is 4 divisions. Okay, 1, 2, 3, 4. And here this will be the 25 percentile, this is the 58th percentile, this is the 75th percentile, and this is the 100th percentile if we are taking it from 0. Now, from this particular question, what we are being told is that we have a difference between the 25th percentile and the upper quartile. The upper quartile is the 75th percentile. So this is upper quartile. This is upper quartile. The 25th percentile is the lower quartile. So this is the lower quartile. But we're told that the interquartile range, originally the interquartile range is given as a difference between the upper quartile, which is Q3, and the lower quartile, which is Q1. But now we have been told the lower quartile, that's 25th percentile. So the Q1 we're given to be 16. Okay, the interquartile range we are given to be what? To be 7. So and we are asked to find the upper quartile, which is the 75th percentile, that's Q3. So we just plug in the values of this data that we are given. Interquartile range is 7 is equal to Q3 that we are looking for minus the 25th percentile, which is Q1. That's Q1. So we can just put in the value as that is 16, such that Q3 will be 16 plus 7. When 16 moves to the left hand side, it will become positive, and 16 plus 7 is nothing but 23. So looking at our options, you can see option C is corresponding to that, and 23 is our answer. We just need to understand this particular set of percentile and the quartile for us to be able to find the interquartile range and substitute as appropriate to get our answer. All right. Here in this question, we're told that the graphs of the equations y is equal to 2x plus 5 and y is equal to 2x squared plus x minus 1, they are shown. So this straight line, the linear graph, is the one corresponding to y is equal to 2x plus 5, and this curve, okay, is one corresponding to y is equal to 2x squared plus x minus 1. So we have to use this information to answer questions 48 and 49. And here, in question 48, we are told to find the point of intersection of the two graphs. Yes, now, normally we know that we normally use graph and we plot the solution to this kind of question, and we look for the point of intersections, in which, in this case, this point here and this point here, the one shown in red, they are the point of intersection. And we can say we want to try and trace them. And if we want to trace them, we'll do something like this. From here, we just move to the left hand side, and then from here we move to the right hand side, and the point on the x-axis is going to be one of the solution. And here also we can see we are moving from here to the y-axis and also to the x-axis, and the point of intersection is also the solution. Now, if you look critically at this, I'm having quite a very difficult time trying to get that point out. For example, look at the first case, okay, in this right hand corner. What I'm saying is 10, but look at the options. I'm not seeing 10 there. And even by the scale of this particular graph, initially I was thinking maybe it was a diagram that was not captured properly, but looking more and more intently, I'm saying that I think it's deliberate, because by reason of a consistent scaling, this should be 5, this should be 10, maybe here should be 15, here is 20, here is 25. But deliberately, they put 5 in between this particular two, okay? And look at, now, if that is not even the case, look at this lower one. This should be 5, okay? This should be 10. Or like they said, like they did in this upper range, this actually should be, now this should be, 5 should be somewhere here. So I think what was being requested was not actually to solve the question from the graph. Yes, the graph was there. I take it as a distraction. What are we solicit that we do? We are asked to find the point of intersection of the two graphs. These 2 points of intersection are the point in which the two graphs, they are actually equal. So I can just say the point of intersection is the point in which 2x plus 5 is equal to 2x squared plus x minus 1. And I will get out the value of x and substitute for the value of y. Alright, so if I want to do that, I will say that is implying that 2x squared plus x minus 1 is equal to 2x plus 5. I move everything to the right hand side, okay, to get the value of y. So I can say I'm having something like 2x squared. When 2x moves to this place, it becomes minus 2x, okay, and then x minus 2x will be minus x, then minus, when we have minus 1 here and we have 5 here, when 5 moves to the left hand side, it becomes minus 5, so the two of them will become minus 6 is equal to 0. And this is what I'm going to do. Now, looking at this, I'm having this particular quadratic equation that I can try and solve with whatever means I find suitable. Looking at this, I'm having a product that is 2 and minus 6. That is, the product is minus 12x squared, and the sum will have to be minus x. Okay, now trying to solve that, what two numbers can I multiply together to give me minus 12x squared? I can consider minus 4x and 3x. Okay, if I'm using that, I know that minus 4 times 3, that is minus 12. X times x, that's x squared, so I'm good. Now, if I'm to sum them, minus 4x being added to 3x will still give me minus x. So I think that is a very good thing to use. I can just say, now, instead of writing minus x, I'll say I still have my 2x squared, okay, but now I'm going to say minus 4x, okay, plus 3x minus 6 is equal to 0. So I can just collect like terms. In the first instance, I have 2x is common to both, so I will have x minus 2 remaining, then plus 3 is common to both, x minus 2 remaining, that is equal to 0. So this is going to give me 2x plus 3 and x minus 2 is equal to 0. If I solve for this, then I can say this is here. I want to manage my space here, so I can say from this particular left hand side, I have 2x plus 3 is 0, or x minus 2 is 0. For this particular case, x will be minus 3 over 2, and here x will be 2. Minus 3 over 2 is the same as minus 1.5. Then for the other case, x is 2. But that's the value for x. Okay. Now, looking at the options that I have in this particular case, I can see that now, where are the options for x to be minus 3 over 2 and 2? Okay, yeah, okay, we have this. Look at this. For all of this, x is 2. In short, that is 2. And for all of this, minus 3 over 2, that's minus 1.5. That's consistent. So the bone of contention is not even the x, it is now the y that we need to look for. Okay, is the y. And for my graph, if I want to look at that, the value for x in the first case, minus 1.5, you can see this is 1, this is minus 1, this is minus 2. Minus 1.5 is originally supposed to be in this particular middle, but it's not reflected there. It's moving towards the left. And here it's supposed to be exactly on 2, but what I have is not exactly on 2. So working from the graph is not what they really want us to do. So I've gotten the value for x to be minus 1.5 and 2. Let me clear my board. So now, from where we are coming from here, we've been able to get that our x is minus 1.5, or the x is 2.0. So now, the task before us is that these particular values for x, we are going to use it in any of these two equations, either the linear equation or the quadratic equation, to find the corresponding values for y. You can even look at the options that we are given. We are seeing that now 2 is common to all of the options, minus 1.5 is common to all of the options. So the bone of contention is not with x, it is y that we need to clarify. So in the first case, when x is minus 1.5, okay, what's going to be our y? If we want to use the equation, y is equal to 2x plus 5, okay. In that case, y will be 2 multiplied by x will be 2 times minus 1.5, okay, plus 5. 2 times minus 1.5 is minus 3, okay, plus 5. Minus 3 plus 5 is equal to 2. So for that first case, when x is minus 1.5, y is equal to 2. Now, I use this particular equation just to get that. In the second case, I can say I even want to use the other quadratic equation, because if we use any of them, we are going to get the same answer. So in the second case, when x is equal to 2.0, I want to use y to be 2s squared plus x minus 1. Okay, so in that particular case, y will now be 2 multiplied by 2 raised to power 2, okay, plus x, that's 2 minus 1. This is going to give me 2 raised to power 2 is 4. 4 times 2 is 8. So we have 8 plus 2, which is 10 minus 1, and that is 9. Okay, so that is going to give me the solution as in the first case, when x is minus 1.5, I have minus 1.5. What's the corresponding value of y? It is 2.0. Okay, and in the second case, when x is equals to 2.0, what's the corresponding value of y? That is 9.0. And you can see, looking at the options that we have, you can see that option A, 2, 9, and minus 1.52, minus 1.52 is the correct solution to this question. So if you are trying to just solve it from the graph and you want to accurately read it, you are not going to get this correctly. This is a good way. This is the way that WAEC even expect that we go about trying to solve this question. And it is our understanding of the intersection between a linear and a quadratic graph that can help us to solve this appropriately to get our answer as option A. All right.
So here in this question number 49, already we have established the fact that we cannot trust the diagram that we are looking at. We need to do our calculation ourselves. We are now being told that if x is minus 2.5, what is the value of y on the curve? Now, what's the equation for y from the curve? We are told that y originally is 2s squared plus x minus 1. That is for the curve. This particular curve is not a straight line, it's a quadratic graph. And that's why we have 2 raised to power 2 times x raised to power 2. Okay, that's why we have the power of x to be 2. But now we're not told that when x is equal to minus 2.5, what is that value of y? You know, if we also say we want to trace, and when x is minus 2.5, okay, this is minus 2, this is minus 3. Yeah, in between the two, we just want to look at what's the value for y. Okay, yeah, okay, then we want to trace to the right. Okay, this corresponding value, you see, it's as if it's lying between 5 and 10, and that midpoint is supposed to be 7.5. But for crying out loud, 7.5 is not even in the option. So let's calculate this and see what we are going to get. So we can say that means that we can plug the value of x as minus 2.5 into this equation, so such that our y will be 2 times minus 2.5 raised to power 2, okay, plus minus 2.5 minus 1, okay. So this is going to give us 2 times minus 2.5 raised to power 2. That will be the same as 2.5 raised to power 2, okay, that's 6.25. So this 2 multiplied by 6.25, okay, then plus multiplied by minus, that will be minus 2.5 minus 1. All right, so in that case, the y will be 6.25 multiplied by 2 will be 12.5, okay, minus 2.5 minus 1, that will be minus 3.5. All right, so 12.5 minus 3.5 is nothing but 9.0. Okay, so you can even see, how can we conclude that this is 9.0? No, it's not closer to 10 in that regard. So, but for this question, we've been able to work out and evaluate that the correct solution to the question that when x is minus 2.5, the value of y on the curve is going to be 9.0. So option C is the correct answer. If x plus 2 is a factor of s squared plus px minus 10, we have to find the value of p. Now, this is a beautiful question on polynomial in which we can employ the factor theorem. Okay, factor theorem is going to help us to solve this question correctly. And here, like we are told that x plus 2 is a factor. So x plus 2 being a factor means that we can say
x plus 2 is equal to 0 because we are solving for quadratic equations. You notice that we solve to a point in which you now say that we have a number of factors, maybe x plus 2 bracket x minus 3, both of them are equal to 0, then x plus 2 is 0, or x minus 3 is 0, then x will be minus 2. Okay, now that's the first thing we need to note. But it's not only stopping there. When we now do this, normally if we plug in the value of x, which is minus 2, into this question, it should give us 0. That's what the factor theorem is postulating, that here the function of x in the particular equation is going to give us 0. So if we want to do the function of x, we can just say what's our x is minus 2. So we are looking for the function of minus 2 in the equation that we are giving as s squared plus px minus 10, and that is going to give us 0. So we just want to do that. We can say instead of x, we are now going to put minus 2 raised to power 2, okay, plus p multiplied by x. X is again minus 2 minus 10, that's going to be 0. So minus 2 raised to power 2, that is 4. P multiplied by minus 2 is minus 2p. Then this minus 10 is equal to 0. If you collect the like terms, we will take minus 2p here and we just rearrange. What we are going to have is that 2p is equal to 4 minus 10, okay, and that is minus 6. Therefore, p is minus 6 over 2, and that will be minus 3. So looking at the option that we have, we can see that this is option B, minus 3, and that's how we can use the factor theorem to solve questions like this whenever we come across them.
We have this question here on set theories, and we are told that if A is defined as a set of multiples of 2, and B is defined as a set of multiples of 3, and C is defined as a set of factors of 6, all these, they are subsets of the universal set that is defined as x in the case in which 1 is less than or equal to x, which is less than or equal to 10. We are to find A complement intersect B complement intersect C complement. So you have seen how to make the statement for this particular question. In order for us to solve this effectively, we need to first define our universal set, because every other thing are going to be subset. They are going to come under that universal set. So to start, we can just say we want to define our universal set to be, here we are told that x, where x is from the range 1 to 10, so we need to define it. Here, look at what they are saying. They said 1 is less than or equal to. Because of the or equal to, we need to include 1, okay? So we just have incremental values 1, 2, 3, 4, 5, 6, 7, 8, 9, and also because we have x to be less than or equal to, because of the or equal to, 10 will be inclusive. Had it mean that it's just less than 10, then we would have stopped at 9. Okay, so this is our universal set. Then we can go ahead to define all that we are given. Like in the first case, A were given to be the multiples of 2. So looking at this particular universal set, what are the multiples of 2 that we can have here? We can have 2 multiplied by 1 is 2, multiplied by 2 is 4, multiplied by 3 is 6, multiplied by 4 is 8, and then multiplied by 5, that is 10. So that is the set that contains the elements of A. And then B, we have to look at B. B is the set that is defining the multiples of 3. So we have 3 multiplied by 1 is 3, multiplied by 2 is 6, multiplied by 3 is 9. Any other value will go beyond the scale of our universal set, okay? And then C is the set that is defined as the factors of 6. So what are the factors of 6? We know we can have 1 times 6 to give us 6, okay? We can have 2 times 3 to give us 6. Then again, we can have 3 times 2 is still 6, and then 6 times 1. But you can see these are just repetitive value of this particular 2. So it will suffice for us to just pick the first 2, and just, if we are to arrange them sequentially. So you can say we have 1, 2, 3, and 6, in which 1 times 6 or 6 times 1 are factors of 6. 2 times 3 or 3 times 2 are also factors of 6. Okay, so we've been able to define our set as we are asked to do. Now, look at what we are asked to find. We are asked to find the intersect of A complement, intersect B complement, intersect C complement. So it's a set that is defining A complement, intersect B complement, intersect C complement. But we have not gotten A complement, B complement, and C complement. We only got A, B, and C. So our next task will be to just define, okay, here I'm coming to A complement. And what do we mean by A complement? We need to define the set of values that are in the universal set, but they are not in A. These are the ones that are in A, but the ones that are in the universal set and are not in A, that is the complement of A, and that's how we notch it A complement. So if we look at the universal set and A, 1 is in the universal set, is not in A, so we have 1 here, okay? But we have 2 in universal set and 2 in A, that's not going to go. We have 3 in universal set, is not in A, so we have 3. In short, since A are multiples of 2, all other numbers that are not multiples of 2, we should put them now. And now we're talking about odd numbers in that case. So 1, 3, 5, 7, and 9, they are the set of values that will constitute the complement of A. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so for B, we can just say we are looking for the complement of B also, and here we have elements in B to be only 3, 6, 9. So every other number we have to just include them. So we have 1, 2, 3 is there already, we don't use that. 4, 5, 6 is there already, we don't use that. 7, 8, 9 is there already, we don't use that, and 10. Okay, so that's the set of values for B complement. And finally, C complement, we are going to define C complement, and here we have C as 1, 2, 3, 6. So just like we've been doing, this will now be 1, 2, 3 are there already, so we can start this from 4, 5, 6 is here, so we can't put 6 again. We have 7, 8, 9, and 10. Wow, interesting. So looking at what we are asked to find, we are asked to find the intercept of these 3 sets now, the A complement, intersect B complement, intersect C complement. We need to look at the elements, okay, that are common to the 3 of them. That's why we're intersecting the 3 of them. And so we can just look here. In the first case we have 1, in the second case we have 1, but it's not in the third case, so that is not going to be the answer. Okay, in A complement we have 3, in B complement we don't have 3, definitely that's not going to be it. In A complement we have 5, good. In B complement we have 5, good. In C complement we also have 5, so 5 is actually common to these 3, and so that qualifies. In the same way, look at 7. We also have 7 in A complement, 7 in B complement, and 7 in C complement. So we can also take 7, okay, and then we have 9 in A complement, but there's no 9 in B complement. We have 8 in B complement, there is no 8 in A complement, so those are not going to satisfy the condition that we're looking for. So holistically, we can just say, after having done this, the set that is defined as A complement intersect B complement intersect C complement is going to be the set in which the elements are containing only 5 and 7. And with this, we've been able to solve this question on set theory. We just need to understand how to interpret the sets that are defined for us, and then look for the complement and look at the common factors, and we'll get our answer as 5, 7. All right. So in this question on commercial mathematics, we are told that tickets for a movie premiere cost $18.50 each, while the bulk purchase price for 5 tickets is $80. So if 4 gentlemen decide to get a 5th person to join them so that they can share the bulk purchase price equally, how much would each person save? So I love the fact that these gentlemen are trying to cut costs. So originally, if they had gone ahead to buy individually, so the total amount total individual purchase would have taken them individual purchase is going to be $18.50 times 5. Okay, so and that is going to amount to 18.5 times 5, that is 92.5. So this is going to be $92.5, but the bulk purchase, as we are told in the question, cost a total of $80. So the savings would have been for the 5 of them. Okay, that's good. The savings for the 5 would have been this $92.50 minus the $80 that they have the option to procure it from, and that will be $12.50. That's the savings for the 5. Okay, so the savings for each one of them will be this savings for the 5 divided by 5, since they are sharing it equally. So the savings per person will just be this particular $12.50 divided by 5, because now this is for the 5 of them. For each person, we just need to divide it, and we want to do that. 5 in 12, that is 2, and 5 times 2 is 10. So 12 minus 10 is 2. So we have point here. 5 in 25 will just give us 5, and we have the 0. So $2.50 would have been the amount that each person of them, each one of these gentlemen would have saved by buying in bulk instead of going to buy individually. So teamwork is good. Let's team up. Here in this question on change of subject of formula, we're told that given that P is equal to RK over Q minus MS, all in brackets raised to power 2 over 3, we have to make Q, this Q, we have to make it the subject of the relation, and then find correct to 2 decimal places the value of Q when P is equal to 3, M is 15, S is 0.2, K is 4, and R is equal to 10. So we have our question drawn out for us, and what we're asked to do is just to change the relation and append Q as the relation which it will be standing alone on one side, and then the other will be on the other side, and we can now solve for that value of Q when we have the values of every other variables that were given in the equation. So what we are given was that P is equal to RK over Q, okay, minus MS all raised to power 2 over 3. What we need to do first is that we should just multiply both sides by 3 over 2. We are doing that so that we can knock off this power that is actually bonding Q, and then that power will be reflecting here, but then we'll be able to isolate Q and solve for it to make it the subject of the relation. And for me to do that, just see what I'm going to do here. If I have my P here, and then I'm multiplying both sides by 3 over 2, then I will just say the right hand side multiplied by 3 over 2, the left hand side multiplied by, it's as if we're having P here is P raised to power 1, okay, then multiplied by 3 over 2. Now this is what is going to happen. This 3 will cancel this 3, and this 2 will cut out this 2. Then here we only have P raised to power 3 over 2, and then on the right hand side we only have RK over Q minus MS, okay. And then for us to further evaluate this, we want Q to be on the side that we can actually relate with, so we can move MS to the other side, and once we do that, this negative sign will become a positive side, so we'll have something like this: P raised to power 3 over 2 plus ms is equal to rk over q. Now, on the left hand side, it's as if we're having all of this over 1. Okay? And then on the right side, we have rk over q. For us to solve that, we can actually cross multiply so that q we can bring to stand on its own. And if we are to do that, we now have q is multiplying the whole of p raised to power 3 over 2 plus ms is equal to rk, because here 1 is multiplying rk to give us rk, q is multiplying the whole of this to give us the whole of this. And once we have this and we want to isolate q, we can divide both sides by the expression in brackets that is multiplying p. So I can say this over p raised to power 3 over 2 plus ms is also equal to rk over the same expression p raised to power 3 over 2 plus ms. Why am I doing this? Because I want to isolate q to be alone, and you can see here this whole expression is cutting out this whole expression, and q that I'm looking for, that we're asked to make the subject of the relation, will be rk divided by p raised to power 3 over 2 plus ms. The critical steps that we took was that starting from the onset, we multiply by the inverse of the power that we have here. So we have 2 over 3 as a power, and we multiply by 3 over 2, which is the inverse of that power, so that we can free up the right hand side from its power. And we are doing that because q is included in that. Okay, so from there we just solve algebraically to arrive at the answer that q is equal to rk over p raised to power 3 over 2 plus ms. This is the solution to the first question that we're asked to solve, that we should make q the subject of the relation. So we'll now go ahead to try and solve for the second one. So now to solve for the second part of our question, already we have found q to be rk over p raised to power 3 over 2 plus ms. But look at what we are given. We are not given that p, each of all these values are appended for us. P is 3, m is 15, s is 0.2, okay, k is 4, and r is 10. So this is just as simple as it can get. We just need to put all of these values, we need to put them into this particular equation to say that we have q is equal to, what's the value for r? That is 10. What's the value of k? That is 4. So we have 10 times 4 divided by, what's the value for p? P is 3. So we have this to be 3 raised to power 3 over 2. Okay. Plus, what's the value for m? M is 15. Then what's the value for s? That is 0.2. Now we need to be careful because we need to bring into our operation the technique of BODMAS or PEMDAS, whichever one you want to call it. That means we should solve the ones in bracket first. On the numerator, we have 10 times 4, that is 40 over 3 raised to power 3 over 2 plus 15 times 0.2, that's if you're having 15 times 2, that is 30. But then the decimal place, which is only 1, will come to affect our 30, and that will give it only 3. Okay, so what we need to actually evaluate now is what this value is going to give us. 40 over, what is 3 raised to power 3 over 2? We can bring in our calculator to say we want to find 3 to the power of 3 over 2. Okay, that's 5.1962. Okay, because this 5 I can round up to 1 and add to this one. 5.1962, 5.1962 plus 3. Okay, so this will be 40 over 5.1962 plus 3 is 8.1962, and that is equal to, so I have Okay, my answer plus 3 is equal to 8.1962. Then 40 divided by that answer, which is my denominator. So I have this as 4.88033. But looking at the question, we are even told to find correct to 2 decimal places. And looking at the calculator, we are seeing that 4.88 and 0 is coming next. Then 0 will not have any effect. So our final answer will be 4.88 because that is in 2 decimal places already. So I can just write this as being approximately equal to 4.88, and that is the solution to this particular question. In this question on ratio, we are given that x plus 2y over 5 is equal to x minus 2y, and we are to find the value of x ratio y. Okay, good. In this question, we can just write out the equation that we are given, that we have x plus 2y over 5 is equal to, here we have x minus 2y. A number divided by 1 is still that number, so I can write this as over 1, and then I can cross multiply, because the aim of what I want to do is to simplify this to its barest minimum and then try to find the ratio x over y from the resulting solution. So here x plus 2y multiplied by 1 will still remain x plus 2y, okay, equal to 5 multiplied by the whole of x minus 2y. Okay, so if I want to open this bracket, I can see this to be x plus 2y is equal to 5 times x is 5x, okay, minus 5 times 2y is 10y, and then I can collect like terms. And looking at this, if I want to take 5x to the left hand side, okay, let me just do that. I will have x minus 5x is equal to, here I have minus 10y, and then when 2y moves to the right hand side, it becomes minus 2y. So I will have x minus 5x is minus 4x is equal to minus 10y minus 2y is minus 12y. Now look at this, or let me just knock out the negative sign first, or just better still, what we want to find is x ratio y, that is like x over y. So I want to divide both sides by y, okay? So I'm saying this is over y, but what I do to the left hand side, I also do to the right hand side, okay? That's the first thing I want to do. Then again, look at this. I want it to be just x over y, but this coefficient of x, which is minus 4, is still remaining here, which is hindering me. So I should also divide by minus 4 and minus 4. So what I'm actually using to divide is minus 4y. So on the left hand side, I can say here I have minus 4 here, can cut minus 4 here. So I will have x over y remaining here. Then here, minus 4 can go in minus 12 in 3 places. Here it can go 1, here it can go 3. So what I'm going to have eventually is that I will have it to be x over y is equal to 3 over 1, because also look at this y has also cut out this y. So I've eliminated y and on the right hand side, and I've eliminated minus 4 on the left hand side. What you just need to note, student, you don't need to be confused with this. What you just need to note here is that what we have is we have minus 4x, and here we have minus 12y. First, divide both sides by minus 4 to knock out the minus 4 that is the coefficient of x, and then because we want it to reflect x over y, then also divide both sides by y. So on the left hand side, you can see here we have x over y, and on the right hand side, the negative numbers will cut out each other to give us 3 over 1, meaning that eventually what we're asked to find, that the value of x ratio y is going to give us 3 ratio 1, and that is the solution to this problem. Here in this question on circle theorems, we're told that in the diagram, O, this O, is the center of the circle ABCDE. Then line BC is equal to line CD, and angle BCD, this angle here, is equal to 108 degrees. we are to find angle CDE. So if you want to identify that, you can just go ahead to say this angle here is the angle CDE that we're asked to find. You can see starting from CD and ending at A. That's the angle we're asked to find. So how do we go about solving this type of question? What we need to bring to mind is our understanding of all the circle theorems that we can employ to try and solve this question. And for me, first and foremost, I'm looking at this question. It's in the compulsory part of the exam paper, and I know that generally questions there are not expected to be as difficult as questions in the other section B. And then look at this. This is even question 3A. Then this should be a simplified work. There are so many theorems I could have tried hacking my head into trying to solve. For example, I know that from the diagram, if I take BD as 2 points that I can actually consider taking angles of the circumference from, like I can have BAD, I can have BED. Those two angles are going to be the same. So the angle here, I know we also equal to the angle here, okay? Because they are angles in the same segment of the circle. And this is the chord. If I draw a line from B to D, just like this, so I know that is obtainable, and angle BAD is equal to angle BED. But because this is just a simplified diagram, do I really need that? I don't think I do. Because if I look at this particular triangle BCD, from the triangle BCD, there's something I can note, because in the question we are told that line BC is equal to line CD. So BC here and CD, they are equal. So the triangle BCD is actually an isosceles triangle. So for an isosceles triangle, the property we know is that the base angles are equal. So if I render this as, let me say this is X, at B here, if I have this as X, then this angle here is also equal to X. And why? Is because they are the base angles of isosceles triangle. So I can say from triangle BCD, angle CBD is equal to angle CDB, and that is X. You can see CBD and CDB, each of those angles is X, and they are equal because they are the base angles of isosceles triangle. So my understanding of an isosceles triangle had helped me to actually postulate that theory, and since I know that, I can now go ahead to add up the sum of the angles of that particular triangle. So from the same triangle BCD, I can say the 180 degrees that we are given plus X, which is the angle here, plus the other X, they are going to sum up to 180 degrees because they are the sum of angles of a triangle. So if they are the sum of angles of a triangle, they normally will sum up to 180 degrees, and then I can just say that implies that 2x is equal to 180 minus 108. So 2x in that case is equal to 72, and if I divide both sides by 2, I can just see that here 2 here we'll call this 2. 2 here 1, 2 in 7 is 3, remaining 1, 2 in 12 is 6. Therefore, angle X can obtain to be 36 degrees. So this X is 36 degrees. But another thing I can also note from the diagram is that, look at this, we were told that O here is the center of the circle. So the line BOE happens to be the diameter of the circle. You can see starting from one end of the circumference, passing through the center of the circle, and ending at the direct opposite end of the circle at the circumference. So this is actually the diameter, and if that is the diameter, then the angle BDE, this angle here, I want to indicate this in blue. This is going to be a right angle because it is the angle subtended by the diameter of the circle at the circumference. So this is because it's angle subtended angle subtended by diameter at the circumference of the circle. Okay, so knowing that this is 90, and initially I can see that the angle that we're asked to look for originally is from this point at C to that inclination at E, and you can see this particular angle is incorporating the two angles that we just evaluated. First, it is x plus 90, so I can say that the angle CDE that we're asked to find from the diagram is equal to angle BDE that we just evaluated to be 90 plus the angle X, which is CDB. Those are the two angles that constitute that angle we are asked to find. So if we are to evaluate that, BDE is 90 and CDB is X, which is 36. So 90 plus 36, that's going to give us 126 degrees. And with that, we can just see that our solution to the question is out and our answer is 126 degrees. What did we make use of? It is our understanding of the fact that the base angles of isosceles triangle, they are equal, and that's why from triangle BCD we can get X, and then if we sum all the angles of a triangle, they add up to 180 degrees, which will help us to evaluate X to be 36 degrees. And then looking at the diameter of the circle BOE, we know that the angle subtended at the circumference by the diameter is a right angle. That's one of the postulates of the circle theorems. And then CDE, which we are asked to find, is the sum of BDE and CDB. So if we add those two, we got our final answer to be 126 degrees. If you want more questions on circle theorem, circle geometry, just go ahead and check our playlist. We have quite a lot of videos, particularly on circle theorems, that you can use to build your proficiency in solving questions like this. All right. Yeah, in this question on trigonometry identities, we are told that given that tan x is equal to root 3 and the value of x is ranging from 0 to 90, so meaning that x is an acute angle, at most it is a right angle, okay? Then we are to evaluate cos x raised to power 2 minus sin x over sin x raised to power 2 plus cos x. So there are actually two ideal ways that you can go about trying to solve this. Is in the first case, you can say you bring your calculator and you are saying that we want to evaluate the arctan of root 3. Like already we are given in the question that tan x is equal to root 3. Then we can say x is going to be arctan root 3, and that's going to give us a particular value that we can evaluate from the calculator. That we want to evaluate arctan square root of 3, and then you want to close the brackets, so that is 60, and that is 60 degrees. And you can see 60 degrees is actually between this range of values that were defined for x. So you can now say you want to get cos x raised to power 2 minus sin x over sin raised to power 2 plus. But I'm not going to be doing that. I'm going to be giving us a pictorial view of our triangle, and for us to be talking about these values like this, perhaps we can actually look at the diagram as if it's a right angle. Okay, let's say you have a right angle triangle here, and in this particular triangle we can take one of the angles to depict x, and then we know that tan x from SOHCAHTOA, we want to look at SOHCAHTOA, which is telling us that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. Tan x will be the opposite side facing x over the adjacent. And look at this, we are told that it is root 3, so we can say this is synonymous to root 3 over 1. So that means from there we have our opposite to be 3, the opposite is not 3, is root 3. Okay, the adjacent is 1. Then we need to find the hypotenuse. So if you want to find the hypotenuse, you can say, looking for the hypotenuse, we can make use of the trigonometry identity. Here we have this to be root 3, which is the opposite, the adjacent to be 1. So what's going to be the value of this? That hypotenuse, the square of it, call it h. H raised to power 2 is actually equals to root 3 raised to power 2 plus 1 raised to power 2. So h raised to power 2 will be root 3 raised to power 2. The power 2 and root will cancel out, so we have that as 1. Then 1 raised to power 2 is 1. So h raised to power 2 is 4, and h itself will be square root of 4, which is 2. We don't need to be talking about plus or minus 2 here, because on the measurement scale we will not have it as -2. So the hypotenuse here is 2. So I just took the pain to express that. We really don't have need of that, because this is actually as plain as you can get. If tan s is root 3, then you have the adjacent to be 1, the hypotenuse to be 2, and the opposite to be root 3. So now for us to evaluate this particular question, we want to look at cos x raised to power 2 minus sin x divided by sin x raised to power 2 plus cos x. So we need to actually find cos s sin s for us to be able to use this. And from what we have defined before, sine is opposite over hypotenuse. So in this particular case, sin x will be, what's the opposite? It's still root 3, okay, over what's the hypotenuse? That is 2. Then cos x will be, the cos is adjacent over hypotenuse. What's the adjacent? That is 1. And what's the hypotenuse? That is 2. So that's what we need to input into this particular equation that we are trying to solve. And for us to do that, we are going to have it that, yeah, cos x we have gotten to be 1 over 2. So we have 1 over 2 raised to power 2, okay, minus sin s is root 3 over 2, okay, divided by sin s again, that's root 3 over 2, all raised to power 2, plus cos x is 1 over 2. So this is what we just need to solve. 1 over 2 raised to power 2 is 1 over 4 minus root 3 over 2 divided by root 3 over 2 raised to power 2. If we take it fraction wise, at the numerator, root 3 raised to power 2 will be 3 as explained initially here. Then over 2 raised to power 2 is 4 plus 1 over 2. So if we want to solve this, for the numerator, we can find the LCM to be 4. And here, 4 divided by 4 is 1. 1 times 1 here will be 1, okay. Then this negative sign minus 4 divided by 2 is 2. 2 times root 3 will be 2 root 3, okay. Over here, we also have 4 as the denominator. Then 4 divided by 4 is 1. 1 times 3, that is 3, plus 4 divided by 2 is 2. 2 times 1, that is 2. So if we are actually to solve this, that means we are going to have, at the numerator, we have 1 minus 2 root 3 over 4, okay, divided by 3 plus 2 is 5 over 4. So if we are to actually solve that, this will become multiplied by 4 over 5, okay. So I just want to do that because I'm running out of space now. So this will be times 4 over 5. So we can see that 4 at the denominator here and 4 at the numerator here, they will cancel out such that our answer will be 1 minus 2 root 3 over 5. So this is going to be the solution to this question. And like I said before, you could have said that you want to evaluate x to be 60 degrees, then you find sine 60 raised to power 2 minus sine 60. So you find cos 60 raised to power 2 minus sine 60 over sine 60 raised to power 2 plus cos 60. But all the same, you still arrive at this. But this is the ideal way that you are actually expected to solve this question And if you do it right, your final answer will be 1 minus 2 root 3 over 5.
This is a question on mensuration of shapes, and we're told that the total surface area of a cone of slant height L centimeters and base radius R centimeters is 224 pi centimeters square. Then, if the ratio of R to L is given as 2:5, we're to find correct to one decimal place the value of R, and then correct to the nearest whole number the volume of the cone. And for this question, we can take pi as 22/7. Now, here is a pictorial view of what we are asked to actually work with, in which we have the cone of slant height L centimeters. So this is L, okay, and then the base radius R is, this is the base radius R. So from the question, we are told that the total surface area of the shape is 224 pi, and then we're also told that R ratio L is equal to 2/5. Okay, that's the mathematical expression for this. R over L is 2/5. Now, we are asked to find, in the first case, the value of R. If we want to find R, we know that the expression for the total surface area is given as pi R square, corresponding to the circular base, plus pi RL, corresponding to the upper part. But in this particular question, look at this. We are given the total surface area as 224 pi, okay? Now, of course, we have even pi. We don't have problem with that. But R and L, they are expressed with respect to one another. So, what would have been ideal is for us to actually express one of them in terms of the other. And looking at the question, we are asked to find the value of R. So, we should let R reflect in the solution we are trying to procure. So what could have been ideal for us to do is to say that from here, if we cross multiply, we can say that L to L is equal to 5R, so that L will be 5/2R. Now, I'm using this because, look at this, it's the value of R that we are looking for. So R should reflect in that equation, since we are not needing L. So for R to reflect in that situation, we can now say that means that our total surface area, which we are given as 224 pi, we can say this is now 224 pi is equal to, look at these two entities. We can see that pi is common to both, so we can just factor out pi, okay? Then even R is also common to both, so we can also factor out R. So here we just have R remaining, plus here we have L remaining. But instead of L, look at this. L has been expressed as 5/2R. Okay, in short, I can also see that R again is common. So first, I can see that pi is common, and I can knock that out, and then I can have this to be 224 is equal to R. Initially we have here another R is also still being expressed here, so I can say that is R square multiplied by 1 plus 5/2. Okay, so if I want to express this correctly, I can just say this is 224 is giving me R raised to power 2. 1 plus 5/2, I can express the LCM as 2. 2 divided by 1 is 2. And here, I have 2 times 1 to be 2. Plus 2 divided by 2 is 1. 1 times 5, that is 5. Such that I can have 224 is equal to R square multiplied by 2 plus 5 is 7/2. And here, if I cross multiply, I can have it that from here, R square is now going to give me 224 times 2/7. Okay, so if I want to express that, I can say R square is equal to 224 times 2 divided by 7, that is 64, so that R itself will be the square root of 64. So the square root of 64 is 8 centimeters. But here we are told to
evaluate it correct to one decimal place. So to just do that is 8.0 centimeters, and that is the solution to this particular question. Now we've been able to do this because we are able to know that from the ratio that we are given, we can express L in terms of R, and since R is what we are looking for, that's why we are doing that. I don't mean that we are looking for L. We could have expressed R in terms of L and then substitute back so that L would have reflected, but here we want R to reflect since that's what we are asked to find. So the radius of this particular cone is 8 centimeters, and we can just reflect that to be, this is 8 centimeters. All right, so we can now move to the second question. So in the second question, we're asked to find the volume of the cone. Okay, the volume of the cone is what we're asked to find there. But recall that initially we are saying that we have R over L to be 2 over 5, and now we have gotten the value of R. But from here we can say that, the other time we cross multiply and we got that L is equal to 5 over 2R, and here that we have gotten the value of R to be 8 centimeters, we can say that means that L is equal to 5 over 2 times 8, and this 2 can cut it to give us 4, so that L is 5 times 4, and that is 20 centimeters. Okay, now L being 20 centimeters, we are finding this because we are going to need that to evaluate the volume of the cone. Now, what's the formula for the volume of a cone? The volume of a cone is expressed as 1 over 3 multiplied by pi r square h, where h is the vertical height of the cone. So for that, we can just express it as, this is h, this is h here, and recollect our L we just got to be 20 centimeters. So L here is 20 centimeters. We have our R to be 8 centimeters, and you can see something is coming out already because the radius and the height, the vertical height of the cone, are actually inclined at a right angle. Here, this is a right angle, and by the Pythagoras theorem, we can see that the square of the hypotenuse, which is the longest side or the side facing the right angle, that is 20 raised to power 2, is equal to the sum of the square of the other two sides. So that is equal to 8 square plus h square. Okay, that's the statement of the Pythagoras theorem, such that h raised to power 2 will be 20 square minus 8 square. Now that implies that h raised to power 2 is 20 square is 400, 8 square is 64. So h raised to power 2 is 400 minus 64 will give us 336, and h will be the square root of 336. All right, so I can just keep that and use directly in the formula for the volume. So now that we know the parameters that we need, pi we have been given to be 22 over 7, r we have gotten to be 8 centimeters, h we have gotten to be square root of 336. We can now go ahead to evaluate the volume of the cone to be 1 over 3 multiplied by pi is 22 over 7 multiplied by r raised to power 2. R raised to power 2 will be 8, so this will be 8 raised to power 2 over 1, okay, multiplied by h is square root of 336. And so we can just take our calculator to express all of this out, that 1 over 3 times 22 over 7 multiplied by 8 raised to power 2 multiplied by the square root of 336. What's that going to give us? This is going to give us 1229.00 1229.003158 3158. Now, if you look at the question, we are seeing that we are asked to find this correct to the nearest whole number. So if you want to just use the nearest whole number, we won't be using any of the decimal places. And you can see 0 actually is not going to be significant to add to this. So the volume of the cone is 1229
29 centimeter cube. Don't forget to put your units. That will earn you your full mark. And with that, this particular question we have correctly solved and we are done with it. This is a question on probability, and we are told that a die was rolled a number of times and the outcomes are shown in the table. So here's the table in which the number of the die are shown at the top and the outcomes are shown at the second row. Now we are told that if the probability of obtaining 2 is 0.15, we are to find the value of m, the number of times the die was rolled, and the probability of obtaining an even number. So in the first case, if we were to look at the value of m, we are told that the probability of obtaining 2 is 0.5, and here when we look at the feature for the number 2, we are saying that the outcomes is being denoted by m, and we don't know what that m is. But if you could recall, the probability is defined as the desired outcome over the total possible outcome. So this is desired outcome that we are looking for out of all the possible outcomes. So we have a desired outcome over the possible outcomes. So if you want to make use of this particular equation, we can say that for this particular die that was being rolled, the desired outcome to obtain 2 is m. You can see that is m, and then the possible outcome is the total of all these outcomes: 32, m, 25, 40, 28, and 45. So you can say our possible outcome for this particular case, the possible outcome is the addition of all the outcomes that we have, and that will be 32 plus m plus 25 plus 40 plus 28 and plus 45, and that's going to give us m. We don't know, so we just know this is m plus, it is m plus another value, and that value is going to be, okay, we have 32 plus 25 plus 40 plus 28 plus 45 again. Okay, that's equal to what? That is 170. So this total possible outcome is m plus 170. Plus, from the definition we have as probability is desired outcome over possible outcome. That means that our desired outcome, which is m, over the total outcome, which is m plus 170, is going to give us what? 0.15. Or you can just write it as 0.15 over 1. And all we have to do is just to solve for the value of m, and we can cross multiply this to say that we have m is equal to 0.15 m plus 0.15 times 170. 170 times 0.15 is equal to 51 over 2, which is 25.5 plus 25.5. So if we take m to the other side, we just have m minus 0.15 m is equal to 25.5. m minus 0.15 will be 1 minus 0.15, because this particular m is just as if we are having 1 as its coefficient. So this will be 0.85 m. 0.85 m is equal to 25.5. So in that case, m will be 25.5 divided by 0.85, and we have to get that on our calculator. 25.5 divided by 0.85 is equal to what? That is 30. So the value of our m from this particular question is that m is equal to 30. So what we've been able to do is that we've been able to use the definition of the probability as desired outcome over possible outcome, and here our desired outcome is m, which you don't know, over all the possible outcomes, which is the addition of all these outcomes, and we equate it to the probability of obtaining 2, which we are given as 0.15, and solving, we're able to get m to be 30. So we can go ahead and try and solve these other 2 questions that were asked. So here in the first case, we've been able to get m to be 30, and here in this second question, we are told that we are to find the number of times that the die was rolled. The number of times that the die was rolled is going to be the addition of all these entries, all of the outcomes. So that number of times is going to be the addition of all the outcomes. And if you recollect, we have just gotten the addition of all of these without m to be 170, and if we add them to it, you can say it's just 170 plus m, and the value of m is 30. So the number of times the die was rolled is 170 plus 30, which is 200. Okay, and then the last question here, we have to find the probability of obtaining an even number. Probability of obtaining an even number. So first, for us to do that, we know that will give us the outcomes of even number over the total outcomes. Now the total outcomes is going to give us 170 plus 30, which is the addition of all this. But where are the even numbers for this particular question? You can see 2 is an even number, 4 is another even number, and 6 is another even number. So that means that the probability of obtaining an even number is going to be the outcomes of all the even numbers. Here we have, and this outcome is m, and m will go to be 30. So we have this as 30 plus the outcome of 4 as an even number, which we are given to be 40, okay, plus the outcome of 6, which is another even number, which we are given to be 45, okay, over the total outcomes for all the numbers of the die, that is 200. We just evaluated that. So this is going to be 30 plus 40 is 70, 70 plus 45 is 105 over 200. We can just simplify that by looking at the barest division, or I can just use my calculator to say this is 115 divided by 200, and that is 23 over 40. So this is 23 over 40, which is obtained by dividing both sides by 5. So 5 here is 23 and 5 here is 40. So the probability of obtaining an even number is 23 over 40. And you can see how the fact that we've been able to evaluate the value of m to be 30 and helped us to get the number of times the die was rolled to be 200, and also helped us to evaluate the probability of obtaining an even number to be 23 over 40. And with that, we have finished this question on probability as requested. So here is a question on a graphical solution to a trigonometry function that we're asked to copy and complete the table of values for the relation y is equal to 3 sine 2x. And here is the table of values. So we're told to use a scale of 2 centimeters to 15 degrees on the x-axis and 2 centimeters to 1 unit on the y-axis to draw the graph of y is equal to 3 sine 2x for values of x ranging from 0 to 150 degrees, okay? So we are to use a graph to find the truth set. This statement means that we should find the solution of these equations, and in the first case, 3 sine 2x plus 2 is equal to 0, and 3 over 2 sine 2x is equal to 0.25. So, like we're told, our first mandate is to copy and complete this table of values for the relation y is equal to 3 sine 2x. And we are going to be taking values of x from 0, 15, 30, 45. But we need to note something. This is where students most likely will make mistakes. You will forget that we are told to use 2x. Look at this question. It is 3 sine 2x. And I'm going to show you on the calculator how you can do that seamlessly. So if you bring in your calculator, this is a very good way to do this. This is just a basic calculator, not too scientific, but you can actually play around it to also try and see how to solve it. We have 3 sine 2 times. Now we now need to input the values of x as we are given on the table. Like in the first case, we have x is 0, so it is 2 times 0. So I can close the bracket and say this is equal to what? It is 0. And you can see as it was given on the table, we have the value of y to be 0 when x is 0. So that was given already and we don't have any problem with that. But what about the second situation in which the value of x is 15 degrees? So you can just press the back button on your calculator and instead of 0, you put in 15 and this is going to be 3 sine 30 because 2 times 15 is 30 and that will be 3 over 2 because sine 30 is 1 over 2, that's half. And times 3, that will be 3 over 2. So you can just express this in decimal and that is 1.5. So here we have 1.5 as the value for y. And then just like that, we will continue by going back to change the value of x. And here in the next one, we've done the one for 15. Then we need to do the one for 30. So 3 sine 2 times 30. And you can see the value here in decimal place is 2.59807611. But if you notice the consistency with which they input these values, they are given in 1 decimal place. So we need to convert this also to 1 decimal place. And if we are going to do that, that means that the 9 that is after the decimal place we want to take, we either round it up or round it down. In short, numbers between 5 to 9, we need to round them up to 1 and add to the number just before them. So 9 we take as 1 and add to 5. So we have 2.6 as the value. So here will be 2.6, alright? And then we can just go on like that. When x is 45 degrees, instead of 30, we have 45. What's that solution? That is 3. We want to put it in 1 decimal place. That will be 3.0. And then when x is 60, you just want to change this. So this is 60. So what's that? This is also 2.6 in 1 decimal place. So this is 2.6. And on like that, you can just input all your values. When x is 90, so what's the value for y? Y will be 0. So this is 0.0, just like they did here in the first case. So when x is 105 degrees, 105 degrees, okay, y is minus 1.5, minus 1.5, and then when x is 120 degrees, you can see I'm being consistent such that I'm not going to make mistake of forgetting to multiply by 2. So this is going to give me minus 2.6 in 1 decimal place or so, okay. And finally, when x is 135, 135, what's the value of y? That will be minus 3.0 in 1 decimal place. So that is a very good means in which you can be sure that you won't make any mistake by forgetting to multiply x by 2. Okay, so that is the first mandate. We have copied and we have completed that table as requested. So we can now, before we draw our graph, okay, before we come up with the solution to the graph and plot the graph, let's look at this question 6c, in which we have to find the truth set of 3 sine 2x plus 2 is equal to 0 and 3 over 2 sine 2x is equal to 0.25. Now, the mandate for us is that we should try as much as possible to reflect y in these particular equations. And in the first case, look at what we are given. In the first case, we are told that 3 sine 2x plus 2 is equal to 0. And looking at the equation, look at this. We already know that y was given as 3 sine 2x. And that means that this first expression in the equation is nothing but y. So we can say y plus 2 is equal to 0, such that the value of y will be minus 2. Now, minus 2 is just a constant, so it's not depending on x. There's no variable that is being reflected there. we just know that y is minus. So it's going to be a straight line graph that is constant across the axis of the x values that we are going to be considering. Okay, it's going to be constant across the x-axis of the graph. So that's just y is equal to minus 2. What about the second case in which we are told that 3 over 2 sine 2x is equal to 0.25? Yes, already we know that 3 sine 2x is x. So this particular equation, I can rewrite it to be, this is the same as 1 over 2 multiplied by 3 sine 2x to give me 0.25. And look at this, 3 sine 2x, is that not y? So I can just write y and say this is 1 over 2 multiplied by y is equal to 0.25. And I can say this is over 1. So if I cross multiply, that means y is equal to 2 multiplied by 0.25. Okay, and 2 multiplied by 0.25 is 0.5. Okay, so y is 0.50 here, and here we have y is minus 2.0. So for the two of them, the value of y is constant, so it's not going to depend on x, meaning that it's going to be a straight line graph that is running across the length of the x-axis. It is just constant, minus 2 in the first case, 0.5 in the second case. So now that we have all that we need to plot our graph, we can go ahead to plot our graph and find the truth set of this solution as requested. Alright. So we need to look at our table of values to see how we can divide the graph to accommodate these values appropriately. It doesn't need to be at the origin, at the center. We just need to look at the values that we have, and it's going to help us to know where we can put the origin of the graph so that we will be able to input all our values as appropriate. Now, if you look at the values for y, you can see that y is increasing in the positive and the negative axis. So we can just know that. That means we can divide the graph into two equal parts to cater for y. So we can just go ahead to do that. Now for the x, we have how many values for x here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are 11 values for x, but the graph, the standard graph, is ideally 12 divisions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that means I can actually choose to start from this particular first box, and it will be able to cater for all the values that we have. So vertical axis can be drawn here just to cater for all the values of x that we are noticing on the graph. So we can just draw our straight line there, the origin 0, and this is the positive y, okay, and this is the positive x. Okay, so now if we want to scale appropriately, we've been told that we need to have 15 degrees represented by 2 centimeters on the x-axis. So this will be 15, 30, 45, 60, 75, okay, and 90, 105, 120, 135, and 150. Alright, so it's because I was able to scale my graph correctly. That's why you can say from 0 to 150, they are taken appropriately on the x-axis, and then on the y-axis, 2 centimeters to represent 1 unit. So this will be 1, this will be 2, 3, and 4, and 5. Okay, and this will be minus 1 because we have negative values. Minus 2, minus 3, minus 4, and minus 5. So our scale on the graph is quite interesting. We are done and dusted with that. Then in that case, we now need to look at how we can plot these values to one another. Like in the first case, when x is 0, y is also 0. So here at the origin, we have x is 0 and y is 0, and I'm using my blue ink to indicate that, so that students out there, you can see this clearly, okay? So when x is 15 degrees, here 15 degrees, y is what? 1.5. So this is 1, okay, and this is 2. In between them is going to be 1.5, but for x, that is 15. So I can just say I want to trace like this, 15 going up, okay, and then 1.5 coming in between 1 and 5. And the point of intersection here is the point that is corresponding to x 15 and y is 1.5. So I will just note that, and I can just directly notice it is going to be here. All right. Okay, so when x is 30, y is 2.6. So this is x is 30 here. Y is going to be 2.6. Now, this is 2, this is 3, and here I have 1, 2, 3, 4, 5 divisions of my boxes. So, if that's the case, I will just need to take it that the first one here is 2.2, this will be 2.4, this will be 2.6, this will be 2.8, and then you can see it's not 3.0. I'm just having incremental values of 0.2 units. So, if I'm going to just take that, I can easily see that 2.6 is coming somewhere here, and the point of intersection here is what I need to note. So if I'm to know that, I will see that it is just coming here on the graph. That is the graph that's the point of intersection for x to be 30 and y to be 2.6. And then when x is 45, y is 3, that is quite straight. And now, because it's a trigonometry graph, it's going to be a sinusoid. It just repeats, like it's going this positive axis, it will also decline with the same value, and that is why you can see when x is 60, y is what? 2.6 again. So it's just here. You can see that it's symmetrical with this initial value, just on the same line, 2.6 and 2.6. In the second case, it will be 75 and 1.5. So 75 and 1.5 that we got initially. You can see how it's shaping out to be symmetrical. When it is 90, when x is 90, y is 0. So here we have the 0 and 90. So when x is 105, y is minus 1.5. And just like we got it initially, this will be 105 and minus 1.5. When x is 120, y is minus 2.6, and minus 2.6 is going to be here. Just a reversal of what we did on the positive y-axis, okay? When x is 135, y is minus 3.0. So 135 and minus 3.0 just here. And then when x is 150 degrees here, again, it is minus 2.6. So minus 2.6 here. Oh, interesting. So that's how a sinusoidal curve looks like. And then the task that is now left for us is to join all these dots together and get the sinusoidal curve as appropriate. And that's what I'm going to do. For you, the student out there, you can easily make use of your French curve, or if you have a very flexible material, maybe a broomstick, or there is a rubber curve that is normally available in the market, you can also use that. But here, in my digital tool, I'm just going to use freehand, but I'm going to try as much as possible to ensure that all the lines are joining together and it's going to form a sinusoidal curve, alright? So, let me just try and do that. Alright, so that's my sinusoidal curve, and of course we are stopping at 150 degrees like this. So this is the curve for y is equal to 3 sine 2x. As a rule of thumb, always make sure that you label your graph, okay? This is the answer to question A, this is the answer to question B, and then we need to look at the solution to question C. And here we are told that 3 sine 2x plus 2 is equal to 0. But we've been able to ensure that this is the same as y is equal to minus 2, okay? So we can just draw our straight line. This is minus 2 on the vertical axis, and we can just plot our graph straight. So we can also correctly label this to be 3 sine 2x plus 2 is equal to 0. Or you can say y is equal to minus 2. Okay? Any one of the two will be suitable for you to define that. So for us to find the true set of this, we need to look at the point of intersection of this straight line graph and the graph that we are looking at initially. So this is that point of intersection, and we can trace it to the x-axis to just get that particular value. So that is quite straight. Let me just make that some broken line so that you'll be able to see it appropriately. So how do we get the value for this particular solution here between 105 and 120 degrees? Okay, we are going to look at it this way. Here, there are 5 divisions in the box that I'm considering as 2 centimeters. So I can say 5 is corresponding to 15 degrees, because between 105 and 120 is an incremental value of 15 degrees. You can see we are told 2 centimeters to 15 degrees on x-axis. So I want to get what one box will correspond to, so I can call that x. If I am to cross multiply, I can say 5x is equal to 15 degrees, such that if I divide both sides by 5, x, which is the value for each of the box, is going to be 15 over 5, and that is 3 degrees. So that means that in this particular case, each of these small boxes will take 3 degrees. So I have 105 plus 3 is 108 plus another 3. That will be 111 degrees. Alright, so I can say in that case, for y is equal to minus 2, the truth set is given as x, such that x is equal to 111 degrees. To leave some margin for errors, you can say plus or minus 1 degrees. Okay, so what I got originally was 111, but I'm just leaving a margin for error of 1 degrees, and that will be the solution to 3 sine 2x plus 2 is equal to 0. But that's not all. In the second case, we're told that 3 over 2 sine 2x is equal to 0.25. Okay, and for that, we are able to get the expression of y to be y is equal to 0.5. Okay, so for y is equal to 0.5, we just need to go to the point at which we have 0.5, which is on the positive y-axis, and that is here. So we draw a straight line, okay, just to cut the graph for the sinusoid that we have initially. So we're going to have something like this. So that's our curve for y is equal to 0.5. And you can see, different from what we had initially, here we are going to have 2 solutions, one here and one here. And just like we did before, we can just trace that down, and also here, trace it down. In this fourth case, we have incremental values of 3 degrees. So here is 3 degrees, here's another 3 degrees, that is 6 degrees. But this, our solution, is closer to 6 degrees, so we can say it's like 5 degrees. So the true set here, the true set for this second case is defined as 2 cases here. So we have it defined as, in the first case, x, in which x is equal to 5 degrees plus or minus 1 degree, okay, or x in which x is equal to, what's the other solution? Here we have 75, okay, and we have 1, 2, 3 boxes. So we have incremental values of 3. So 3 in 3 places, that will be 9. So 75 plus 9, that will be 84. So we have 84 degrees plus or minus 1 degree. So this will be the solution to this other equation in which we are told 3 over 2 sine 2x is equal to 0.25. So we can reflect that here, that this is the graph for 3 over 2 sine 2x is equal to 0.25. Or, like I said initially, you can say it's just y is equal to 0.5. Either of these two, defining the straight line graph, will be sufficient. Okay, and just like that, we've been able to look at this question holistically and provide the solution that we're asked to actually provide as appropriate. Here in this question on mensuration, we are told that this diagram, shows a wooden structure in the form of a cone mounted on a hemispherical base. So we need to know that this is the hemispherical base. Then the vertical height of the cone is 48 meters and the base radius is 14 meters. We have to calculate, correct to 3 significant figures, the surface area of the structure, and we can take pi as 22/7. So now this is the shape and this is the diagram that we are being given, and we have to actually calculate the surface area of the structure. But we need to note something. First, we are told that it's a wooden structure in the form of a cone. Look at this. It's a wooden structure in the form of a cone and mounted on a hemispherical base. These are indications that we are not talking about 2D. It's not 2D, rather we are talking about 3D. Something like this is what we are talking about, and you can see here at the top, the wooden structure, we have the shape of a cone, and then it is mounted on a hemispherical base. So this is the hemispherical base, and this is the cone that is the uppermost structure. So if we want to put the information that we're given, we can just denote that yes, the vertical height of the cone from here down to here, that was given as 48 meters. But then we're also told that the base radius is 14 meters. Now, this is the base, and the radius we mean from the edge of the circumference to the center. So we have this is implied at right angle, and we're told that the vertical height is 48 meters here, and then the base radius is 14 meters. This is 14 meters. So now, since the cone is sitting directly on the hemispherical base, that means that the radius of the hemispherical base is also going to give us 14 meters. So from that circumference to the center of the hemispherical face, we also have this to be 14 meters. Now, if these are the two shapes that we are concerned about, how do we go about to find the surface area of the structure? You can see here that the surface area of the structure will give us the surface area of this particular cone and then this hemispherical base, this hemisphere. Okay, so we can say that the surface area of the shape is going to give us the addition of the surface area of the cone and the surface area of the hemisphere. So if we can get the surface area of the cone and we can also get the surface area of the hemisphere, if you add them together, that will give us the surface area of this particular shape that we're asked to find. But now, what is the formula for the surface area of the cone? That is going to be pi RL. Now, pi we are given to be 22/7. The radius is the radius of the base of the cone, which is 14 meters. Then the slant height L. But looking at this particular diagram, we don't know the slant height L. We have the vertical height to be given as 48 meters. Is this L that we're asked to actually use? But then no problem, we're going to add that to the surface area of the hemisphere. Now, the hemisphere is half of a sphere. So we can say if we want to find the surface area of the hemisphere is half multiplied by the surface area of a sphere, which is 4 pi r squared. So this is the formula that will help us to get the surface area of this particular shape. So now we need to actually look to see how we can solve this particular question, because for us to solve for the surface area of the cone, we need the slant height. And if you look at this diagram, you know, we are given that this is L, this is point M, and this is point N. Okay, from the diagram, we can see that M, L, so if we call this O, being the center of the conical base, we can see that triangle MLO constitutes a right angle. And for that, we can make use of the Pythagoras theorem to actually get the slant height of the cone, which is L. And we can get that by saying that that is going to be the square of the hypotenuse, which is LM square, is equal to the sum of the square of the base and the vertical height, which is going to correspond to the adjacent and the opposite if we take the angle here or here. So that will be OM raised to power 2 plus OL raised to power 2. LM is L, so we can just say L raised to power 2 is equal to OM is 14, so we have 14 raised to power 2 plus OL, that is 48 raised to power 2. So if you are to use our calculator for that, we can say 14 raised to power 2 plus 48 raised to power 2, that's equal to what? 2,500. So this is 2,500, such that L will be the square root of 2,500 and the square root of the answer that we just got is 50. So L is 50 meters. Okay, so we can just append it here that L is 50 meters from the fact that we employed the Pythagoras theorem to solve for that. So can I use the value of that slant height L to actually compute the surface area of this particular shape? And then I can just put in the value that pi is 22 over 7 multiplied by R, that is 14, okay, multiplied by L, that is 50, and that is the surface area of the cone, plus now half multiplied by 4 is 2, so I have this as 2 times pi is 22 over 7 times the radius is also 14, just like in the first case, and we have it as 14 square. And this, if we are actually going to evaluate it, let's do that piecewise, or even first, let's say here I can say 7 can cut 14 to be 2. So in the first case, we are going to have 22 times 2, 22 times 2 times 50. That will be 2,200. So this is 2,200 plus, in the second case, given 22 over 7 and 14 square can cut. No problem. I can just say 2 times 22 times 14 raised to the power 2 divided by 7. That's 1232 plus 1232, which happens to be the surface area of the hemisphere. Okay, now 2,200 is surface area of the cone, and then 1,232 is the surface area of the hemisphere. The surface area of the shape will be the addition of these two, and if we are to evaluate that, say 2,200 plus 1232, that's going to give us 3,432. So 3,432 meters square, but we are asked to get it correct to 3 significant figures. So if you want to make it to 3 significant figures, meaning that the vital digit that we need to see should be 3. And now if you are to take it, here we have the first one, the second one, and the third one. We should consider 2 and see if we need to round it up or round it down. 2 is not up to 5. Numbers between 0 and 4 will round down to 0 and add to the previous number. Numbers between 5 and 9 will round up to 1 and add to the previous number. But since 2 is not up to 5, that means we can just have our final answer as 3,430 meters square as the surface area of this particular shape. What we just need to note as students is that we should not be confused with this shape and think it is a two-dimensional diagram and say, yeah, this is a triangle and then here this is a semicircle. No, because we are talking about a wooden structure which is a physical shape. It is three-dimensional, and that's why we should be talking about a cone and an hemisphere. And just using the formula for the surface area of the cone and the surface area of the hemisphere, which is half of a sphere, we can go ahead to evaluate by first finding the slant height and then imputing correctly into the equation to solve, and our final answer is 3,430 meters square. Here in this question on word problem on simultaneous equation, we are told that 5 years ago, Musa was twice as old as Sese. Now, if the sum of their ages is 100, we are to find Sese's present age. We need to distinguish something very clearly. We have two case scenarios, okay? There are two case scenarios that we are looking at here. First, 5 years ago, and then the present time. So, we need to represent these two timelines correctly for us to be able to solve our question. Now, we are told that the sum of their ages is 100. In that case, if I say that Musa's age should be, let Musa's age, let it be X, and Sese's age, let it be Y, we'll be able to interpret our questions mathematically if we are to do that. First, we're told that the sum of the ages is 100. That means X plus Y is equal to 100. That's presently. But we're told that 5 years ago, Musa was twice as old as Sese. So what's Musa's age 5 years ago? Since he's X today, 5 years ago, it will be X minus 5. Okay, that's 5 years ago for him. But for him, he is twice as old as Sese. So if X minus 5 is Musa's age, then Sese's age should be X minus Y 5 years ago. But we are told that the age of Musa 5 years ago is 2 times the age of Sese 5 years ago. So these are the two equations that we need to note and work with, and we can say that this is equation 1 and this is equation 2. But we are to find Sese's present age. Sese's present age is Y. So Y is our point of interest in this particular case, okay? But I can look at the equation and I can say from equation 2, and you can actually use any method of solving simultaneous equation to solve it, because already you can open this bracket and notice that this is just nothing but a simultaneous equation. But from 2, I can say Y will be, or since I'm looking for Y, I can eliminate X. So I can say X is equal to 100 minus Y. So this is what I can say. I can call equation 3, and I can use in equation 1. Okay, so from 2, I've found the value for X, and that value for X in equation 1, wherever I see X, instead of writing X, I'm going to write that value for Y. So in that particular case, what I'm going to have is that instead of X minus 5, I'm going to have that as 100 minus Y, okay, which is X, then minus 5, okay, is equal to 2 multiplied by X. What is X? X is 100 minus Y. Then again, I still have this minus Y. So we have to simplify this. 100 minus 5 is 95. So I have 95 minus Y is equal to 2 times 100 is 200. Then minus Y is minus 2Y times 2. That will give me minus 4Y. And here, if I collect like terms, if I say let minus 4Y move to the left hand side, it will become 4Y. Then minus Y is equal to, here, 200. When 95 moves to the right hand side, become minus 95. So 4Y minus Y is 3Y. And that's equal to 200 minus 95 is 105. And from here, I can just say, yes, from having 3y is equal to 105. I can divide both sides by 3, and here already I can see that 3 here can cut 3 here. I have 3 here, 1. 3 in 10 is 3, remaining 1. 3 in 15 is 5. So, for that particular case, y, which happens to be the age for CSE, is equal to 35 years. And, x was what we are using to denote Musa's age. Y was what we are using to denote CSE's age. They are not asking us for Musa's age. They are asking us to find CSE's age, and that is 35 years. So, understanding how to interpret our timeline question, okay, had helped us to simplify this question into a set of simultaneous equations in two variables. And here we just use the substitution method to substitute for the value of x from the second equation into the first equation, and simplifying, we're able to get y, which is CSE's age, to be 35 years. And that is the solution to this question. Here in this question on commercial mathematics, we're told that Miss Maureen spent 1/4 of her monthly income at a shopping mall, then 1/3 at an open market, and 2/5 of the remaining amount at a mechanic workshop. So we need to take note of that so that we don't get confused. Then after spending all of this amount, if she had 225,000 naira left, we are to find her monthly income and the amount she spent at the open market. So the ideal approach is for us to represent our monthly income by x. So we can say let x be a monthly income. It as a monthly income, we can now work around trying to extrapolate all the values that we are giving so that we can arrive at the solution to the question we are given. In the first case, we are told that she spent 1/4 of her monthly income at the shopping mall. So the shopping mall will take x/4, okay, and then she spent 1/3 of her monthly income at an open market. So this is going for the shopping mall. Then x/3 is going for the open market. Let me use that as O. Then 2/5 of the remaining amount at a mechanic workshop. How do we get first the remaining amount before we evaluate 2/5 of that remaining amount? Okay, so first we can say the remaining amount will be x, which is the total amount, minus the sum of the amount she spent at the shopping mall and the open market. So that will be x/4 plus x/3. So if you want to get this is the same as if we just have x minus, looking at the expression in bracket, we can find the LCM. 4 and 3, the LCM is 12, and 12/4 is 3. 3 times x will be 3x, and here we're having an additional sign. 12 divided by 3 is 4. 4 times x is 4x, and this is going to give us x itself is just as if we're having 12x/12. I just want to do this to simplify it. Then minus 3x plus 4x is 7x/12. So the remaining amount, after spending some of our income at the shopping mall and at the open market, will be 12 minus 7. That will be 5x/12. But we need to note something. We are now told that she spent 2/5 of that remaining amount at the mechanic workshop. So meaning that the amount that she spent at the workshop will take 2/5 of 5x/12. This is where students most likely will make mistake. We need to note that it is 5x/12 that is remaining after she spent money at the shopping mall and at the open market. So the amount she's now spending at the mechanic workshop is 2/5 of that remaining amount. So this will be 2/5 multiplied by 5x/12. So you can see 5 can cancel 5, 2 can be used to divide 2 here. 2 in 12, that is 6. So this is x over 6, meaning that the amount she spent at the workshop is x over 6. Now, let's look at these three statements, because we are now being told that if she had 225,000 naira left after spending all of this money, then we have to find her monthly income and the amount she spent at the open market. Now, what is the implication that she is having 225,000 left? That means that out of her total monthly income, we need to take out the amount she spent at the shopping mall, plus the amount she spent at the open market, plus the amount she spent at the mechanic workshop. So we subtract these three amounts from our total monthly income, which is x. And that is what we are going to be doing now. And that is the interpretation that students really need to note to get this question correctly. So the total amount left now, after spending everything, the total amount left is going to be x minus all the money that she spent in all the places she went to, which is x over 4 spent at the shopping mall, plus x over 3 spent at the open market, plus x over 6 spent at the mechanic workshop. So this, we know it to be x minus the LCM of these three, 4, 3, and 6 is 12, and 12 divided by 4 is 3. 3 times x, we have 3x, plus 12 divided by 3 is 4. 4 times x, that is 4x. 12 divided by 6 is 2. 2 times x, that is 2x. Okay? So that total amount left is going to be x minus 3x plus 4x is 7x, plus 2x, that is 9x over 12. Okay? And so if I'm to also find the LCM, this will be 12 as the LCM, and here we're going to have 12x minus 9x, because this is just as if I'm having x over 1, and 12 divided by 1 is 12. 12 times x, that's 12x. So this is going to give me 3x over 12, and I can use 3 to divide both the numerator and denominator to have this as x over 4. So now, if you want to take note of what we have done so far, we've been able to find that the amount she spent at the workshop is x over 6. That's the amount they spent at the workshop. And after spending all of this money, the amount remaining, okay, the remainder is x over 4 as we evaluated here. So I'm going to I've taken note of all these calculations. I'm going to clear this so that we can answer the questions that were asked as appropriate. So now, to find our monthly income, which is the solution to the first question that we are going to be dealing with here, we're told that if she had 225,000 naira left, we need to know that that amount that she had left is corresponding to this remainder that we have as x over 4. Okay, so that implies that the amount left, which is x over 4, is corresponding to 225,000 naira. So from here, if you just cross multiply, we can say, therefore, x is 225 times 4. 4 times 225,000 naira. If you want to get that, so if you want to get that, we just say 225,000 multiplied by 4. That's what? That is 900,000 naira. So this is 900,000 naira as the solution to the question of we finding a monthly income. In the second case, we are told that we are to find the amount she spent at the open market. Now, the amount she spent at the open market, what did we use to represent that initially? We are told that it's 1/3 of her total monthly income that she spent at the open market. So, amount she spent at the open market, is given as 1/3 of x, which is her total monthly income, and that will be 900,000 divided by 3. Okay, 900,000 over 3 is 300,000 and that is the solution to this question. What we just need to note is that we need to just take our monthly income, which is x, to be a value that we can use fractions on, and that's where we started. 1/4 at the shopping mall, 1/3 at the open market, then 2/5 of the remaining amount at the mechanic workshop. We need to first find that remaining amount and then evaluate 2/5 of it, which will got to be x/6 as the amount spent at the mechanic workshop. Then the remainder, after spending the 3 of this, the total remainder which she had left was obtained as x/4, which corresponds to 225,000 naira. So for us to find our monthly income, we just need to say x/4, which is the remaining amount, is equal to 225,000, and then we can find the monthly income x. So I can just append this as monthly income x. The monthly income x was obtained now as 4 times 225,000, which is 900,000, and then the amount spent at the open market, we are told initially it is 1/3 of our monthly income, and 1/3 of 900,000 is 300,000, and that is the solution to our question here. In this question on arithmetic progression, that is sequence and series, we are told that the third term of an arithmetic progression, an AP, is 4n minus 2n, and if the ninth term of the progression is 2n minus 8n, we are asked to find the common difference in terms of m and n. So for us to solve this question, what we need to note first and foremost is that the nth term of an AP is given as a plus n minus 1 multiplied by d, where a is the first term, n is the nth term, and then d is the common difference. So now if you want to consider the third term, which was given as 4m minus 2n, we know if you want to make use of this equation of the nth term of an AP, that is the same as a plus n, in this case is 3, and we have it as 3 minus 1d, such that we can say here, if I want to write this on the left hand side, I can just say a plus 2d is equal to 4m minus 2n, okay? And then in the second case, we are talking about the ninth term, t9. If we want to express the ninth term, we are given as 2m minus 8n. So this is also equal to a plus, now the nth, the term we're talking about is the ninth term, so our n is 9 minus 1 multiplied by d, and we want to express just like in the first case, we'll have this as a plus 9 minus 1 is 8, so we have 8d is equal to 2m minus 8n. Now these two is actually a set of simultaneous equations, which you can call this equation 1 and we can call this equation 2. Now what are we asked to find? We're asked to find the common difference in terms of m and n. So m and n, okay, is just a value that we can work with. We can say this is actually solvable because we have two unknowns and we have two equations and we can actually solve that, not considering m and n, since our answer is going to be in terms of m and n. And because we are not looking for the first term a, look at the question, we are told to find the common difference, then we can eliminate a out of this equation so that we can solve for d. And for me, I think it will be good if we say we subtract equation 1 from equation 2. So I can say equation 2 minus equation 1 will warrant that in the first case, a minus a, you know it's right, I'm saying 2 minus 1. So a minus a will be 0. 8d minus 2d is equal to, here I have the 8d from the second equation minus 2d from the first equation is equal to, here 2m minus 4m, this first entity, okay? Then here, look at it, you have minus 8n here, I'm just writing down minus 8n, then minus 2n, or better still, if I want to write this out just straight so that you don't get confused, I can just say it is 2n minus 8n here, the one in equation 2 minus 4m minus 2n. Alright, so 8d minus 2d is 6d is equal to, we have 2m minus 8n. Now I'm trying to open this bracket. I still have minus 4m, but in this particular case, minus will multiply minus, so giving me a positive sign. Then I have that 2n still remaining. So this is 6d is equal to 2m minus 4m is minus 2m, okay, minus 8n plus 2n is minus 6n. And I can see that a negative sign is common to this. So I can say 6d is equal to minus 2m, or even not only a negative sign that is common, I can say minus 2 is common to both sides. Then I have m plus 3n, because minus 2 times m is minus 2m, and minus 2 times 3n is minus 6n. So since I have this, I can divide both sides by 6 so that I can find the expression for d, and then 6 here can cancel 6 here, and minus 2, I'm going to have minus 1, and then in 6, I'm going to have 3, such that the value for the common difference we have to find will be minus 1 over 3 multiplied by m plus 3n. And this is going to be the solution to this particular question. And that's how we can go about solving this question on arithmetic progression. In this beautiful question on bearing and distance, we are given that two cyclists X and Y leave town Q at the same time. Then cyclist S travels at the rate of 5 kilometers per hour on a bearing of 0.49 degrees, and cyclist Y travels at the rate of 9 kilometers per hour on a bearing of 319 degrees. First, we are to illustrate the information on a diagram. Then, after traveling for 2 hours, we are to calculate to the nearest whole number the distance between cyclist X and Y, and then the bearing of cyclist X from Y. And finally, we are to find the average speed at which cyclist S will get to Y in 4 hours. So yeah, our first mandate is to illustrate the information on a diagram. And looking at the question, we are told that they leave town Q at the same time. So Q will happen to be our point of reference. So if we are to locate point Q and we draw our 4 cardinal points, this is a 4 cardinal point from where we are going to take our bearing from. And in the first case, we are told that the cyclist S travels at a rate of 5 kilometers per hour on a bearing of 0.49 degrees, and cyclist Y travels at the rate of 9 kilometers per hour on a bearing of 319 degrees. So to locate the bearing of cyclist S, which is 0.49 degrees, if we take this as the north, the south, the east, and the west, and we are trying to locate the bearing of 0.49 degrees, that is going to be between north and this, because normally we start taking bearing from the north and we go in the clockwise direction like this. But here we are told it's 0.49, meaning that it's not yet a right angle. Between north and east is a right angle, which is 90. So 49 will be here in this particular first quadrant. So we can just take our bearing that will go from north, and this is 0.49. okay, so we can just take that bearing to now go somewhere like this. So this is where the cyclist X will be. Okay, so that's the first thing we need to do. Then for the cyclist Y, we are told that he is traveling on a bearing of 319 degrees. So how do we get 319 degrees? From the north to east, that is 90. From the north to the south, you can see it's a straight line, that is 180. From the north to the west, that's that 180 plus another 90, making 270. So from north to west is 270, and from north, making a complete circle, is 360 degrees, because that will now amount to the angle at a point. But here we are being told it is 319. So that will be in this last quadrant between 270 and 360. So you can just say we are moving somewhere like this. And this will be 319 degrees. So you can also take that bearing just straight up to where cyclist Y will be located. So I think this is a good representation of what we have as that bearing. So if you want to label, we can say this is point Q, okay, then this is point X, and this is point Y. Something of interest that I would like us to note, I took this to be longer than X because look at the information that we are giving. We are told that the cyclist X travels at the rate of 5 kilometers per hour. So that is 5 kilometers per hour. This is for the X. But the cyclist Y travels at the rate of 9 kilometers per hour. And this is Y. Now, look at 9 kilometers per hour and 5 kilometers per hour. Of course, definitely, the one running on 9 kilometers per hour would have covered more ground, more than the one running 5 kilometers per hour. In short, I think my 5 kilometers per hour is way too long because 9 is almost twice the size for the X, so I should have it somewhere here, okay? And that is where you paying attention to the details that was given will really help to solve the question that you are trying to solve. So I can say this is my X because Y would have traveled almost twice the length of X with the information that we are giving. And why am I doing this? Is because you are going to get your diagram more correctly and you'll be able to solve the question better and easier, okay? You won't have a drawing that will be negating what you are trying to postulate as the thing to get from the drawing. So good and beautiful like this. This is the information that we're asked to illustrate on a diagram, and it's like this. Now I want to just put some little effects. I want to bring in my cyclist, so let's just wait for that. So I love the fact that I brought in my cyclist to reflect on my diagram, just like we used to have on our textbooks. So then you don't need to show this. I just using this so that I can have a pictorial view of what I'm trying to talk about. You can see I'm reflecting that the person traveling at 9 kilometers per hour is traveling faster than the person moving at 5 kilometers per hour. And just to complete the triangle that we are drawing, we can use a straight line to join X to Y, just like this, and then we are good to go. I love this. So with this, we have the information illustrated in the diagram as requested, and then we can move on with the other questions. So now, after looking at the first question, we are being told here that after traveling for 2 hours, we are to calculate to the nearest whole number the distance between cyclist X and Y and the bearing of cyclist X from Y. Let's take it piecewise. To get the distance between the cyclists, look at all the information we are given. We are given the speed, and now we are being given the time to be 2 hours. Now, by reason of understanding of speed, distance, and time, we know that speed is defined as distance over time. Speed is distance over time. But normally, working with bearing and distance, even look at the word that we use. We say bearing and distances. So here we need to find the formula for the distance, and distance in this case is equal to the speed multiplied by the time. Okay, so this is what we ensure that we are working with the right values, because given the speed we need to get the distances that we work with so that we can even find the distance between cyclist X and Y. So for the cyclist X, after 2 hours, we can say after 2 hours, the distance covered by cyclist X, the distance covered by cyclist will be his speed multiplied by the time, and the speed we are given already as 5 kilometers per hour multiplied by the time, which is 2 hours. Now 5 times 2 is 10, but here we have kilometer per hour multiplied by hour. Now per hour means divided by hour, then multiplied by hour. You can see the hours will cut out and we have only the kilometer left. So That is actually the distance covered by cyclist X. And in the same vein, the distance covered by the cyclist Y will be, what's the speed for Y? It is 9 kilometers per hour multiplied by, they are using the same time, so we multiply by 2 hours, and that will be 9 times 2, that will be 18 kilometers. We now understand how to knock out the hours from the unit. So if you go back to our diagram, that is just telling us that the distance from Q to Y, that's the distance of the cyclist Y, is 18 kilometers. So here we have 18 kilometers, okay? And the distance from Q to X, distance of X is 10 kilometers. So we have here is 10 kilometers. But look at the question that we're being asked first and foremost. We are to find the distance between cyclist X and Y. This is the line XY, which is facing Q. So here is what we are told to look for that we don't know. And for us to evaluate this, let's look at the diagram holistically, okay? If you are looking at this diagram holistically, look at this particular point. Here we're having a triangle and we don't even know any of the included angles. So starting from Q, where we are taking our bearing, let's see if we can find this angle so that we can use any of the mathematical rules that we have at our disposal to solve for this length XY, which will correspond to distance between cyclist X and Y. So here at point Q, originally we have this bearing of X from Q to be 49, and then we have the bearing of Y from Q to be 319, but we can say we want to look for this particular point, this angle. And how do we find that? Look at it. From north to north is the angle at a point, and that is 360 degrees. And from that 360 degrees, we have already taken 319 out. So this particular place will be 360, which is angle at a point, minus 319. So we can say that will be 360 degrees minus 319 degrees, okay? So 360 minus 319, you can say we borrow 1 from this 6 remaining 5. 10 minus 9, that is 1. Then 5 minus 1, that is 4. So we have this as 41 degrees. So we can just go to that point at Q and say this is now 41 degrees. Right. This is very good. That's very interesting. So 41 and 49. What's 41 plus 49? 41 and 49. 1 plus 9 is 10, remaining 1. 4 plus 4 is 8, plus that 9 is 90. This is quite interesting now. So we can say the angle here at N is actually nothing but a right angle. A right angle here. This is angle 90. And if you can define this as angle 90, that means here we are working with nothing but a right angled triangle. Right angled triangle. I love this type of questions because our understanding of how to interpret the question is going to give us quite a whole lot of solution that we need. For a right angle triangle, we know that Pythagoras theorem, I love this. Pythagoras theorem can be used to solve for the side that we are looking for. And what is that telling us? It's telling us that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. And the longest side, or the side facing the right angle, is the hypotenuse. So here, if you want to actually represent this well, the side facing Q will be small q, so this is small q. The side facing x will be small x, so this is small x. And the side facing y will be small y, so this is small y. So from here, we can just see that this implies that q raised to power 2 is equal to x raised to power 2 plus y raised to power 2. And x we found to be 18 kilometers, y is 10 kilometers, and we're looking for q. So we can say the square of q is equal to x square will be 18 raised to power 2 plus y square will be 10 raised to power 2. And if you want to bring in our calculator to solve that, you can just say 18 raised to the power 2 is what? That's 324. So this is 324 plus 10 raised to the power 2 is 100. So 324 plus 100 is 424, such that Q, this is Q raised to the power 2. So Q itself will be the square root of 424. Okay, so how do you find the square root of 424? We go to our calculator and press square root of 424 is equal to what? This is 2 root 106. But I want to express it in decimal place. So this is 20.5913. So this is 20.5193. But look at the question. We're told to calculate to the nearest whole number. So we need to approximate this to a nearest whole number, meaning that we don't want any decimal place there. And for us to do that, we need to look at the number immediately following the decimal place, and that is 5. So numbers between 5 to 9 will round up to 1 and add to the initial number before it. Numbers between 0 and 4 will round down to 0 and it will not have any effect. But here it is 5. So when we round 5 up, it will become 1 and we add to 20. That will be 21 and the unit is kilometers. So 21 kilometers is the distance between cyclists X and Y, and we can just reflect on our diagram that this is here that we tag as unknown. We have now gotten it to be what? 21 kilometers. I love this question. Okay, so now we've gotten the distance between cyclists X and Y to be 21 kilometers, approximately 21 kilometers. Now we have to find the bearing of cyclist X from Y. From Y means that we need to go to Y to consider taking our cardinal point from there and look at the bearing of X from Y. So we can go to Y to take our bearing, okay, just the 4 cardinal points that we'll be needing. All right, so here we can just identify these to be the north, the south, the east, and the west. Okay, so the bearing of X from Y, we need to start from the north and look at it to the inclination of X to Y. So if you are looking intently, we can see that that is identified as this particular place here from the north to this angle. Okay, this is the bearing of X from Y. That particular angle, let me just call it theta. Okay, then looking at this, because if you're identifying that as theta, we need to now look at how do we get that angle theta. From what we have done before, we got this angle at Q to be 41, but we can observe that this is going to be alternate to this angle at Y, but to the south of it. I can show that with the aid of a diagram, that if you take this particular angle here and you run it down to Y, okay, and then you come down south, this new angle here, this angle here, and this angle that we got initially as 41, they are alternate angles. So this will also be 41 degrees because alternate angles, they are equal. So that is 41 degrees, just like this is also 41 degrees. So if you have been able to find that to be 41 degrees, you can find a suitable means to evaluate this angle theta, because you know that angle on the straight line north to south, that's a straight line. The sum of angles on that straight line is going to be 180. Now we have 41 here. If you can find this angle at Y, okay, this angle at Y, this one in red, which is the angle corresponding to Y, okay, at that particular point of this triangle, then we can use that to sum 41 and this angle and theta, and we can equate it to 180 degrees in such a way that we can now find the value for theta. We can just say that at location Y, theta plus the angle XYQ, that's the angle at Y here, okay, plus 41 degrees that we have gotten to be alternate to this 41 from Q. The addition of the 3 is equal to 180 degrees. Why? Because they are the sum of angles on a straight line. So sum of angles on a straight line, they add up to 180 degrees, and we are leveraging on our understanding of that. So we already know 41 degrees. How do we find angle SYQ? Look at this triangle. Okay, look at this triangle. We already know the hypotenuse. We know the opposite to this angle. Opposite to this angle is 10 kilometers, which is small y. Then we also know the adjacent, which is 18 kilometers. But we are looking for this angle. So what do we want to make use of that will help us? We can make use of any of SOHCAHTOA. Okay, SOHCAHTOA is a trigonometry identity that we can use for a right angle triangle like this, in which we are looking for a particular angle while we know all the sides, and we also know the right angle included. So yeah, let's say we want to use either opposite and adjacent or anyone, but we want to relate it to this particular angle. We can say, which one do we use? We can say we want to use tan. We can say from there tan XYQ, which is ideally opposite over adjacent, because from here, SOHCAHTOA, tan is opposite over adjacent. This is the same thing as, what's the opposite? The opposite is 10 and the adjacent is 18. Students, as a rule of thumb, it's even good that we use tan, because the value that we got for the hypotenuse, you can remember, it was an approximated value. So here we have approximated it. It was actually 20.59126 or so. But we are using absolute values that were given in the question here, so our approximation can be on the right track, because at the end of the day, we are still going to find our answer to the nearest whole number. So we don't need to complicate issues for ourselves. Let's just use the values that we are given. So tan is ideal for us. So that means that tan XYQ is equal to 10 over 18. What is 10 over 18 from our calculator? 10 divided by 18 is what? It's 5 over 9, which is 0.5. This mark on top of the 5 means that it is a repeated value. So I can say it is 0.5555, then 6, since I will approximate that, such that angle XYQ is equal to arctan, I could even have said arctan 10 over 18 straight. Okay, so arctan 10 over 18, what's that? Here I can say arctan, the answer I just got, that's 29.054, or I could have said directly it is arctan 10 over 18. So what's this? 29.0546. That's 29.0546. Good. But this is where we're actually going. We want to make use of that in this equation, such that we are going to have, therefore, our theta that we are looking for is going to be 180 minus the sum of this SYQ and 41, and XYQ we have gotten to be 29.0546 plus 41. Okay, when these two, when they move to the other side, they will become minus, so we can subtract them from 180 to find the value of theta, which is the bearing of cyclist X from Y. All right, so if we bring in our calculator, we can say this is 29.0546, okay, plus 41, that is equal to what? So now I can say 180 minus the answer I just got. So this is 109.9454. 109.9454. This is 109.9454. But look at the question. They told us to get it to the nearest whole number. So we need to approximate this. So, and in short, bearings are always expressed only in 3 digits. You don't put decimal place in bearings. So that means we need to knock out this particular 9. And if we take 9, we are going to round it up to 1 and add that 1 to the initial number before it, and that is 9 here. That 9 plus 1 is 10. So what we are going to have is 110. Okay, so this is approximately equal to 110 degrees. So the bearing of cyclist X from Y, here our theta is nothing but 110 degrees. All right. So here in our final question, we are asked to find the average speed at which cyclist X will get to Y in 4 hours. So when X got to here and Y is here, Y will be stationary, and then X wants to move from this particular point to Y at this point. So we have to find the speed which he needs to travel at to get to Y, but in 4 hours. If you recall, initially we said our speed is nothing but what? Is distance over time. So that's one of the things that we did immediately we are starting with this particular question. But here we are told that we have to find the speed of X to Y, okay, in 4 hours. So that time we have been given to be 4 hours. But what is the distance that we need to look at? Look at what we have here. We have 21 kilometers, but recall that this is an approximated value. Whenever you are working, don't use approximated value to solve further questions. Use the original value. Then when you get the final answer, you can approximate. But even look at this question. They didn't ask us to approximate. You know, they just said find the average speed. So what was the original value we got for Q the other time? It was, I think, 20.591. Yes, 20.59126 kilometers. But now, what's the time that we are looking at? We are looking at this time that is given is now 4 hours. So the speed that X will need to take to get to Y will be this 20.59126 divided by 4. So we can bring in our calculator to say we have 20.59126 divided by 4, and that is what? 5.1478. 5.1478, but now it will be kilometer per hour. This is quite long. We can just take some little approximation to take this is nothing but 5.15 kilometers per hour, because if we take 7, we will round it up to 1 and add that 1 to 4 to make 5. So the average speed at which cyclist X, this guy, will get to Y, this guy, when he's here in 4 hours is nothing but 5.15 kilometers. So you have seen how we can actually solve questions on bearing and distances, how we can interpret the question as we are given, how we can use our understanding of triangles, the rules that pertain. Sometimes we get to use sine and cosine rule, but here we get to use the Pythagoras theorem and trigonometry identity, SOHCAHTOA, and we've been able to solve this question, albeit we use our understanding of the fact that speed is distance over time. So we first converted to distance to get the distances in bearing and distance, and then later we're also working with the speed again. And the more you practice with this type of question, the better you are going to be. You can check our playlist. We have quite a number of questions on bearing and distances, angle of elevation and depression, triangles in general, and you can make use of them to build your proficiency in this type of questions. All right. This question is a question featuring the cumulative frequency curve, popularly called ogive, and in the question, we're told that the table shows the distribution of marks obtained by students in an examination. So we have those marks and the associated frequencies with each set of the marks, and then we're told to construct first a cumulative frequency table for the distribution, and then we have to draw the cumulative frequency curve for the distribution, and then using the curve we have to find correct to 1 decimal place, the median mark, and the lowest mark for distinction if only 5% of the students passed with distinction. So this is the question, and we are going to go ahead to attempt them correctly. In this particular year, students, you just need to take notes. You cannot run away from questions on graph. This is the second question on graph, and so let's put our minds together. If you can get your pen, your biro, your graph sheet, let's work this together so that once you know how to do this, you'll be able to replicate it in your exams, and that excellence you are going to gain. So we are going to come up with a table right about now. So this is going to be the solution to the question on the cumulative frequency curve. Okay, so first we are asked to find the cumulative frequency table, and that's what we are going to be coming up with here. And the feature of the table is that we have our marks as we are given, we have the frequency which we are also given, but we are going to compute the upper class boundary, the UCB, and the cumulative frequency. And this is the way to go about it. Now, to get the upper class boundary, we need to look at the higher mark in the first set, okay, and the lower mark in the second set, and find the average of the two. Here we have 9 and 10, meaning that we will just say the upper class boundary for the first case will be 9 plus 10 divided by 2. 9 plus 10 is 19, so we have 19 over 2, and 19 over 2 is 9.5. So that's how we are going to compute the upper class boundary for each of the class. The upper class boundary in this particular case is going to be 9.5. So we just put that in as 9.5, and the same incremental value will just happen to these higher marks for each mark set. So we have, in this case, we have 19.5, and then 29.5, and 39.5, and on like that. All right, so let me just fill this up. So this is the set of values for the upper class boundary. You don't need the lower class boundary, okay? You just need the upper class boundary to compute the table for the cumulative frequency table and use subsequently in the cumulative frequency graph, okay? Now, how do we get the cumulative frequency? For the first set of marks, the cumulative frequency will also be the frequency. So here we have 7. But for subsequent ones, we are going to add the initial cumulative frequency to the next frequency. So here, the cumulative frequency initially is 7, then plus this frequency, 7 plus 11, that will be 18, okay? Then here, it will be 18 plus 17. So that's why you call it cumulative. You continue to add each subsequent frequency to the initial cumulative that we have gotten before. So 18 plus 17, that should be 35, okay? Then we have 35 plus 20, that will be 55. 55 plus 29, 9 and 5, that is 14. 2 and 5 is 7 plus 1, this is 84, okay? 84 plus 34, 4 plus 4 is 8. 8 plus 3, that is 11, okay? 118 plus 30, that will be 148. 148 plus 25, 8 plus 5, that is 13. Okay, 4 plus 2 is 6, plus that 1, that will be 7, and I have 1 here. 173 plus 21 will be 194, and 194 plus 6 will be 200. So now that we've got the final cumulative frequency to be 200, you need to check so that you don't make mistakes. So to check, what you do is you add by the use of the calculator, okay? You add each of these entries of frequencies together, and you have to ensure that the sum you get here and this final cumulative frequency you get, they are going to be the same. So if you want to do that, you can just say here we have 7 plus 11 plus 17 plus 20 plus 29 plus 34 plus 30 plus 25 plus 21 and plus 6. What's the sum of that? Good. That is 200. So we're on the right track. We've been able to compute all the cumulative frequencies as needed for this particular cumulative frequency table. And then in the second question, we are told to plot the cumulative frequency curve. That is the OGIF. So we are going to go ahead to look at how to do that now. So we have our graph sheet here. Now in plotting the cumulative frequency curve, what we do is that we have the cumulative frequency on the vertical axis and the upper class boundary on the horizontal axis. That's the ideal way to go about plotting the particular graph. And if you look at this, here we have our least value to be 7 and then the highest value to be 200. So we need to scale this vertical axis in such a way that 7 up to 200 are appropriately catered for. And if you look at the number of buses that I have in this particular graph, you also need to confirm with your graph sheet that is supplied to you in the exam. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 12 divisions. Let's say I want to leave the margin at the lower space and at the upper space. So I can say I have 10 divisions. I have 200 as the highest mark. So how do I divide 200 in 10 positions? I can just say 200 over 10 and that will be 20. So each of these big box, which is generally taken as 2 centimeters, for me should represent 20 units on the cumulative frequency scale. Okay, so if I have that, look at the upper class boundary. This is on cumulative frequency. On the upper class boundary axis, I have 9.5 down to 99.5, and there are incremental values of 10, 9.5, 19.5, 29.5. Then I don't need to really start from the origin. Okay, that's not necessary here. I will just say that for that particular horizontal axis, then my scale should be 2 centimeters to represent 10 marks on the upper class boundary axis. So this is going to be the scale that I'll be using for this particular question. So I can say I have my scale as 2 centimeters representing 20 units on the cumulative frequency axis and 2 centimeters representing 10 marks on the upper class boundary axis. Now we want to divide our graph in such a way to cater for all of this. We only have positive values to the horizontal and positive values to the vertical in both cases. So what we need to just do is that we need to make them meet. I think this will be a good position, so I can draw my horizontal graph just like this. That's the horizontal axis, and then can also cater for the vertical axis just like that. All right, so that is as good as it gets. And then because the upper class boundary is not on a scale of 10, okay, normally what I advise students to do is you can notch that origin, showing that you are not really scaling from the origin. Then you can use these thick lines, okay, the 2 centimeters to represent your 10. Okay, you know the space from each 2 centimeter mark is 10 marks, but because I've notched it, I'm not starting from 0. So I want to say I'm starting this from 9.5. okay, so this will be 19.5, this will be 29.5, this will be 39.5, then 49.5, 59.5, then 69.5, 79.5, 89.5, and 99.5. And you can see it scale appropriately. So I don't need to be saying that it's 9.5 that is in between these last two. No, because I'm not starting from the origin, I notched it and then I can mark it off in incremental values of 10, but starting from 9.5. Now on the vertical axis, I've said that I have 200 and I'm using some divisions of 20. Okay, so here in this first case, this will be 20 and this will be 40, this will be 60, 80, 100, 120, incremental values of 20. Okay, 140, 160, 180, and here is 200. Okay, so that's how that's going to be. We are now having all our values I want to represent correctly denoted in this particular graph sheet, and we can say we want to go ahead to start extrapolating those values against one another. So here I've appropriately labeled my scale of the graph. I have my axis, the horizontal axis and the vertical axis. I have my cumulative frequency table. I just need to extrapolate those values as appropriate. And this is what I would love to do. Now, on the cumulative frequency axis, already I'm saying 2 centimeters. Each of these tick box is representing 20 units. So here on my graph, I have 5 divisions. So I can say 5 is corresponding to 20 units. Okay. So how much value is just a box going to take? I can call that M. To find the value of that singular small box, I will just cross multiply to say 5M is equal to 20, so that if I divide both sides by 5, my M is going to be 20 over 5, that is 4. Okay, so each of these small boxes that I'm having is going to take 4. This is the classical way that you can use to find how to extrapolate your values on the graph without any stress. Like here, I have 5 divisions, no problem. In your graph paper, on your graph sheet, you may have 10 divisions, so you can say 10 is equal to 20 units. So how much unit is 1 going to take? Of course, that's going to be 2. Or just like in this second case now, you can see on the upper class boundary axis, I'm just showing this so that you can understand perfectly how to construct your graph and go ahead without having any headache. Already we are saying that 2 centimeters, which is actually the division here, is corresponding to 10 marks. So on my graph, what I have is 5 subdivisions. So those 5 subdivisions is equivalent to 10 marks. Okay. And then what's 1 mark going to be? If I call that n, again I cross multiply. I will just like I did there, n will be 10 over 5, and that is 2 marks. But I don't even need that, because on this particular axis, all of the extrapolations I want to do will land directly on the tick boxes. That is why I was recommending that you need to notch so that your 9.5 don't fall here. They just fall directly on the tick line. So we are good to go. We have our subdivisions. We know what to do. We can go ahead to extrapolate those values. So let me just clear my board here. And then good enough, we can look at the first case. When the upper class boundary is 9.5, we know this is 9.5. So we are tracing from 9.5 here. And we're trying to get the corresponding values on the vertical axis, okay, the cumulative frequency axis. Here we have 7, but we already know that this is 4, this is 8, 12, 16, and 20. So that is consistent. So 7 will be just before 8. Just before 8, if I want to just do that, I will say it's just somewhere around here. And if that's the case, you can just try and join them together just like this. And you can see that point of intersection is the point of interest for us. So I don't want to make my graph clumsy. I just want students to see what I'm doing. So I'm noting that here is my point of interest. In the second case, we have 19.5 and 18. This is 20. Just before it is 16. So in between the two is 18. So I will just have my 18 here. I think this will be more beautiful for you if you are having subdivisions of 10 units on the graph. You'll just be able to locate your values appropriately. But no problem, we can go ahead with what we have here too. When the upper class boundary is 29.5, we have the cumulative frequency to be 35. Okay, so here this is 20, 24, 28, 32, 36, and 40. So 35 will be somewhere here. Just extrapolating with 29.5. Then for 39.5, we have 55. 55, look at what I want to do now. This is 40, okay? Here is 40 on this line. This is 40. Here is 60. 50 will be in between them, like this. Then 55 will be in between 60 and 50. So it should be somewhere here. And that's what I will trace here to extrapolate with 39.5. It will be somewhere here. And you can see how I'm even managing my graph, despite the fact that I have quite small divisions to use. It's just for you to build your proficiency in knowing what to go about, how to go about solving this also. So 49.5 and 84. So here we have 80 and the next one is just 84 because we are using 4 as our subgraph division. So that's quite clear. Then we have 59.5 and 118. Now it's getting interesting. 118, if you take 4 out of 120, that would be 116 here. So 118 will be just in between those two. Alright, okay. Then 69.5, 69.5 and 148. This 140, 144, 148. I hope you are getting this quite easily, okay. The more you practice with this, I can assure you the better you are going to become. You can check some of the videos we've done before. It's not as vast and quick as this, but practice is now getting us better on working questions like this. So when the upper class boundary is 79.5, okay, the cumulative frequency is 173. So here we have 79.5 on this line. So we have 160, 164, 168, 172, and we're looking at 173. So it's just very close here. All right, and then when we have 89.5 on the upper class boundary, we have 194 on the cumulative frequency. 194, this is 180, 184, 188, 192, 196. So just here is 194, and then 299.5. This is the simplest that you can do. And so we have our points that we can now try and join together to form our cumulative frequency curve. So that's what I'm going to do now. Students, you can make use of your French curve. For the cumulative frequency curve, the French curve is quite versatile for you. It's just a matter of you trying to locate all the points together and joining them as appropriate. But I'm going to employ freehand there because I'm using my digital tool and I can't bring in a French curve. So let's see how that goes. So here is my cumulative frequency curve, popularly called the OGIF. On your graph sheet, just appropriately label it as the cumulative frequency curve, okay? So that is as good as done. So the other thing that we're asked to find in question C is that in the first case, we're asked to find the median mark. How do you find the median mark given this cumulative frequency curve? This is what we do. Look at the cumulative frequency that we got finally. It's 200, okay? So we have the median mark will be at the 200 over 2 position. Okay? And that will be the 100th term. Okay? So we are looking for the 100th term. 200 over 2 is 100. So here we can see this is our 100. And I can just come over to my graph. On the cumulative frequency graph, this is 100 here, this 100, and then I want to trace from 100 to the curve. Oh, beautiful. Okay, then from there I want to trace down to see what my mark is going to be, and here it is, just particularly at this location. You can see. So the question is, what mark is corresponding to that on the upper class boundary axis? You can see from the graph that is going to give, it is exactly in the midpoint of 49.5 and 59.5. okay? So, or if I want to just take my normal division that I extrapolated before, I will say there are subdivisions of 2 marks. So I have 49.5 here plus 2, that will be 51.5, plus another 2, that will be 53.5. If I want to add another 2, that will now be 55.5. So I have 53.5, I have 55.5. What is the middle of that? And that will be 54.5 marks. Okay. normally there will be a margin for error in the exam, so they may add plus or minus 1 mark, but for this particular question we can see that we are quite on point. It is 54.5 marks. So this is corresponding to the first question in number C. Okay, now we need to look at the second question in C, in which we are told that if 5% of the students add distinction, so 5% add distinctions, then we are to look at the least mark for distinction. Now, this is what we need to do. If 5% add distinction, that means that 95%, that's 95 over 100 of 200 is going to be the least mark for distinction. And like this, you can just cut 100 here 1, 100 here 2. So 95 times 2, that is the 198th term. So it is the 198th term that will correspond to the least mark for a student to get to earn distinction in the result for the marks that we are collating. So we need to look at the 198th term, and if you look at this curve now, this ogive curve, this 180, this 200, in between them will be exactly 190 because it's the median of the two. So we have 190 here, but we are looking for the scenario in which we trace this 198th term to the curve and then find the mark on the upper class boundary as it. So we can just trace like this from 190, just take it to the curve, ensure that is a straight line. I don't want to miss that. Okay, and then from whatever it is that we are looking at, we can just ensuring we have our straight line, so that you can make use of your ruler to find this correctly. And you can see this is quite good. So we are looking at this position, that is the value of the mark that we are concerned about. Now look at this. Initially we have identified that each of the small divisions of my box is taking 2 marks. So here this is just the box immediately before the 89.5 marks. So just taking 2 marks out of that will amount to 87.5. So this is going to give me, this one was 54.5 marks. This is going to give me 87.5 as a mark for distinction. Okay, you can just take a margin of error of plus or minus 1, but 87.5 will be the least mark for distinction in this particular set of data that we are given for the marks scored by students in the test. And like that, we have come to the end of this beautiful question on cumulative frequency curve, in which first we evaluated the cumulative frequency table, we found the upper class boundary, we evaluated the cumulative frequency, and we used those data to plot the graph of the cumulative frequency curve, that is the ogive, just as it was shown here. And then we're able to use the curve to find the median mark, which amount to half of the total cumulative frequency, that's half of 200, which is the 100th term, and we found the corresponding mark for the 100th term to be 54.5 marks. And then we were able to find the least mark for distinction if 5% of them are distinction. The 5% will amount to 190 to 200. This region here, this region at the top of the curve, that's the distinction. So the least mark, we just trace it to the upper class boundary as is to get the least mark for distinction as 87.5 marks. So this is just the process that you need to follow as student to be able to work with cumulative frequency curve, the ogive curve, the cumulative frequency table. And the admonition we always give is that the more you practice with this, the better you are going to become. Okay, so just take your pencil, take your graph sheet, take your workbook, go through your past questions, look at all the years in which you are seeing questions that are featuring the cumulative frequency table or the cumulative frequency curve, and make sure you attempt them, and you will see that to be better prepared for your exam to gain. In this question on circle theorems, we are told that in the diagram, MNPQ, this MNPQ is defining a circle with center O, and then line MN is equal to line NP. So this is MN and this is NP. You can see they are being notched together. Okay, they are, both of them are notched to show that they are of the same length. And then angle OMN is 50 degrees. Here OMN is 50 degrees. We are asked to find angle MNP and angle POQ. So in the first case, we are asked to find angle MNP. So what we are looking for is angle MNP. And if you look at the diagram, MNP, so this is the angle in question. Let me just show that in red. This is the angle in question, and I can call that angle X. So I can say my MNP is equal to X from the diagram, okay? And then how do we go about solving this particular question to find the value of X? This is where we need to bring in our ingenuity and understanding of circle theorems and every other practical laws that we can bring into play to solve this question. Now, looking at the question originally, we are told that MNPQ is a circle with center O, but that's not the only thing we can say about MNPQ. If we are not defining MNPQ along the path of the circumference, we can also define it along these straight lines in which we are having a polygon with 4 sides, and that is forming a cyclic quadrilateral. What's the meaning of that? That means a polygon with 4 sides that is inscribed in a circle, so we call it a cyclic quadrilateral. And if I want to just show that, I will just start from M again. We have M, N, P, and Q. You can see that's the third side, and then here we are having the fourth side. So that is a cyclic quadrilateral, and there's a property that we are going to make use of, that the opposite angles of cyclic quadrilateral are supplementary. So we need to note this: opposite angles of cyclic quadrilateral are supplementary. I'm just writing this in short notes. I know you'll be able to follow through. So if you are to apply this particular theorem, how do we go about applying it in this particular case? We need to identify the opposite angles of this cyclic quadrilateral. It has 4 sides, 1, 2, 3, 4. So what is the side facing this particular 50 degrees angle? It is this particular angle. Okay, so we can say angle QMN plus the angle opposite it, that is angle QPN, both of them add up to 180 degrees. Okay, and in the same vein, look at the angle we are looking for, MNP, which is X. Let me just write it as angle MNP plus the other angle MQP, they also add up to 180 degrees, following this particular postulate that opposite angles of cyclic quadrilateral are supplementary. Okay, so that's the first thing I want us to note. The second case, look at this. Just take a look at this. The diameter of the circle, from what we are looking at in the diagram, happens to be the line MQ. So we are told that O is the center of the circle, and you can see this is a straight line starting from one end of the circumference, passing through the center and going to the other end of the circumference. So that is the diameter of this particular circle. But we're also seeing that that diameter is subtending an angle at P. Okay, so from M to Q, you can see MPQ, in which MQ is the diameter. And there's another theorem for the circle that we are told that the angle, we are told that angle subtended at the circumference, of a circle by diameter is a right angle, is 90 degrees. That's what it means by is a right angle. The angle subtended by the diameter of a circle at the circumference is a right angle, it is 90 degrees. That means that what we have here is this angle is going to give us 90 degrees. Okay, that is this other postulate that is giving us that information. Okay, then in the question we are told that line MN is equal to line NP. So MN here and NP, they are equal. And what is the implication on that? From the triangle MNP, we can see that this particular angle and this particular angle, they are going to be equal. So if I call this A, this will also be A. Why? Because they are base angles of an isosceles triangle. Isosceles because two of its sides are equal, and then the base angles are also going to be equal. So I can say this is A, this is A. I can say angle NMP is equal to angle NPM, and that is A. I denoted that as A. All right. And then all of this, how are they going to help me to solve this particular question? I know that this is angle 90 degrees now. All right. And I know that the sum of this angle 50 here and this angle, they are going to be supplementary. They will add up to 180 degrees. That will allow me to find the angle A. If I know this particular angle A, I can actually use this particular triangle that I said is isosceles to sum the angles of this triangle, which I also know to be 180 degrees. And since I know A, I can find this A also. Of course, both of them are A. I can add 2A to X to equate them to 180 degrees to solve for the value of X. That's why I'm actually postulating all of this. And from what I've been saying all along, that means that I can say QMN, angle QMN plus angle QPN, which are opposite angles of the cyclic quadrilateral. They add up to 180 degrees. Now, what is QMN? QMN will be given to be 50 plus QPN. Now, look at QPN. QPN happens to be this 90 plus this A. That's the beauty of what we need to actually apply here. 90 plus A, which is QPN. QPN. It is this right angle, this 90 degrees, plus this particular A here. So the sum of the three is 180 degrees, such that A will be 180 minus 50 plus 90 is 140. So A is nothing but 40 degrees. Good and interesting. So I have my A to be 40 degrees. I can now look at this triangle MNP to say from triangle MNP, I know that the sum of angles of a triangle is 180 degrees. So I can say the sum of angles is going to give me 180 degrees. And summing the angles, I can say that means that X plus A, you can see X, A, and A, they are the angles of the triangle MNP. The three of them is 180 degrees. And in that case, X will be 180 degrees minus 2A, because A plus A is 2A. And that is going to give me my solution that X is equal to 180 degrees minus the value of A that we got was what? Was 40. So X is 180 minus 2 times 40 is 80. And 180 minus 80 is 100 degrees. So the value of X, which is angle MNP that we're asked to find, is nothing but 100 degrees. And you can see how we're able to find it, because we look at the cyclic quadrilateral and we also look at the isosceles triangle, and then we look at the fact that the angle subtended by a diameter and the circumference of the circle is a right angle. And bringing these three together, we're able to postulate and apply the applications of these theorems to get the solution to angle MNP as 100 degrees. So we can now move on to angle POQ. Okay. So in this second question, we are to look for angle POQ. Okay. And POQ, what is POQ? This is POQ. Is this angle here that we are looking for now? Let me call that angle Y. So I can say it's angle Y. Alright, so that I will not be confused just writing POQ and POQ all around. Now, there are quite a number of ways that we can apply to solve for this particular question. But first, let's just identify some other things. Looking at this triangle, we can notice that here, from the center of the circle to any point of the circumference. Any straight line drawn from the center of the circle to any point on the circumference is going to constitute the radius of the circle. So this line OQ is the radius. This line OP is also another radius. Okay, so OQ and OP constitute the radius of the triangle. Okay, this triangle OQP. And if that is the case, then I can know that the base angles of this triangle are also going to be equal. So this angle here, this angle, if I call this B, then this angle here, it's also going to be B. Why am I saying that? Because they are the base angles of this isosceles triangle. So I can just state that out, that angle OQP is equal to angle OPQ, and I'm denoting that as B, and I'm calling them the base angles of isosceles triangle OPQ. Okay, they are the base angles of the isosceles triangle OPQ. But you recall that we have gotten the value of x to be 100 degrees. Now, MNP, just look at this now. Angle MNP plus angle MQP, if you are observant, we will see that they are also opposite each other. This is a circle quadrilateral, so MNP, this x, and MQP, this b, they will add up to 180 degrees because they are supplementary. So MNP is x, so this is x, plus MQP is b, and the sum of the two is 180 degrees. So our b will be 180 minus x. And from our previous question, we have gotten x to be 100. So angle B is 180 degrees minus 100 degrees, and that is nothing but 80 degrees. So B here is 80 degrees. But looking at the triangle OQP, but from triangle OQP, we can sum the angles in that triangle to say y plus b is equal to 180 degrees. Why am I saying that? Y, b, and b, they are the angles in that particular triangle. And we know that the sum of angles of a triangle is 180 degrees. So y will be 180 minus 2b, and that is nothing but 180 minus 2 times 80, and that will be 180 minus 2 times 80 is 160 degrees. So y, which is the angle POQ that we are looking for, is nothing but 180 minus 160 is 20 degrees. Now, this is what I want you to note. Students, there are so many ways you could have gone ahead to solve these questions. It just depends on your ingenuity of how to identify the theorems that you need to use. So I could have said, here, this angle here is going to be 2x because it is going to be twice the angle subtended at the circumference that we have at the center. But look at something. Both of them are facing the same side. X is facing here, and here in the middle is also facing here. Okay, so this is 2x, and 2x is going to be 200. All right. Now, that 200 that we just got, we can see that it is the angle on the straight line, MQ, which is 180, that is adding to this y plus y that is giving us this particular 200 degrees that we got as 2x. And if that is the case, you can say that y is nothing but 200 minus 180. And look at it. Is that not the same answer? Of course, that is also going to give us 20 degrees. So there are just so many ways. You just need to master all the theorems of the circle theorems. Then you need to understand the circle quadrilateral. You need to understand the properties of an isosceles triangle, and you'll be able to solve questions like this. There is no particular single way to solve it. There are just many ways. This is just another method I showed. There are so many other ways I could have chosen to say, no, I also want to apply this. But the thing is that you need to practice. The more you practice, the better you become, and that's why you should just check our playlist to develop your proficiency in solving questions like this, and then you'll be able to dust them in an exam and gain that excellence. All right.
Here in this question on the equation of a line, we are asked to find the equation of the line which has the same gradient as 8y plus 4x is equal to 24, and the line also passes through the point minus 8, 12. So the understanding that we need to have to try and solve this type of question is to know that whenever we are talking about two lines in which we are looking at them to have the same gradient, like here, we are told that it has the same gradient as 8y plus 4x is equal to 24. So we can have a pictorial view of something like this. If you have our Cartesian plane and we are looking at the vertical axis and the horizontal axis, if you have defined a first line to say this like a particular first line, if we define it as y1 is equal to mx1 plus c1, in which here c is the intercept and this is the y-axis and here is the x-axis. But now we are being told that this particular line, just like we are given in this equation, has the same gradient with another line, but we are now told that that other line passes through a particular point like minus 8, 12. Now this is what we are going to have. That means both of those lines, like the first one we are given and the other one that we have just like this, you can see it means that if this is the second one and we have it like y2 is equals to mx2 plus c2, in which here this is also the intercept, that's c for the second one, and we have the x-axis and the y-axis. The thing common to the two of them is that for them to share the same gradient, then the slope of the first one is equal to the slope of the second one. So m1 is equal to m2 for them to have the same gradient. So once we have this particular understanding, it will make our work easy, because what we now need to do is that from the first equation, we can find the slope by writing it in the order y is equal to mx plus c, and then since we know the point that we are given for the second equation, we just interpolate those points with y and x and use the gradient that we have gotten for the first one. So for this particular question, we are given that 8y plus 4x is equal to 24. But we want to look at a means in which we can arrange like y is equal to mx plus c, and we can say this means that 8y is equal to minus 4x plus 24, and that is obtained by moving 4x to the right hand side. And now we can see that if we want it to be y is equal to mx plus c, we should divide this equation by 8, the left hand side and the right hand side. Each of the entities, in fact, we can divide by 8, and if we do that, we are going to have something like this. 8y over 8 will be y, okay, is equal to minus 4 over 8x plus 24 over 8. In short, let me just put the first one also as, this is also 8y over 8. We are dividing each of the entry by 8. Therefore, what we have is that this 8 and 8 will cut, so we have y is equal to minus 4 over 8 is the same as minus 1 over 2x, then 24 over 8 is 3. So this is the alternate representation of this equation that we have here. Instead of writing 8y plus 4x is equal to 24, we can write it as y is equal to minus 1 over 2x plus 3. Why did we do this? Because we want it to look like y is equal to mx plus c. And you can see from here, what are we noticing? We are noticing that this means that our m is equal to minus 1 over 2. And this is what we need to use for the other equation. That's why we are trying effortlessly to make sure that we express it in the form y is equal to mx plus c. So having done that, we can now look at the means by which we can get this other equation that is passing through the point minus 8, 12. So what I want to make use of is this general equation that the change in y is equal to m multiplied by the change in x. And what's the meaning of this? This implies that y minus y1 is equal to m multiplied by x minus x1. So where is my y1? Where is my x1? It is the same as what we are giving here. This that we are giving is the same as x1 comma y1. So x1 is minus 8, y1 is 12. So here, if you want to plug in those values as appropriate, you can just say this is now going to give us y minus, our y1 is 12, so we have 12 is equal to, what's the value for our m, the gradient? That is minus 1 over 2 multiplied by x minus x1, and that x1 is not 8, it is minus 8, so we need to put it appropriately as minus 8. And this will mean that we have y minus 12 is equal to minus 1 over 2 multiplied by x. When we say minus 8, it's like we are multiplying two negative numbers, okay? And the product of two negative numbers is a positive number, so we have this to be plus 8, okay? So having done that, what we can also do is we can cross multiply these two at the numerator. These two at the denominator can be used to multiply the whole left hand side. So we are going to have something like 2 into y minus 12 is equal to minus 1 multiplied by x plus 8. So again, if you expand that bracket, you can see 2 times y will be 2y, 2 times minus 12 will be minus 24 is equal to minus 1 times x is minus x, minus 1 times 8 is minus 8. Okay, so now we want to just leave y on the left hand side and take the other number, this minus 24, to the right hand side. So we are going to have 2y is equal to minus x minus 8, but now it will be plus 24 because initially it was negative. When it moves to the right hand side, it will become positive, and that is the same thing as saying 2y is equal to minus x minus 8 plus 24 is plus 16. I want to write it in such a way that we will express it just like we expressed the first one, and to do that we can just divide each of the entry by 2, and if we do that, that means what we are going to have is that here these two can cancel. So we have y is equal to minus x over 2 is the same as minus 1 over 2x, okay? Then 16 over 2 is 8. And like this, we've been able to solve this particular question correctly. And you can see, look at the two equations. Here we have the slope to be minus half, and here the slope is also minus half. It's only the intercept that is changing. In the first case, the intercept is 3, but here the intercept is 8. So this is how to go about solving our question, and the correct solution is y is equal to minus half x plus 8. In this question on circle theorems, we are told that in the diagram, line AB, this line AB, is a tangent to the circle with center O. So this circle with center O has line AB as its tangent, and COB is a straight line. So this is COB, that's a straight line. If line CD is parallel to line AB, so CD here is parallel to this line AB, and angle ABE, that angle is 40 degrees, we are to find angle ODE. So let's try and locate that. This will be the angle ODE here. We can call it X, okay? That's the angle that we're asked to find. Now, how do we go about trying to solve this particular question? Looking at all that we are given, we need to bring in the ingenuity of our understanding of parallel lines, intercept theorem, circle theorems, and triangles to try and solve this particular question. And the first thing I would like to look at is, look at this line COD. The line COB that we're given is a straight line, means that line COE is the diameter of the circle. So if COE is the diameter of the circle, the angle that the diameter of the circle subtend at the circumference, this angle CDE, is going to be 90 degrees. So this here, this angle here, this is going to be a right angle. So I can say from my diagram, the angle CDE is going to be a right angle. Why? It is the angle subtended by the diameter at the circumference. Angle subtended by the diameter at the circumference. That's the reason by which I can postulate that this is nothing but 90 degrees. So it's the understanding of circle theorems that is allowing me to make that postulate. Now, if that is the case, I can look at this particular triangle ODE. If I look at the triangle ODE, from here I can see that, look at this, the center of the circle. From O to E, this is the radius of the circle. From O to D, this is another radius of the circle. So, meaning that this angle here, I can also render it as x. Why? Because they are the base angles of an isosceles triangle. Why am I saying isosceles triangle? Is because this triangle ODE has two of its sides to be equal, and so it inherently have the base angles to be equal. That is the property for the isosceles triangle. So I can say angle ODE is also equal to angle OED, and I've tagged it as x, and because they are base angles of isosceles triangle, base angles of an isosceles triangle, a triangle that has two of its sides equal, and therefore it also have the base angles equal. Okay, finally, I think we just need one more thing and we'll be able to solve this particular question. Look at this particular diagram here. If we consider, we are told that the line AB and the line CD, they are parallel to each other. So we can look at the transversal running across the line AB and line CB, and this is the transversal, it is the line COEB. If I go to this line AB and draw this particular straight line, and I also go to C, okay, and I also come here, I can see readily that this angle here, that we're given to be 40, and this angle, they are going to be equal. So this is also going to be 40, meaning that I can say the angle ABE that we're given is also equal to angle BCD, and the value is 40 degrees. And why? Is because they are alternate angles. That's another property of parallel lines in which we have a transversal running across the two of them. So with these three postulates that we have already, how can we make use of that to solve for the value of x, which happens to be the value of the angle ODE that we are looking for? This is what I want to look. Just look at this. Consider the triangle CDE. We can see that we have three angles there. We have 40. Here we have 90 degrees. This is a right angle. And here we have x. We can say 40 degrees plus 90 degrees plus x is equal to 180 degrees. And why are we saying that? Is because they are the sum of angles of a triangle. And we know that the sum of angles of a triangle, they always add up to 180 degrees. And in that case, if you are to solve for x will be 180 minus the sum of 40 and 90. Now, 40 and 90 will give us 130. So x will be 180 minus 130, and that is 50 degrees. And therefore, the angle that we are looking for, which from our postulate we've been able to say that angle ODE is equal to x, you can say angle ODE, we said it was x, and the value is nothing but 50 degrees. And you can see how our understanding of parallel lines and the transversal running across them can help us to generate alternate angles. How the fact that the line or the diameter of a circle subtends a right angle at the circumference here at D, and finally the sum of angles of a triangle adding up to 180 degrees. All these postulates, you can see how they have helped us to evaluate the correct solution to this question, that angle OD that we're asked to find is nothing but 50 degrees. All right. In this question on mensuration of shapes, we're told that ABCD is a parallelogram in which the line CD is 7 centimeters, the line AD is 5 centimeters, and the angle ADC is 125 degrees. First, we have to illustrate the information in a diagram. I think this is a bit for the examiners to actually ensure that students have some good understanding of how to construct, because this is as good as a question which are being asked to construct. But how do we go about solving this particular type of question? First, we need to understand what we are being asked. Here, we are being told that we are working with a parallelogram, all right? So, what is our understanding of how a parallelogram looks? A parallelogram actually has its four sides being parallel 2 by 2 to one another. So this line and this line will be parallel, and this line and this line will also be parallel, all right? But here in the question, we are told that, look at this, the line CD is 7 centimeters, AD is 5 centimeters, ADC is 125 degrees. As a rule of thumb, even if you look at this and you consider this particular diagram, you can see that the angle that will be greater than 90 is either this one or this one. Any of the two will be suitable for you, okay? So for me, I think I want to pick here. So that means that I will have something like this. I just want to do a rough, in which if this is the 125 degrees, ADC means that is the midpoint here. This is D that we are taking the angle. Then we are told that AD is 5 centimeters and CD is 7 centimeters. Between these two, which one is longer? You can see that this is the longer one. So this will have to be CD and this will be 7 centimeters. And here will have to be A, so that this is AD and this will be 5 centimeters. So is the understanding of knowing how a parallelogram looks that will enable you to solve this question wonderfully and correctly. Like here, since I now know this is AD, this is CD, of course the last vertex will have to be B. So I've drawn my parallelogram ABCD as requested. So this is my rough. I'm still going to construct it correctly, and I can just say I want to clear the board, and now I can just correctly represent the diagram just like this. I have this line, I have this line, I have this line, just some pictorial view or something at least that will make sense, and we need to show that this line is parallel to this line. And this line is parallel to this line. I got this to be D, in which here is angle 125 degrees. This is A, so that AD is 5 centimeters, and then this is C, so that CD is 7 centimeters, and finally the last vertex is B. So this is the first solution that we're asked to find, that we're to illustrate the information in a diagram. Now we're to find correct to one decimal place the area of these parallelograms. And what is the formula for the area of a parallelogram? The area of a parallelogram is given by the product of the base multiplied by the perpendicular height. Okay, so this height is not this slant height. We need to look for a means to find the perpendicular height here. Okay, and that perpendicular height, by reason of its definition, it has to be at right angle to the base, and so this is the h that we need to multiply by. In this particular case, 7 centimeters is the base. So how do you find the value for the height? That's the first task that is also confronting us like this. Now there are two particular ways we can actually evaluate it from here to try and find this particular angle and then sort it out, or we can actually bring it here, which is what I want to do. I can just say here, this is also going to be my height. Okay, and I want to show you just a beautiful symmetry that is going to be here. Now this angle at D we're given to be 125, but already I'm saying that I'm looking for a right angle here. So if I take 90, which is a right angle, out of 125, this is going to remain 35. Okay, so looking at this particular shape, if I call this O, I can say from triangle ODA, which is something that I have like this. Okay, so this is also 90, and this is 35. This is H, and this is 5. Now, this is the angle that I'm considering at D is 35. This is O, this is A. This 5 will happen to be the hypotenuse, okay, because it's the side facing the right angle and it's also the longest side. And then H is the adjacent. So my question is, what is the formula that is relating the adjacent and the hypotenuse for a right angle triangle? Recall, we are actually going to make use of SOHCAHTOA. So we are looking for what is relating the adjacent and the hypotenuse, and you can see it is cos. So from here, I can say cos 35, which is nothing but adjacent over hypotenuse, is going to give me the adjacent is H that we are looking for, and the hypotenuse is 5, such that H will be 5 cos 35 degrees. And if I bring in my calculator to evaluate that, I can say 5 cos 35. What is that going to give me? 4.09576 or 4.096. So this is 4.096 centimeters. All right, but nobody asks us to find the height. We actually asked to find the area. So since I now know the height, I can say the area of the parallelogram is the base, which is 7 centimeters, multiplied by the height, which is 4.096 centimeters. And if I'm going to evaluate that, I can say that's the last answer that I just got, multiplied by 7, and that's going to give me 28.67. That's 28.67 centimeters square. But look at what we're asked to find. We're asked to find correct to 1 decimal place. So this is approximately equal to, if we want to put this to 1 decimal place, that means only one number, only one digit will reflect after the decimal place. So we'll take 7 and round it up. Numbers between from 0 to 4 are rounded down to 0, but from 5 to 9 they are rounded up to 1 and added to the initial number. So 7 will be rounded up to 1, and when we add that 1 to 6, this is becomes 7. So we have 28.7 centimeters square as the area of the parallelogram that we are given here. So alternatively, we could have said that, looking at this particular H in blue, you can say that 125 plus this angle here, if I call this theta, the two of them, they are actually supplementary. They will add up to 180 degrees. So this will be 180 minus 125, so it will be 55. Then we can also use SOHCAHTOA to find, because this is also 5, this is 5 centimeter, and no, so now we have the hypotenuse, which is 5 centimeter, and we are looking for the opposite. So instead of using cos, we will now be using of sine, which is opposite over hypotenuse, and we'll still find the value of H to be 4.096, and then we can multiply the areas to be 7 times 4.096 and still arrive at the same answer as 28.7 centimeters square. All right. Yeah, in this question on algebra processes on surd, we are told that if x is 1 over 2 multiplied by 1 minus root 2, we are to evaluate 2x squared minus 2x. So we can just go ahead directly and put in the value for x into this particular expression and open our bracket and solve algebraic wise to see what the solution is going to give us. So we can say, given that x is equal to 1 over 2 multiplied by 1 minus root 2, okay, we want to find 2x squared minus 2x, but I can even say, okay, maybe s is common. Let's just substitute the values of s and see what we're going to get here. So that will be 2 multiplied by x squared will now be 1 over 2 multiplied by 1 minus root 2. All of this raised to power 2 because this is x, then minus 2 multiplied by 1 over 2 of 1 minus root 2. Alright, so if we are to try and solve this, these two I'm still writing, the square of this 1 over 2 raised to power 2 will become 1 over 4. Okay, then 1 minus root 2 raised to power 2 will be 1 minus root 2 multiplied by 1 minus root 2. Okay, so then that's the first entry, minus these two and these two can cut themselves, so we still have only 1 minus root 2 remaining for this second expression. All right, so here I can just say this 2 here 1, this 2 in 4 is 2. So what I'm having is 1 over 2 multiplying the product of 1 minus root 2 times 1 minus root 2. So we can take this piecewise. 1 times 1 is 1. 1 times minus root 2 is minus root 2. Okay. Minus root 2 times 1 is minus root 2. Then minus root 2 times minus root 2. First, we have two negative numbers. The product of two negative numbers will be a positive number. Then root 2 times root 2 is the same as if you're having 2 raised to power 1 over 2 times 2 raised to power 1 over 2. And by loss of indices, we just take 1, 2, and we say half plus half, and that is 2 raised to power 1. So this is 2, meaning that root 2 times root 2 is nothing but 2. Okay, so let me just clear my rough working. So this here is 2, and I can close the bracket, then minus times 1 will be minus 1, minus times minus root 2, the two negative numbers will multiply, so this will be plus root 2. Okay, so here we can just see that what we have is 1 over 2 multiplied by 1 plus 2 here is 3. Okay, then minus root 2 will give us minus 2 root 2. Okay, then minus 1 plus root 2. I think our work is getting done now. So if you want to expand this, this will be half times 3 will be 3 over 2. Half times 2 root 2. These 2 and these 2 will cut. So we have minus root 2. Okay. Then we have here minus 1. Then we have plus root 2. Look at this. Minus root 2 plus root 2. Those will cut out. So we have 3 over 2 minus 1. And we can just say we want to find the LCM, which will be 2. 2 in 2 is 1. 1 times 3 is 3. Minus, this is 1, which is also 1 over 1. 2 divided by 1 is 2. 2 times 1, that will be 2. So this will be nothing but 3 minus 2 is 1. And we have 2 as the denominator. So all these expressions, all these that we're asked to evaluate, look at how it's just easily simplified for us, and our solution is 1 over 2. All right. In this theory paper from the WAEC 2020 WAEC exam, here is a question on construction in which we are asked to use a ruler and a pair of compasses only to construct, in the first case, a triangle ABC with line AB to be 7.5 centimeters, line AC to be 13.5 centimeters, and angle ABC to be 120 degrees. And then we should find the locus L1 of point, which is equidistant from A and B, and in the same vein, the locus L2 of point, equidistant from B and C, and then using N, which happens to be the point of intersection of line L1 and L2 as a center, we are to draw a circle to pass through the point A, B, and C. So we are going to be taking our ruler and compasses that they just asked us to use, and we are going to be constructing this triangle and finding the solution as requested. But before we do that, I just want to run through a rough of what we're going to do so that we can have at the back of our mind, this is what the diagram is going to look like. Then we can appropriately plan and also section our construction paper as appropriate. So in this case, we are told that line AB is 7.5, line AC is 13.5, and angle ABC is 120 degrees. As a rule of thumb, it's ideal that we start
with the angle so that we can get the inclination of the sides of the triangle as appropriate. So here that we are told that ABC is 120 degrees, that means it is at point B that 120 degrees is going to reflect. So if we have our straight line like this, we can say we want to locate point B. So this will be point B, and it is on point B that we can mark off 120 degrees. So from B, we want to mark off 120 degrees to go to line A. Okay, something like this. But for me, I will just note that here this is going to be 120 degrees. Okay, and then from B to A, that will be 7.5 centimeters. So this is going to be 7.5 centimeters. Okay, and then the other thing we are told to do is to find AC is 13.5 centimeters. AC, so from A to C, and you know C is also going to be on inclination of the line from B. So I can just take another line from A going to, this will be quite longer than 7.5, almost twice the length. So I can stop here to say this is now point C, that is 13.5 centimeters from A. Okay, so this is the triangle that we're asked to construct. It's going to look something like this, and then we have to find the locus L1 of point equidistance from A and B. The locus of point equidistance from A and B is going to be the perpendicular bisector of this line AB. So we are going to have something like this. This is just a rough, okay, so no problem. We are just trying to look at that rough. Okay, we are going to get that. So this will be the line L1, this will be line L1, and in the same vein we are to look at another perpendicular bisector of B and C. So that will also be something like this, because it will divide the line BC into two equal parts. That is what will define the locus of point equidistance from B and C. So this will be the line L2, this will be line L2, and then the point of intersection, like we are told there, N is the point of intersection. This is N. Then we are to draw a circle to pass through the point A, B, and C. So that means that from N to any of these points, any of these vertex of the triangle, it's going to be the radius of that circle we're asked to draw. So the circle will now look something like this. N as the center, then from here you may have something like this. Okay, and then the circle will just continue and go all around like this. So this is what our diagram is going to look like. Alternatively, you could have said maybe this is B, A could have been inclined to this side, and then in that case C will come to the left, but you will still get almost the same, you get the same thing. It's just that now your angle will be flipped to the other side. So this is what we are going to construct, and we are going to take out our construction sheet and use just ruler and compasses to define all of this that we are looking at in this diagram. Now, since we understand what we really want to do, we can go ahead to carry out our construction as appropriate. And the first thing that we want to do is that we want to draw the straight line. So a straight line on the ruler, that's going to be the general reference, and I want to identify the point B. Okay, so I'll just take a particular point, let's say here. That will be my point B. Okay, so I can just label that appropriately and say everything will actually now emanate from that point B, since I've identified that as the point of reference that will be appropriate for me to use. Now, to construct angle 120 degrees at point B, what we do is we bring the compasses to that particular point, okay, and then take an arbitrary radius, not too large. So we just want to take this particular arc, which is going to be angle on a straight line, and that is 180 degrees, but now maintaining the same radius. Okay, we still maintain that same radius. We can take the compasses to one end of the arc that was just drawn. So that's what we're doing here, and then we can mark off
the 180 degrees that was just drawn. And here, what we are doing is that this particular arc is marking off 60 degrees to this left, okay, and then to the right is 120 degrees, because that arc that we used to mark, if we mark another one here, we are dividing that particular straight line angle into 3 equal parts. Now, one part is taken out. One part of 3 is actually 60 out of 180. So the remaining here is 120. So there we have our 120 degrees. Okay. So that is done. We want to mark off the line AB, and AB we are told should be 7.5 centimeters. So to do that, we just need to bring in the ruler and then mark off 7.5 centimeters on the ruler. So if we go to the starting point of the ruler and we extend that to 7.5, just try as much as possible to be accurate. So this is 7.5. that is what we are going to use to mark off an arc from B, but it will be linking this particular arc that we have drawn. So if you want to take it, it should go from here to here. So we can mark off our point on this arc. Okay, so once we've done that, we'll now need to bring in our ruler to appropriately join this particular point B, but it needs to pass through the arc that will mark off as 120 degrees. Okay, and then we can bring in, so then we can mark this off on our construction sheet, and that is how we will be able to actually get our point A as requested. So here, this will be point A. Okay, that's point A, and you can see we mark up the 120 degrees, and then we look up with the marked 7.5 centimeters and draw a straight line passing through point B to point A, and then we can label this appropriately that this is 7.5 centimeters, and then we already have our 120 degrees. This is 120 degrees. Okay, then we're also told that the length of side AC is 13.5 centimeters, and in the same way that we just mark off A, we can actually go to the ruler and use the compasses to mark off 13.5 centimeters. That is almost extending to the full length of my compasses, but no problem, you'll be able to do that quite easily. And then I will now mark off from point A, because we are going to C from A, and this is what I need to do. So just maintaining that my point of compasses on the right position, I will need to go to point the line from B, this straight line. Okay, and then I'll need to mark off that particular arc, and the intercept between that arc and this line is going to give 13.5 centimeters that was measured on the ruler to give us point C. So here you can just mark off that. You can see, and once that is done, you can just appropriately label again after we just join the 2 points A to C. So that's what we are left to do now. I want to join point A to point C. So just bring in your ruler and join those 2 points. And I want to use blue ink again. So yeah, I can just draw a straight line. All right. So just like that, our triangle is done and dusted, and I can just mark off the point C. So this is point C. All right, and it is 13.5 centimeters from A. So and just append that as appropriate. It is 13.5 centimeters. Then we are now asked to
find the locus of points that is equidistant from A and B. The locus of points equidistant from A and B is going to be the perpendicular bisector of the line AB, okay, such that at any point on that particular line, the distance from A to the line and the distance from B to the line, they are going to be equal. So for us to now bisect the line AB, we just take a particular radius, okay, but we need to be consistent with that radius. So just take a particular radius and we are going to use it to mark off. I think I'm okay with the ruler for now. So let's say we mark off this particular point here, and in the same vein we also mark it off here. And then we're going to use the same radius and also take the compass to point B, and then at point B we cross the other arc that we just drew, okay, and then we also go to the one on top and we also mark off that. So what we've just done is that we've been able to successfully look at 2 points that we can join. That's going to give us a line that is the set of locus which is equidistant from A and B. Is going to be the perpendicular bisector of line AB. So in the same way, we can just do the same to point BC, because we are also going to find the locus of points equidistant from line B and C. So that means we are looking for the perpendicular bisector of the line BC. So I'm just using the same arc because I think it will be appropriate. So I'm marking off from C, and then both at the top and at the bottom, and I will use the same radius and go to point B now, and go to point B and also mark off to cross the other arc that I just constructed, and this is exactly what is expected of us. All right, so having done that, I just need to bring in my ruler to join these two lines. Okay, so this is going to be my line L1 and L2, so I just need to join them with a ruler. So this is line L2. I'm using green for that, okay, and then I can also go and join the other set of arcs that was gotten initially. So I need to make them a very straight line, okay. I think that is okay, and then I'll just join these two lines also, and I think that is interesting. That is good. Okay, I'm bringing my label into this diagram. Now look at this. This is the line L1. That is the locus of point that is equidistant from A and B. It is the perpendicular bisector of the line AB. So if you take any point, maybe here, the distance from here to A and distance from here to B is going to be the same thing. Okay, so that is the perpendicular bisector of the line AB. And here we have the perpendicular bisector of the line BC, that's L2. So this is L2, the perpendicular bisector of the line BC. And then this is looking very interesting. Finally, we are told that N is the point of intersection of the two loci. So this is point N here. N here is the intersection of the two loci that we have constructed on the triangle. And finally, what we are now asked to do is that using N as a center, so we are to use N here as a center, we are to construct a circle that should pass through A, B, and C. Now, that statement is telling us that N is the center of the circle, and the distance from N to C, which is also going to be the distance from N to B, and also going to be the distance from N to A, is going to be the radius of the circle.
So I can just verify that it's going to pass through point C, point B, and point A, and I think looking at this, I'm okay with that. So I can just construct the requested circle. Alright, and you can see this is quite interesting as the circle that we're asked to construct. And just like that, we've been able to answer this question holistically as we are requested to do, and that is the beauty of knowing what you are requested to construct. And you can see from this particular question, we've been able to look at first how to get our point of reference, which in this case we identified as point B, because that's the point at which we are going to take our angle as 120 degrees, and then we mark off the arc that is corresponding to 7.5 centimeters along the line in which 120 is inclined. Then we use our ruler to construct the line AB, and then from A we now mark off from the protractor on the ruler, we mark off 13.5 centimeters and put the needle point on A, and then we mark off the arc of 13.5 centimeters on the line coming from B to get our C. And after constructing the triangle in that way, we went to find the perpendicular bisector of the line AB, which is defining the set of locus of points that is equidistant from A and B. And we did the same thing for the line BC. We constructed the perpendicular bisector to define the set of locus that is equidistant from B and C. And finally, we are able to use the point of intersection of the two loci, that is point N, as the center, and use the length to any of the side of the triangle to construct the circle that we are requested to draw. And with this, we've been able to complete our solution to the question on construction from the WAEC 2020 mathematics theory paper, question number 13A. So if you want more videos on construction, just check our playlist. There are quite a few videos that are there that will also help you to build your proficiency in solving questions on construction in mathematics.
Here in this question on solving quadratic equations with completing the square method, we are told to use the completing the square method to solve for this equation 4x squared minus 4 multiplied by root 3x plus 3 is equal to 0. So the question before us is, how do we use the completing the square method to solve for this question? And as a guide, this particular list of steps that can help us effectively to solve this question. So we have this as our guide for completing the square method in solving quadratic equation, and looking at what we have noted there, we are going to follow so that you students can have a superb understanding of what we are talking about when we are using completing the square method to solve questions like this. In the first case, we have the equation giving us to be 4x squared minus 4 root 3x plus 3 is equal to 0. If you are to compare this with the general equation ax squared plus bx plus c is equal to 0, you can see that already a, which is the coefficient of x squared, is synonymous to 4, b, which is the coefficient of x, is minus 4 root 3, and c, which is a constant, is 3 in this particular case. So what we are told first and foremost is that if the coefficient of x squared, that is a, if it is not equal to 1, we should divide the quadratic equation by a. So for a particular case here, that means we divide by 4 to say we now have 4x squared over 4 minus 4 root 3 over 4x plus 3 over 4, that's equal to 0. Okay, so here we can see that 4 can cancel 4, and this 4 can also cancel this 4, and we will have our equation now to be x squared minus root 3x plus 3 over 4 is equal to 0. Alright, and then in the second step, we are to write the quadratic in the form that the variables will be on the left hand side and the constant on the right hand side. So if you are to do that here, we just have x squared minus root 3x is equal to, when
3 over 4 moves to the right hand side, it becomes minus 3 over 4, and we are done with the second step there. Now, this is the key factor we need to really consider when we are working with completing the square method. And what we're asked to do is to add the square of half of the coefficient of x to both sides of the equation. Now, for us, that is actually minus root 3, okay? So what we need to do is we add minus root 3 over 2 all raised to power 2 to both sides of the equation. This is the most critical step that students generally make mistake from. So we should actually take note of it. And if we want to do that, we'll say this is nothing but s squared minus root 3x, okay, plus, now, when you have the negative of the number raised to power 2, that negative will actually become a positive because the negative number will multiply itself to take effect of the square, and that will now become positive. So it's the same as saying we have root 3 over 2 all square is equal to c, which is our minus 3 over 4 plus root 3 over 2 all square. Okay, so at this stage, students need to be very careful because what you now have on the left hand side is nothing but this is the same as x minus root 3 over 2 raised to power 2. This is the expression on the left hand side, and I'm going to show that in a minute. This is equal to minus 3 over 4 plus, now, root 3 raised to power 2 is 3, okay? Then 2 raised to power 2 is 4. Wow, interestingly. So here on the right hand side, we can see that minus 3 over 4 plus 3 over 4 will amount to 0. But I want to show you this because this is originally what you have. And I know this is where students generally make mistake. Originally, if you want to expand this, you will see that this is nothing but x minus root 3 over 2 multiplied by x minus root 3 over 2. Now, if you want to expand that, x times x is s squared. X times minus root 3 over 2 is minus root 3 over 2x. Then again, minus root 3 over 2 times x is again another minus root 3 over 2x. Then minus root 3 over 2 times minus root 3 over 2. The negative signs will multiply each other to give plus, then we have root 3 over 2 all raised to power 2, and you can see this expression is nothing but s squared. Now we have minus root 3 over 2 minus root 3 over 2. It's as if we are having half of root 3, and half in two places is going to give us a whole, so we can say it's minus root 3x then plus root 3 over 2 all square, which is the same thing that we have here. You can see that. So student, this is what you need to take note of, that when you have your expression like this and you are trying to use the completing the square method, this left hand side will resolve into this particular expression that we have x minus root 3 over 2 all raised to power 2. So that is just a very good point for you to note. I will clear my board now. And now, as easy as it gets, what we just have is that we have x minus root 3 over 2 raised to power 2 is equal to 0. Therefore, if we were to find the square root of both sides, you can say x minus root 3 over 2 is equal to 0. So this will give us x to be, when minus root 3 over 2 moves to the right hand side, it becomes root 3 over 2. And notice that this will now be occurring twice. So you can say you want to check if all that we worked is actually the correct thing. Like here we are saying that x is equal to root 3 over 2 twice, meaning we have x minus root 3 over 2 and x minus root 3 over 2 as the two factors like we are coming from here, okay? So of course, this is also the expression of this. This is x minus root 3 over 2 raised to power 2 and is reflecting here. So if you want to open this bracket, x times x will give us s squared. X times minus root 3 over 2 will give us minus root 3 over 2x. Minus root 3 over 2 times x will give us another minus root 3 over 2x. Then minus times minus here will give us plus. Root 3 over 2 times root 3 over 2. Root 3 multiplying itself will give us 3. Then 2 times 2 will give us 4. This is equal to 0. Now, this is the same as s squared. Here is as if we are having half. Look at this. We have half of root 3 and another half of root 3, but they are both carrying negative sign. So, it's as if we are having two halves that whenever we are combining them together, they will give us a whole. So, we have minus root 3x, okay, plus 3 over 4 is equal to 0. We want to reverse back to see if we can get our original equation. And for that, we can multiply both sides by 4. So 4 times the whole of s squared minus root 3x plus 3 over 4 is equal to 4 times 0. What we do to the left hand side, we also do to the right hand side. 4 times x will be 4x squared, okay? 4 times minus root 3x will give us minus 4 root 3x. Then 4 times 3 over 4, the 4's will cancel each other. We have this to be plus 3 is equal to 4 times 0 is 0. And you can see this check is actually confirming to us that x is equal to root 3 over 2 twice is the solution to this problem. The other area in which you could have had the problem is when you have something like, say, maybe originally we could have said that s squared is equal to, maybe we have 3 over 4. Therefore, x would have been square root of 3 over 4. And then this is the case in which it could have been plus or minus root 3 over 2, because root 3 will still be there. Square root of 4 is 2. But what we have here is not that s squared is equal to 3 over 4. You can see the square here was knocked out directly in this particular location, and then our x is root 3 over 2 twice. And that is the solution to this particular question.
Pam 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 pam. Alright, so students, let's assume it is the D-Day, the day for your exam, and all along you have effectively prepared. You have looked at your syllabus to know the topics that you're supposed to study for, to prepare for. You also prepared a timetable that will help you effectively prepare for this particular exam. And now, on the D-Day, all these preparations are good, but much more importantly are the instruction sets that you're supposed to follow in doing your exam. So today we are going to run you through some critical instructions that you need to follow to ace your exam and come out with flying colors. And we're going to be looking at the marking scheme for one of the exams from WAEC, particularly the mathematics 2020 exam. And so you can see here we are going to cover that, and that exam is going to be 2.5 hours. So you have this mandate before you that within 2.5 hours you want to attempt the questions that are expected of you, what you need to do, but there are instruction sets to follow, and that is what this video is going to be focusing on. And much more importantly, the marking scheme that will enable you to get your full marks without missing anyone. There are steps, there are instructions that you need to follow, and this video is going to prepare you for that. So let's just sit in, let's learn together, and I'll be back in a gimmick. Okay, so yeah, this is your question paper, and you're expected to write your surname, your other names, your index number, or your exam number. And so we are going to follow with this instruction set on what to do. So let's look at this instruction. In the very first case, you should ensure that you read these instructions, okay? Before starting your exam, you will have some time between the time you are given this question paper and the time you are told to start. Now, I just want to point out a number of things. First, in addition to writing your name on the front page of your booklet, you should write your index number in the area provided at the top of the pages in the designated space index number. So that means that on each page of your answer booklet, make sure you also write your exam number, your index number, because I've had occasion to know about instances in which some people, they swap booklets, okay? They remove the cover page and just swap with another person. So even the exam is also trying to help you that such will not happen to you. So on each of the pages
that you are going to be writing, make sure you write your index number, okay? Then please write boldly and legibly in ink, either blue or black, and state your answers precisely. Students, if your writing is not too good, I want to just implore you, just develop a means in which you write clearly and legibly. You don't want a situation in which the examiner will be looking at what is this person writing. Such will just warrant you that you are going to lose quite a number of marks. So write boldly, write legibly, let it be bold for any reader to see, and then state your answers precisely. Now, as you attempt each question, make sure that you write the number of each question at the top of each page. So within the spaces that are provided, we are going to see that when we look at this particular question paper, there are some spaces that are provided. Just write your answers within that. Don't go outside of that. And again, much more importantly, please do not tear off any part of the question paper or the answer booklet. If you make some mistake, just cross it out, okay? Just cancel it out, but do not tear off. That is not different from examination malpractices and will be graded as 0. So those are some instructions that I want to highlight, but you can just go through all in your exam. And then as we just move on to the question, look at this. Now, this is what I was saying initially. At the top of each page, you can see you have your index number where you can write your exam number, and then the question number that you are attempting. In this particular section of the mathematics paper, you are asked to answer all the questions, and you note that all the questions carry equal marks. But already you can see for this case, you are to answer this particular question 1A in this space that is provided. So for section A, you are not using your answer booklet, you are answering in your question paper. So you are going to submit both the question paper and the answer booklet. That is why you need to take note that this particular solution should be here. But for the section B, you will have another separate booklet and even graph sheet and construction sheets for mathematics in which you are expected to answer those questions. Now, this is a margin that is left for the examiner to grade you, so you are not expected to write in this margin. All your working should be between this space and this space, okay? That is what was provided, and you should just reflect everything within that space. So let's just take a look at a number of questions so that you can know how you will approach them, how you will answer them in the exam hall, okay? It's not just that you just walk anyhow, you just write anything and you expect that you are going to get your answers, okay? There are some guidelines with which WAEC had already earmarked that this is the way we are going to grade, and I'm going to show you them now, okay? Now, this is the exam scheme. You can see it's also for the general mathematics core paper 2, and it is for the year 2020. So this is the marking scheme that is going with this question paper. So if you are to look at it, I just also want to draw your attention to quite a number of stuff so that, see, there is no excuse for you not to make excellence. Following these guidelines, you can actually make your distinction and you can gain your admission and be the best that God has prepared you to be, okay? So good. Now, these are the general instructions that can help you. And the very first one of them is that marks are subdivided into methods, okay? So the method marks are the ones you obtain by using the right method that you are expected to use, okay? Then there is the accuracy mark, in which they need to grade you that, okay, you got the answer correctly, you got it right or you got it wrong, and then you get your mark if you got it right. And then independent accuracy marks that are not preceded by the method, and that one is marked as B. So you will see M, A, and B as we are going to be looking at the marking scheme. So for the right method, that is a M mark that you are going to get. For accuracy, you are going to get A, okay? Okay, not A as in decision, as in A for accuracy in the way that you approach the question. Then there are some that the mark that you'll be giving will not be dependent on the method that you use, okay? So you may have used another method, but it's still acceptable, so you'll be given that mark, and that is graded as B, okay? Now, there are some other things I just want to note the very key concept that you need to understand. Now, look at this option, this instruction 3. 2 marks are going to be deducted for you whenever you misread the data. If you do not answer any question to the given degree of accuracy, 1 mark will be reduced for you, okay? Then if you give an answer prematurely, 1 mark will also be deducted from you. So you should note that you should read your data appropriately. Don't misread what you are looking at. They are giving you, say, 100 as a particular data, and you are using 200. Of course, you have misread the data, okay? If you are using an accuracy, maybe at the end of the question, you are asked to approximate maybe to 2 decimal places, then you should know how to approximate to those two decimal places accurately, okay? And then you don't just approximate prematurely. I make it a rule of thumb, students, whenever you are working, only get to the final answer before you approximate. So these are some of the things you need to take note to ensure that you get your full marks, okay? So if you just want to move on, look at this. If you are working now, WAEC is saying that you are going to get 0 results for any work that is indecipherable or it is wholly suppressed. Indecipherable means that you didn't show it clearly. They couldn't get what you are really writing. They couldn't get what you are really working. So definitely you are not going to get any mark for that. And then if you suppress what you are really doing, you have some means of hiding or shading it, then that will also not get you any result. Now, if you omit any essential working, you are going to lose 1 mark, okay? So you just need to take note of all this. In instruction set 6, you are told that for proofs, unless otherwise stated, you will lose a 1 mark for not stating the reason for which you are applying those proofs. So you are going to see examples in which we have worked some questions, particularly from this year 2020 mathematics, and you see how we stated all of these proofs as we are working along, okay? Then students, you don't work without putting in your units. You are going to lose 1 mark for the omission of units or for wrong units, but well, it will not be more than once, but you don't even want to lose any mark, okay? So if you are working, maybe you are working in bearing and distances, and you are given distances in kilometer, and you are asked to find the distance between one point and the other, make sure you append the right unit as kilometer for that question. That will ensure that you get your full mark, okay? So another point I would like you to just note is this. Now look at this instruction set 10. Candidates who fail to draw diagrams for questions that require diagrams must be scored 0, whether the solution is correct or not. So sometimes you are given some questions in which you are first asked to illustrate the question in a diagram. Now, if you don't draw that diagram, even though you may get the working right, you may get the final answer right, you are going to be scored 0 because you do not show the required diagram. So please, whenever you are asked to draw a diagram, ensure that you draw the diagram, and then your work will be done and dusted. So we are going to look at one example now, like in this particular case where we are coming from. So here in this question, we are told that if A is multiples of 2, B is a set of the multiples of 3, C is a set of the factors of 6, the 3 of them, they are subsets of the universal set, which is defined so that 1 is less than or equal to S, which is less than or equal to 10. We are to find A complement intersect B complement intersect C complement, okay? This is the question. Now let's look at the marking scheme, and then we'll look at the way that we solve this question in Deep Tutor Academy, okay? Here you can see this is the marking scheme, okay, particularly for Nigeria and Gambia, but it's going to apply to you from the whole of West Africa. Now this is the question number 1A, okay? Now look at what is being done. First, there is a mark for you to state each of these sets that was defined, like here the universal set, okay, the set A, okay, the set B, and the set C. And you can see you are going to get marks for defining set A, B, and C. Okay, that's not all. If you also state the complement of A, the complement of B, and the complement of C, you're also going to get marks for stating those sets. You see, A complement, B complement, and C complement. And then finally, you are now going to state the solution to A complement intersect B complement intersect C complement. Now, it is by doing all this that you are going to get your full 5 marks that was appended to this question. Now, let's look at the way we solved ours from Deep Tutor Academy, okay? So, this is the solution that was snapped from the video that we have done. Access to that video is in the link below. You can watch it for you to effectively prepare for your exam. So look at this. This is the question. A is multiples of 2, B is multiples of 3, C is factors of 6. They are subset of the universal sets that we have read initially. And now look at this. This is the way we define our universal set, okay? And then we stated the set A, the set B, and the set C. And we didn't stop there. You also need to state the set A complement, B complement, and C complement. And you can see I'm marking this because these are the steps with which you get your final answer. And finally, we're able to state that A complement intersect B complement intersect C complement is 5, 7. So this is the right approach. And I even showed it there. You can see 5 is common to the 3, 7 is common to the 3. So this is the solution. So it is steps like this that will actually apportion you the full marks that WAEC is expecting you to get. And doing all this, you can see your distinction is just a matter of simplicity. You just seamlessly walk into excellence in your exam. Okay, so now let's take another question. Now this is a question on circle geometry, and we are given this diagram. We are told it's not drawn to scale, no problem. We are told that in the diagram, O is the center of the circle, A, B, C, D, E. Okay, line BC is equal in length to CD, and angle BCD, this angle here is equal to 108 degrees. Our mandate is to find angle CD. Now this is a question, okay, and let's look at what is expected of us to take stepwise so that we can get our full mark. Now in the first case, we are told that okay, you can represent the angle with a particular alphabet, and then after doing that, you will see that A plus 108 that was given is 180 degrees, and then for that you are going to get a mark. You can see here this is going to apportion you a mark. Okay, then you get A, no problem. For the accuracy that A is 36, you also get a mark here, A1 for 36. Then you also state that the angle BDE is equal to 90 degrees, and you also get a mark for that. And then the angle that you are looking for, CDE, is actually 90 plus 36, so you get a mark for adding. And then finally, for your final answer, you get 126. Now let's look at how we did this at Dave Academy. Okay, so here this is question number 3. Let's just go to question 3. Okay, good. This is question 3, and you can see from what we are being asked. First, we look at the diagram, and we represented with X. Okay, then we can see that 108 plus x plus x is 180, just like it was stated there. You can see a plus 108 is 180, and this is what I want you to notice. Why? It is because they are the sum of angles of a triangle. You can see this. We stated that the reason we are adding 108 plus x is equal to 180 is because they are the sum of angles of a triangle. Doing this, you are going to get your full mark, and then of course we got x to be 36 degrees. Okay, now that is not only all. Angle BDE, this angle BDE here, this one is actually 90 degrees, and we also stated the reason why, because it is the angle subtended by the diameter of a circle at the circumference. So for this, there is also a mark apportioned to that. And then finally, just as it was stated in the marking scheme, the angle CDE that we are looking for, CDE, is the sum of angle BDE, the 90 that we just got, and angle CDB, that was x. Okay, and that is 90 plus 36, and that will give us 126. And you can see that exactly what is expected of us from the marking scheme was what was used to solve our question, and with this your full mark is just given correctly. Okay, now I want to look at a question that involved a diagram in which you students, you yourself, you will draw the diagram. Okay, graph. Okay, yes, we can just use graph before we get to that particular question. Look at this particular question on graph. We have to copy and complete the table of values for this particular equation. Y is 3 sine 2x. So we have to use the scale to draw the graph, and then use the graph to find the truth set. Look at what they say. We say to find the truth set. Okay, 3 sine 2x plus 2 is 0. 3 over 2 sine 2x is equal to 0.25. Let's look at how to do that from the marking scheme, and then from Dave Academy. Okay, so yeah, this is the question number 6. I think first we are asked to copy and complete the table of values. So now this is the table of values that we are asked to complete, and let's see how we did that. For each of that, you are going to get for each of the entries that you have, you are going to get a mark. 1, 2, 3, 4, 5, 6, 7, 8. You are going to get marks for doing that. Okay, so you have 3 marks to get those values. Now if you look at our solution, question number 6. Okay, yes, you can see here, this is the table of values. Okay, this is the table of values that we append us some of those full marks. Okay, and then for the graph, you also get 3 marks for getting your graph, and you can see this is the graph, and it is appending you some marks. But I also want you to see this. I think students generally find this challenging whenever they are solving for this question. Now for the equation that we're given that we need to solve for, we are given 3 sine 2x plus 2 is 0. You are expected to evaluate with respect to y. So eventually it was worked, and the solution was found that y is minus 2, and for the line y is minus 2, you are going to get some mark. And then for reading that. And then for the truth set, here, this is the truth set that was obtained as 112 plus or minus 1.5 degrees. That's the margin for error. And look at what we did here. Okay, look at what we did here. So in short, this is interesting. They got 112, we got 111 because of course it's graph you're reading and co. And then you will see that we got y to be minus 2, just as it was defined in the page below. This is the working. Okay, here, this is the working here that is expected of us from the equation to get y is minus 2. And then here, this is actually the truth set from the graph. Okay, and then in the other way, we are also to get for this equation 3 over 2 sine 2x is equal to 0.25. You can get your y to be 0.5, and then the truth set will be both 4.5 and h 4.5 with margin of 1.5 degrees error. So let's look at that again. You can see here we also worked it out and we got y again to be 0.5. Okay, and then we also found the truth set to be, look at this, 5 plus or minus 1, then 84. That is very consistent with what we have. So doing this, your full math is assured and nobody will be able to deny you anything. You can see that all the solutions that were preferred, they were written legibly, very clearly. You can see it very boldly. Even the graph, you can read it very boldly. Okay, and the same you can also do in your exam so that you can gain that academic excellence. All right, so initially I wanted to look for a question on involving diagram. Graph is one of them, but one that is not graph based. Okay, this is a question on bearing and distances, question number 9. Okay, you can see here this question number 9 that we're looking at. Two cyclists X and Y leaving town Q at the same time. One is traveling at 5 kilometers per hour on a bearing of 49 degrees. The other 9 kilometers per hour on a bearing of 319 degrees from Q. Okay, so first, this is what I want to draw attention to. You have to illustrate the information in the diagram. Remember, in the rule, we were told that if you are being asked to illustrate the information in the diagram and you didn't include the diagram, then for the whole of this question, you are going to be scored 0. Okay, now let's look at the marking scheme. That is question number 9. Okay, question number 9, that's the graph. Okay, first we are asked to see the attach for the bearing for the diagram that was drawn, and I think that's in the next page. Good. Okay, this is the diagram. This is the diagram that we're expected to also draw. Okay, and you can see the noted 49, 319 and 41. Okay, but look at what was stated in the marking scheme. See, students, these are things that you just need to take note of. You can see you are going to get marks for the diagram showing 49 degrees, 319 degrees or 41 degrees and the relative positions of point X and point Y. That's what they're expecting from you as a student. And now let's look at how we solve that. Question number 9. Good. This is question number 9. And you can see this is a question, and very legibly, very clearly, you can see the diagram as it was shown. Okay, if you watch the video, you see the step on how to actually go about this. Is well explained, well detailed. There's no ambiguity about it. You just get it and get it clear. And you can see what we are asked to note. They said that you should note 319, 49 and 41, and you can see how they are explicitly shown in this particular diagram, and the relative position of X and Y. So this is point Q, this is X, this is Y, and with this you're on the way to success. Okay, then looking at the marking scheme again, in solving for the questions here, we are to get a particular distance, and then for stating the Pythagoras theorem, okay, you can see you have a mark, you have some mark for stating the Pythagoras theorem. Then you are going to get 18 kilometers or 10 kilometers, which would have been identified initially. So here you can see 18 and 10 kilometers, and look at the way we solve that. Now that's the very first step, that after 2 hours the distance of X is going to be the speed multiplied by the time, and that will give 10 kilometers, and for Y is going to be 9 multiplied by 2, that's 18 kilometers. So again, here you have your full mark, here already you have some mark, here you also have some full mark. And using the Pythagoras theorem, you can also see Pythagoras theorem is stated like this, and then we also got the distance Q between X and Y to be 21 kilometers. And look at the marking scheme, you can see that is also stated there, that you also have a mark for accuracy for 21 kilometers. Student, I cannot emphasize enough why you need to actually follow these steps. And at Daytut Academy, these are the things that we do to ensure that, see, it's not just about solving questions. We in-depthly explain for you to get a good grasp of the understanding, but not just understanding, you also need to know how to present this understanding that you would have already gained by watching our videos. So watching those videos will effectively keep you for excellence, and it will take you to that point, that position where we are trusting that God will take you to in life. Okay, so moving on with the question again, we are also asked to, let's look at the question that, okay, we are also to draw the diagram which is done. We are to find the distance between cyclist S and Y, okay, then the bearing of cyclist S from Y, okay, that is being done here, the bearing of the cyclist S from Y. Look at what they are telling us now. Now they are using tan to get one of the angles, and here what did you use? Okay, we also use tan, okay, you can see, but initially we also stated that, see, for the sum of angles on a straight line, we can see that the theta, this particular theta at this point Y, theta, okay, plus the angle XYQ, this angle here, okay, plus 41, the angles on a straight line. And if I'm the examiner, definitely I'm going to consider that, yes, you know what you are talking about, okay. That's why you're able to actually state this explicitly, and then you got the angle here to be 29, and then just like the exam scheme is saying, look at this, this is actually the statement of that angle on a straight line, okay. And for each step you also get some mass, and then you got the angle to be 109.94 degrees. Very good, very interesting, 109.94 degrees. But in bearing and distances, actually you express bearings in 3 digits, and I think even in the question we are just asked to find the bearing. The bearing is not going to be a decimal place. So if you stop here, you are not going to get your full mark, okay. You should actually approximate, and it is a whole number that you use to express a bearing. So that is why for 110 degrees you get the mark for 110, not for 109, okay. So with that you will just get your full mark. And then finally, the average speed is just distance over time, okay. And then this is expressed correctly, and looking at, yes, you can see the speed is expressed as distance over time, and then that average speed is 5.15 kilometers, and here is 5.15 kilometers. You can see, students, how this is quite interesting, how it's very good for you to actually use to prepare for your exam. But knowing all this is what will really help you, not just by saying I've read, I've studied, I've worked. The methodology, the way you go about it, is also very, very crucial, okay. Let me see if we can just pick one more question. Oh, this is beautiful, the cumulative frequency curve. Okay, maybe we can just take this cumulative frequency curve and construction, and we'll call it a day, okay. So now in this question number 10, let's go to question number 10. So this question number 10, so here we're asked to construct the table for the distribution, the cumulative frequency table. We're asked to draw the cumulative frequency curve. Then we use the curve to find the median mark and the lowest mark for distinction. If 5% pass the distinction, but it is to 1 decimal place. Look at this. This was explicitly stated. It was even written in bold ink. So you should know that your answer should be to 1 decimal place. So in the marking scheme, the student is going to get, for any 2 correct cumulative frequencies, the student will get some mark. But for the whole, for this whole table, you will definitely get 4 marks. And looking at what we did, okay, yes, you can see this is also the table, and drawing that already, some marks are apportioned to you appropriately, okay. Then from the question again, we are asked to construct the cumulative frequency curve. Here we are told to see the attached for the, so here this is the curve, and you can see here we have class boundary on the horizontal layer, and then we have cumulative frequency on the vertical layer, okay. So in the same way, from Day Tutor Academy, you can see this, you have your cumulative frequency, you have your upper class boundary, and this is the curve. I think this is more clear than the one we are seeing in black and white, okay. But let's look at the working. This is what, there are some things I just want to point out. So for the graph, you are going to get some mark, okay, and then for using the upper class boundary, you are also going to get some mark. So using what you are asked to use, what is expected of you in constructing the cumulative frequency curve will earn you some marks. But look at this, this is where I'm going. Now from the curve, from the question, we are asked to find the median mark correct to 1 decimal place, and then the lowest mark for distinction if 5% passed with distinction. And now look at this, this is what they are expecting, that then from the curve median you are going to get the 100th term, and then the mark will be 54.5 with a margin for error for the student as plus or minus 1. And look at what we did here. You can see we also stated, okay, that is the 100th term, that will be the median, and that will be 54.5 marks. And I'm also giving the margin for students to know, and you can see 54.5 and again 54.5. okay, it's just, you can see here on the graph, it's just very clear for you to see. And even if the examiner is seeing your work very neat like this, drawn effectively, of course definitely you will get your full mark. And then that finally, that 5% are distinction, that means that 95% are the remainder, and then that 95 scaled to 200 will be the 198th term, and that mark will be 87.5. okay, and you can also see here it is 88, but of course we have the margin plus or minus 1, and 87.5 is within that scope, and that will give us our full mark. It is doing this that will allow you to get the full mark that is apportioned, and that is exactly what we are doing. Okay, finally I just want to touch on construction. I don't generally advise students to construct, okay, but let me just touch on construction here. Okay, so in question number 13, the last question, okay, here in question 13, we have to use a ruler and a pair of compasses only to construct a triangle, the locus of points that are equidistant from the vertices of the triangle, and then using N, which is the point of intersection of the loci, to draw a circle to pass through points A, B, C. Now, that's the question. Look at the marking scheme. In question 13 here, we have to see the attached for this construction. So this is the construction that was shown, and here this is A, B, C, and then you can see the triangle and then the circle. I think the space is not enough to actually include. The circle was actually drawn like this. Okay, it was drawn just like that, and we did that in our question. You will see it now. But much more importantly, this is what I want you to note: the grading for the mark. Here you can see that. Okay, let me just go to us. Okay, now this is the sketch before construction, and this is the main construction. Let's look at what we have. We are told that, see, there should be a mark apportioned to anybody that got the length AB as 7.5, length AC as 13.5. So here you can see 7.5 AB, okay, 13.5 AC, okay. And that's not all. You also get accuracy mark for completing the triangle, and then the angle 120 degree also. So this is angle 120 degree, and then you can see the triangle in this thick blue. Okay, so that's already earning me some of my marks. Then you also get marks for getting the locus L1 and locus L2 and the point of intersection N. So let's look at that. This is, you can see this is L1, this is L2, and this is the point of intersection N. All right, and then finally, for drawing the circle to pass through ABC, you're also going to get A1 for accuracy. Okay, so you can see, look at this circle, and it's passing through A, it's passing through B here, it's also passing through C. Okay, you see, so you can see in all that we have highlighted in this video that, see, even our solutions from Dave Tut Academy, our video tutorials, they are complying only with what is expected of you to know, the way you're also supposed to approach your questions, the steps you're supposed to take, the way you're supposed to input your diagram, input your approximations and everything, just with the aim of providing you with academic excellence. So just go ahead and study with us. Our aim, our plan is that I want you to prepare to be the best that God has prepared you to be, and getting academic excellence in your exams, we know it's going to be a step further in achieving that particular result. So if you are here to subscribe to the channel, I wonder what you've been waiting for. Resources are constantly being uploaded for you to prepare for excellence in your exam. So go ahead, subscribe to the channel, like our videos, leave comment for us. Those are feedbacks that we normally get to know that yes, what we are doing is having impact in the life of somebody out there, is helping somebody to become a better person, is helping somebody to gain that excellence and prepare for that glorious future that God are prepared for him, and will be encouraged to do more as we see you gaining that particular excellence. It's Day Tutor Academy, and we hope this video has been wonderful. It has been useful for you. We hope you will find it useful in preparing for your exam. And until next time, God bless you.